Welcome to this course about Flutter and Firebase. I am very excited that you decided to enroll, and in this video I want to give you a general overview of how the course is structured and what resources are available so that you can make the most of it. And the first thing I want to tell you is that this is primarily a video course that will teach you how to build real-world apps with Flutter and Firebase. And since there is a lot of content to cover, I decided to organize it as multiple sections or modules. And on the main course page on my site, you can find a list of all the modules that I have planned, along with the main topics that will be covered. And if you head over to the course curriculum on Teachable, you find a list of all the lessons that I've included in each module. And that will give you a better idea of how big each module is. And one thing that I'd like to mention is that alongside the video content, each lesson will also include some notes with code snippets that cover the most important steps, so that you can more easily reference the material in the course. And some lessons will also include some diagrams and illustrations that will help you understand some of the most important concepts that we will cover. And in addition to this, you'll often find some additional links to useful articles on my website, or specific resources that you can use to complement the material in the course. So just be aware that alongside all the video content, all these additional resources are available for you. And by the way, the full source code for this course is available on GitHub. And since the main course project that we will build is an e-commerce app, and this app is relatively complex, we won't be writing all the code from scratch. And instead, what we're going to do is that at various points during the course, I'll share an updated code snapshot with you, which will contain all the latest code, and then we'll code along starting from there. And that will make it easier for you to follow along without getting lost or stuck on some code that doesn't work. And I'll share more instructions on how to do this as we make progress. And in addition to all these resources, I want to tell you about my Discord server, which is the recommended place for getting help with this course. I created this server in January 2024 to replace my old Slack workspace, which is no longer in use. And going forward, I'm planning to build a large community of developers who will come here to grow and learn about Flutter. So make sure you join this server by using the link that you can find below. And once you're in, please spend a couple of minutes reading the rules. And then you can jump over to the introductions channel, where you can introduce yourself and tell everyone else what brought you here. And finally, you can jump over to this courses section, where you can find the right channel for this course, and use it to ask questions and get help directly from me. Alright, so once again, welcome on board, and I hope that you're excited to dive in and get started with the course. It gives you a wide range of features that will be very complex to implement on your own. And what makes Firebase so popular is that it is very easy to use. In fact, you can easily add authentication and a remote database and server-side functions to your app with very little effort. And since Firebase is hosted on Google Cloud, you don't have to worry about managing your own server and scaling issues if your app becomes successful and is used by millions of users. But of course, Firebase is not a silver bullet, and depending on your app requirement, it may or may not be the right choice. So in this video, I'm going to give you an overview of all the Firebase pros and cons for Flutter app development. And in order to give you the full picture, we'll consider many factors, including what features are available, with particular attention to the remote database, because this is often the most important deciding factor. We'll also look at what platforms are supported. And we'll talk about Dart support both on the client and on the server. Then we'll talk about pricing, as well as portability and vendor lock-in, which is an important factor to consider. And then we'll focus on the documentation and the developer experience, which are very important too. And we'll wrap up with a summary of the pros and cons, so you can decide if Firebase is right for you. Okay, so let's get started. And when it comes to how many features are available, Firebase is in a very strong position by offering things like Cloud Firestore, authentication, and Cloud Functions, which are needed by most apps. But in addition to that, you also have things like extensions, app check, as well as hosting, cloud storage, and machine learning. And when it comes to releasing and monitoring your app, you can use products like Crashlytics, Google Analytics, performance monitoring, as well as Firebase Test Lab and app distribution. And also you can engage with your users using features like remote config, A/B testing, cloud messaging, dynamic links, and in-app messaging. And the bottom line is that for the vast majority of apps, Firebase is likely to offer all the features you need. But as they say, the devil is in the details, and one of the most important things to consider when starting a new project is what kind of database you need. And if you use Firebase, the most popular option is Cloud Firestore, which is a NoSQL database. And what I really like about Cloud Firestore is that it is very easy to use and comes with useful features like real-time listeners, caching, and offline mode, which are definitely things you want from a modern database. In fact, real-time listeners are my favorite feature and make it easy to sync your data across multiple devices and rebuild your UI automatically when the data changes on the backend. And on top of that, offline support is enabled by default on mobile, because the Cloud Firestore Client SDK caches every document that is received from the backend. And this means that Cloud Firestore will work smoothly when your users go offline for a couple of seconds, or minutes, or days. And as soon as the connection is back, then all the data is synced with the server and across devices. Though keep in mind that if you want a truly offline-first solution, Cloud Firestore is probably not the right solution for you. So overall, real-time listeners, caching, and offline mode are some great advantages that come out of the box, and not something that you would want to implement in your own custom backend. With that said, Cloud Firestore has some disadvantages too. For example, it does not support full text search, which is something that is needed in many kinds of applications, such as e-commerce sites, where you need to be able to query an entire product catalog. So keep in mind that if full text search is important to you, you may need to use external services like Algolia, which can be integrated with Firebase. And since this is available as a Firebase extension, it is quite easy to set up. But it's also relatively expensive, at $1 per 1,000 requests. And it would be nice if we had full text search directly with Cloud Firestore without having to rely on third-party services. And another disadvantage is that when it comes to querying data, Cloud Firestore has some limitations. And these limitations may not be obvious when you're just starting out, but they can bite you later when your database structure and queries become more complex. Though the good news is that support for all conditions was recently introduced in Cloud Firestore. But overall, a bigger question that you need to ask yourself is whether a NoSQL database is what you want, or if you should go with a relational database, such as PostgreSQL or MySQL. And while relational databases come with a steeper learning curve, they can make your life easier down the line, especially if your data is highly structured and will benefit from being able to run complex SQL queries. Next up, let's switch gears and talk about what platforms are supported. And a quick search on pub.dev reveals that all the Firebase packages can be used on Android, iOS, macOS, and web. But if you're building a Flutter app on Windows or Linux, then you are out of luck, because these platforms are not supported by Firebase. And the only exception to this is Firebase Auth, which can run on Windows and Linux using the Firebase Auth desktop package. But once again, all the other packages are available on these 4 platforms only. And one important thing to note is that all the Firebase packages for Flutter rely on the underlying iOS, Android, and web SDKs, rather than being implemented in pure Dart. And this also means that they require some platform-specific configuration. And for simple apps, this is easy to do using the Flutterfy CLI tool. But as soon as you start adding more complex features like analytics or push notifications, then configuring everything correctly on each platform can become a challenge. However, a bigger problem is that if you want to write server-side code using Cloud Functions, then you have to use the Firebase Admin SDK, and this is available for JavaScript or TypeScript, but not for Dart. And this means that there is no official way to write full-stack applications in Dart using Firebase. And if that is what you really want, then you have to look into alternative backends, such as ServerPod and Dart Frog. But assuming you do use Firebase, then you end up in a situation where your Flutter client code is written in Dart and your server-side code is written in JavaScript or TypeScript, which is not ideal because you have to learn 2 different languages, which impacts your development speed. And also, you can't share your business logic and data models across the entire stack. And you can't reuse your favorite Dart packages on the server. On the plus side, when you write Cloud Functions in JavaScript or TypeScript, you get access to the entire JavaScript ecosystem, and this is far more mature than the Dart ecosystem. Next up, let's talk about pricing. And this is something that for some reason people are scared about, when the reality is that Firebase has a very generous free tier, meaning that for most hobby projects, your cost will be a big fat 0. And if you ever exceed the limits of the free plan, then your cost will scale up based on usage, but still remains very affordable. And in any case, most Firebase products include a usage tab, where you can see the usage for any given period. And there's also this usage and billing page, where you can see a breakdown of all your billable metrics. And for extra peace of mind, you can go to your Google Cloud account and set budgets and email alerts if your usage exceeds certain thresholds. And the biggest takeaway here is that pricing shouldn't really be your main concern. On the other hand, portability and vendor lock-in is a more tricky subject. And one of the biggest drawbacks about Firebase is that Cloud Store is a proprietary database, and all your customers' data is stored on Google servers. And this means that if you ever want to migrate all your data to a different backend or host it somewhere else, then you are in for a world of pain. Though at least Firestore offers some options to back up your data using the Google Cloud Console. And you can use these options to export the entire database or select one or more collection groups, which will be saved to a Google Cloud storage bucket of your choice. Though keep in mind that you'll be billed for this based on the number of documents, reads and writes. And this brings us to the next drawback of Firebase, and that is that unlike other popular backends like Supabase, Firebase doesn't offer a self-hosted solution. And on one hand, this is not a big problem, since the whole point of a backend as a service is that you don't want to manage your own servers. On the other hand, all your data is hosted on Google servers, meaning that Google owns your data and not you, and you don't have full control over your backend. Next up, let's talk about documentation and the developer experience. And documentation is something where, for the most part, Firebase is doing a good job. In fact, Firebase comes with extensive documentation covering the most important features. And you'll find that many of the examples in the docs include code snippets which are written in Dart. However, the documentation can be spotty at times, and there are cases where you'll only find what you need in the old Flutter Fire website, which is no longer updated. With that said, the Firebase console makes it easy to add Firebase to your Flutter app by showing you all the required steps. And for simple apps, the setup only takes a few minutes and can be done with a CLI tool known as Flutterfire. And once you've added Firebase to your Flutter apps, you can use the Firebase UI packages to more easily integrate various Firebase features into your app. And this can save you a lot of time, particularly when it comes to adding authentication flows, so that the user can sign in with email and password or Google signing. Alright, so this wraps up our overview about the Firebase pros and cons, and we can do a summary. And overall, I find that what makes Firebase good is that it offers a large number of useful features, along with a good developer experience that helps you ship your apps faster. And as you have seen, the pricing model is quite affordable, and overall, Firebase is a great solution to ship secure apps at scale. However, what is not good is that there is no Windows or Linux support, and we also don't have a native Dart client SDK. And as we have seen, we can't write cloud functions in Dart, which leads to a bigger learning curve and less code reuse across the client and the server. And as a drawback, I would also include the limitations of Cloud Firestore, which only offers limited query capabilities and no full text search. And as we have seen, if you choose Firebase, you are locked in, and you'll find it hard to migrate to a different backend later on. With that said, Firebase is a very mature platform, which is backed by Google and integrates very well with Flutter, and I've been happy to use it as a backend for most of my Flutter apps for many years. Okay, so this completes our overview about Firebase. And if you're not sure if Firebase is the right solution for you, you can find a list of alternatives in the description below. But since you have enrolled in this course, I assume that you are happy to go ahead and learn Firebase. And this is exactly what we are going to do, starting from the next lesson. Welcome to this first chapter of the course, where I'll give you an introduction to Firebase by building a simple full-stack application using the latest Firebase UI packages. I designed this chapter to be a gentle introduction to Firebase, and as long as you already know how to build simple apps with Flutter, you should be able to follow along even if you never used Firebase before. So here is an overview of what we will cover. We will start by getting familiar with the Firebase console, so that we can create projects and enable features like Firebase authentication and Cloud Firestore. Then we'll learn how to add Firebase to a Flutter app using the Flutter Fire CLI. And we'll see how easy it is to add and customize an email and password sign-in flow using the Firebase UI Auth package. Then we'll learn about how to use GoRouter to redirect users to different pages when the auth state changes and complete our authentication flow. And then I'll give you an introduction to Cloud Firestore as a NoSQL database. And we'll use it to create, read, update, and delete items using a list view inside our Flutter app, taking care of separating all the data access logic from the UI code. And to make our life easier, we'll use the Firestore list view widget from the Firebase UI Firestore package. And we'll also talk about using type-safe model classes, as well as how to run queries and filter the data that comes from Firestore. And then things will get interesting, because we'll talk about data modeling and security rules. And I'll show you some issues that you might run into if you model your data incorrectly, as well as how to fix them. And then we'll cover some additional concepts, such as working with timestamps, sorting data, and offline mode. And we'll finish up by learning about pagination and the Firestore Query Builder widget. So by the end of this chapter, you understand how straightforward it is to work with Firebase and use it to add authentication and a remote database to your Flutter apps. And this will give you a solid foundation to build upon in the rest of the course, where we'll explore Firebase in greater depth by building a real-world e-commerce app with cloud functions and third-party integrations like Stripe and Algolia. I really hope that you will enjoy this course, so let's get started with this introduction to Firebase. And as I mentioned before, we'll be building a simple full-stack application using Flutter and Firebase. And while we could start completely from scratch, I decided to share a starter project that contains a very basic skeleton for the app that we will build. So before we do anything else, please head over to this page on GitHub, where you can find the starter project. And you can find the link to this repo on the description below. And as you can see, the README contains these commands that you can use to clone this project on your machine. So let's go ahead and open a terminal. And then we can copy this command and paste it in here. And then we can go ahead and open this folder. And then we can check out the starter project by running this command, like this. And once this is done, we can open this project in our IDE, like this. And just so you know, I'll be using VS Code in this course. But feel free to use Android Studio if you prefer. Okay, so by now you should have the project loaded in VS Code. And if you open the pubspec.yaml file, you'll find that we are using Dart version 3.0, which was released as part of Flutter 3.10. So make sure that you're running on Flutter 3.10 or above if you want this project to work. And you can quickly verify this by running Flutter Doctor on your terminal. And as you can see, here it shows that I'm running on Flutter 3.10 stable. And by the way, if you want to speed up your workflow, I also recommend that you go through this article on my website, which lists all the extensions and settings that I use for Flutter development. Okay, so next up, let's look at the packages that we have installed. And as you can see, the two main packages that I've included here are GoRouter and Flutter RiverPod. And since this is a course about Firebase, I won't be spending much time covering the basics of GoRouter and RiverPod, but I will still point out things that you may not be familiar with. And I'll also share any resources that you can use to fill any knowledge gaps as we go along. Okay, so now that we have reviewed the pubspec.yaml file, we should go ahead and download all the packages. And then we can go ahead and try to run this app. And we can do this by selecting one of the available devices and then pressing F5. And I'll be using the iOS simulator for now, but feel free to use the Android emulator if you prefer. And just so you know, the Firebase SDK for Flutter is currently available on Android, iOS, macOS, and web, but not yet for Windows and Linux. And since we'll be building a mobile app, I recommend that you use iOS or Android. And by the way, if you encounter any issues in running the iOS app, please check the notes below, where I've included some troubleshooting tips. And as soon as you get the app running, you should see this empty screen with just a title that says sign in. Okay, so let me give you a quick walkthrough of the code in this starter project, starting from the main.dart file. And as you can see, this file is very simple, and all it does is to declare a root widget called myApp. And since we use RiverPod, this is wrapped inside a provider scope, so that we can create and access providers inside our widget. And inside the build method, we use materialapp.router, which is configured with a GoRouter object that we get from this provider. So let's go ahead and take a look at this. And as you can see, this is just a simple provider that returns a GoRouter instance. And this contains two routes. The first one returns a custom signing screen, which is the screen that we see over here. And the second one returns a custom profile screen that we will use later. And I've also added this enum at the top that I can use to define a name for each route. And the values of this enum are used over here. And if we take a look at the custom signing screen, we can see that it is a very simple widget with just a simple scaffold and an app bar. And the custom profile screen is also very simple. And I've also added a couple of extra files called homescreen.dart and job.dart, but for now we don't need them and we will use them later on. So as you can see, there isn't really anything fancy in this starter project, and all I've done is to configure a GoRouter instance that defines the various routes that we will use in our app. And I've also configured RiverPod so that we can work with providers when needed. So let's continue on the next lesson where we'll start learning Firebase. are now ready to get started learning about Firebase. And just so you know, Firebase offers a large selection of products that you can use to build and release your apps, as well as engage with your users. And since we are covering the basics, for now we'll focus only on authentication and Cloud Firestore. But feel free to take a look at all the other products if you want to get a better idea of what you can do with Firebase. Similarly, if you head over to the docs, you'll find extensive documentation for all of these different products. And for some of these products, such as Firebase Authentication, you'll find specific pages that show you how to use them on each platform, including Flutter, of course. But for now, we just want to get started. And the best way to do that is by heading over to the console, which can be found at console.firebase.google.com. And from here, we can go ahead and create a new project. And then we need to give it a name. So in this case, we could call it Faker App Flutter Firebase, like this. And then we can hit continue. And then we should disable Google Analytics because we don't need it for this project. And then we can go ahead and create the project. And this is something that may take a minute or two. So we can give it a bit of time. And once this is done, it will tell us that the project is ready and we can continue. And then we'll be taken to the Firebase dashboard for our project. And here we get this suggestion telling us to add one of these apps to get started. And as we can see, Flutter is one of the available options. So let's click on this. And this will take us to a page with some instructions to add Firebase to our Flutter app. And in order to proceed, there are two tools that we need to install. The first one is called the Firebase CLI, and the second one is called the Flutter Fire CLI. And of course, we need to have the Flutter SDK installed. So let's go ahead and click on this link so that we can learn how to install the Firebase CLI. And depending on whether you're running on Windows, macOS or Linux, you can find the latest instructions on this page. So in my case, I can click on macOS. And the most common way to install the CLI is by using npm or Node Package Manager. So if we already have npm installed on our system, we can install the CLI by running this command. However, this will only work if you already have Node.js installed on your system. So if you try to run this command and you get an error telling you that npm is not found, then it means that you don't have Node.js installed on your system. And in that case, you need to follow these instructions. So make sure that you download and install Node from here if you don't already have it in your system. And once you have done that, you should be able to run node -v on the terminal, and this should print the version number like this. And once you know that Node.js is installed correctly, then you can go back to this command and copy it. And then on your terminal, you can paste it like this. And this will go ahead and install the Firebase tools if they are not already in your system. And if everything has worked correctly, you should be able to type in Firebase on the command line, and you should get all this information printed on the console, telling you about all the commands that are available with this client. And the next thing that you want to do at this stage is to run Firebase login, so that the CLI can sign you in with the Google account that you've used to create the Firebase project. So let's go ahead and press enter at this prompt, and this will open a separate page. And if you have multiple accounts, make sure that you select the one that you've used to create your Firebase project. And once you've done this, you can click on allow so that the Firebase CLI has access to your Google account. And once you're done with this, you can get back to the console, and you should see that you're correctly signed in with the email address that you have selected. Okay, so let's carry on. And as the next step, we need to install the Flutter Fire CLI, because this is the tool that we'll use to add Firebase to our Flutter project. And this is easy because all we have to do is to copy this line, and then we can paste it on the terminal like this. And by the time this is finished, you should see this message saying that the Flutterfile CLI was activated. Okay, so this completes the setup of all the CLI tools that we need. And we can continue on the next lesson where we are going to add Firebase to our Flutter project. The Flutter CLI, we can use it to configure our Flutter project. So let's copy this line from here, and then we can get back to our project in VS Code and open the terminal, and then we can paste it in here. And then we get a prompt asking us which platforms we want to configure. So in our case, we definitely want to use Android and iOS, and if we want, we can disable macOS and web. Or if you prefer, you can leave them on, so you can test on these platforms as well. And then we can press enter, and now Flutterfire CLI will go ahead and do a bunch of work for us by registering a Firebase app for each selected platform. And as we can see, here is registered a Firebase Android app. And then it's going to do the same thing for the iOS app. And then again, it's going to do the same for the macOS app and the Flutter web app as well. And then it's asking us if we want to update the Android Gradle files to apply the Firebase configuration. So let's go ahead and press enter. And this will complete the installation process by showing us all the Firebase app IDs that have been registered. And one thing that we can notice at this stage is that the CLI has generated a new file called firebase options.dart. And this file contains all the configuration code that is needed to run our project. But as we can see, this code does not compile because we have not installed the Firebase core package yet. So let's make sure we add this by opening the command palette, and then we can use the Dart add dependency option and use this to install the Firebase core package. So let's go ahead and do this. And once this package has been installed, then we can see that all the errors go away. And if we go back to the pubspec.yaml file, we can confirm that Firebase core has been installed. And as I record this video, the latest version is 2.13.0. And just to make sure that we use exactly this version, we can remove this caret from here. And if any of these packages introduces any breaking changes in the future, I'll make sure to update the course accordingly. Okay, so let's get back to our Firebase options file. And just to be clear, the purpose of this file is to hold all the configuration that our Flutter project will need to talk to Firebase for each specific platform, as we can see over here. And now that we have created this file, there is only one step left to complete, and that is to initialize Firebase inside our main.dart file. So let's go ahead and copy these 3 lines of code from here, and then we can get back to our project and open the main.dart file, and then we can paste them in here, like this. And here we can use the quick fix option to import the Firebase options file that we have generated a minute ago. And we should also import firebase core.dart, like this. And since here we are using an await call, then we should also mark our main method as a sync, like this. And we should also make sure that we have a call to widgets flutter binding.ensure initialized. And this is a requirement because our Flutter app needs to call the native code in order to initialize Firebase. And under the hood, this is done using platform channels, which are initialized asynchronously. So what this code do is to ensure that the widgets binding is initialized before we attempt to make any calls that will communicate with the native code. In fact, at this stage, it would be a good idea to run the app on iOS and Android to make sure that everything works as intended. So this time we could select the Android emulator, for example, and try to run the app. And this might take a little while. And once the build is complete, you should see the signing page appear on the emulator over here. And if anything is not working for you, you can check the notes below for more information. In summary, we have now created a new Firebase project and used the Flutterfire CLI to configure our Flutter app and initialize the Firebase SDK by following these steps. And before we move on, I just want to mention that it has taken us just a few minutes to get everything installed, and that's because the Flutterfire CLI does all the heavy lifting for us. So trust me when I say that in the old days it was a big pain to configure Firebase manually on every single platform, but with Flutterfire our job becomes much easier. And by the way, I also want to point out that when we run Flutterfire configure, some new files such as this Firebase options.dart file are added to the project. And the reason that this file appears with a dark color on the Project Explorer is that I've included it inside my gitignore file over here, along with all these other files, which contain some platform-specific configuration and are also generated by Flutterfire. And in general, it's okay to commit these files to version control if you want to make sure that other people in your team connect to the same Firebase project. But since this is a tutorial, and you'll be connecting to your own Firebase project and not mine, I think it's best to add these files to gitignore. And with this, we have completed all the Firebase installation and configuration steps. So let's continue on the next lesson, where we'll start working on the Flutter app. In this lesson, we're going to see how easy it is to add user authentication to our Flutter app by using the Firebase Auth and the Firebase UI Auth packages. And for now, we're going to just focus on email and password authentication, since this will give us a way to easily create and test the app using multiple accounts, which is something that we will need later when we write user-specific data with Cloud Firestore. Okay, so as a first step, let's get back to the Firebase console And here we can select authentication from this card. And then we can click on Get Started. And once we have done this, we get this table showing all the different authentication options that are available. And for now, we can go ahead and select email and password authentication. And in order to use this feature, we need to enable it with this toggle. And once we have done this, we see a confirmation that this has been enabled. Next up, it's time to start using this in our Flutter app. And at this point in time, we have a decision to make. And that is whether we implement all the user signing and registration UI ourselves, or we choose the Firebase UI packages to do this. And if we just want to get going without having to spend a lot of time reinventing the wheel, then Firebase UI is the way to go. So as a next step, we can head over to pub.dev and find the Firebase UI auth package. And as we can see, this table shows us which authentication features are supported on which platforms. And if we scroll down, we can see how to install this package, along with some example code for how to implement a minimal authentication flow. And as we are about to see, it is indeed possible to add a working authentication flow with just a few lines of code. So let's see how to do that. So let's get back to VS Code, and here we can open the command palette and type dart add to add a new dependency. And here we can add Firebase auth along with Firebase UI auth, like this. And what this will do is to add both packages at once inside our pubspec.yaml file. And like I've done before, I'm going to remove the caret so we can pin these exact version numbers. So let's go ahead and get the latest packages. And now that these packages have been installed, it's a good idea to run the app on iOS and Android, because these packages rely on the native Firebase iOS and Android SDKs, and some platform-specific configuration is needed. So let's start by selecting the Android emulator, which I have over here, and then we can go ahead and run the app. And what will happen at this stage is that we'll get a build error, which we can see over here. And this is happening because Firebase requires a greater min SDK version than the one that is currently in use. So to fix this, we should open this build Gradle file that we can find inside the Android folder and inside this app subfolder. So let's make sure that we open this build Gradle file. And then we can scroll down until we locate the min SDK version inside the default config section. And to fix our problem, we need to replace this value with a sensible value, such as 21, for example. And now that we have done this, we can save this file, and then we can try to run again. And this time we may still get some warnings on the console. However, these are just notes and not actual errors, so there's nothing to worry about. And as we can see, after a little while, the app is built, and we can run it on the Android emulator. So make sure that you have this fix in place before you run the app on Android. On the other hand, if you want to test your app on iOS, you should be able to run the app without problems and see that everything looks fine on the console logs. However, if you want to run on macOS, then some additional configuration is needed, and I'll show you what to do at the end of this lesson. So for now, what I suggest you do is to stick to Android or iOS. And at the end of this lesson, I'll share some updated source code that you can use to get the app working on macOS. With that said, let's get back on track. And now we are ready to add some UI. So let's move over to the custom sign-in screen. And then at the top of the build method, we can declare a final auth providers variable equal to a list that contains an email auth provider instance. And then we need to use the quick fix to import this. And as we can see, this is a class that exists both in the Firebase auth and in the Firebase UI auth package. And the one that we want in this case is Firebase UI auth, like this. And then we need to add a body to our scaffold. And here we can pass a sign-in screen widget as an argument. And this widget takes a provider's argument, which should be our auth providers, like this. And at this stage, we can already save the app and run it on our iOS simulator. And this is gonna take a bit of time, so let me pause the video and resume when the app is running. My app is now up and running, and as you can see, we already have a fully functional email and password UI that we can use to sign in or register. And we even get a forgot password flow out of the box. And this is great because we barely had to write any code to enable this. But there is more, because if we wanted, we could add some additional auth providers. For example, here we could add a phone auth provider, along with this type annotation, so that Dart can infer the correct type. And if we save and hot reload, we now get this option to sign in with phone. And if we click on this, we get to this separate screen, where we can enter our phone number. And this shows how easy it is to add multiple authentication methods with the Firebase UI packages. Okay, so for now, let's stay on track and focus on email and password authentication only, like this. So let me revert these changes. And then we can try to sign in. So for example, we could enter an invalid email. And if we submit, we can see that we get an error, because the Firebase UI auth package can do client-side validation for us. On the other hand, if we enter a valid email such as test@test.com and test1234 as a password, and we try to sign in, then we get an error telling us that this account doesn't exist. And this is a kind of server-side validation, because it is only after we submit these credentials that Firebase can verify if there is a corresponding account. And of course, since we are talking about email and password authentication, then we had to register an account first before we can use it to sign in. So let's click on register, and then we can enter an email like this, along with a password, and we can confirm this as well, and then we can submit our request. But it seems like nothing has happened and we remain on the same page. However, if we head over to the Firebase console and open the Users tab inside Firebase Authentication, then we can see that a user account has been created. And this line shows the email that we have provided, along with this icon that represents the authentication provider, and a field called User UID, which we'll talk about in the coming lessons. So everything looks good on the Firebase console. And the reason that we are still on the same page is that we haven't told Flutter what should happen when the sign-in or registration is successful. So let's continue on the next lesson, where we'll see how to deal with auth state changes. And by the way, what we said earlier on is that if we wanted to get the app running on macOS, some additional configuration was needed. And as it turns out, if we use Firebase, then getting the app to run on macOS is quite complicated, and we are likely to encounter many issues. So if you want to learn more about this, then make sure to read this article on my website, where I explain all the required steps. However, what I suggest we do at this stage is to get the latest code directly from GitHub. So please go ahead and open a terminal, and then you can type git reset --hard head and discard any working changes that you may have. And then you can go ahead and run git checkout macOS project fixes. And what this will do is to get all the latest code. And just so you know, if you want to run on macOS, then you'll have to open the macOS project in Xcode, and then you'll have to go to signing and capabilities and change the development team. And this is something that you can only do if you have an Apple developer account. But once again, as far as we are concerned, it's going to be much easier if we stick to iOS or Android going forward. Okay, so let's continue on the next lesson. Before we continue, make sure that you are running on the latest code. So if you haven't done this at the end of the last lesson, please go ahead and check out this branch called macOS Project Fixes, since this should allow you to run on all the platforms without errors. And now let's get back on track. And at the end of the last lesson, we have discovered that a user account has been created on a Firebase console, but the Flutter app remains on the same screen when we try to register or sign in. And if we want to go to a different page, then we need to add a list of actions to this sign-in screen. So let's do that. And the first action should be an auth state change action of type signed in. And if we hover over this class, we get some sample code showing us how to use it. And this sample code uses the Navigator API, but in our case, we are going to use GoRouter instead. So let's go ahead and provide a callback that gives us a context and a state object. And then inside the callback, we can call context.goNamed, passing approute.profile.name as an argument. And just to be clear, goNamed is an extension method on the build context class. And in order to use it, we need to import gorouter.dart. Likewise, we need to import our approuted.dart file, because this is where we define all the routes. And just to be clear, we want to navigate to this page when the user has successfully signed in, but also when we register a new user. And to do that, we can copy these 3 lines, and then we can paste them in here, and then we can use a different action called user created. And if we go to the definition of the signed in type, we can find a number of classes such as user created, signed in, auth failed, and these represent all the types of auth state that are supported. And as you can see, all these classes extend this base auth state class. In fact, one thing that I really like about the Firebase UI packages is that they are very configurable. In fact, we can even open the definition of the sign-in screen widget. And as you can see, there are many arguments that we can provide to customize the behavior and appearance of this screen. And you can hover over each one of these arguments to learn what is their purpose. But for now, let's get back on track. And if this code is correct, we should be able to sign in using the test email and password that we have registered before. And as soon as we sign in, we can see that the app moves to the profile page. And this is because this callback has been executed. And GoRouter has taken us to the route that matches this name, which contains the custom profile screen widget class. But what should we show on this screen? Well, wouldn't it be cool if the Firebase UI auth package also had a drop-in widget that we can use for this page? And of course it would. And as it turns out, what we can do is to replace this scaffold with a profile screen, which we can import from the Firebase UI auth package. And then inside the build method, we can define a final variable called auth providers, which is going to be equal to a list that contains the email auth provider, just like we have done on the sign-in screen. And then we can pass this as a parameter to the provider's argument of the profile screen. And at this stage, we can save and hot reload. And we can see that this entire profile screen has been updated. And this is really cool because it means that we get all these widgets out of the box, meaning that we can easily configure a display name like this. Or if we want, we can send a verification email. And we can also see which sign-in methods we can use to access this account. And finally, we get two buttons that we can use to sign out and delete our account. And just like we have done for the sign-in screen, we can add an actions list to this widget. And in this case, what we want to do is to add a signed out action, which takes an argument, which is a function that gives us the context. And we can use this to call context.goNamed, passing uproute.signing.name as an argument. And of course, we need to import GoRouter in order to use this, as well as the file that contains all the routes. And then we can save our file once again. And at this stage, we should be able to click on sign out and get back to the sign-in page. And this confirms that the sign out action is working as intended. And now we can sign in once again with our test email and password to get back to the profile page. And once again, it's great that we get a ton of functionality for free with just a few lines of code. And if we want, we can even customize the UI on this screen. For example, here we could change the avatar size to a value of 64, for example. And if we save now, we can see that the avatar becomes smaller. And if we hover on the profile screen widget, we can see all the other properties that we can customize. And there's even an option to show some additional UI for two-step verification, which can be enabled over here. So overall, it seems clear that the Firebase UI auth package can save us a lot of time because we don't have to implement all the custom UI ourselves. And instead, we can get this stuff done quickly and move on to building the features that are unique to our app. In fact, the biggest takeaway from this lesson is that if you're starting a new project and want to get quickly up and running with user authentication, then you should really consider using the Firebase UI auth package. Okay, so let's get back to the profile screen, and here we can remove these two arguments since we don't need them. And by the way, there is one important detail that we haven't considered, and that is that if we are currently on the profile page after signing in and we hot restart the application, then we end up back on the sign-in page, and this is not something that is intended. So let's continue on the next lesson where we'll fix this. In previous lessons, we have built a working authentication flow, and we have noticed that when we hot restart the app, we end up on the sign-in screen even if we were previously signed in. And this is definitely something that we need to fix because we don't want to force users to sign in every time they restart the app. And to understand why we had this problem in the first place, we can open the app router.dart file. And as we can see, our GoRouter instance defines an initial location with a value of sign in. And this corresponds to the route that we have defined over here. And what this means is that when the app starts, we're always gonna end up on this route, even if we're already signed in. So how can we take into account the current authentication state when the app is first loaded? Well, one way to handle this is to use a property of the GoRouter class called redirect. And this is a function that gives us a context along with a state object. And the way this works is that this function will be called every time a new route is requested. And if we don't want to apply any redirect logic, then we can just return null, like this. And in this scenario, GoRouter will work out what route to take based on the current state and the definition of all the existing routes. But we can also choose to redirect to a different route if certain conditions are met. For example, here we could type if is logged in, which is a variable that we are going to define shortly. And then inside this condition, we can check if the state.location is /signing. And if that's the case, we can return /profile. On the other hand, if we are not logged in, we can add an else branch. And inside here, we can type if state.location is equal to /profile. And then in this case, we should return sign in instead. And now that this logic is in place, there is only one thing left to do, and that is to define this variable. So over here, we can type final is logged in equal to, and on the right hand side, we can type firebase auth.instance.current user is not equal to null. And in order to use this, we need to import firebase auth like this. And if we hover over this current user property, we can read that it returns the current user if they're currently signed in or null if not. And that seems exactly what we need to determine if the user is logged in. And what is nice about this property is that it is synchronous, meaning that we don't need to use async await to find out if the current user is signed in or not. And I should also point out that we are accessing this variable using this instance of Firebase auth using the singleton pattern. And this is not something that I would recommend, and we will change this in the upcoming lessons. But for now, let's stay on track. And now that we have made this change, we can save our changes and we can hot restart the app as well. And since we were previously signed in, then we would expect to end up on the profile page, which is exactly what we see over here. And if we want, we can even run the app on Flutter Web, which I have just started over here. And as a proof that the redirection logic works, I can try to go to the profile page by changing the URL in the address bar like this. But as you can see, we are immediately redirected back to the sign-in page. In summary, in this lesson, we have learned how to use the GoRouter APIs to redirect to a different route based on the application state. And the main things to remember are that the redirect function will always be called when a route change is requested, which is normally when we try to push, pop, or go to a new route. And we can inspect the state object to find out what is the current location, along with all these other properties. And if we return null from the redirect function, then GoRouter will move to the desired route as expected. But we can choose to return a value that is not null if we want to redirect to a specific route. And one benefit of the redirect function is that we can centralize our routing logic to a single place in our code, alongside the definition of all the remaining routes. And as we have just seen, this function is well suited for redirecting based on the authentication state. So let's continue on the next lesson, where we'll build upon what we have just learned and talk about the refresh listenable argument. In the last lesson, we have made sure that the app shows the correct page when we hot restart by adding some code to the GoRouter redirect function to check if the user is logged in. And as a result, our app works as intended, and we can use it to sign in and sign out. And as we have seen, the reason we can transition from the sign-in page to the profile page and vice versa is that we've added some auth state change actions that we can use to go to a specific route. And while this works well for simple apps, it would be nice if we could tell GoRouter to automatically reevaluate the current route when the authentication state changes, so that we don't even need these custom actions in the first place. And if we use Firebase auth, we can do this with the auth state changes method. So let's see how this works. And as a first step, we can comment out these actions from the custom sign-in screen. And if we head over to the custom profile screen, we can comment out this action as well, like this. And if we save and hot reload at this stage, and we press on the sign out button, we can see that we are no longer taken back to the sign-in page. So let's go back to our app router file. And if we want to listen to auth state changes, we can add a new refresh listenable argument. And then we can type firebase auth.instance.auth state changes. And if we hover here, we can see that this method returns a stream of user. And in Dart, streams are very useful because they can be used to set up real-time listeners and update the UI when the data changes. However, in this case, we get an error because this method returns a stream, while this argument is of type listenable. And this means that if we want this code to work, we have to do some kind of stream to listenable conversion. And to help with that, I've included this GoRouterRefreshStream class in the starter project. And this is nothing other than a wrapper that takes a stream as an input argument, and then it subscribes to it using the listen method, and then it calls notify listeners when there is a new stream event. And this is possible because this class has been defined to extend from change notifier, which in turn implements the listenable abstract class. And what this means is that we can go back to our app router, and here we can wrap this call with a GoRouterRefreshStream like this. And in order to use it, we need to import it like this. And as a result, our code now compiles and we can hot reload. And in fact, since we changed a few things, it might be actually better if we hot restart instead. And this takes us back to the sign-in page. And then we can verify that if we enter the correct email and password, then we are taken back to the profile page. In summary, what we have just seen is that we can remove explicit calls to context.goNamed when certain events take place inside these change action callbacks. So let me go ahead and delete all this old code from here. And I'm also going to do the same thing on the custom profile screen, like this. And instead, all we had to do is to listen to the auth state changes method inside our GoRouter by using this refresh listenable argument. And this will cause the redirect function to be called again when the auth state changes, so that our redirect logic is executed and the UI is updated. So this is a useful trick that I often use in my apps whenever I want to show a sign-in page or a home page depending on the authentication state. And indeed, this is a very common requirement for many apps. So feel free to use this if you want. Okay, so let's continue on the next lesson. The signing flow works as intended. It's time to make some changes that will make our code more maintainable and testable going forward. And as you can see inside the app router file, we access the current user and the auth state changes method using this Firebase instance, which is a singleton. And in the vast majority of cases, it is not a good idea to use singletons. And if you want to find out why, you can read this article on my site, which goes through all the drawbacks of using singletons and offers some alternative solutions instead. And the short version of this is that we don't want to call Firebase auth.instance directly inside our classes. And instead, it will be best to create a provider instead. So what I propose we do is to add a new provider, and we are going to call this Firebase auth provider, which will be a provider of type Firebase auth. And inside it, we are going to return Firebase auth.instance like this. And by the way, if you also want to be able to create providers using code snippet, you should install the Flutter Firebase snippet extension, which does what it says on the tin. And now that we have this provider, we can go inside here and type final Firebase auth equal to ref.watch with Firebase auth provider. And then we can go ahead and replace these calls with Firebase auth. And we can do the same over here as well, like this. And this may seem like a small detail, but I can guarantee that it's a better idea to declare and access providers rather than using singletons directly inside your codebase. And by the way, while we are talking about Riverpod, I want to point out that both in the custom profile screen and the custom sign-in screen, we are declaring this variable that contains the email auth provider. And this kind of code duplication is not good, because if we want to add another provider, we may forget to do it in both places. So what I suggest we do is to create a Riverpod provider to hold on to this list of auth providers. So let me open the Project Explorer, and inside this screens folder, I can create a new file called UI-auth-providers.dart. And then inside it, I can create a new provider, and I'm going to call this auth providers provider. And this is going to be a provider of type list of auth provider. And in order for this code to compile, we need to import provider from Flutter Riverpod and auth provider from Firebase UI auth, like this. And then inside here, I can return a list which contains an email auth provider, like this. And now that we have this, we can get back to our custom sign-in screen. And since this is already a consumer widget, which has a widget ref, then here we can replace this expression with ref.watch, passing the auth providers provider as an argument, and we need to import this. And then we can copy this line and get back to the custom profile screen, and we can paste it in here, replacing the old one, like this. The benefit of this approach is that we are now defining all the auth providers that we want to use in one place, and this makes our code more dry. And with this last change, our authentication flow is truly complete, and now our code is using Riverpod for dependency injection, rather than trying to access singletons directly. And overall, what is really remarkable is that we managed to get everything working with all this UI for free with just a few lines of code. So once again, the main takeaways from the last few lessons are that the Firebase UI packages make it super easy to add authentication flows to your apps. And you can use the go router, redirect, and refresh listenable arguments to make sure that you always show the correct screen depending on the current application state. Okay, so let's continue to the next lesson. With the Firebase UI packages, I want to spend a bit more time talking about Firebase authentication, because beyond the simple email and password signing method that we have just implemented, Firebase authentication offers a ton of extra features that come handy if you want to build enterprise-level applications. And the best place to start learning about these features is the official documentation that you can find on this page. So what you'll find here is a list with all the key capabilities, which includes the Firebase UI auth stuff that we have covered, along with all the supported authentication methods, which includes Google, signing with Apple, Facebook, and so on. And Firebase also supports phone number authentication, custom auth system integration, and anonymous auth. Not only that, but one of the latest additions to the Firebase platform is the new identity platform, which is an optional upgrade that gives you access to all these additional features. And if you want to learn how to integrate all these features into your Flutter app, you can head over to this Flutter section that includes a number of useful guides. And if you want to use Firebase authentication features inside Cloud Functions that run on the server, you can also learn about the Firebase Admin SDK, which covers all these additional topics. And one of the most interesting ones that we will explore is control access with custom claims, which will allow us to implement role-based authorization inside the e-commerce app we will build in the full course. So feel free to check the notes below, where I've shared more resources about Firebase authentication. And with this, we have completed our introduction to Firebase authentication, and we can move on to the next lesson, where we'll start talking about Cloud Firestore. How to authenticate users with Firebase, it's time to take a look at Cloud Firestore, which is a real-time NoSQL database that we can use to store data on the backend. And with Cloud Firestore, you can create, read, update, and delete data. And since Firestore is a real-time database, it's easy to keep the data in sync across multiple clients. And thanks to the Firestore Client SDK, we can also support caching and offline mode, which are very important concerns if we want our apps to be performant and reliable. So how does Cloud Firestore work in practice? Well, to find out, we can head over to the Firebase console, and then on the main page here we can select Cloud Firestore, and then we can go ahead and create a database. And now we need to choose if we want to start in production mode, which makes all the data private by default, or in test mode, which makes all the data open for 30 days. And for now, we are just poking around, and we can start in test mode, but we'll write proper security rules later. So let's go ahead and click on next. And then we need to choose the region where we want our data to be stored. And normally it's a good idea to choose the region that is closest to the majority of your users. And by opening this dropdown, we can see a list of all the regions that are available. For now, we are happy with the default region in the United States, so we can go ahead and enable Cloud Firestore. And as soon as this is done, we are taken to this page where we can start adding some data. So let's start by creating a new collection. And we could name this users, for example. And then inside it, we could create the first document. And note how each document has a document ID, which is a string that can be set manually. Or if we prefer, we can click on this button to auto-generate it, like this. And for each document, we can create one or more fields, each with a type and a value. For example, we could add an age, which would have type number with a value of 38. And we could add something like a job, which could be a string. And we could say manager here, for example. And maybe we could add a name as well, which could also be a string. And here I could put my name. And once we save, we can see that a users collection is created with this user ID inside it. And here we can find all the fields that we have created for this document. And at this stage, we could choose to add another field, for example. And aside from the usual primitive types, such as string, number, and boolean, We also have composite types such as array and map, along with other special types such as timestamp and geopoint. So let's cancel this. And once we have a document, we can also decide to add a sub-collection. For example, here we could create a nested collection called books. And inside it, we could add some documents. For example, here I could add a name and call this Atomic Habits. And then I could add a year published field, which could be a number. And in this case, I could write 2018, like that. And by doing all of this, we are essentially creating a hierarchical tree of data, where at the root, we always add 0 or more collections, and then each collection contains 0 or more documents, and each document contains 0 or more collections, and so on. And the main idea here is that we always have to alternate between collections and documents in this fashion. And if you're coming from a relational database background, there is one thing that you may find strange. And that is that in Cloud Firestore, there isn't a way to enforce a schema in your database. In other words, Cloud Firestore will let you put anything you want inside your documents. And there is nothing stopping you from having a book with a name and year published, like in this case, and then having another one, which has a title, and a serial number, for example. Like that. And this means that these two documents have completely different keys and values, even though they are siblings. And while there isn't any good reason to do this, Cloud Firestore will not stop you. And in practice, it's up to you as a developer to enforce consistency when writing data, rather than relying on a predefined database schema. So this covers the very basics about how to add documents and collections to Firestore. And in addition to what we have seen, it's also possible to add some filters by clicking on this icon. And these are very useful if you have a lot of documents and you want to find specific ones based on certain conditions, like this, for example. And if you want, you can also set a sort order, which can be ascending or descending. And in addition to all of this, we also have a query builder that we can use to select a number of different criteria, such as count, where, order by, and limit. And once we run the query, we get a result down here. And in addition to that, we also have some other options inside this Google Cloud dropdown, as well as an additional protection feature known as App Check. And at the top, we have these tabs, known as rules, indexes, and usage, which we will explore later. And if you remember, when we first created the database, we tried to set the rules in test mode. However, this doesn't seem to have worked because I can see this if false condition that disables reads and writes to all documents in this database. And this is the default setting for production mode. But as we said, for now we're just experimenting. So let's make sure that this condition is set to true and then hit publish, as this will allow us to read and write data without restriction. And we'll revisit this later. So as you can see, this dashboard UI contains a lot of nifty little features that make it easy to work with Cloud Firestore, and I recommend that you spend some time getting familiar with them. But for now, we just want to stay on track and figure out how to use Cloud Firestore inside our Flutter app. So let's do that in the next lesson. Time to start using Cloud Firestore in our Flutter app. So the first step is to open up the command palette, and here we can choose this option to add a dependency, and we can enter Cloud Firestore like this. And this will add Cloud Firestore and install it as a package. And once this is done, we can open the pubspec.yaml file. And as you can see, Cloud Firestore has been installed here. And I suggest that we remove this caret to ensure that we run exactly on this version. And once we have done that, we want to make sure that we can run the app on iOS and Android. So let's start by selecting the Android emulator, and then we can go ahead and run the app. And at this stage, the app should build and run correctly, as long as we have remembered to update the min SDK version with a version of 21 or above in the build.gradle file, which is something that we have done in the previous lessons. And once the build has completed, you should be able to see the app running on the Android emulator. And now let's check that we can run on iOS as well. And of course, keep in mind that if you are running on Windows, then you can't build Flutter apps for iOS, and you can skip to the next lesson. But assuming that you are running on macOS, just like me, you can carry on and select an iOS simulator. And before we run, I want to point out that it's a good idea to open the iOS folder. And inside here, we should find this file called podfile. And what we want to do is to go at the top and uncomment this line, that will set the platform to iOS 11. And at this stage, we could try to go ahead and run the app. And what this will do is to compile the native Cloud Firestore SDK for iOS, which is a very time-consuming task, and it will make your build very slow. And by very slow, I mean over 10 minutes on the average machine. And to work around this and make our builds faster, I published this article on my website, which explains how to speed up our Xcode builds by using a precompiled version of the Firestore SDK for iOS. So if you want to improve the speed of your iOS builds, you can go ahead and grab this line from my article, and then you can get back to the pod file, and then you have to scroll down and locate this target runner section, and here you can paste this line, and here you want to change the tag to a version of 10.9.0. And this tag represents the version of the Firestore iOS SDK that corresponds to the Cloud Firestore version that we have installed in the pubspec.yaml file, which in this case is 4.7.1. And the bottom line of all of this is that by using the precompiled Firestore SDK, you should manage to get the Flutter app running on the iOS simulator without having to wait for a very long time. And by the way, I want to mention that the Firebase SDKs are supported on Android, iOS, macOS, and web, but not yet on Windows and Linux. So keep in mind that if you want to use Firebase on Windows or Linux, you are out of luck, and you'll have to choose a completely different backend altogether. Okay, so let's continue on the next lesson. In this lesson, I'm going to give you an overview of what we will build next, which is a new page that we will use to show a list of jobs, such as these ones that you can see on the completed app. And the main idea here is that I thought it would be fun to use the Faker package to generate some fake data, such as a list of job titles and company names, that you could use to write a fake resume. In fact, the Faker package is something that can be very useful, especially if you are in the early stages of app development and you want to show some fake data in the UI. And the most important thing here is that we want to use Cloud Firestore as the source of data that we see in the app. So the idea here is that every time we press on the plus button, then a new item is added to the list, and this corresponds to a new document in Cloud Firestore. And by reading this jobs collection inside the app, we can retrieve all the jobs and show them in the UI. And we can also click on an existing job to update it with new data. And of course, we should also be able to delete jobs. And the completed app will make this possible by using a swipe to delete gesture, like this. And as you can see, as soon as we delete an item, then the corresponding document is also deleted in Firestore. In fact, what I just shown you is a simple example of a CRUD application, because we can use this UI to create, read, update, and delete items. So our goal for the next few lessons is to create this UI and learn about Cloud Firestore along the way. And as part of this, we will also learn about data serialization and how to use type-safe model classes, as well as how to run queries and filter the data that comes from Firestore. And we'll also cover data modeling and security rules, and I'll show you some issues that you may run into if you model your data incorrectly. And after that, we'll talk about working with timestamps, sorting data, and offline mode. And along the way, we'll learn about the Firebase UI for Firestore package. That gives us some useful widgets such as Firestore List View and Firestore Query Builder that we can use to more easily show this data and handle things like pagination. So as you can see, even though this app is quite simple, we can learn a lot of interesting things along the way. So let's continue on the next lesson where we'll start implementing this page. Now that we have seen what the completed app looks like, let's get back to VS Code and see how we can add a new homepage that will contain this list of jobs. And one thing that I'd like to point out is that I've already included a home screen widget in the starter project. And this returns just a simple scaffold with an app bar and a button that we can use to navigate to the profile page. So the main idea here is that we can go back to the app router file, and what we want to do is to add the home page as a new route. And to do that, we can add a new home value to this app route enum, and this home page will become the parent route of the profile page, such that as soon as we sign in, we end up directly on the home page. And from here, we can open the profile page like this if we wish. And in order to make this happen, we need to go to the definition of these routes. And what I suggest we do is that we copy all these lines that define the profile route, and then we paste them in here. And this time we're going to change the path to home, and we can also change the name to approute.home.name. And here, rather than returning the custom profile screen, we should return the home screen, which is a widget that we need to import, like this. And what we said before is that we want the profile page to become a subroute of the home page. And to accomplish this, we can add a routes argument over here. And then we can take all these lines and then we can move them inside the routes argument like this. And by the way, let me return back to the app that we are currently working on, since we'll be testing this shortly. Okay, so now that we moved this profile route inside the home route, we need to keep in mind that this is no longer a top level route, and GoRouter will shout at us if this path starts with a leading slash. So we had to make sure that we remove it like this. And now that we updated the definition of the routes, we should update the redirect logic as well. So let's go over here and make sure that we redirect to the home page if we are logged in and we try to go to the sign-in screen. And we should also update this condition, because when we are not logged in, we should go to the sign-in page if we attempt to go to the profile page or the home page. And we could do this by updating this condition to if state.location is /home or state.location is /home/profile, since the profile is now a subroute of the homepage. And actually, I think that a more future-proof way of doing this is to merge these two conditions into one. And we can do that by typing if state.location.starts with /home, like this, since this will ensure that the redirection happens for all routes that start with home if we are not logged in. Okay, so we are now done with the GoRouter changes. And at this stage, we can hot restart and test if everything is correct. So let's go ahead and try to sign in with email and password. And as we can see, as soon as we do this, we land on the home page. And from here, we can click on this icon, which takes us to the profile page. And from here, we can sign out and get back to the sign-in page. So as you can see, everything seems to work as intended. And if you get any errors at this stage, then make sure that all these hard-coded strings are correct and look exactly like this, both on the routes definition and on the redirect logic as well. Okay, so let's continue on the next lesson where we'll start working with Cloud Firestore. We are now ready to start working with Cloud Firestore. And one of the first things that we'll need to figure out is what code to write in order to read and write data with Firestore. Not only that, but we should also figure out where that code should live so that we have a good separation of concerns between the data and the UI. And what I suggest we do is to put all the Firestore specific logic inside a repository. If you are not familiar with the repository pattern, I highly recommend that you read my article about this topic. And what this shows is that all the widgets belong to the presentation layer, while the repositories belong to the data layer. And if we follow this architecture, we need to make sure that the UI code and the data code is separate. So let's get back to VS Code. And what we are going to do at this stage is to select this data folder. And then inside it, we're going to create a new file called Firestore repository.dart. And then inside it, we can create a class Firestore repository that will contain all the code for reading and writing data with Firestore. And since we'll need to use Firestore inside this class, we can declare a final Firestore variable equal to Firebase Firestore.instance. And if we want to use this, we need to import it from Cloud Firestore. And if you recall, in the previous lessons, we said that it's not a great idea to use singletons like this. So what I suggest we do instead is to remove this assignment and add the correct type to this variable. And what we want to do is to select this option to create a constructor so that we can pass the Firestore object as an argument when we create an instance of this class. And while I'm here, I'm also going to create a provider, and I'm going to call this Firestore repository provider, which will be a provider of type Firestore repository. And in order to use this, I want to import Flutter Firebase, and then inside the provider, I want to return a Firestore repository passing Firebase Firestore.instance as an argument, like this. And now we can start writing the methods that will represent our CRUD operations. So let's start by creating a method that returns a feature of type void, and we can call this add job. And this method will take 3 arguments. The first one will be a string UID, the second one will be a string title, and the third one will be a string company, like this. And as you can see, I've declared these as positional arguments because it's quicker. But keep in mind that to make it easier to call this method correctly, they should probably be named arguments. So what do these arguments represent? Well, the UID is the so-called user identifier for the currently signed in user. And this is something that we could access directly by typing Firebase auth, which we would have to import. And then we could type .instance.currentUser ref.uid, like this. But keep in mind that we don't want this repository to have an explicit dependency to the Firebase auth object. So by passing a UID as an argument instead, we can keep our code more modular. So let's remove this code for now, and we'll take care of passing the correct arguments to this method in the next lesson. But for now, let's stay on track. And if you remember, when we talked about authentication, we have seen that every time we create a new user account, then that user will get a UID. And when we work with Cloud Firestore, we can use this UID to store data that is user specific. And this is exactly what we want in this case, because each user should have his or her own list of jobs. So how can we represent this data in Firestore? Well, earlier on, we said that we can store data using collections and documents. So as a first attempt, we could create a top-level jobs collection like this. And we could generate an ID for each new document. And then inside it, we could store the UID along with a title and a company like this. And then we could go ahead and create this document. And these three fields that we can see inside this document would be the three arguments that we are passing to this method. So just like we can create a document like this inside the console, in the Flutter client, we could implement this method to write a new document using Firestore. And the way to do that is to use this Firestore object. And then we can type .collection, passing a hard-coded jobs string as an argument. And as we can see, this will give us a collection reference to this top-level jobs collection. And we can use this reference to call the add method. And as we can see, this is used to return a document reference with an auto-generated ID. And to this method, we need to pass a map of key-value pairs using the UID, the title, and the company arguments that we have provided. And if we choose to store the data like this, what will happen is that we would have a single top-level collection that will store the jobs not just for the current user, but all the users in the app. And the only way to tell which jobs belong to which users would be to check the UID field, which will be stored inside the document itself. And as we will see later on, this approach will cause some problems when we need to access and secure this data. But for now, just know that this is an intentional mistake that I'm making when structuring this data. But we are not going to fix this now, because this will be a great opportunity to explore data modeling and security rules in the coming lessons. But for now, I just want to show you how we can write some basic data into Firestore. So let's stay on track. And what we said earlier on is that this method returns a document reference inside a future. And this means that over here we can add an await along with an async over here as well. And then we can assign the result of this expression to a final docref object. And once we have a document reference, we can use the dot notation to inspect all its properties and methods. And we'll take a look at these later. But for now, we just want to add a debug print statement that we can use to print the docref.id like this. And to use this, we need to import foundation.dart. Okay, so this wraps up our first practical lesson about Cloud Firestore. And what we have learned so far is that it's a good idea to put all the Firestore code inside a repository class, so that we don't leak any implementation details of the data layer into other parts of the codebase. And we have seen how to work with collection and document references, as well as how to add a new document as a map of key value pairs, and also print its ID once the data has been written. So let's continue on the next lesson, where we'll see how to call this method when we press on this button in the UI. With this simple method to write a document to Firestore, we need to hook it up to the floating action button in our UI, and this will allow us to see if the code works correctly. So let's get back to the home screen, and over here we can remove this print statement inside the floating action button callback, and instead we can access our Firestore repository by calling ref.read Firestore repository provider, which we need to import like this, and then we can use this to call the addJob method. And this is a good time to figure out what arguments we need to pass. And as I said before, the UID is a property that we could get directly from the current user. And we can get the user by calling ref.read with Firebase auth provider .current user like this. And then we could pass user bang.uid as an argument. And by the way, note how here I've used the assertion operator, because we are inside the home screen, and it's only ever possible for us to be on this page if the user is signed in. Because if the user is not signed in, then GoRouter would have redirected us to the sign-in page. But of course, this is only something that can be known at runtime, and there is no way for Dart to know this at compile time. So this is a situation where we know more than Dart about the runtime behavior of our app, and so it's okay to use the assertion operator. Okay, so let's go ahead and add the two remaining arguments, which are the title and the company. And for now, we can just pass two hard-coded values, such as Chief Flutter Hacker and Remote Async Working Limited. And now we have everything that we need to test our code. So let's save and hot reload, and we can open the console as well. And then we can try to press on the plus button. And as we can see over here, we get a console log with the new job ID, which is something that we are printing inside this method inside our repository. And if we hop over to the Firebase console, we should see that this document has been added over here. And if we press on the button again, we can see that a new document has been added. And if we take a look at this document, we can see that they all have the same UID, title, and company. And we can also delete this old document that we created earlier on. And we can also double check that the UID that we see over here is the same UID that is stored on the authentication page. And at this stage, we could sign out and sign back in with a second account and add some more jobs. And what we will find is that the jobs collection will contain some documents with the UID of the second account. So keep in mind that whenever you need to store some user-specific data in Firestore, you should always do so using the UID of the current user. And you can obtain this from the current user property of the Firebase auth class. And before we continue, I think it would be nice if we could find a way to generate some random values for the title and company name every time we create a new document. And the easiest way to do that is to use a package called Faker, which is great when you want to generate fake data. So let's go ahead and use the command palette to add a new dependency called Faker. And once this is installed, then we can start to use it. And over here, we can create a new final Faker object equal to a new Faker instance, which we need to import from faker.dart. And once we have this, we can use it to generate all sorts of things like addresses, animals, colors, companies, and all these different types of things. And in this specific case, we can use it to generate a final title equal to faker.job.title. And we can do the same thing to generate a fake company. And once we have these new variables, we can set them over here and use them when we create a new job, like that. And then we can save and hot reload. And if we get back to the Firestore console, we can try to add a new job. And if we look at the document that has just been added, we can see that it now has some random company and title. Okay, so this is good progress. And before we continue, I want to mention one thing. And that is that at the moment, this onPressed callback contains some business logic for getting the current user and generating some random values. And we're also calling this repository method directly from the widget code. And if you care about writing maintainable and testable code, then it would be good to move all this logic into a separate class. And if you choose to follow my app architecture, then you can use so-called controller classes to do that. And I have several articles on my site about this, which you can find in the notes below. But for now, let's not worry about that. And we can continue on the next lesson, where we'll see how to read these data back out of Firestore and show it inside a list. In this lesson, we're going to see how we can easily show all this Firestore data inside our app. And we'll do this using a widget called Firestore List View that comes from the Firebase UI Firestore package. And for now, we just want to show something in the UI, and we'll do this by reading all these documents and showing the title and company name in the UI by reading these key value pairs directly, without worrying about data conversion and serialization. And in the next lesson, we'll revisit our code and deal with data serialization, so that we can convert the raw documents data from Firestore to type-safe model classes that can be used in the UI. Okay, so let's get started. And as a first step, we can use the command palette to add the Firebase UI Firestore package, which will give us some useful widgets that make it easier to work with Cloud Firestore. And once this is done, we should see that the package has been installed in a pubspec.yaml file. And after we have done this, we can get back to our home screen. And what we want to do here is to show a list view inside the body of this scaffold. But rather than adding all the list view code in here, I think it would be best to write a dedicated widget class for this. So let me go ahead and undo this change. Then we can scroll to the bottom. And over here, we can add a new stateless consumer using the rearpod snippets extension, like this. And we could call this class jobs list view. And then inside the build method, we can return a Firestore list view widget, which we need to import from Firebase UI Firestore. And as we can see, this is a widget that takes many different arguments. And if we use the quick fix option, we can see that at the very minimum, we need to give it an item builder and a query. So let's go ahead and add a query argument. And if we hover over the query argument, we find an example with full source code explaining how this works. And as we can see, this example works by declaring a movie class with these two properties, along with from.json and toJSON methods. And this class is then used by the code that declares this movie collection variable, which is used to fetch movies data from a Firestore collection. And this movies collection is then passed as a query argument to the Firestore list view, which also specifies this item builder. So let's go ahead and do something similar in our project. And the first thing we're going to do is to get back to our Firestore repository. And over here, we could add a method called jobsQuery. And we could use this to return firestore.collection, passing jobs as an argument, because this is the name of the collection that we are adding jobs to. And as we can see, this collection returns a collection reference of type map with string and dynamic as key value pairs. So if we wanted, we could copy this return type and use it as the return type of our method, like this. And what I'd like to do at this stage is to open the definition of this class. And as we can see, it is an abstract class that implements the query T type. And this means that if we want, rather than returning a collection reference, here we can return a query directly, like this. So as it stands, this method will return a query with the raw data from Firestore as a map of key value pairs. And as we will see in the next lesson, we should really convert this map into a type-safe model class. But for now, let's go ahead and save this file, and then we can get back to our home screen. And then at the top of the build method, we can declare a final Firestore repository equal to ref.watch Firestore repository provider. And now that we have this, we can pass Firestore repository.jobs query as an argument. And now we have one thing left to do, and that is to add an item builder argument. So let's go ahead and use the quick fix to add this. And I'm also going to save, so my code gets formatted a bit better. And as we can see, this builder gives us a build context and a query document snapshot variable, which we can import from Cloud Firestore. And now we need to return something inside this builder. So let's go ahead and return a list tile widget, which takes a title argument, which will show the job title. And we can also pass a subtitle, which will be a text that shows the job company, like this. And once we have done this, we can save and hot reload. And at the moment, it looks like nothing is showing on this page just yet. And can you guess why that is? Well, the issue here is that we have declared this jobs list view widget, but we are not using it yet. So if we scroll up, we can find the parent scaffold. And here we need to remember to add a body, passing our job lists view as an argument, like this. And now we can save and hot reload once again, and voila! We now see a list of items in the app. And if we press the plus icon, then a new item is added right away. And that's because the Firestore list view will automatically update and call the item builder when anything inside the jobs collection changes. In fact, if we want, we can get back to the console and try to add one more document. And as we can see, this is added both in Firestore and in the UI right away. And this is pretty cool, because we've been able to show this list of items with the data from Firestore with very little work thanks to the Firestore list view widget. But as I was saying earlier on, it's really not a good idea that we are using a map of key value pairs here, because this code is very brittle. And if we make a mistake here, such as using a capital T, and then we save and hot reload, then the code blows up immediately, because there isn't a title field with a capital T. So let's continue in the next video, where we are going to add type safety to our code. In this lesson, we have figured out how to read the documents data from Firestore and showing them inside the app. And now it's a good time to revisit some of the code that we have added in the previous lesson and get rid of these hard-coded values in the UI. And the best way to do this is to get back to our Firestore repository And what we want to do here is to replace this map of key value pairs with a type safe model class as soon as we get the data from Firestore. And for this purpose, I've created this job class that you can find on this file. And as you can see, this already comes with all the properties that we need, along with some handy fromMap and toMap methods. So let's go ahead and try to use this in our Firestore repository. And we can do this by changing the return type of this method from query of map to query of job, like this. And in order to use this, we need to import it from this file. But as you can see, we now get a compiler error, because this Firestore method will return a collection reference with a map of key value pairs. But this return type is now using the job class. And to address this, we need to use a so-called converter, which we can use by typing dot with converter, like this. So let me just format this code, and then we need to provide some values for these arguments. So let's remove this. And here I can specify a closure, which gives us a snapshot, and also an options object that we are not going to need. And we can use this to return job.fromMap, passing snapshot.data with an exclamation mark at the end, because this method is nullable. And then we can focus on the second argument. And this is also a closure that gives us a job snapshot along with some options. And we can use this to return job.toMap, like this. And the important thing to point out is that this method still returns a collection reference, but this time it's using the generic type R, which in our case is the job class, which is the same as the one we use in the return type for this method. And this means that we can save this file and get back to our home screen. And as we can see, here we get an error telling us that Dart couldn't infer the type parameter. And in fact, here we should make it explicit that this Firestore list view should work with objects of type job, like this, since this will give us some additional type safety guarantees. But as we can see, we still get an error, telling us that the argument type query job, defined inside our job model class, can't be assigned to the parameter query job, where job is defined inside the faker package. So as it turns out, the issue here is that the faker package also defines a job class. And to help Dart disambiguate between the two, we should go all the way to the top of the file. And here we can use a hide directive to tell Dart that we don't want to import the job class definition from the faker package. And then we can save our file and get back down to the build method. And now we can select this job type from here and make sure that we import it from the correct file, which is this one. So just keep in mind that if you ever end up with a type that is defined in two different files, you need to use the hide keyword to tell Dart which one you really intend to use. And now that we've made this change, we need to be careful because this document object no longer contains a map of key value pairs, but instead it is now a query document snapshot of type job, like this. So let's make sure that we are using the correct type here and here. And what we would expect at this point is that this code no longer compiles, because we shouldn't be able to read properties from this snapshot using square brackets like this. And I think this is a scenario where the Dart type system is not as tight as it should be, because this syntax should not be allowed. In fact, what I didn't highlight in the previous lesson is that this is a query document snapshot. And the correct way of reading data from a query document snapshot is to declare a final job equal to doc.data, like this. And now that we have this variable, we can go ahead and replace this syntax with job.title and this one with job.company, like this. And this is great because we can now be certain that these text widgets will receive a non-null string. And in fact, we should be able to save and hot reload and see that our code still works as intended. In summary, the main takeaway from this lesson is that you should always define your own types and use them to convert any raw data that comes from the network, like we have done in this case using a converter. And one additional benefit of defining your own model classes is that you can add your own data validation inside these methods. And this can be quite handy, especially when you use NoSQL databases such as Cloud Firestore, which does not enforce any schema at the database level. And indeed, we will talk a bit more about data validation later on. And by the way, I'd also like to mention that if you have complex data models with many properties, you don't have to write all the serialization code by hand. And instead, you can use packages such as freeze And what's great about Freest is that it lets you specify all the properties that you need, and then it generates all the required methods for you using code generation. And I should also mention that there is an experimental Cloud Firestore ODM package for Flutter, which can be used to further streamline the definition of your application-specific collection and documents type when you use Cloud Firestore. Though keep in mind that this package is still in beta and is not very well documented yet, so we won't be using it for now. Okay, so let's continue on the next lesson where we'll add support for update and delete operations on this page. That's how to create documents and read them back using Firestore. We could also look at update and delete operations. But which user gestures should we use to support this? Well, if I show you the completed app, you can see that I've decided to use the list style on top event to update the current document by generating a new title and company name. And when it comes to deleting items, we can use a swipe to delete gesture using the dismissible widget. So let's get back to our app, and then in VS Code, we can get back to the home screen and locate our Firestore list view. And inside this list style widget, we can go ahead and add an on top event like this. And to make our life easier, we could scroll all the way up to our floating action button. And here we could copy all these lines. And then we could paste them in here like this. But in this case, if an item is pressed like this, we don't want to add a new job, but rather we should update the existing one. And in order to support that, we need to add a new method to our Firestore repository class. And while we are here, we can clean up this method a little bit by removing this print statement. And here we can remove all this code as well and just use the arrow operator like this, since we only need to execute one statement. And then we can copy this entire method and paste it over here. And then we can change this name to update job like this. And in order to update a job, we need to pass a string job ID as an argument so that we can point to the correct document in Cloud Firestore. And over here, rather than adding a new document to this collection, what we want to do is to access the document itself, which is located at jobs/job ID using string interpolation like this. And as we can see, Dart shouts at us because we can't add that document to a document reference. Instead, what we should do here is to call update, passing the same key and value arguments as we did before. And now that we have done this, we can save this file and get back to the home screen. And here we can call the update job method. And here we need to remember to pass the job ID. But as we can see, the job ID is not a property of the job class itself. And instead, we can get it from this document snapshot that is returned by the item builder. In other words, what we can do here is to type doc.id like this. And now we can save and hot reload. And as we can see, as soon as we click on an item, some new fake data is generated and written to Cloud Firestore. And we can verify that this data is updated in the console as well, like this. And this all works because when we use the Firestore list view widget, then the item builder will automatically rebuild when any of the data changes. And this is because Cloud Firestore is a real-time database. And this makes it very easy to write reactive applications that automatically update their UI when the data changes. And we'll talk more about the benefits of using real-time data later on. But for now, let's go ahead and add support for deletes as well. And this is very easy to do because we can just wrap this list style widget with a dismissible widget like this. And this widget requires a key, which is absolutely essential if we want the list view to sync correctly with the data from the database. And the simplest way to do this is to pass a key object using the document.id as an argument like this. And this way, Flutter will know how to correctly update the widget tree when list items are deleted. And then we can customize the appearance and behavior of this widget by adding a background, which could be a colored box with a red color. And we can also specify a direction, which is normally set to dismiss direction.end to start, so that we can only dismiss by swiping from right to left. And finally, we need to add an onDismissed callback that we can use to decide what to do when the item is dismissed, like this. And we're going to use this callback to call a method in our repository that we can use to delete an item. And to do that, we should first get the user, like we have done before, from the Firebase auto repository.currentUser, and then we can call ref.read with Firestore repository provider. And then we are going to call a method called deleteJob, which will take the user.uid as an argument, along with the ID of the document that we want to delete. And of course, this deleteJob method is not defined yet. So let's get back to our Firestore repository. And over here, we can define a method that returns a feature of type void, and we can call this delete job. And this will take a string UID along with a string job ID. And we can use the arrow notation to return firestore.collection, passing jobs as an argument. And then here we can type .doc, passing the job ID as an argument. And then we can call the delete method, which is what we need to delete the current document from the collection. And by the way, one thing that I'd like to point out is that here I've used this syntax to obtain a reference to this job for the given ID. But in the method above, I've used this syntax instead. In fact, these are two different ways of pointing to the same path in Firestore. And they are both perfectly valid as long as you use the correct syntax. And in general, I prefer to use this shorter syntax, especially when I have many nested documents and collections. But it's up to you to choose whichever one you prefer, as long as you remember that documents and collections always alternate in this fashion. So let me go ahead and use the same syntax in both methods for consistency, like this. And now that we've made this change, we can save this file and we can get back to the home screen. And as we can see, this syntax is now valid as well, because we are passing the UID and the job ID as expected. So let's save this file as well and hot reload. And then we can get back to the Firestore console over here. And if we pay attention to this document that is currently selected, we should be able to swipe to delete it from the app and see that this disappears from the console as well. Okay, so this completes the implementation for all of the 4 CRUD operations, since we can now create, read, update, and delete jobs with Firestore. And the fact that we've been able to do all of this in less than 30 lines of code inside the Firestore repository class is quite remarkable, and shows us that the Firestore APIs are very well designed. And I know that I've said this before, but I want to stress again the importance of having a separate repository class that abstracts away all the data access logic, so that we don't have to deal with networking code and access raw data directly inside our widget. And just to be clear, the code inside our home screen is still far from perfect, and it would be best to move all this logic inside separate classes so that our callbacks become even more tight. But for the time being, this is good enough, as we are just building a small demo app. Okay, so let's continue on the next lesson, where we are going to talk about security rules. In the last few lessons, we have managed to add all the CRUD operations to our Firestore repository and wire them up to our UI. However, so far we have ignored one fundamental problem with the way we have structured our data. And that is that as it stands, this jobs collection contains all the jobs that were created by all users. But is this what we want? Well, if we were building a public chat room where users can see the messages from everyone else, then a top-level collection may make sense. But in this case, users should only see their own private jobs. In other words, we don't really want Alice and Bob to see all their jobs mixed up together. In fact, earlier on, I said that I made an intentional mistake in the way I've structured this data, and now we are in a perfect spot to highlight why this was a mistake. And as a proof of this, we can go ahead and sign out, and then we can click on register to create a new account. And this time I'm going to type in test2@test.com, and then I'm going to choose a password, like that. And as we can see, as soon as we get to the homepage, we can see the full list of jobs that were created with the other user account. And just to make this completely obvious, here we could choose to show the job.uid on the subtitle. And then we can save and hot reload. And as we can see, all these 5 jobs have the same UID. But as soon as we add more items, we can see that jobs from different users get mixed up. And this is definitely not what we want. So how can we make sure that users only see their own jobs? Well, one thing that we could do is to open the Firestore repository, and then we could scroll down to the jobs query method. And over here at the end, we could call the where method, which is useful if we want to filter out some documents. So in this case, we could write where UID as a string literal, and then we need to pass a second argument. And here we can start writing is. And as you can see, here we get a number of different comparison operations. And in this case, we could choose to use is equal to, and then we could pass a UID argument like this. And then we could pass this UID as a string argument to this method, like we have done with all the other methods. And with this change, we could get back to our widget. And as we can see, we now need to pass a UID to the jobs query method. So what we can do, just like we've done before, is to copy this line and paste it over here at the top. And since here we are inside the body of the build method, we should call ref.watch like this. And now that we have this user, we can pass user bank UID as an argument like this. And if we save and hot reload now, we can see that only the jobs that have been created by the current user are visible. So this seems to fix the problem that we were talking about. However, I need to tell you that this is only a workaround that doesn't take into account one important thing. And that is that even though we can filter the jobs by user ID, the way we are storing this data is still fundamentally insecure. And if we really want to make this user data private, then we have to do so using security rules. So let's continue on the next lesson. In this lesson, we're going to talk about security rules, which is a topic that you absolutely must understand when working with Cloud Firestore. Because if you get this wrong, you're leaving an open door for attackers to tamper with the data in your database. And this is a great time to talk about security rules, because we are finally going to explain why storing all the user data into a top-level collection was a mistake. And just to be clear, for now we'll take a look at the basics, and in the rest of the course we'll learn about security rules more in detail. Okay, so let's get back to our console, and over here at the top we can open the Rules tab. And as you can see, here we have an editor that we can use to define all the rules for who can access what data on the database. And the way to write security rules is to use match statements that will apply to certain documents or collections at a given location. And what we see here is a match statement with a so-called recursive wildcard, which applies to all the documents in the entire database. And here we have this allow rule to decide which operations are allowed and under what conditions. So what kind of rules can we write? Well, we can make the data always available to everyone by setting this condition to if true, like we have done over here. Or we could make it available to no one by changing this to if false, like that. But these conditions are quite broad and not really specific enough for our use case. And since we already know that we are writing data to the jobs collection, we could target documents in that collection specifically by writing match /jobs/job like this. But what if we wanted only signed-in users to be able to access this data? Well, to do that, we could change this condition to if request, and then we can press dot. And this shows us a number of different properties that we can use in this condition. So in this case, we want to choose request.auth, and then we can type .uid not equal to null, like this. So this is already an improvement, but it's not quite enough. Because what we really want is for users to only be able to access their own data. And we can do that by updating the right-hand side of this condition by using the equality operator. And then we can type request.resource.data. And by using this syntax, we can access the fields that we have stored inside the document itself. And just as a reminder, each job that we have added to this collection contains the UID, title, and company fields. And this means that inside the rules, we can use resource.data.uid to update this condition. And the way this rule works is that we can only read and write documents inside the jobs collection that have a UID that matches the UID of the authenticated user. So let's go ahead and save this rule. And as you can see, we get a banner telling us that the published changes can take a bit of time to propagate. And if we get back to our Flutter app, we can see that nothing seems to change. However, I think it would be a good idea to show some kind of error if we can't read the data because we don't have the right permissions. And to do that, we can get back to the home screen, and then inside the Firestore list view, we should add an error builder argument, which is a closure that gives us a context, an error, and a stack trace. And we should use this to return a center widget, passing a text widget as a child, which will take the error.toString as an argument, like this. And now that we have made this change, we should be able to save and hot reload. And now that we have done this, we can see that we get an error telling us that we don't have the permission to execute the specified operation. And to understand why this happens, we can get back to the Firestore repository, which defines the jobs query method that we use to read the data from the jobs collection. And as we can see over here, we are trying to filter only the documents that match the UID of the authenticated user. But the problem is that Firestore still has to process all the documents inside this collection before returning the filtered results. And this is now forbidden by the security rules, because now we have only read and write access to the documents that match the user UID. And now we can finally address the elephant in the room, because we have made it all this way to this point with a fundamental error in the way we structured our data. And the problem is that we shouldn't really have a top-level jobs collection that contains user-specific data. And instead, what we should have done from the start is to create a users collection where each document identifies a specific user by UID. And for each of these documents, we should have added a sub-collection containing the jobs for that user. So let's go ahead and change the implementation of our Firestore repository to reflect this. And this means that we can modify the add job method to access a collection located at users/$UID/jobs, using the same shorthand syntax that we have used over here, where we have explicitly referenced a document inside a collection. And one important thing to notice is that since the UID is now part of the path, we no longer need to store it as a key value pair, so we can remove it from here. And later on, we will remove it as a property from the job model class as well. But for now, let's update the remaining methods. And over here, we want to update this method by using this prefix so that we access the document at users/UID/jobs/jobid. And we should use this to update the title and company, but we no longer need to specify the UID. And then we can copy this location and paste it inside here, because this is now the document that we want to delete. And finally, we can update this jobs query method to get the data from the jobs subcollection. And we can do that by copying this location and pasting it in here. And now we can remove this where clause, since this collection will only contain the jobs for the current user. So this completes the implementation of the repository class, and we can save this file. And in addition to this, we should also open the job class. And here we should remove this UID property, since we are no longer storing it as a key value pair, and we don't really need to show it in the UI anyway. So let's make sure that we remove it from here, and here, and here, and here from the list of props, like this. And finally, we can get back to the UI inside the home screen. And here we can remember to show the job.company inside the list style subtitle, like this. And now there is only one step left to do. And can you guess what that is? Well, of course, we need to update the security rules because the old ones apply to a collection that we are no longer using. And the correct way to fix this is to update this match statement so that it applies to /users/ and then we can type UID inside curly braces, /jobs, / and I think here it will be best to rename this to job ID inside curly braces, like this. And then we just need to update this condition to say that we are allowed to read and write if request.auth.uid is equal to the UID that we have specified over here. And we should be able to publish the updated rules. And at this stage, we should be able to go ahead and hot restart. And as we can see, the old error message disappears and we are left with an empty list because currently there is no data inside the new subcollection that we have created. In fact, we should probably go back to our Firestore list view. And over here, we could add an empty builder argument, which is a closure that gives us a context. And we can use this to return a center widget with a text widget inside it that says no data, like this. And then we can save and hot reload one more time. And we should see that this text appears in the middle of the screen. And finally, we should get back to our console and open the data tab and go inside the users collection, which at the moment only contains some example data. And just to make sure that everything works, I want to completely delete this collection, which I can do like this. And now we can get back to the Flutter app and press on the plus button. And as we can see, a new item appears over here. And it seems that this is not showing in Firestore just yet. So let's refresh this page. And this is something that sometimes is necessary. And as we can see, now we have a users collection, which contains the UID of the current user. And this contains a sub-collection called jobs inside it. And this is where we can find all the jobs of the current user. And we can see that the title and company name is matching with this one. And if we want, we can create some more jobs and see that they get added to Firestore, or we can update existing one and delete them as well. And as we can see, the data always remains in sync with the data in Cloud Firestore. And what's really important is that we can now do all of this securely, because with this updated structure, we are only accessing the jobs that are private for the current user. And we can enforce this with the security rules that we have configured over here. Okay, so this is great progress. And since we no longer need this jobs collection, we can delete it manually like this. In summary, we have now seen that security rules play an essential role in keeping your users' data safe. And in general, when you design your collections and documents, you should take into account what kind of queries you want to run with your data, what security rules will need to be in place, and how many reads and writes you'll expect to make. And by taking all these factors into account, you can make a more informed decision about how to structure your data. And just so you know, security rules are a broad topic, and I highly recommend that you spend some time reading all the pages in the docs, so that you can learn all the things that you can do with security rules and what syntax to use. And in any case, this was just an introduction, and we'll look at security rules and data modeling much more in depth in the rest of the course. Okay, so let's continue on the next lesson. We'll look about how to work with timestamps and how to do sorting when we read data from Firestore. In fact, one of the problems of the current app is that when we add a new item, we don't really know in what position it will show up on the list. And it would be better if we could sort items in some kind of chronological order. But how can we do that? Well, the main idea is that we could write a created@timestamp as an additional key value pair when we add new documents to this collection. And then we could use that timestamp to sort the data inside our jobs query. So let me show you how to do this. And the idea here is that when we add a document, we can add a created@key using a special value called fieldValue.serverTimestamp. And just so you know, this is a technique that I've explained in my list of Flutter tips on GitHub. And you can find a link to this in the notes below. And by the way, I think it would be useful to not only write a timestamp over here, but also to show it in the UI. And this is only possible if we add the timestamp as a property to the job class. And the way we can implement this is by adding a final datetime object, which will be optional. And of course, we should add this as a constructor argument, like this. And then inside the from map factory constructor, we can extract the created@value from the map, like this. And then we can use it when returning this job object. And over here, we could check if the created@value is not equal to null. And we can use the ternary operator so that we can return created@, which we should cast as a timestamp, which is a type that we need to import from Cloud Firestore. And since we declared this property to be a datetime, over here we had to cast this to a date, like this. On the other hand, if created@ is null, then we can just return null, like this. And by the way, I'm also going to add a comment to a Stack Overflow thread that explains this technique more in detail. So this is how we parse the created@timestamp when creating a job object. But we also need to make sure that we write it back to Firestore. And we can do this using a collection if operator by checking if the created@ property is not null. And in that case, we can add a created@key value pair, passing timestamp.fromDate with created@ using the assertion operator as an argument. And finally, we can also add this created@ to this list of props, which will be used by the equatable package to generate the equality and toString methods. And even though all this code looks a bit complicated, there is nothing special to it. And the main idea is that this field is stored as a timestamp in Firestore, but it's more convenient for us to use it as a datetime object in the UI. And all this code does is to convert it from a timestamp to a datetime and vice versa. And by the way, I will explain a bit later why I've chosen to make this a nullable property. But for now, let's stay on track and we can head over to the home screen file, where we can locate our Firestore list view. And if we scroll down, we can find this list style, which we show over here. And what I'd like to do here is to add a trailing argument. And here I'm going to use the ternary operator to pass a text object with the created@value converted to a string. And I'm also going to specify a style of theme_of_context.texttheme.bodysmall. But if the created@ property is null, then I'm just going to use null, like this. And at this stage, we could save and hot reload. And we should see that nothing changes, because all the data that we had inserted before didn't have a timestamp. But now we should be able to click on the plus button. And as you can see, a new item is added and the timestamp appears on the right. And one small detail to notice is that when we add a new item, the title and company appear first and the timestamp appears shortly after. Like this. And I'll explain why that is in a little while. But for now, I think it would be a good idea to delete all the old items that didn't have a timestamp, like this. And as we can see, the 3 items that remain are not sorted by time. So let's get back to our repository and see if we can implement the sorting code. And this is just a case of going to our jobs query method, which reads the values from this collection. And over here, we can add a order by clause, passing created at as the property name. And we can also specify a descending argument, which in this case we can set to true. And at this stage, we can save and hot reload one more time. And as we can see, the items are now sorted by time, and new items are always added to the top, like this. And at this stage, we can get back to the Firestore console. And if we navigate to any of the jobs that we have created here, we can see that they all have a created at timestamp, which is a special field that contains a date and time. And as we have seen, this is quite useful whenever we want to sort items by their creation time, like we have done in this case, by using this order by clause. And we have also seen how to write timestamps when adding a new document, as well as how to convert them to date-time objects inside our model classes. And by the way, inside the UI, we have decided to show these timestamps directly as strings. But keep in mind that you can use the date format class from the intl package if you want to show these timestamps with a specific format. Okay, so this is great progress, and we can continue on the next lesson where we'll talk about offline mode. We have seen how to work with timestamps. It's a good time to talk about offline mode, which is a very useful capability of Cloud Firestore. So what I'm going to show you in this lesson is how it's possible to read and write data with the Cloud Firestore SDK even when we are in offline mode. In fact, this page on the Firestore documentation says that Cloud Firestore supports offline data persistence. This feature caches a copy of the cloud store data that your app is actively using, so your app can access the data even when the device is offline. And you can write, read, listen to, and query the cached data. And when the device comes back online, Cloud Firestore synchronizes any local changes made by your app to the Cloud Firestore backend. So let's take a look at what this means in practice when we run our app. And over here, I have my iOS simulator running as usual. And I've also opened my network settings, showing that I'm currently connected via Ethernet. And what I can do is to toggle my connection to airplane mode so that I can go offline. And then I can try to add a couple of items to this list. And as you can see, everything seems to work correctly. And this is because Cloud Firestore is caching all the reads and writes locally on the client. However, you can notice that nothing was updated on the Cloud Firestore console because the new data hasn't made it to Cloud Firestore yet. And you can also see that the timestamp label is missing because inside our code, we decided to use a server timestamp. And this is only going to be written as soon as we come back online. So let me go ahead and restore my internet connection. And as you can see, as soon as I get back online, the data is synchronized with the server. And we get a new snapshot that contains the updated timestamp from the server. So it seems like Cloud Firestore does the right thing out of the box. And this means that we don't need to write any extra code to handle offline mode explicitly. However, is this also true for Firebase authentication? Well, to find out, we can go back to offline mode, and then we can try to sign out and sign back in. So to do that, we can go to the profile page. But unfortunately, as soon as we do this, we get a network error exception. And if we wanted, we could investigate where this comes from on the call stack. But as it turns out, this seems to be an exception that happens inside the Firebase UI auth package. And there's nothing that we can do to fix this ourselves. However, what we can do is to choose to disable uncaught exceptions like this, and then we can try to carry on. And at least this way, we are able to load the profile page. And from here, we can try to sign out. And from here, we can try to enter some test email and password. But this time we get a network error over here. And this makes sense because we need a network connection in order to authenticate with Firebase, since we need to verify these user credentials. So keep in mind that while offline mode is supported in Cloud Firestore, it is not and it shouldn't be in Firebase authentication. And once again, I recommend that you read this page to learn more about offline mode. Okay, so let's continue on the next lesson. Pagination as well as the Firestore Query Builder widget. The reason pagination is important is that if you have a Firestore collection that contains hundreds or thousands of items, then it's very wasteful to load them all in one go, since we can only see a few at a time on mobile. And to solve this problem, Cloud Firestore offers a feature called cursors, which allow you to return a subset of the data and paginate query results. And if you want, you can read this page to learn more about it. However, there is an easier way because we are already using the Firebase UI Firestore package. And the Firestore list view widget that we have been using until now makes it super easy to work with pagination by specifying a page size argument. And if we hover over here, we can see that page size has a default value of 10, meaning that pagination is enabled by default when we use Firestore list view. But if we want, we could give it a different value of 20, for example. And what will happen is that if our collection has more than 20 items, then only the first page of results will be loaded. And Firestore list view will automatically take care of loading the next page if we scroll to the bottom. So as you can see, pagination with Firestore list view is super easy. But keep in mind that Firestore list view only offers some basic customization options. And you can find out about all the options that are supported by going to the definition and taking a look at all these properties. And with that said, there are certain things that you can't do with Firestore list view. For example, you won't be able to show all the items inside a grid view rather than a list view. If that is what you want to do, then you can take a closer look at the documentation of the Firebase UI Firestore package. And if you scroll down, you can find a section called Advanced Configuration, which introduces a new widget called Firestore Query Builder, which provides the building blocks for advanced configuration at the expense of requiring more boilerplate code. And if you keep reading, you'll find some examples showing how to handle loading and error states, as well as a more complex example using a grid view, along with some code for fetching additional items. In fact, if you want to get some practice with this, I have an exercise for you. And that is to try to convert the jobs list view widget that we have created by using a Firestore Query Builder rather than a Firestore list view. So if you want to try this, make sure that you read the documentation to get a better understanding of the difference between the two. And with this, we have completed our demo app. And along the way, we have learned a whole lot of useful stuff about Cloud Firestore. So let's continue on the next lesson where we'll do a summary. We have now reached the end of this section where we have learned all the essentials about Firebase authentication and Cloud Firestore. And I hope that these lessons have given you a tangible idea of how easy it is to work with Firebase and add authentication and a remote database to your apps. And looking back at the app that we have built, it is clear that the Firebase UI packages have saved us a lot of time. And if we had to write the same app without the Firebase UI widgets, it would have taken us a lot longer to build all this functionality, especially with regards to the authentication flows. So is Firebase UI a godsend and should we always use it, or are there some drawbacks? Well, on the positive side, we get a ton of configurable widgets, which are great to get the job done quickly. But of course, if we need a completely custom UI, they may not be as flexible as we want them to be. And another positive thing is that Firebase UI is actively maintained by Google and many other contributors, and it is constantly being improved. Though keep in mind that it's not a perfect package, and in fact it has a fairly large number of issues on GitHub, and some of them have been open for a rather long time. And if you end up being affected by one of these issues, then you may be in for a long wait before it is resolved. On the other hand, if you choose to write and maintain your own code, then you're fully in control. And another thing I want to point out is that while Firebase UI makes life easier in many ways, it doesn't really let you separate the UI code from the underlying Firebase APIs. And as a proof of this, we can take a look at the jobs list view widget that we have created. And as we can see, this Firestore list view widget has an item builder property that gives us this query document snapshot argument. And this is a type that is defined inside Cloud Firestore, forcing us to have Cloud Firestore as a dependency in our UI. And here is another type that is defined inside Cloud Firestore. And even though we try to keep all the data access logic inside this Firestore repository, our UI code still depends on the Cloud Firestore APIs. And this also means that we can't really write widget tests or integration tests that are completely independent from Firebase. And this makes it harder to set up a test suite because we now have Firebase as a dependency. So overall, my recommendation would be to go ahead and use Firebase UI if you are on the early stages of development and you want to get authentication done quickly. And if you are happy with the pre-built UIs and its limited configuration options. But if you're working on large apps and you want full control over the architectural layers of your app, or if you require a completely custom UI, then Firebase UI may not be for you. And even if you decide to not use Firebase UI, it's clear that Firebase Auth and Cloud Firestore are very powerful services, offering features like caching and real-time updates that can significantly speed up your time to market. In conclusion, we have covered a lot of ground already, but keep in mind that we are just getting started. And in the rest of the course, we are going to dive a lot deeper into Firebase by building an e-commerce app that uses authentication, Cloud Firestore, as well as Firebase storage, Cloud Functions, and many other Firebase features. So let's continue on the next section. In this section, we have built a simple app and explored the basics of Firebase authentication and Cloud Firestore. And now that we are comfortable with the basics, we are going to take on a new, bigger project that will carry us all the way to the end of the course. And the project I'm talking about is this e-commerce app, which contains many features such as product lists, user authentication, shopping cart, checkout flows, and many more. And if you followed my previous Flutter Foundations course, you'll be already familiar with the code base for this app. But if you haven't, or maybe you completed the foundation course a while ago, then this section is intended as a good refresher. So here is an overview of what we will cover in this section. We will start with an overview of all the VS Code extensions and settings that I use for Flutter development, which will make your life easier. Then I'll share the official GitHub repository for this course, so that you can download the starter project and get it up and running. And then I'll give you an overview of all the screens in the e-commerce app itself. And then we'll take a deep dive into the code with a particular focus on how the app is initialized and how the project is structured. And then we will discuss the app architecture that we are going to use and how this architecture makes it possible to create a client app that is backend agnostic. And I'll also give you an overview of different techniques that we can use to integrate Firebase using the existing architecture. And by covering all these topics, you should get a good understanding of the starter project that we'll use in the rest of the course. And I think what makes this course unique is that in addition to learning Firebase, we'll put a lot of emphasis on good code quality and how to write maintainable apps so that you can have a strong foundation that you can use in your own projects. But once again, our main goal here is to learn Firebase and see how we can use it as a backend for our e-commerce app. And for this reason, we won't be spending too much time talking about UI, routing, state management, and testing, because these topics have been already covered extensively in the Flutter Foundations course. And to make the most of this course, you should already be familiar with Dart and Flutter, as well as the GoRouter and Riverpod packages. And I should also mention that this project uses the new Riverpod generator package. And like I said before, there is a strong emphasis on app architecture. And just to make this clear, if you come here to learn Firebase, but you haven't taken my Flutter Foundation course yet, then you should still be able to follow along as long as you're already familiar with all these topics. And just so you know, I've already covered all these topics extensively on my website. And if you look at the resources for this lesson, you'll find a collection of articles that you can use to fill any gaps in your knowledge. And now that I've given you an overview of the prerequisites, let me tell you a bit more about how the course is structured. And the main idea here is that each section covers a specific topic in detail. And since each section of the course builds upon the previous one, I'll always give you a good overview of what code is already in place, what problems we are trying to solve, and what Firebase features we are going to learn. And since we'll be working on a fairly big project, it wouldn't make sense to code everything from scratch. And instead, I'll be sharing up-to-date code snapshots all along, so that we can always start from a working code base and focus on the most interesting concepts and features. Okay, so let's get started on the next lesson. In this lesson, I'm going to share a complete guide that you can use to configure your VS Code for Flutter development. And this is a guide that I update periodically, so even if you read this before, chances are that there may be one or two new things that you didn't know about. And you can find a link to this guide in the resources below. And broadly speaking, this guide contains 3 sections. And the first one contains all the shortcuts that I'll be using throughout this course, such as the quick fix option, as well as the command palette, which I'll often use to run various commands, as well as to search files by name, since this is often quicker than using the Project Explorer. And in addition to this, you'll find a list of all my favorite extensions. And out of these extensions, the one that we'll be using most often is the Flutter Riverpod snippets. So make sure that you've installed this on your system as well. And finally, I have a list of all the settings that I use to improve my workflow. And these contain useful things to fix errors and format the code on save, as well as other visual settings such as bracket per colorization, UI guides, and sticky scroll. And as you will see, I've also enabled file nesting, which is something that is useful to group multiple files together. And this is also very useful in cases where we use code generation and we want to group all related files inside a toggle. And if you want to enable all the same settings that I have on my system, you can go ahead and grab them from here, and then you can add them to your settings.json file in VS Code. And by the way, one thing you may have noticed is that all the keyboard shortcuts that I use always appear over here at the bottom. And this should also help you figure out how to do certain actions using the keyboard only. So once again, you can find a link to this guide in the resources below, and I hope you'll find this useful. Okay, so let's continue on the next lesson. In this lesson, I want to share with you the official GitHub repo for this course, so you know where to find all the source code and documentation. So if you head over to this page, you'll be able to find all the source code for the e-commerce app that you'll build in this course. And just so you know, this is a different repo than the one we used in the Flutter Foundations course. So make sure that you go to the correct URL, which you can find in the resources below. And if you scroll down, you'll find some instructions for how to clone the repo and open the project in VS Code. And if you do this, you'll be taken to the latest code. Though keep in mind that in building the e-commerce app, we won't be starting from scratch. And instead, as you follow the course, I'll ask you to check out specific branch names, which will bring your code up to date so you can more easily follow all the lessons. And to prevent any conflict, you'll be able to discard any working changes you have in your project by running this command. So if you ever get stuck because you missed something or made a mistake, or you want to come back to the course after some time, you'll be able to start again from a specific chapter or lesson by checking out the corresponding branch. And by the way, another thing to notice is that at some point in the course, we'll add Firebase to this project using a tool called Flutter Fire. And this tool will generate a bunch of configuration files that are needed for the Flutter app to talk to your Firebase backend. And since your files will be different from mine, I've decided to add them to git ignore. And I think this will make the course experience much smoother for you. Finally, I want to mention that I created a documentation website for this course. In fact, if you head over here and click on this link, you'll be taken to this documentation site, which I've generated for you. And this site contains many useful resources and FAQs about issues that you and other students may encounter along the way. In summary, the official GitHub repo is a valuable resource and you can access it at any point by going to this URL in your browser. Alright, so let's continue on the next lesson where I'll share the starter project with you. Now that I've told you where to find the official GitHub repo, it's time for you to clone the starter project that we will use in this course. So if you look at the resources for this lesson, you'll find this prompt that you can use to clone the repository, as well as check out a specific tag that will take you to the starter project for this section. So make sure you go ahead and open up a terminal, and then you can copy these lines from the notes below and paste them in here. And what this will do is to clone the repository and check out the starter project. And if you type ls in here, you'll find a few files along with this e-commerce app folder, which contains the Flutter project that we are interested in. So what I would recommend you do is to open this folder using VS Code, which you can do from the command line with this command, like this. So once again, the repository that we have just cloned points to a specific tag that contains the starter project for this section. And since the entire project is a GitHub repo, you can make any changes you want and save them in your own branches. And in fact, I encourage you to experiment with this code as much as you want. And at various points in the course, I'll share some more Git commands that you can use to bring your code up to date, so that you can get a working project that compiles and runs without errors. And now that we have clarified this, let me give you an overview about this starter project. And a good place to start is by opening the pulsespec.yaml file. And what you'll find in here is that this project is based on Dart version 3.0, which was first launched with Flutter 3.10. So make sure that you're running on Flutter 3.10 or above if you want to run this. And as part of this starter project, I've also included a number of different packages. And these are all needed to run the e-commerce app. And the most important packages you'll find here are Go Router, which we'll use for navigation, as well as various packages in the RiverPod ecosystem, including Flutter RiverPod, RiverPod Annotation, as well as RiverPod Generator, and the new RiverPod Lint package that was introduced in February 2023. And for the time being, I'm not going to tell you about each and every package that is listed here, but instead I'll show you where they are used as we make progress. Though I want to point out that in the dev dependencies section, you'll find this Flutter Lints package, which enables all the recommended linter rules for this project. And just to be clear, new package updates will be available in the future, and by the time you watch this video, it might well be that some of these versions are out of date. However, I'll try my best to keep the starter project up to date, so don't be surprised if the latest code uses package versions that are more up to date than what you see in the videos. And with that said, let's carry on. And if we scroll down, we find some directives for generating the app icon. And there is also an option to generate the localized strings for the project. Though I should mention that we will not deal with localization in this course, as I feel that it would just slow us down, and what we really care about is Firebase. And finally, I've also included these assets product folder that contains all the product images that we will need when running the application. And if you open this folder in the Project Explorer, you can open the product folder and find all these product images. And just to be clear, storing the product images here is just a temporary solution. And as we make progress in the course, we'll learn how to store all these images using Firebase storage. But since we are just getting started, the easiest thing to do is to bundle all these images in the app and load them as assets. Okay, so let's get back to the pubspec.yaml file. And what we can do at this stage is to go ahead and download all the latest packages. And once this is done, you should see that all these folders now appear in white and all the errors go away. And this means that we can now run the app to make sure that everything works correctly. And at this stage, we can run on all the different platforms that are supported by Flutter by choosing one from the device selector, like this. And one important thing that I should mention at this stage is that while Flutter supports many platforms, including Windows and Linux, many of the Firebase packages that we need are only supported on Android, iOS, macOS, and web. And this means that once we choose to add Firebase, we'll be a bit limited with the number of platforms we can choose. So just keep in mind that going forward, I'll be using macOS primarily, but if you are on Windows, your options are a bit limited, and you might have to run on Android if you want to use the Firebase SDK. But for now, we are not using Firebase just yet. So in my case, I can choose macOS, and then I can press F5 to run the app. And as for you, feel free to select your target of choice and run the app. And since it's the first time we run this, the build might take a minute or two. But once the build is complete, you should see the app running over here. With that said, if you experience any build errors at this stage, then make sure to check the notes below, which contain a list of common errors and ways to resolve them. In fact, I suggest that you always check the notes in the course lessons, as they may contain some additional information or clarify some questions that you may have. Okay, so let's continue on the next lesson. Running on your chosen device. So this is a good time to give you a complete overview of this app so that you can see all the features that are supported. And just to be clear, if you play around with the app and use the various features, you see that the app appears to be completely functional. However, the way this works is not by talking to a remote backend such as Firebase, but instead what it does is to only store some in-memory data that is lost as soon as the app is restarted. And this happens thanks to some architectural choices that were discussed in detail in the Flutter Foundations course. And as we will see, these choices have made it possible to create a backend agnostic codebase that we can use to incrementally add Firebase support to each feature of the app. And we'll discuss all the details of the project structure and app architecture in the coming lessons. But for now, I just want to give you an overview of all the different screens in the app. And since this is largely the same project that we have built in the Flutter Foundations course, if you're already familiar with this app, you can skip to the next lesson where we'll dive into the updated starter project more in detail. So let's take a look at all the existing features. And as you would expect, this app is completely responsive and adjusts itself based on the size of the window. And on this initial page, we can see this list of products. And we also have this search box at the top, which I have disabled for now. But later in the course, we'll complete the search implementation using Firebase and Algolia. In any case, you can go ahead and choose any product from this list, and this will take you to this product detail page. And from here, you can choose a quantity and add the product to the cart. And we can do this with as many products as we like. And at any point, we can click on this button, which takes us to the shopping cart. And here, if we want, we can update the quantity of each item or delete it. And once we proceed to checkout, we'll be prompted to create an account. And here we can enter a non-empty email and password and create an account. And once this is done, we'll be taken to this payment page, which shows a summary of all the items in the cart. And from here, we can go ahead and pay. And once this is done, we are taken to this orders page, showing a summary of all the orders that we have placed. And once we have purchased a product, we can get back to the product page itself, and here we get an option to leave a review. And this will take us to this page where we can rate the product and leave a comment. And then we can submit this, and this will take us back to the previous page where we can see that a new review has been left. And here we also get the average rating score for the product. And the last thing we can do is to click on this account screen, which is mostly empty. And this includes this button that we can use to log out. So as you can see, all the primary UI flows are already implemented, and we have a fully functional shopping cart experience like this. But as I was saying at the beginning, if we hot restart the app, then we can see that we are taken back to the home page and all the data that we have entered before has been lost. And in fact, the shopping cart is empty. And that's because this app doesn't talk to a real backend just yet. And by using various products like Firebase Auth, Cloud Firestore, and Cloud Functions, we'll be able to implement all the required features for real, so that all the data is saved on the backend and can be synchronized across multiple devices. And beyond what I've just shown you, we'll also implement some admin functionality using role-based authorization with custom claims, so that we can upload new products using Firebase storage. And if you're curious about how this works, over here I have a build with a finished project. And we can see that the product list is currently empty. However, we now have this admin option on the menu, and this takes us to a page where we can manage the products list. And here we can press this plus button to add a product from a list of options. And if we choose any product, we'll be taken to a page that we can use to upload it to Firebase storage. And once this is done, we can customize all these different properties, or alternatively, we can load them from a template. And once this is all done, then the product gets saved to Cloud Firestore, and we can see that it appears on the home page as well. So this is one of the features that we will build in this course. And we'll also see how to integrate Stripe with our Firebase backend so that we can take payments in the app. And we'll learn a lot of cool stuff about Firebase along the way. Okay, so let's continue on the next lesson where we'll start taking a look at the code for this starter project. An overview of the initialization logic that takes place when the app starts. And we'll also take a look at how routing works in this project. And a good place to start is to open the command palette and open the main.dart file. And as you know, the most common way to start a Flutter app that uses Riverpod is to call run app using a provider scope as the parent of the root app widget. However, once your application starts to grow, chances are that you're going to add more and more app startup logic here, and this main.dart file starts getting bigger. And for this reason, I've created this app bootstrap class. And what this does is to take care of initializing some services, as well as registering some error handlers. And in general, the app bootstrap class takes care of all the app initialization logic. And if we get back to the main method, we can see that here we call this method which creates the root widget, and this is then passed to the runapp method. And one more thing we do here is to call this createFixProviderContainer method, which I will explain later on. But for now, all you need to know is that this method is used to create a provider container that is configured to simulate a fake backend. And just so you know, the intention is that we will also add a method to create a Firebase provider container. And this will allow us to choose whether we want to use the fake backend or the Firebase backend. So once again, this is just a high-level overview, and you'll get a better understanding of how everything works in the coming lessons once we talk about app architecture. But for now, we can get back into the app bootstrap class. And as you can see over here, we return this uncontrolled provider scope, passing the container that was given as an argument, and this myapp widget as a child. And if we open this myapp class, we can see that it is a consumer widget that contains the top-level material app using the router API. And this router is configured with a GoRouter object that comes from this GoRouter provider. And if we go to the definition of this provider, we end up over here on the approuter.dart file. And as we can see, this provider is used to return a GoRouter object with the definition of all the routes inside the app. And by the way, note that I've set this debug log diagnostic flag to true. And what this means is that we can open the console and we should be able to see that every time we move to a new route, then this is printed on the console log. This should be quite helpful because it means that you can easily see what screen is returned for each new route. And another thing that you can find inside the GoRouter are these redirect and refresh listenable arguments that we have already covered in the previous section. And these are used to prevent the app from going to certain pages depending on the authentication state. And if you're already familiar with the basics of GoRouter, there shouldn't be anything surprising here. Okay, so this completes the overview of the app startup code. In summary, in this lesson, we have seen how to write some app startup logic with the help of this app bootstrap class. And we have also seen how the routing logic is configured using GoRouter. And you can check the resources below if you want to learn more about these topics. Okay, so let's continue on the next lesson. Now that we have an idea about how the app startup logic works, it's a good idea to take a look at the various folders in the File Explorer so that we can get a better feel for how this project is structured. And as you can see, all the files in the project are located inside this source folder, which contains all these subfolders. And out of these, the most important one is called Features, because this is where most of the code belongs. And since this folder is so important, we'll cover it in detail in the next lesson. But before then, let's get all these other folders out of the way, so that we can better understand what is their purpose. So starting from the top, we have Common Widgets, which is a folder that contains a number of custom widgets that can be reused in many different features. For example, since our app is responsive, I created widgets such as Responsive Center, Responsive Scrollable Card, and Responsive to Column Layout. And I've also created some reusable buttons such as Action Text Button, Custom Text Button, and Primary Button. And as you can see, all these widgets include some documentation that you can read to understand how they work. And if you want to get a better idea about where these widgets are used, you can use the project search feature. For example, we could search for Responsive Center and see that this is used in all these widgets. Alright, so let's move on. And the next folder I want to talk about is Constants. And over here, you'll find a file called appsizes.dart. And this contains this class that is used to define all the constant sizes that are used in the UI. And these are all multiples of 4, which is a good idea if you want your UI to be consistent. And I've also defined some global gap constants, which represent some sized boxes that are often used to space out widgets inside row or column layouts. So if you see these constants in the various widget classes, now you know what they are. And I've also included this breakpoints file that contains 3 main layout breakpoints that we'll use in the app. Next up, we have this exceptions folder that contains an app exception class. And this is using a new feature of the Dart language called a sealed class, which was introduced in Dart 3.0. And what this allows us to do is to define a number of subclasses that represent all the kinds of exceptions that we can handle in the app. And the important thing to understand is that by using sealed, we can take advantage of the pattern matching capabilities in Dart 3 using an exhaustive switch statement. But for now, this is not particularly important, and we'll talk more about exceptions and error handling as we make progress. So let's carry on, and here we can skip the features folder since we'll cover this in the next lesson, and we can jump over to the localizations folder, and inside it we can find an ARB file that contains all the English localizations for the strings that we use in the app. Though I should mention that in order to make teaching easier, I'm not using the localized strings in this project, and instead all the strings that you'll find are hard-coded. And by the way, if you open this string hard-coded file, you'll find this small extension on the string class. And all I do inside here is to add this getter variable, and all this does is to return this, which represents the string itself. So once again, this is just a placeholder that doesn't modify the string in any way. And what makes this useful is that we can do a project-wide search for .hardcoded, and this will reveal all the places in the code where there are strings that need to be localized. Moving on, we can find this routing folder, which contains all the app router logic that we have explored in the previous lessons. And finally, there are also some utilities that I've defined inside this utils folder. And these include things such as currency and date formatters, as well as this async value UI extension on async value, which is used to show an alert dialog to the user when we detect an error. And if we search for this method, we can see that it's used in many different widgets when listening to a provider, such as in this case. And once again, you can spend some time reading the documentation for all these files to get a better understanding of their purpose. And we'll revisit some of them at the most appropriate time in the coming lessons. And with this, we have completed this high-level overview of all these top-level folders. In summary, these folders contain a collection of helper classes and methods that I use in this project, as well as many of my other Flutter apps, since they make day-to-day development a bit easier. And if you feel that this introduction was a bit fast and some of the details are not clear yet, make sure to check out the resources below, which include links to some articles that cover some of these techniques in more detail. And once you're ready, you can move to the next lesson, where we'll take a closer look at the project structure. In the last lesson, I've given you an overview of the top-level folders in this project. And now it's time to look at this features folder, which contains most of the code for this project. And inside here, you can find folders such as authentication, cards, checkout, orders, products, and reviews. And these are all the features that we discussed when I've given you an overview of the whole e-commerce app. And this arrangement of folders is something that is known as feature first. And the way to use this is that every time we add a new feature, we can add a new folder inside here. And then inside each folder, we have layers such as application, data, domain, and presentation. And these layers have very specific names that are based on my Flutter app architecture. And one important concept that I've explained in my app architecture introduction is that each of these layers has its own responsibility, and there is a clear contract for how communication happens across boundaries. And while it may feel unnecessary to structure things like this if you're just building a small app, I can guarantee that this approach is worthwhile if you want to keep your code organized as your app grows. And to help you with that, I've written this article about app architecture, which you can find on my website, as well as this one about the project structure. So make sure that you read these articles if you haven't done so already. Okay, so let's get back to our project. And just to give you a better feel for what goes inside each of these features, let's open this products folder, which represents the feature that we use to show the products list, as well as the product details page in the app. And as you can see, inside it, we have data, domain, and presentation folders. And the domain folder contains this product.dart file, which defines the product model class. And in turn, this contains all the properties that we need to show in the UI, along with from-map and to-map methods that we can use for data serialization. And when it comes to defining model classes, there are various techniques that you can use in Dart, such as writing everything by hand, or you can use a VS Code extension known as the Dart data class generator. Or alternatively, you can use a code generation package such as Freest. And you can also use a hybrid approach where you declare some functionality by hand and use a package such as equatable to take care of equality and generating the toString method. And if I'm honest, all these techniques have their pros and cons, and I tend to choose one or the other depending on my app requirements. And for this project, I felt that a good compromise was to go for the hybrid approach by using the equatable package and writing all the data serialization logic by hand, without using code generation. But once again, there is no right or wrong way of doing this, and if you have a lot of data serialization to do, then maybe something like Freest is the best way to go. And the main thing to keep in mind is that I always define my model classes inside the domain folder for each feature. Okay, so let's stay on track, and next we can look at the presentation folder. And what we can find in here are three folders called Home App Bar, Product Screen, and Products List. And in turn, each of these folders contains multiple files. For example, the Products List folder contains this Products List Screen file, which is the page that we see when we first start the app. And since this page is quite complex, it contains some other custom widgets inside it. And if we scroll down to the build method, we can find this product search text field that we can see over here, as well as this sliver products grid widget, which is used to show this list of cards. And each item in the grid is represented by this product card widget, which I've included over here. And while I'm not going to cover all this code in detail, the main idea here is that I've been making heavy use of composition in order to create reusable widgets, rather than shoving all the complex UI into one gigantic widget. But one thing that should be clear is that all the code inside the presentation folder has to do with the UI only, and you'll find very little logic inside these files. On the other hand, if we head over to the data folder, then we can find this file called fake products repository. And the main idea of this fake repository is that we can use it to simulate access to the products data, which would normally be stored in a remote database. But since this app doesn't have a backend just yet, what we are doing is to store all the products data as a list of products that is defined on this file. So as you can see, all the products are hard-coded, and each of them has an image URL that points to a file that is stored as a local asset. And if we get back to the repository, we can find a number of methods that we can use to access the product's data. And these use a so-called in-memory store, which is a class that was first introduced in the Flutter Foundations course. And the idea behind this class is that it is a reactive store that we can use to store some data, such as the list of products, like in this case. And we can also observe it as a stream, so that we can rebuild our UI when the data changes. In fact, over here we have these methods that we can use to get the products list, either as a feature or as a stream. And if we scroll down towards the end of the file, we can find a number of providers, which are defined using the @riverpod syntax from the new report generator package. And as we can see, the first provider that we define here is the one that is used to create our fake products repository. And then we have all these other providers, which are all quite similar. And what they do is to get the product repository by watching the product repository provider, which is generated from this method. And then they all just call the corresponding methods in the repository so that we can get the product data either as a feature or as a stream. But once again, let me remind you that we are using a fake products repository, and its only purpose is to be a temporary replacement for the real repository that will talk to our Firebase backend. Okay, so this was a high-level overview of the products feature inside our app. And if we take a look at any of the other features, such as authentication or the shopping cart, we can see that they all contain data, domain, and presentation layers. And in some cases, we also have an application layer. And I've explained all these layers in a series of articles about Flutter app architecture, which you can find on my website. And I definitely recommend that you read them to understand the big picture, since we'll continue using this app architecture as we make progress. And at this stage, you may still have some questions, like how does the data go from the repositories all the way to the UI? Or how do we modify the data in response to some input events? In other words, how does the data flow to the repositories to the UI and vice versa? Well, these are very good questions, and we are going to answer them in the next lesson. In the last lesson, we have taken a look at the products feature, and we have seen that it is composed by data, domain, and presentation layers. And inside the data layer, we have this fake products repository, which contains a number of methods for reading data from this in-memory store. And we concluded the lesson by wondering how does the data go from this repository all the way to the UI? And the answer to that is by using providers from the Riverpod package. And I think at this stage, it's a good idea to show you some diagrams that represent the entire data flows, as this will help us visualize what is happening in the code. So what we have over here is the fake products repository, which contains many different methods. And one of these methods is called watch products list, which we can find over here. And as we have seen, this method returns a stream with a list of products. On the other hand, in the presentation layer, we have this sliver products grid, which is a widget that is responsible for showing this list of items inside this page. And if we want, we can use the command palette to go to the sliver products grid widget. And as we can see inside the build method, we make this call to ref.watch with products list stream provider, which is also represented in this diagram. And if we go to the definition of this provider, we can see that it is defined inside a file that has been generated using the Riverpod generator package. And in turn, this provider is based on this products list stream method, which is defined over here inside the fake products repository file. And as we can see, this provider gets access to the products repository provider, which we can use to call the watch products list method, which returns a stream. And if we head over to this method, we can see that this stream is a property of this products instance variable, which is just an in-memory store. In other words, the way things work is that by calling ref.watch with products list stream provider, then this widget can register itself as a listener to this provider. And in turn, this provider calls ref.watch on this provider, which contains the repository. And because this method returns a stream, then this widget will rebuild every time there is a new stream event. And in this specific case, the data happens to be stored inside an in-memory store. But if we decided to swap this with a real backend, such as Cloud Firestore, we would only have to change the implementation of this repository. But these providers, as well as the UI, would not change. So this is how the data flows from the in-memory store all the way into the UI. And one thing that I want to point out is that we don't need to go through all the layers of our app architecture and use controllers and services if we are just reading data, because all we need to do is to add some providers that we can use to watch the data that comes directly from the repository. However, if we want to write data or do data mutations in general, then things are quite different. And one good example of data mutations is the email and password signing flow, which belongs to the authentication feature in our app. And the way this works is that we have an email and password sign-in screen widget that we can use to sign in or create an account. And what happens when we click on the submit button is that we call ref.read on this email and password sign-in controller provider. And this gives us an instance of the email and password sign-in controller, which is an async notifier that we can use to submit the email and password. And what happens inside this controller is that we call ref.read with the auth repository provider, and this gives us access to the fake auth repository that we can use to sign in with email and password. And what this will do is to write the new user credentials to an in-memory store. In fact, if we want, we can use the command palette to open the fake products repository, and we can see that this repository also uses an in-memory store that holds on to the current authentication state. And this repository also keeps track of all the user credentials using a separate list variable. But once again, we could choose to replace this entire implementation with the Firebase Auth SDK and use the repository to authenticate with Firebase instead. But as we can see, all these providers, as well as the UI and this controller, would not change. Okay, so it's time to do a summary. And as we can see from this diagram on the right, when a widget registers itself as a listener to this provider by calling ref.watch, there is an unidirectional flow of data from the in-memory store all the way into the UI. On the other hand, when we want to perform a data mutation, there are multiple method calls that take place in the opposite direction. And in both cases, the data source is the in-memory store, which just represents a fake backend. And in fact, all the repositories that you can find in the current project are implemented in the same way. And one question you may have at this stage is how exactly can we replace the code in the data layer by adding Firebase without breaking the app? And I'm going to answer this question in the next lesson. To have a conceptual understanding of how the data flows through all the different layers, we can ask ourselves how can we add Firebase to our e-commerce app? And what do we need to change in our project structure in order to enable this? And as we are about to learn, there are multiple ways to go about this, depending on what we are trying to accomplish. So in this lesson, we'll look at 3 different options along with their trade-offs. And before we get into all the details, let's get started with our generic app architecture diagram. And based on what we have learned already, it should be clear that any Firebase-specific code should belong to the data layer. And if you remember, this is what we have done in the previous section, where we have implemented all the Firestore CRUD operations inside a Firestore repository. But when it comes to our e-commerce app, we need to keep in mind that we have many different features rather than just one. And at the moment, each one of these features has its own fake repository. And this is something that we'll need to take into account because we need a way to add Firebase to our project one feature at a time. And since in the last lesson we've talked about the products feature and the fake products repository, we can focus on how we might add Firebase to this feature. And to do that, I'm going to show you 3 different options. And as you can see, the current implementation uses a fake products repository, which internally uses an in-memory store. But if we want to load data directly from Firestore, then we need to make some changes. And the first option that we can consider is to completely throw away the fake products repository and replace it with a Firestore products repository that uses the Cloud Firestore package. And as long as these 2 repositories have the same public interface, then the only change that we would have to make is to make sure that this products repository provider returns the new Firestore products repository. And the benefit of this approach is that we are not adding any extra complexity, because all we are doing is to replace one implementation with another. However, if we do this, then the fake products repository is going to be deleted entirely, and this means that we can no longer use it for testing purposes. And I'll talk about testing more in detail a bit later. But for now, let's go over to option number 2. And the main idea here is that we are going to keep both the fake products repository and the Firestore products repository inside our codebase by introducing a base abstract class that is implemented by both repositories. And what this allows us to do is to choose which one we want to use when we run the app. For example, we could create 2 launch configurations for our Flutter app, where the first one would only use fake repositories and the second one would only use Firebase repositories. And one benefit of this approach is that we will still be able to write integration tests that are completely independent from the Firebase backend by using only the fake repositories. And this is quite desirable, but it comes at the expense of extra complexity because we now have 3 different classes to deal with. And every time we decide to add a new method to the base abstract class, then we need to override it and implement it in both subclasses. So this solution takes the most amount of effort because we had to write and maintain more code overall. So let's see if we can do better by exploring option number 3. And the main idea here is that we can designate this Firestore products repository to be the default implementation, which is what we want to use in production anyway. However, we can also keep the fake products repository around so that we can still use it if we want. And to make this work, we need a little trick, and that is to ensure that the fake products repository implements the Firestore products repository, as this helps us ensure that both repositories have exactly the same public interface. And when I was preparing all the content for this course, I ended up testing all these options, and I arrived at the conclusion that option 3 is the best compromise. So this is the option that we're going to choose for this project. But just to be clear, if we had two different repositories, then we need some way to decide which one we want to use when we start the app. And the way I propose we do this is that we should always return an instance of the default repository when we create our provider. But we should also have an option to override this provider, and this is easy to do with the riverpod feature known as provider overrides. And if you remember, at the beginning of this section, we have seen that inside the main file, we call this method to create a fakes provider container. So let's open the definition of this method. And as you can see, over here we create each of the repositories that we want to use, along with some of the services that depend on them. And here at the bottom, we create this provider container by overriding all the providers with all the repositories that we have just created. And then we return this provider container back to the main file so that we can pass it as an argument to app.bootstrap.createRootWidget. And this in turn will take this container and pass it as an argument to this uncontrolled provider scope. And the reason we need to use uncontrolled provider scope and provider container is that over here we need this container to initialize this service. But if your app startup logic is quite simple, you can do the same thing and override your providers using a regular provider scope. And by the way, one thing that I want to point out is that this provider container is used inside the main file. But inside the test folders, we also have a robot.dart file, which is a test class that we use as part of the test suite. And as you can see, this class has a method called pumpMyApp with fakes, which also uses this function to create the fakes provider container. And what this allows us to do is to choose which repositories we want to use when we run our integration tests. And as we have seen in the Flutter Foundations course, we usually write tests by mocking dependencies with the mocktail package. And while this works well for simple tests, if we wanted to test entire user journeys or the entire app, then using fake repositories is the way to go, as they are much easier to set up than trying to configure Firebase for testing. And this is yet another reason to keep our fake repositories around, even if our production code will use Firebase only. Okay, so this completes our overview of all the options that we can use to integrate Firebase into our project. And as we said, our intention is to go with option number 3 and start adding Firebase repositories, which will have the same public interface as the existing fake repositories. But let me remind you that this needs to be done for each feature that we have in the app. And it will be a significant amount of work to add all the extra classes and make sure that all the repository providers are configured correctly. And for this reason, in the next lesson, I'm going to share a new starter project where I've already done all the necessary work for you. So let's continue on the next lesson where I'll show you how the new starter project works. I'm going to share the updated starter project that we'll use going forward. And if you already have a local copy of the GitHub repository, all you had to do is to open the terminal. And then from here, you can run git checkout starter-project-firebase like this. And if you press enter, then you should be taken to the updated starter project. On the other hand, if you're doing a fresh checkout or you have some changes in your local project, then you can follow the notes below this lesson to get everything up and running. And now that everything is up to date, I can show you what is changed. And for the most part, the starter project is the same as the previous one. And in fact, all the folders and project structures haven't changed, and I haven't added any new packages. However, what you can see is that we now have two main files, where the first one is called main_fakes.dart, and the second one is called main.dart. And if you're using VS Code, you'll notice that I've also added two separate launch configurations, called Firebase and Fakes. So keep in mind that going forward, we'll be using the main.dart file to run our app, as this is what we will use for our Firebase integration. But we'll keep the old file around just in case. And something that is different about the updated main.dart file is that here we are now calling this create Firebase provider container method. And if we go to this definition, we can see that this method still creates all the same fake repositories, just like we were doing before. But the main intention is that we will gradually replace them with the Firebase ones as we make progress. So as you can see, all the initialization code is mostly the same. However, what has really changed is the definition of all the repositories. For example, we can go ahead and find the authentication feature in the Project Explorer, and then we can open the data folder, and over here we can see the fake auth repository just like we had before. But what's different is that this repository now implements this auth repository, and this is now an abstract class that defines all these methods. And down here we have this method, which is used to create the auth repository provider. And if you remember, in the previous lesson, we explored various options for how we might add Firebase to our project. And what we said is that we wanted to go for option 3, so that we don't have to deal with any abstract classes, like we do in option 2. But of course, we haven't added any Firebase code just yet. And this means that we are not yet ready to implement this auth repository using Firebase. So for the time being, this abstract class stands as a placeholder that defines the interface that is implemented by the fake auth repository. But in the next section, we will convert this into a concrete class that will depend on the Firebase auth package. And as we make progress with the course, we'll also do the same thing with all the other repositories. So if you want, you can take a look at some of the other repositories, such as the fake products repository, for example. And you see that this repository also implements a base abstract class. And once again, this is something that we will convert to use Firebase in the coming sections. And if you want to get a full overview of all the changes that I made in the starter project, you can take a look at this pull request on the official GitHub repo. And over here, you can check all the files that have been changed. And you can find a link to this pull request in the notes below. In summary, the main changes that I made to this new starter project are that for each fake repository that we had before, I've added a new base abstract class with the definition of all the methods that we need to implement. And I've also updated the corresponding provider to throw an unimplemented error. And for the time being, I've updated the app initialization code to override each provider with a fake repository, just like we were doing before. And if you take a look at all these providers and repositories, you'll see that they are all defined in the same way. And before we move on, I want to remind you that this is just one way of doing things. And if you start working on a new project using Firebase or any other backend and you don't care about having fake repositories, then you might as well go for option 1 and create only the repositories that you need without any abstract classes. However, I do recommend that you keep all your data access code in the data layer, as this will make your app more maintainable and avoid a lot of problems in the long run. And with this, we have completed the overview of the starter project that we will use going forward. And in this section, I try to focus on the most important things, such as the project structure and the app architecture. But I've also left out many other small details. And for now, it's okay if you don't fully understand how all the code works. And as long as you understand the app architecture that we are using, then you should be able to follow along in the coming sections. So let's continue on the next section, where we'll start adding Firebase to our e-commerce app, where we'll talk about Firebase authentication. And this is a topic that we have already covered in the first section about the Firebase basics. And this time we're going to see how to add Firebase auth to our e-commerce app and get a much better idea about how Firebase fits within the app architecture that we have introduced in the previous section. And before we get into all the details, I think it's useful to get an idea about where to start with Firebase authentication, depending on what kind of app you're trying to build. And this is covered quite well by this page in the docs, which describes 4 different kinds of scenarios. And the first one is when you already have a sign-in implementation that does not use Firebase, but you want to authenticate with the Firebase backend services using custom authentication. But this is not the kind of scenario that we are going to cover here. Instead, what we will cover is how to build our own authentication system using Firebase. And this is the most common scenario when we are building a new app or adding signing to an existing app. And if this is what we want to do, generally we have 2 options. The first one is when we want a drop-in solution that is easy to use. And as we have seen, we can use the Firebase UI auth package for that. And the second option is when we want full control over the signing experience. And if that's what we want, we can implement our own authentication flows using the Firebase SDK. And this is exactly what we will learn in this section. And just so you know, there are some other scenarios as well. For example, in some cases, we may want to build a rich pre-sign-in experience using anonymous authentication. And another scenario is when we want to access the Firebase services from our backend using the Firebase admin SDK, rather than using Firebase directly from our Flutter client app. So once again, for now, our goal is to build our own authentication system with Firebase. And to keep things simple, we'll focus on signing with email and password. But feel free to explore the docs if you want to learn more about all these other sign-in providers. And with that said, here is a summary of what we will cover in this section. We will start by creating a new Firebase project and we'll add it to our e-commerce app using the Flutter Fire CLI. And then we will revisit our app architecture and see how we can implement an auth repository class that is based on the Firebase Auth SDK. Then we'll compare this to an alternative solution that is based on the Firebase UI auth package, so that we can understand what are the trade-offs and differences. And as part of this, we'll enable signing with email and password using the UI that is already included in the starter project. And then we'll talk about important Firebase APIs such as auth state changes and the user class. And then we'll figure out how to deal with Firebase auth exceptions in our e-commerce app so that we can show an error when signing fails. And after that, we'll also implement email verification, which is a feature that we will need later on in the course. And we'll wrap up with some considerations about automated testing. And just to be clear, in this section, we will focus on the signing flows only. And we won't tackle any big features because we are still in the early stages of the course. Instead, we will focus on app architecture and see how we can abstract away all the Firebase auth APIs inside the data layer, so that all the code in the remaining layers remains unchanged. And this will give us a good mental model that we can follow in the rest of the course, where we will tackle more complex features. And by the way, if you want to code along in the coming lessons, make sure that you first check out the branch called Starter Project Firebase, which is the same one that I've shared at the end of the previous section. Okay, so let's get started in the next lesson. To get started by adding Firebase to our e-commerce app. And for the most part, this will be a case of repeating the same steps that we have followed in section 1 about the Firebase basics. So let's get this out of the way first. And in the next lessons, we'll dive into the code and see how we can add Firebase auth to our project. And the best way to get started is by heading over to the Firebase console. And from here, we can go ahead and create a new Firebase project. And here we need to choose a name. So I'm going to call this Flutter Firebase Masterclass, like this. And I recommend that you also choose the same name. Then we can click on Continue. And here we get an option to enable Google Analytics. And since we don't need it for this project, I'm going to disable it. And then we can go ahead and create the project. And this may take a minute or two. And once this is done, we will see that the project is ready. And we can continue. And from here, we can choose to add one of these apps to get started. So let's go ahead and choose Flutter. And once again, here we get some instructions to add Firebase to our Flutter app. And by now, I assume that you already have all the necessary tools installed on your system. So we're going to go over to the next step. And then we can copy this command from here. And then we can get back to VS Code and make sure that we open a terminal. And then we can paste this command and run it in here. And assuming that we are already signed in with Firebase, our project will be found. And here we can go ahead and choose all these platforms. And then the Flutterfire CLI will go ahead and do a bunch of work for us by registering a Firebase app for each selected platform. And once it's done with that, it's going to ask us if we want to update the Android Gradle files to apply the Firebase configuration. So let's go ahead and choose yes. And in this case, I'll also get this option because I had already generated this file before, but most likely you won't get this. So let's go ahead and do the same for this other file. And this will complete the installation process by showing us all the Firebase app IDs that have been registered. And at this stage, we can open the Project Explorer, and we can notice that the CLI has generated this Firebase options.dart file, which contains all the configuration code that is needed to run our project. But as we can see, this code does not compile because we have not installed the Firebase core package just yet. So we can make sure that we add this by opening the command palette. And here we can use the Dart add dependency option. And then we can use this to install Firebase core. And while we're here, we can also add Firebase auth, like this. And once this process has completed, then Flutter will get the latest packages. And once this is done, we can see that all the errors go away from this file. Okay, so this is a good time to open the pubspec.yaml file. And here we can confirm that these two packages have been installed. And what I'm going to do is to remove the caret from these two packages to ensure that we run exactly on this version. Though keep in mind that I'll try to keep the GitHub project up to date. And this means that the updated code snapshots that I will share as we make progress may use more recent package versions than the ones you see on this video. Okay, so let's go ahead and move over to the main.dart file. And here we can find this to-do telling us to initialize Firebase. So let's get back to the console and move to the final step. And then we can copy these 3 lines from here. And then we can get back to VS Code and we can delete this to-do and paste the lines in here. And then we can save the file to format our code. And of course, we need to import Firebase core as well as Firebase options.dart in order for this to compile. Okay, so this completes our initial setup. And at this stage, it would be a good idea to run our app on iOS and Android to make sure that everything works as intended. So let's make sure that we are using the launch Firebase configuration over here. And then we can get started by selecting an Android emulator from the list of options. And then we can go ahead and run our app. And I'm also going to open the debug console because as we're about to see, we are going to get the infamous multi-dex error. And in fact, as we can see, we got a big scary error log from Android. And the bottom line is that we need to add multi-dex support if we want to run our app. And the quickest way to fix this is to go ahead and open the Android folder, and then we can open the app folder, and inside the bit.gradle file, we need to locate the default config section. And to fix our error, we can update this min SDK version to 21, for example. And then we can save this file. And then we can try to run the project again. And as we can see, we now get another error, which is something that we haven't come across before. And this error seems to happen if we use Gradle version 8.0, which doesn't play nice with the version of the Google services that was installed by Flutter Fire. And as it turns out, this is something that other people have encountered. And we can find a solution on Stack Overflow, telling us to update the Google services to this version. So what we can do is copy this version from here, and then we can get back to the Gradle file. And here we need to make sure that we use version 4.3.14, like this. And now that we have made this change, we can run the app one more time. And after a little while, we should see that the app is up and running on the Android emulator. So if you are on Windows, you definitely want to make sure that you can run the app on Android at this stage. But since I'm on macOS, I can go ahead and choose iPhone or macOS as targets. For example, here I could choose iPhone 14 as a device, and then I could try to run the app on it. And assuming that all the required tools are installed, then the app should run on iOS as well. And if you get any errors, make sure that you check all the resources below for how to resolve them. And by the way, one thing that I want to mention is that if we head over to the source control panel over here, we can see that our repository has been found in the parent folder. And if we go ahead and open the repository, which is located over here on my system, then we can see that a number of files have been modified, including the Android Gradle files, as well as some of the Xcode project files. And in addition to this, a number of platform-specific configuration files have been added too. But you won't see them over here because I've added all these files to gitignore. And if you want to find out what these files are, you can scroll to the bottom of this file and you can find them here. And if you go ahead and open these files, you'll find that the values inside them will be specific to the Firebase project that you have created. For example, if you open the Firebase options file that you have generated with the Flutterfy CLI, and you scroll all the way to the bottom, you'll see that the API key and app ID that you have in your project are different from the ones that you see in this video. And in order to take this into account, I've added all these files to gitignore, so that you don't end up with file conflicts when you check out my code again in the future. So just keep in mind that when you run Flutterfy configure, then all these files will be generated and added to your project, but we won't be adding them to source control. And with that said, we have nearly completed this lesson, and we have managed to get the app running on Android and iOS. But in the rest of this course, I want to use macOS as my target platform, because this makes it easier to change the window size as desired. And this is something that is not really easy to do on iOS and Android. However, if we want to run the app on macOS, there are some additional configuration steps that we need to do, and I covered all these steps on this article on my website. And to make your life easier, I've decided to share an update code snapshot, which contains all the required changes to get the app running on macOS. So what I suggest you do at this stage is to open a terminal, And from here, you can run git reset --hard head to discard any working changes. And then you can run git checkout starter project macOS, like this. And this branch will contain all the changes that we've made to this lesson, in addition to some additional configuration that is needed for macOS. And as a proof of this, I can go ahead and select macOS as a target, and then I can run the app on macOS. And after a little while, I can see that the e-commerce app is running on macOS. However, if you try to do the same thing and run the app on macOS, you're going to encounter one issue to do with code signing. And the way to resolve this issue is to go to the Project Explorer, and then you can right-click on this macOS folder and choose to open it in Xcode. And from here, what you want to do is to select the runner project over here, and then you have to go to Signing and Capabilities, and here you need to update the development team and select a valid Apple developer account that you own. And of course, this is going to be different from my own developer account. So as far as I can tell, if you want to use Firebase and run your app on macOS, then you need to have your own Apple developer account. And if you don't, then you're better off running this project on iOS instead. Okay, so let's do a wrap up. In summary, in this lesson, we have created a new Firebase project and used the Flutterfy CLI to configure our Flutter app and initialize the Firebase SDK. And this means that we can go ahead and continue to the Firebase console. And by the way, I'd like to mention that to keep things simple, we will only use a single Firebase project in our codebase. And we won't try to add multiple flavors such as development, staging, and production, though this is definitely something you should consider if you want to run your apps in production. And to help with that, I've written this article that you can find on my website. Okay, so let's continue on the next lesson where we'll start adding Firebase Auth to our e-commerce app. Lesson, we'll start figuring out how to add Firebase authentication to our app, so we can authenticate users with Firebase. And if we go back to the Project Explorer in VS Code, I should point out that the starter project already has an authentication feature, which contains data, domain, and presentation layers. And this is something that we have already discussed as part of our app architecture. And if we take a look at the data folder, we can see that we already have this auth repository, which is an abstract class. And this defines all the methods and properties that are needed to authenticate the user, as well as to sign out and check for the authentication state. And as we have seen in the previous section, this class is implemented by the fake auth repository, which is just a temporary implementation that we can use for testing purposes. And as far as the UI goes, we already have a screen that we can use to sign in with email and password or to create an account. And we can find all the widgets and controllers for this screen inside this presentation folder over here. So if we wanted, we could certainly keep all the UI code that is already in place inside the email and password sign-in screen and controller, and only update the data layer to ensure that we talk to the Firebase Auth API rather than using this fake auth repository. However, in the first section about Firebase basics, we have seen that another option is to use the Firebase UI auth package, which gives us some convenient drop-in widgets that we can use to achieve the same result. So which option should we choose? This one or this one? Well, since we have already explored the Firebase UI auth package earlier on in the course, I think it would be a good idea to explore this option this time. And by choosing this, we'll be able to see how Firebase fits within our app architecture, and we'll also learn about the most important Firebase Auth APIs. And this will give us a more in-depth understanding of how Firebase Auth works, rather than focusing on the UI only. So the way we are going to approach this is by implementing all the methods inside this repository, by talking to the underlying Firebase Auth SDK, while preserving all the existing UI. And as we'll see, this approach has some advantages and disadvantages, which we will discuss in the coming lessons. Okay, so let's get started. And as a first step, let's head over to the Firebase console. And here we can open this build toggle and select the authentication feature. And then we can click on this option to get started. And as a first step, we need to make sure that we enable email and password authentication. Otherwise, our code is not going to work. So let's hit save. And once we have done this, we should see that this status is enabled. And then we can get back to VS Code. And then we can focus on our auth repository class. And as we can see, this is currently defined as an abstract class, which cannot be instantiated. And for the same reason, this provider body throws an unimplemented error. But since we have now installed the Firebase Auth package, then this no longer needs to be an abstract class. So let's remove this to-do and the abstract keyword. And our next goal is to implement all these methods. But before we can do that, we need to add a final Firebase auth_auth property. And in order to use this, we need to import it from Firebase auth.dart. And we can also add a constructor for this field, like this. And since we now have this constructor, we can quickly go down over here and remove these two lines from the provider body. And instead, what we can do is to return a new auth repository, passing Firebase auth.instance as an argument, like this. And now that we have made this change, let's go ahead and implement all these methods. So let's go ahead and add a body to this method. And then inside here, we can type _auth dot. And as we can see, here we get a list of all the properties and methods that are available in the Firebase auth class. And as you can see, there are quite a lot of them. And the one that we want is this signing with email and password method. And we can give it the email and password as arguments, like this. And if we hover over this method, we can see that it returns a feature of type user credential. And if we want, we can command click to go to the definition of the method. And here we can get a better idea about what this method does, as well as what kind of exceptions it throws. And this is something that we will revisit in one of the upcoming lessons. But for now, let's stay on track and get back to our file. And since our method returns a feature, then we need to return something. And because this is a feature of type void, then it is okay to return auth.signing with email and password, even though this returns a feature of type user credential. And by the way, I just want to point out that since this method has only one statement inside it, then we don't need to use async and await, because this entire expression is a feature, and the return type of this method is a feature too. Okay, so let's go ahead and implement the remaining methods. And in this case, we can just return auth.createUser with email and password, like this. And likewise, we can implement the signout method by returning auth.signout, like this. So as you can see, there is nothing special here, because all these methods do is to call the corresponding methods from the Firebase auth class. And if we wanted, at this stage, we could try to implement the auth state changes method as well. And we could do this by returning _auth.auth state changes, like this. But if we do this, we can see that we get an error telling us that a value of type stream with a nullable user can't be returned from a method that returns a stream with a nullable app user, because these two types are different. And in fact, we get the same problem if we implement this current user getter variable by returning auth.currentUser, like this. So let's continue on the next lesson, where we'll figure out how to fix this. In the previous lesson, we started implementing the auth repository class using the Firebase auth package. And as we have seen, we have some compile errors telling us that a value of type nullable user can't be returned from the function currentUser because it has a return type of appUser. In other words, these two types are not matching. And we also have a similar problem over here. So in this lesson, we'll talk about different ways to solve this problem, along with their trade-offs. And we will also learn about the user class more in detail. And as a first step, I think it's a good idea to open the definition of this property, which is used to return the current user if they are currently signed in, or null if not. And what this also says is that this getter only provides a snapshot of the user state. And applications that need to react to changes in the user state should instead use auth state changes. And what this means is that current user is useful when we want to do a one-time read and check if the user is currently signed in. On the other hand, if we want to react to changes in the user state so that we can rebuild our UI, then we can use the auth state changes method, which returns a stream. But what does this user class look like? Well, if we command click to go to the definition, we can see that it represents a user account. And this also contains many different properties and methods that we can discover by exploring all the source code. And since there is a lot of stuff inside this class, I think it's best to look it up in the official documentation for the Firebase auth package. And as we can see, the user class contains properties such as the display name, email, the photo URL, and the user UID. And it also contains a lot of methods that we can use to update these properties. And we can also use this class to link the user account with additional credentials and much more. In fact, the user class is one of the most important classes in this package. However, at the moment, we don't need all this functionality. And if we go back to VS Code and return to our auth repository, we should ask ourselves if we want to expose the user class and all its functionality to the remaining layers of the app. In fact, a very simple way to fix our compile errors would be to modify this return type to return a stream of user, and this getter to return a user, just like this. And we could do the same thing by updating the return type of this provider over here. However, the outcome of this would be that anytime we use the auth state changes provider in the UI or inside other providers, then we would get access to the user type, which is defined inside Firebase auth. And this means that the remaining layers would now depend on the API of the Firebase auth package. And by the way, since the fake auth repository implements the auth repository, then we would have to update the implementation of these methods to also use the user type. But this doesn't make sense because this repository shouldn't have anything to do with Firebase. In other words, if we change the public interface of this class so that some of its methods return the user class, then we are effectively leaking some implementation details of the Firebase auth package in the rest of the app. And if we are not careful, we can end up in a situation where we call methods of the user class in the wrong places. And the way to prevent this is to define a separate app user class, which lives inside the domain layer over here. And because we have full control over this class, we can decide to expose only the properties and methods that are needed by our app. So let me go back to the auth repository and undo these changes so that these methods return the app user class once again. And if we go to the definition of this class, we can see that it only has UID, email, and email verified properties, but we can add more in the future if we need them. So once again, by exposing this domain-specific user class, we have more control over which data is available in the remaining layers without exposing the API of the entire user class from the Firebase auth package. But this requires a bit more work on our side because we had to write some code to convert instances of type user to instances of type app user. So let's see how to do that. And since this is a stream, we can use the map operator, which gives us a user object. And inside here, we can use the ternary operator to check if the user is not null. And if that's the case, then we can return an app user by passing along the UID, the email, and the email verified properties that come from the user object. On the other hand, if the user is null, then we just return null, like this. And now that we have done this, we can see that the errors go away, because by using the map operator like this, we can convert a user object to an app user object. And by the way, the same conditional logic that we have written over here could also be reused for this current user getter, so that we return an expression of type app user over here. So what I propose we do at this stage is to create a helper method that returns a nullable app user object, and this could be called convert user, and it would take a nullable user as an argument like this, and then we can take this entire expression that we have written over here, and we can cut it from here, and then we can use it over here like this. And then we can pass the name of this method as an argument to the map operator using a method terof like this. And this will ensure that this method is called to do the conversion each time the stream emits a new value. And now that we have this helper method, we can use it over here to fix our current user getter like this. And with this, we have completed the implementation of the auth repository class. And the most important takeaway from this lesson is that we had to make a decision about the public interface of this class by choosing if we want to expose the user class from the Firebase auth package in the return type of these methods. And for the time being, we have decided to not do that by converting any instance of type user to this type, which we have defined in the domain layer over here. However, I should point out that once we have converted a user to an app user, then we no longer have access to all these methods. And in fact, later on in this section, we will talk about email verification, which is a feature that requires us to call this method inside the user class. And as we will see, we will have to revisit our approach slightly in order to implement this feature. But for now, we can keep things as they are. And at this stage, you may have a burning question in your head, and that is, should you do the same thing in your project and also use a domain-specific app user class? Or should you not bother and just use the user class from Firebase auth whenever you need it? And to be honest, if you want to keep things simple, then you don't need all these extra abstractions, especially when you're starting out. But if you end up working on a big project with a large team, then it can be worthwhile to introduce more rules about what you can and cannot do in the various layers of the app architecture. And before we continue, I want to mention one last thing, and that is that in the Firebase docs we can find this page, which explains quite well what is the purpose of the user class. And I recommend that you read this if you want a high-level overview of what the user object represents and what you can do with it to avoid confusion later on. Okay, so let's continue on the next lesson. Our auth repository class is now complete, and before we can test our implementation in the e-commerce app and see if everything works as intended, we need to make a change to our app startup code. In fact, if we head over to the main.dart file, we can find this call to create Firebase provider container. And if we command click on it, we can go to the method definition. And if we scroll down a bit, we can see that here we are still overriding this auth repository provider with this auth repository, which is an instance of fake auth repository. But now we can remove this override because our provider no longer throws an error. So let's do this and delete this line. And we can also delete this repository since we no longer need it. And now that we have made this change, we can save this file and we can also hot reload just in case. And then we can go ahead and open the sign-in page. And for example, here we could enter test@test.com as the email and test1234 as the password. And if we try to sign in, we get this error from Firebase telling us that there is no user record corresponding to this identifier. And this makes sense because we should create an account before we sign in. So let's switch over to the option to register, and then we can enter a password once again, and then we can click on the option to create an account. And as we can see, this time everything works. And if we head back to the Firebase console and go to the Users tab, we can see that an account has been created with the email that we have used. And as you can see, here we have a user UID, which in my case starts with RFYP. And if we go back to our app and go to the account page, we can see that the UID matches exactly with the value in the Firebase console. So it seems like everything is working as intended. And as we have seen, we no longer need to override the auth repository provider because we now have a working implementation that uses the auth repository class. And as we make progress with the course, we will also implement these other repositories using Firebase and remove these overrides. And up until now, we have only focused on the data layer of the authentication feature. And if you're not too familiar with this feature, you may wonder how everything else fits together. And to make this clear, I prepared this diagram, which shows what happens when we sign in with email and password. So from the UI point of view, everything starts with the email and password sign-in screen. And inside this file, there is a submit method, which we can find over here. And this is used to validate the email and password form. And then we get access to a controller that contains a submit method. And this in turn calls the authenticate method over here. And here we get access to the auth repository provider that we can use to call these methods to sign in or create a user, depending on the form type. And if we command click to go to the definition of this method, we can see that it takes us directly to the right place inside the auth repository. So as you can see, it is relatively easy to navigate this codebase as long as you have a good understanding of the app architecture that we are using. Okay, so this is good progress, and we can continue on the next lesson where we'll talk about error handling. We're going to talk about Firebase auth exceptions, which is something that we have not considered up until now, but is definitely something that deserves our attention. And one thing that I'd like to point out is that the auth repository class contains all these methods that we have implemented, but we are not really handling any exceptions in here. However, if we open the source code for any of the methods that we are calling, such as the signing with the email and password method inside Firebase auth, we can read that a Firebase auth exception will be thrown in all of these different cases. And as we have seen in the previous lesson, if we attempt to sign in with the wrong credentials, then we'll get an alert with this error. So how does our app know that it needs to show an alert if authentication fails? Well, as we have already seen in the previous lesson, when we press on the sign in button, then we make a call to the submit method in our email and password sign-in controller. And this in turn will call the sign in with email and password method inside our repository, which in turn will try to sign in using the Firebase auth SDK. However, if an exception is thrown at this stage, it will propagate through the call stack until it encounters a try and catch statement. But as we can see, there is no try and catch inside this auth repository. But if we go back to our email password sign-in controller, we discover something interesting, because inside this submit method, we are using this call to asyncValue.guard. And if we open the definition of this method, we can see that it does have a try and catch statement inside it. So what happens in practice is that if the signing method fails, then the exception will be caught here. And as a proof of this, we can add a breakpoint in here, and then we can try to sign in again with the wrong details. And as we can see, the execution stops immediately at this breakpoint. And in the debug panel, we get a Firebase auth exception, which contains all of these details. And as we can see from the code, this exception is caught and returned inside an asyncValue.error object. And this is then used when setting the state inside our controller. But how is this error handled in the UI? Well, to find out, we can open the email and password signing screen file. And if you scroll down to line 122, you can find a build method. And in here, we can find this call to ref.listen, which takes the email and password signing controller provider as an argument. And then whenever the state changes, it calls this callback that we used to show this alert dialog on error. And this is a method which is defined inside this extension on the async value type. And what we do inside here is to check if the state is not loading and if we have an error. And if that's the case, we extract the error message and show it with an alert dialog. And in fact, if we want, we can add another breakpoint here, and then we can try to sign in once again. And we can also remove the old breakpoint. And if we continue the execution, we can see that we end up exactly here. And if we take a look at the debugger, we can see that the current async value is an async error, and this contains the Firebase auth exception as the error value. And this is what causes this dialog to show. And this way of handling errors is a pattern that I'm using in all the screens where we are submitting some data and there's a chance that something may go wrong. And at this stage, we may ask ourselves if this is what we want to do. In other words, should we let Firebase auth exceptions propagate all the way into the UI, where we can handle them with a provider listener? Or should we try to catch exceptions in the data layer and make it explicit that our repositories can return an error by making this part of the return type inside our methods? And this is something that I've already covered in detail on this article on my website. And if you want, you can read this to understand all the details. But I'd like to suggest that what we have in this case is already more than appropriate. And it is not worthwhile to build a heavyweight error handling solution just for the sake of catching errors in the data layer and defining our own error types. And besides that, Firebase auth already does a lot of the heavy lifting for us by returning an error code along with a user-friendly error message. And all we need to do really is just to show this information to the user, like we're doing over here. However, we could do a small tweak to this method where we extract the error message so that we don't show the error code from Firebase auth. And this is easily done by typing if error is a Firebase auth exception, which is a type that we need to import from Firebase auth. And then here we can return error.message. And since this happens to be a nullable string, we can use the null coalescing operator and return error.toString if this value is null. And then we can put an else statement over here so that we preserve the previous functionality if we get an error that is not a Firebase auth exception. And after we save and hot reload, we can dismiss this message. And if we try to submit this again, we see that this time we only see the user-facing error message, but not the error code. In summary, in this lesson, we have seen how errors propagate from the data layer all the way to the UI. And the way our approach works is that we don't try to catch any exceptions in the repositories. And instead, we use asyncValue.guard inside our controllers to catch any exceptions and return them inside an async error that we can use when setting the state. And inside our widgets, we can use ref.listen to check when the state changes and use this helper method to extract the error details and show an alert to the user. And one benefit of this approach is that it is very lightweight and it doesn't require us to write a lot of functional error handling code with custom result types, which is something that many people advocate for. But I find that in practice, this is not worthwhile because Firebase already gives us some handy error types that we can use. Though I should point out that since we are now checking if this error is a Firebase auth error inside this file, then we need to import Firebase auth at the top. And this means that Firebase auth is now a dependency inside this helper extension. But once again, I think this is not a big deal. And as we will see, we will use the same approach to error handling in the coming sections, where we'll use other Firebase features like Cloud Firestore and Cloud Functions. And if you want to learn more about error handling, you can read the resources in the notes below. Okay, so let's continue on the next lesson. In this lesson, we're going to tackle email verification, which is a feature that will help us explore the Firebase Auth APIs a bit more in detail, with particular focus on the user class. And it's also something that will be useful in a later section, where we'll talk about role-based authorization using custom claims. And by the way, I consider this to be an optional lesson, so feel free to skip to the next one if you want. Okay, so how does email verification work in Firebase? Well, the main idea is that when users create an account using email and password, there is no way to guarantee that the email address exists unless we verify that email. And for this reason, we can provide an option inside our app to start the email verification process. And in fact, when we open the account screen, we can see that I've included this button that we can use to verify the email. However, if we click on it, we can see that this feature is currently not implemented. So let's see how we can tackle this. And if we open the account screen, then we can scroll all the way to the bottom and find this email verification widget. And this widget takes an app user as an argument, which is obtained by watching the auth state changes provider in the parent widget. And as we can see, the build method uses this if statement to decide which UI to show, depending on whether the email is verified or not. So how can we enable email verification? Well, the main idea is that the user class has a method called sendEmailVerification. And if we find a way to call this method when this button is pressed, then Firebase will send an email with a link to the email address of the currently signed in user. And if the user clicks on the link, then the email will become verified. And while this is not a particularly exciting feature, we can use it to improve our understanding of how to work with the user class in relation to our app architecture. And as we are about to find out, implementing this feature would require some refactoring, and some of the steps involved are a bit error-prone. So for this reason, I decided to share an update code snapshot that will contain the completed implementation. This way, we don't have to struggle to get the code working, and instead we can focus on the most important concepts. So please go ahead and open a terminal. And then from here, you can run git checkout email-verification like this. And this will help you get all the latest code. And if this fails for any reason, then you can check the notes below for how to resolve this. And now that we have the latest code, I can give you an overview of what's changed. And to start off, let's head over to the auth repository class. And as we can see, this looks mostly the same as before. However, there is one change, and that is that inside this convert user method, I'm returning an instance of Firebase app user if the user is not null. And this Firebase app user is a new class that I've added to the project. So let's take a look at it. And the way this works is that it takes a user object as a constructor argument and sets it as a private variable, which means that we cannot access it from the outside. And the important thing to notice is that the Firebase app user class implements the app user class. And this means that it needs to override all the public methods and variables of the base class. However, it does not use the implementation of the base class, because here we are implementing it and not extending it. And as you can see, all these variables are simple getters that return the corresponding properties from the user class. And what this means in practice is that inside our auth repository, we still have methods that use the app user class in the return type. And this is what is visible in the rest of the app. But internally, we return instances of Firebase app user, and this gives us the ability to hide away the user class from the public interface of the auth repository. But it still allows us to call methods on it, like we are doing here, by calling the sendEmailVerification method. And if we discover that we need an additional method from the user class, we can add it to the base app user class, like we have done here with an empty implementation. And then we can override it in the Firebase app user class and use it to call the corresponding method like this. And now that we have seen how this class works, let's see how the email verification flow works in practice. So let's head back over to the account screen file, which is where our email verification widget lives. And as we can see, inside the onPressed callback of this button, we have some new code, which reads the account screen controller provider.notifier and uses it to call this sendEmailVerification method, passing the user as an argument. And inside this method, what we do is to update the state and make a call to user.sendEmailVerification using this guard. And then this method returns true if there aren't any errors. And this means that inside the widget, we can check if this call was successful, and if the widget is still mounted, then we can show an alert informing the user that an email has been sent. Okay, so let me go ahead and hot restart, and then we can go to the account screen and make sure that we are logged out in the first place, because this was not a real email address. So let me go ahead and log out, and then we can open the sign-in screen. So what we want to do is to create a new account, and in this case, I can use my own email. And then I can choose a password, and then I can go ahead and create an account. And then I can head over to the account screen, where I can see the email that I just registered, and here I can click on this button to verify the email. And if I head over to my email client, I should see that I've received an email from Firebase with this email link. And it also has this signature, which is something that we should definitely configure so it's more recognizable. But for now, I can go ahead and click on the link. And this takes us to a page telling us that the account has been verified. And at this stage, we can get back to our app. However, it looks like the account page has not been updated, and we still see this button to verify the email, rather than a green badge telling us that we are verified. And ideally, it would be nice if we could somehow register a listener to ensure that we rebuild this page as soon as the email has been verified. And after doing some research, I've come across this page on Stack Overflow, showing that email verified is always returning false even after verifying the email. And down here, there is an answer from one of the top Firebase developers explaining that it should be possible to update this by refreshing the ID token. However, I tried this myself and I couldn't get it to work. And I found that the only reliable way of getting this UI to update is to sign out and sign back in, since this should generate a new ID token with the updated email verified value. So let me go ahead and sign in again. And now I can get back to the account page. And as we can see, we now get this green check mark, which I've specified inside this layout, which is only returned if the email is verified. Okay, so let's do a summary of what we have learned in this lesson. And as we have seen, we can add email verification by using the send email verification method from the user class. And in order for this to work without exposing the user class inside our UI, we ended up creating a Firebase app user class, which implements the app user class that is returned by the methods inside our app repository. And if we wanted, we could have used the app user class directly in the UI by calling user.sendEmailVerification like this. However, I don't recommend this, because if this method throws an exception, then we won't be able to catch it. Instead, I think it's best to move this logic into a method in our controller class. And this takes the user as an argument, and we can use this to call the method that we want, as well as to update the state. And overall, this idea of hiding the user inside a Firebase app user class seems to work well. But you can see that it takes a bit of work to set up. So once again, this is all about trade-offs. And if you want to get stuff up and running quickly, maybe you should avoid all these abstractions and just use the user class directly. And while we talk about email verification, I'd like to mention that if we open the Firebase console and go to the authentication page, then at the top we can find a templates tab that we can use to configure the emails that are sent by Firebase when certain events take place. So keep in mind that you can customize some of these templates if you want. And the other thing I want to mention is that if we open the project settings, we can find a number of configurable properties, such as the project name. And it is a good idea to update the public-facing name to something that your users will recognize. For example, here we could call this a commerce app. And ideally, we should also specify a support email, like this. And if you want to learn more about email verification, you can check the resources below. And finally, I want to mention that the user class contains many additional methods that you can use to link multiple auth providers to an account. And if this is something that you want to offer in your apps, then you can read this page for more details and implement your logic in a similar fashion to what we have done for the email verification feature. Okay, so let's continue on the next lesson. Section about Firebase authentication, and the end result is that we can now sign in and sign out using Firebase, using the UI that was already included in the starter project. And the way we managed to accomplish this is by implementing an auth repository that uses the Firebase auth APIs under the hood. And as we have seen, it has taken us a bit of effort to abstract away all the Firebase auth behind a domain-specific API based on the app user class. And if we take a look at some of these diagrams, we can clearly see that our implementation has multiple layers, and more moving parts compared to what we would have been able to accomplish using the built-in Firebase UI package. And in fact, our entire implementation of the authentication feature contains all these different files. And this is all code that we had to maintain. So we should really ask ourselves if this was worth it, or if we should just have used the Firebase UI auth package without going through all the trouble. And indeed, as far as authentication goes, it would have been a lot easier to just use the Firebase UI package and make the most of the built-in widgets that it gives us. But I think it was worthwhile to learn a bit more about the Firebase Auth SDK and get a better understanding of how things work under the hood. And by the way, if you want to do an exercise, you could try deleting all the authentication code from the presentation layer and replace it with some simple screens that use the built-in widgets from the Firebase UI package, so that you can get a sign-in screen that looks like this. However, keep in mind that if you do this, a bunch of widgets and integration tests will break, because they were relying on the old UI in our project. In fact, a good question to ask ourselves is it possible to write widget or integration tests for any flows that use the Firebase UI auth packages? And how can we mock the Firebase auth dependency so that we don't talk to the Firebase backend when we run our tests? And the answer is that yes, this is possible in theory. However, when I was testing this, I discovered one bug in the Firebase UI auth package that causes the widget tests to fail. And you can read more details about it on this bug report. So for now, keep in mind that until this bug is fixed, you won't be able to write tests that rely on the Firebase UI auth package. And once this is fixed, I'll write a new article about automated testing with Firebase UI, and I'll share it here. But for now, it's time for a wrap-up. And one thing I should mention is that while in this section we have covered the basics using email and password authentication, Firebase Auth contains a lot of different features, which are all listed in the documentation. And these include signing with Google, Apple, Facebook, Twitter, GitHub, as well as phone number authentication, custom auth system integration, and anonymous auth. And on top of that, you can upgrade your apps to the new identity platform, which includes all these additional features. And these are advanced features that are beyond the scope of this course. But for now, I just wanted to cover the basics and give you a mental model for how to integrate Firebase using this app architecture. And in fact, we continue to follow this architecture as we integrate additional Firebase features in the coming sections. And if you want to learn more about Firebase Auth, you can check the resources below. Okay, so let's continue on the next section where we'll talk about Cloud Firestore and Firebase Storage. I'm going to build a full image workflow using Firebase. And as you can see from this diagram, this is going to be a complex feature made of many different moving parts. In fact, in order to build this feature in its entirety, we'll have to learn about Firebase Storage, Cloud Firestore, as well as the Firebase Local Emulator and Firebase Cloud Functions. And the reason we are going to build this feature is that if we want to create a real e-commerce app with a dynamic product catalog, we should be able to upload images to Firebase, but only if we are an administrator that has the right permissions, while regular users should only have read-only access to this data. And using Firebase for this is much better than the solution that we have been using up until now, which is to hard-code all the product's data as a global variable inside the client app, and storing all the product images as assets inside the app bundle. So let me give you an overview of what we will build by the end of this section. And as we will see, the updated app will start with an empty page because initially the product catalog will be empty. But as an admin user, we'll get access to an admin page where we can manage the list of products that will be stored in Firebase. And from here, we'll get an option to add new products from a list of templates. And once we choose a product, we'll be able to upload it to Firebase Storage. And when this is done, we'll be able to edit all these product fields or add them from a template. And once we save, the product will become available and visible to all the users of the app. And as an admin, we'll get the option to add another product. Or if we prefer, we can edit an existing product. And if we want, we can delete it as well. So overall, the goal of this section is to implement this entire product upload workflow so that we can add, edit, and remove products using Firebase Storage and Cloud Firestore. And here is how we are going to tackle this. First of all, I'll share an updated code snapshot that will contain all the UI that we need for this feature. And then we'll figure out a plan of attack so that we can work out what kind of classes and components we need in order to build this feature. And then we'll start building all these classes one by one until we get a small working prototype. And then we'll polish our code and take care of all the small details so that our feature is robust and work under all edge cases. And as part of this, we'll learn about some interesting topics. such as how and when to use real-time listeners versus one-time reads with Cloud Firestore, how to implement basic security rules, and how to add a CORS policy to Firebase storage so that we can load the product images when we run the app on Flutter Web. And we'll wrap up this section with some exercises so that you can build upon what we have covered and customize the image upload workflows. And by the way, what I said earlier on is that only admin users should have access to this new functionality. And this means that if we want to make this feature secure, we need to implement role-based authorization with custom claims, which is something that we will cover on section 6. And before we do that, we need to learn about cloud functions as well, which is something that we will cover in the next section. So as you can see, by covering just one big feature, we'll get to learn about many different Firebase features. And as usual, we'll make an effort to write modular code and make the most of the app architecture that has served us so well up until now. Okay, so let's get started in the next lesson. We're going to configure Cloud Firestore and Firebase storage in the Firebase console so that we can use them to store the product data for our e-commerce app, rather than keeping everything hard-coded inside this k-test-products variable and loading all the images from local assets. And just to be clear, the main idea here is that we will store all the product metadata, which includes all these properties inside Cloud Firestore. But the product images themselves are files that need to be uploaded to Firebase storage. And to do that, we will upload each product image from the client app to Firebase storage. And in order to access it later, we will grab a download URL and write it to a document that will store all the product data inside Cloud Firestore. And for anything to work at all, we need to enable Cloud Firestore and Firebase storage for our project. So let's get back to our Firebase console. And then we can select Firestore database from the menu. And here we can choose this option to create the database. And as soon as we do this, we get this dialog asking us how we want to secure our database. And we get two options to start in production mode or in test mode. And as we said earlier on, for now we just want to get things working. So we can go ahead and start in test mode, and then we can click on next. And the next step is to choose a Firestore location from this dropdown. And for now we can go ahead and choose the default location, and then we can click on enable. And once we have done that, Firebase will go ahead and configure the project for us. And once it is done, it should take us to this page where we can start adding some data. And if for any reason this page doesn't load right after creating the project, you should be able to reload it directly from the browser. Like this. Okay, so before we move on, let's take a look at the rules tab. And what these rules are telling us is that reads and writes are enabled for all documents as long as they happen before this date. And for the time being, we can disable this time limit entirely by setting this condition to if true, like this. And then we can hit publish to save this setting. Though keep in mind that this is not a setting that you ever want to use in production, because it allows anyone who knows the location of your database to read and write to it. And once again, we will update this later. So this completes the initial configuration of Cloud Firestore. And next up, we can get back to our menu. And from here, we can select the storage feature. And on this page, we can read that we can use Firebase storage to store and retrieve user-generated files like images, audio, and video without any server-side code. So let's go ahead and click this option to get started. And once again, we get to choose how we want to secure our data. And like we said earlier on, for now, we just want to get things working. So let's go ahead and start in test mode. And then we can click on next. And now we need to choose our cloud storage location. And as we can see, this option is disabled because we have already done that when we have configured Cloud Firestore. And it just makes sense that the database and the storage live in the same location. So let's just go ahead and click on done. And this will create a default storage bucket for our project. And it will also set up some security rules. And once this is done, we end up on this page that we can use to upload files or create folders manually. So if we want, we can upload files manually by clicking on this button. And this will reveal the system file picker that we can use to upload the images that are already bundled in the Flutter app. So if I select a file, this will be uploaded to Firebase storage. And here on the right, we can see all the file metadata, as well as the file storage location. So if we wanted, we could choose to upload all the images by hand. But what we really want to do is to write some Dart code so that we can do this from the client app as an admin user. So for the time being, we can go ahead and delete the file that we have just uploaded. And as a next step, we can open the rules tab, where we can find the test rules that enable all reads and writes based on this time limit. And like we have done for Cloud Firestore, we can disable this time limit entirely by setting this condition to if true, and then we can hit publish. And once again, keep in mind that this is not a setting that you ever want to use in production, because it allows anyone who knows the location of your storage bucket to read and write to it. And once again, we will update this later. Okay, so this completes the initial setup of Cloud Firestore and Firebase storage for our project. And we can continue on the next lesson, where I'll share a new starter project that we will use going forward. In this lesson, I'm going to give you an overview of the starter project that we'll use in this section, since I've included some new code that we will use as a starting point to implement the new image upload flows. So let's get back to VS Code, and then we can open our terminal. And inside here, you should run git checkout starter image uploads, which is the name of the branch that we will use going forward. And if anything is not working for you at this stage, please check the notes below for how to resolve it. And next up, we can go ahead and open the pubspec.yaml file. And if we scroll down a bit, we can find that I've added Cloud Firestore and Fire Storage as additional dependencies, since we'll need both packages to implement all the required functionality. And all the remaining packages are the same as before. So this is a good time to go ahead and run the app. And in my case, I'm going to run on macOS. Though keep in mind that if you're on Windows, the only options you have at this stage are to use the Android emulator or Google Chrome, because Windows and Linux are not supported as build targets if you use Cloud Firestore in your app. And by the way, I would not recommend that you use Google Chrome at this stage, because Flutter Web doesn't support hot reload yet. And as we will see later on, we will need to do some additional configuration on web to ensure that the product images load correctly. So the bottom line is that if you're on Windows, you should use the Android emulator as your target device. So let me go ahead and make sure that I've selected the Launch Firebase configuration, and then I can start the build on macOS. And by the way, since we've just added Cloud Firestore, it might take a little while to start the app for the first time. And by the way, one thing that you should know is that I've updated the pod file for the macOS and iOS projects to ensure that we use the pre-compiled Firebase Firestore SDK. And this is something that is necessary if you want to speed up your Xcode build when you use Cloud Firestore. And if you want, you can learn more about this by reading this article on my website. Okay, so let's get back to VS Code, and we can open the debug console to check if the build is working. And one thing that you may see if you are also running on macOS or iOS is that the console log will show some red lines with some warnings. Though notice that these are only deprecation warnings, and they're not really something that you should worry about. And as long as the build completes, you should be good to go. And as you can see, my build has completed and the app is now running over here. And you should see that on the homepage, we get this label that says no products found. And just to be clear, this is intentional and not a mistake, because we'll have to figure out how to upload products using Firebase before they can show up over here. So as a next step, we can try to sign in with one of the accounts that we had previously created using Firebase. So let me sign in with email and password. And once we have done that, we should see that there is a new admin button on the app bar at the top. And if our device is quite narrow, then this ends up being an option that we can reveal with this dropdown. And if we select this option, then we end up on this page, which is also empty. But down here, we can find a new button that we can use to add a new product. And if we select this, we are taken to this page where we can add a product. And this is basically a screen that I've built so that we can choose a product from a template. And if we select any product from this list, then we end up on this page where we can try to upload the product. But as we can see, for the time being, this feature is not implemented. So for the time being, this is as far as we can go. But once again, by the time we get to the end of this section, we'll complete the implementation of the entire feature. And in fact, over here, I have the completed app, and I can use this to show you that once we select a product, we can go ahead and upload it. And once this is done, we'll get to this page where we can finalize all the product details. And once we hit save, then these are saved to Cloud Firestore, and the new product that we just added will end up on the homepage. And from the admin page, we'll be able to add additional product, or alternatively, we'll be able to edit existing products. And now that we have seen what is new in the app, as well as what we are trying to accomplish, let me give you a walkthrough of what's changed in the starter project. And a good place to start is by opening the products repository.dart file. And if you remember, this used to be an abstract class, which was not used, and the corresponding provider used to throw an unimplemented error. And in order to show a product list inside the home page, we used to override this provider inside the app bootstrap code and use a fake products repository instead. And by using this repository, we were able to show the products list by reading all the products from this global constant. But instead, I now made some changes so that we actually use this products repository. And as you can see, all these methods return either a feature or a stream with an empty list. And this is the reason why this page is empty. And it will be our job to figure out how to implement these methods using Cloud Firestore if we want the products list to appear once again. Alright, so next up I want to show you a small change that I made in the Home App Bar class, which is the widget that we use to show all these actions. And if we go to the build method and scroll down a little bit, we can see that I've added this new action called admin. And this is what we can use to navigate to the new image upload flows. And as you can see, we only show this action text button if this is admin user flag is set to true. And at the moment, this is just a placeholder value that is always set to true as long as we are signed in. But keep in mind that in the coming sections, we'll add all the necessary changes so that we can only navigate to the admin features if we have the right authorization level. And next up, it's time to look at the most interesting changes. And if we open the File Explorer and take a closer look at the features folder, we can see that over here we have a new feature called Products Admin. And at the moment, this contains data and presentation folders, which are usually the most important layers in our app architecture. So for the time being, let's focus on the presentation layer. And as you can see, inside here we have 4 different screens, which are all part of the product management flows. And to enable these new flows, I've also made some changes to our app routing code, which lives on this file. And as you can see, the app route enumeration now contains 4 new routes. And if we scroll down to the declaration of the actual routes, we can see this route called admin, and this has some additional sub-routes inside it, which are used to add, upload, and edit an existing product. And all the screens that are returned by these routes have all been created inside the presentation folder of the product admin feature. And if we want, we can take a look at each one of these screens. For example, when we open the admin page, we navigate to the admin products screen. And this is the screen that we use to show the Manage Products page, which is currently empty. And as we can see, down here we have this floating action button, which is used to take us to the Admin Products Add screen widget, which looks like this. And the purpose of this screen is to show us a list of products that we can choose from, with the intent of uploading them to Firebase storage. But how does this screen work, and where does it get the data from? Well, as you can see here, it is just a regular scaffold. And over here, we have a little bit of custom UI so that we can show this gray banner at the top. And the most important part here is this widget called Products Template Grid, which is used to show all these products. And if we go to the build method of this widget, we can see that what it does is to show all these products using this sliver products aligned grid. And it does this by loading data from this template products list provider. And this is a provider that is defined inside this file in the data layer. So if we open this file, we can see that at the top I've declared a template products repository. And all this does is to return an instance of the fake products repository that we are already familiar with. And down here we have this template products list function, which is used to generate a provider that returns a string containing a list of products. And all this does at the moment is to get the data it needs by calling the watch products list from the template products repository, which is declared over here. And now that we have seen this code, then perhaps this diagram makes a little bit more sense. Because what this shows is that the add product screen loads the data using this provider, which in turn gets it from the fake products repository. And in turn, this gets it from the global list of products that is hard-coded inside the app. And once we select any of these products, then we end up on this screen. And the work we are going to do in this section is to figure out how to take both the product data and the image and upload it to Firebase. So once again, the main idea here is that I've already implemented some of the logic for reading the data from the fake products repository. And it will be our job to implement this part on the right by uploading the data to Firebase. And in addition to the 2 screens that we had just reviewed, we also had this admin product upload screen and the admin product edit screen widgets. But I think it's best that we cover them in the upcoming lessons, since we are not yet using them in the starter project. Likewise, I'd like to mention that I've also included an image upload repository that we will use to upload images to Firebase storage. But as you can see, the implementation of this class is incomplete, and we will address this in the coming lessons. So this completes the overview of the changes that I've included in the starter project. And if you're feeling a little bit overwhelmed by all the new changes, then don't worry, and rest assured that we will cover things more in detail in the coming lessons. Okay, so let's continue on the next lesson, where we will get a better idea about how to build this feature and add the missing functionality. Of the updated starter project, I think it's a good idea if we take a step back and consider the requirements of the image upload feature as a whole, so that we can come up with an implementation plan. And since this is a complex feature, I think it's helpful if we try to break it up into smaller sub-features that we can tackle one at a time. And as we can see from this diagram, one of the first things that we'll need to figure out is how to upload images to Firebase storage. And once we are done with that, we'll also have to figure out how to write the remaining product data to Cloud Firestore. But uploading images and writing data is not enough, because we also need to figure out how to read the products data and images so that we can show the products list using Cloud Firestore as a data source. And as we will see, this will be easy to do using real-time listeners. And with this in mind, let's take a closer look at the UI flows that we're going to implement. And the easiest way to explain this is to show you the completed feature that we will build by the end of this section. So if we start from the Manage Products page, we can consider the flow that we will use to add new products. And as we're seeing, the way this works is that when we press on this button, we can choose a new product from a list of options. And once we select a product, we end up on this page that we can use to upload it. And finally, we end up on this page where we can edit the product details by entering these fields by hand, or alternatively, we can load them from a template. And then once we save, we can see that the product now appears over here. And from here, we can go ahead and add a new product. But if we prefer, we can edit an existing product, and this will take us to this page where we can edit all the details. And if we want, we can choose to delete the product as well. And if we do this, it will be removed from Firebase and disappear from the original list. So this is what we're going to implement. And as we make progress, I'll introduce some new diagrams that will guide us, so we have a better idea of where we are headed. And by the way, keep in mind that from my UI point of view, this is just one possible way of implementing an image upload flow. And of course, if your app has different requirements, then the sequence of screens may be different, and the source of images could be different too. For example, if you're working on a social media app like Twitter or Instagram, you could use different image sources such as the built-in camera, or images from your photo gallery, or other images that are stored in the local file system. And in addition to that, you might even want to add filters and other post-processing effects before uploading the image to Firebase. And for this reason, I think it's important that we write code that is modular, so that it's easier to support additional requirements in the future. And now that we have a clearer idea about what we are trying to accomplish, I think we should figure out what components and classes we should add to this feature. And once again, the first thing that we are going to tackle is how to upload images using Firebase storage, as well as how to save the download URL to Cloud Firestore. And as we already know, when it comes to talking to a remote backend, it is normally a good idea to create a repository class. But as we can see, we need to talk to both Firebase storage and Cloud Firestore to make things work. And while we could create a single repository to do all the work, I think our code will be more modular if we talk to two separate repositories instead, which I have called the image upload repository and the products repository. And the main idea here is that we could talk to the image upload repository for the image upload part and the products repository for creating a product and writing all the product data. And of course, once we have these two repositories, we also need to figure out what goes in the middle, so that we can trigger this new functionality from the UI layer. And for now, I don't want to share the entire solution just yet. And I think what I've shared here should be already enough to get started. So let's continue on the next lesson, where we'll focus on the image upload repository. So we're going to start implementing the functionality for uploading some images to Firebase storage. And to get started, we can head over to the image upload repository class that I've included in the starter project. And as you can see, this class has a Firebase storage property, which can be used to communicate with Firebase. And over here, we have this public method called upload product image from asset. And we will use this to upload an image asset to Firebase storage and return a download URL when it is finished. And in addition to that, I've also included this helper method, which takes the raw byte data from our image and then converts it into an array of bytes in this syntax. And then it uploads these bytes to this location using this code to ref.putData. And it also sets the content type. So as we can see, this repository already has some code inside it. And our goal is to complete this implementation. But where should the asset data come from? Well, if you remember, the app already contains a collection of product images inside this assets folder. And we also have a file called test products, which contains all the test products. And each of them has an image URL, which points to a path inside the app bundle that contains one of these images. And the idea here is that when we want to upload a product, we can call the upload product image from asset method by passing this image URL as the asset path argument. And we can also pass this ID to the product ID argument. And what this means in practice is that once this method is implemented, then we'll be able to upload all these assets to Firebase storage. Okay, so let's go ahead and implement this. So let's remove these two lines. And the first step that we need to follow is to load the image data from the root bundle. And we can do this by typing final byte data equals to await. And then we can type root bundle dot load with asset path as an argument. And if we hover over the root bundle, we can learn that this is the asset bundle from which this application was loaded. And that the root bundle contains the resources that were packaged with the application when it was built. And now that we have this byte data, we need a way to extract the file name that we will use to decide the upload location. And here is an example showing how the asset path may look like. So if we wanted to extract the file name, which is the last part of the path, we can declare a final components variable, which will be equal to asset path dot split, and we can use the / as the separator. And what this will do is to give us a list of 3 components, where the first one is assets, the second one is products, and the third one is the name of this file. And this means that we can extract the file name by getting the components at index 2, like this. And now that we have both the byte data and the file name, we can perform the upload by calling await upload asset, passing the byte data and the file name as arguments. And in turn, this will take care of uploading all the image bytes by calling this method. And if you're curious about what you can do with this ref object, you can simply type ref dot, and this will show you a list of all the supported methods. And if you're uploading an asset, like in this case, then put data is the right method to use. So keep in mind that Firebase storage gives you all the APIs that you need if you want to upload stuff. And one more thing that we can see is that this method returns an upload task. It's an object that you can use if you want to get progress updates. But in our case, we just want to know if the operation has completed. And we can do that by using await and then assigning the result of this expression to a final result variable. And what I said at the beginning is that we want our method to return a download URL, since we will need this to show the uploaded image in the UI. And to do that, we can return result.ref.getDownloadURL, like this. So this completes the implementation of our image upload repository. And in summary, we have now figured out how to load images from the application's root bundle and upload the image data to Firebase storage. And this is what we set out to do in the first place. But keep in mind that you can repurpose this repository if you want to support additional data sources. For example, you could use the image picker plugin for Flutter to pick images from the image library or taking new pictures with the camera. So it's up to you to decide what you want to use as the source of images. But for our purposes, we will load images from the root bundle. Okay, so let's continue on the next lesson where we'll make more progress with the image upload feature. Now that we have implemented our image upload repository, we need to work out how to use it so that we can upload the selected image when we press on this button. And since uploading an image is an asynchronous operation which takes some time and may even fail, what I suggest we do is that we write all the relevant code inside a controller class that will mediate between the widget class and the repository. So for now, we will implement things following this diagram. And once we are done, we will revisit our implementation and see if we can improve it. So let's get back to VS Code. And from here, we can open the Project Explorer. And inside the presentation folder, we can create a new file called admin product upload controller.dart. And one thing I'd like to mention is that this controller will be an async notifier from the RiverPod package. And we're going to use the RiverPod generator to automatically create the provider for us. So at this stage, we should open a terminal, and here we can run this command, flutter pub run build runner watch -t. And what this will do is to start build runner in watch mode so that it can generate any new providers as needed when we make changes. And the first time you run this, it might take a minute or so, and you'll probably see some errors in the project until the process is complete. But this is completely normal, and all the errors will go away as soon as the updated files have been generated. So at this point, we can close the terminal, but we will keep this process running. And now we can go back to our empty file. And what I suggest we do is to create a RiverPod async class, which is one of the available snippets. And then we can call this admin product upload controller, which extends $admin product upload controller. And in the build method, we need to update the return type to future or type void. And in order for any of this to work, we need to import the RiverPod annotation file. And we should also not forget to declare a part file using the RiverPod part snippet, like this. And this will automatically choose the correct file name for us. So let's go ahead and save this file. And under the hood, we should see that the RiverPod generator has created a new file. And we can find this on the File Explorer over here. And by the way, if you are not too familiar with all the shortcuts and snippets that I've been using to create this controller, I recommend that you read this article on my site, which explains how to speed up these kind of tasks using RiverPod lint and RiverPod snippets. Okay, so let's get back to VS Code. And here we can remove this return statement, since this build method doesn't need to do anything. And then we can focus on the logic for uploading a product. And to do that, we can create a method that returns a feature of type void, and we can call this upload. And this will take a product argument like this. And we can also mark this method as async. And in order for this to work, we can use the quick fix to import this file. And then inside this method, we can set the state to async loading because we are about to start an asynchronous operation. And then we can call await with ref.read image upload repository provider. And in order to use this provider, we need to import it. And this will give us access to the repository so that we can call upload product image from asset. And to this method, we can pass the product.image URL as argument along with the product ID like this. And now that we have done this, we can set the state back to async data with a value of null. And the reason I'm using null here is that we don't need to store any value inside the async data object itself, because this is enough to know if the operation was successful. And as a next step, we can add a to-do to remind us that on success, we should go to the edit product page. And this is something that we will handle later. And while we are here, I think it's also a good idea to add a try and catch statement. And then we can take all these lines and move them inside the try block like this. And then we can use this catch block, which also gives us a stack trace. And inside it, we can set the state to async error, passing the error and stack trace as arguments. And by the way, if you're familiar with my code style, you know that sometimes inside my controllers, I wrap the asynchronous call inside a call to async value.guard. And this can be quite useful because it means that we don't have to use try and catch explicitly and set the state to async data or async error. But as we will see in the next lesson, we're going to add some more asynchronous code to this method. And for this reason, using try and catch is a bit more flexible in this case. So let me remove this line. And with this, we have completed a minimal implementation of the admin product upload controller. And just as a reminder, what we said in previous lessons is that in addition to uploading an image, we should also store the download URL in Cloud Firestore so that we can retrieve the image and show it in the UI. So let's get back to VS Code. And if we want, over here, we can assign the result of this expression to a final download URL variable. And we can also add a to-do to remind ourselves that we want to save the download URL to Firestore. And this is something that we will tackle shortly. But for now, let's see if we can use this controller as it is from our widget class. So let's go back to our admin product upload screen. And if we scroll all the way down to this primary button, here we find some code that we need to uncomment. So let's go ahead and uncomment these lines. And we can also remove the old onPressed callback like this. And then we can import the admin product controller provider that was generated for us. And by doing this, we can get access to the notifier so that we can call the upload method that we have just created. And while we are here, we should also scroll up and we should uncomment these lines as well, since they help us to deal with error and loading states. So let's go ahead and remove this to-do comment, and we can also import this file, and we can remove this temporary variable like this. Now we are ready to save our file and see if we can test our implementation. So let me go back out and back into the upload screen just in case, to make sure that the controller is loaded. And then we can get back to the controller, and here I can save this file as well. And what I'm also going to do is to put a breakpoint after this line that gets the download URL. And then we can go ahead and press on the upload button. And as soon as the upload is complete, we can see that this breakpoint is triggered. And if we want, we can hover to inspect the value of the download URL, which includes both the project name as well as the location where we store the image. And as a proof that the image has been uploaded, we can copy this URL without the double quotes. And if we want, we can paste it on the web browser. And as we can see, this is now showing our image. And not only that, but if we go to the Firebase storage console, we can see that we now have this products folder that has been created. And if we click on it, we can find the file that we have just uploaded. So this is great progress because it means that we have been able to upload our image to Firebase storage. So let's get back to VS Code and remove this breakpoint. And then we can continue on the next lesson. In this lesson, we're going to continue with the image upload flows and learn how to store the download URL and product ID with Cloud Firestore. And this is a step that we need to complete before we navigate to the edit product page, which I've included over here. And if we get back to our architecture diagram, we can see that in order to complete the implementation of our admin product upload controller, we should also call a method to create a product using the products repository. Okay, so let's get back to VS Code. At this stage, we can head over to the products repository file. And as you can see, all these methods inside this class are not implemented yet. And this is something that we will need to address in the coming lessons. But for now, let's see if we can add a method to create a product. So let's scroll down a little bit and add some space over here. And then we can create a method that returns a feature of type void, and we can call this create product. And this will take the product ID and the string image URL as arguments. And now we need to decide where we want to write the products data using Firestore. And if we wanted, we could use a top-level collection called products. And once we have a reference to this collection, we can use the add method to add a new document. And this method will take a map of key value pairs, which will include our product ID along with the image URL, like this. And finally, we could add a return here, because this method returns a feature. And if we implement this method like this, what will happen is that every time we call it, it will create a document that will contain the ID that we want as a field. But the ID of the document itself will be auto-generated, because this is how the add method works. However, what I propose we do in this case is to use the product ID that was passed as an argument as the ID of the document itself. And the way to do this is to use a different syntax to access a document rather than a collection. And the location of this document should be products/ and then ID using string interpolation. And because this is now a document reference, then we can't really use the add method. And instead we should call set, like this. And if we hover on it, we can see that this is used to set the data on the document, overwriting any existing data. And if the document does not exist, it will be created. Okay, so this should work fine. And what it allows us to do is to use the same IDs that we have specified in this list of hard-coded products as the document IDs that we use to write to Firestore. And as we will see, this will make testing easier. So keep in mind that if you're building a large e-commerce app with a large product catalog, then maybe using auto-generated IDs is a better choice, so that you don't have to rely on any client-side logic to decide what IDs to use. And by the way, I want to point out that when we call the set method, we can also provide a set options argument. And when we do this, the data will be merged into an existing document instead of overwriting. And while this is strictly not necessary at the moment, I think it's probably a good idea to enable this so that we can preserve any existing fields if needed. And this will come handy for testing purposes. And we can do this by adding a set options argument, setting the merge flag to true, like this. And I'm also going to add a comment to remind us the purpose of this. Okay, so this completes the implementation of the create product method. And one thing we can notice at this stage is that if we open the Project Explorer, we now have an error inside the fake products repository. And that's because this class implements the product repository, and we are not overriding the create products method that we had just created. So let's go ahead and fix this quickly by adding the missing override. And as we can see, this has created a new method which throws an unimplemented error. And since we are focusing on Firebase, we are not really going to spend more time on the fake repositories. So we are going to leave this method unimplemented. In summary, we have now added the create product method to our repository so that we can write the product ID and image URL as a document in Cloud Firestore. And as part of this, we have decided to use the given URL as the ID of the document itself. And once again, sometimes this is what we want, but other times we don't really care or we can't decide what the ID should be. And in those cases, it's probably best to use auto-generated IDs. Okay, so let's continue on the next lesson where we will see how to use this method. We have added a create product method to our products repository. We can get back to our admin product upload controller and see if we can call it from here. So let's go ahead and remove this to do, and instead we can call await ref.read, passing the product repository provider as an argument, which we need to import from this file. And now that we have this, we can call create product, passing the product.id as the first argument, and this download URL as the second argument, like this. And now that we have done this, we can save and hot reload, and then we can try to test our code again. So let me get back and open this page one more time. And then from here, we can press the upload button. And as we can see, this operation seems to complete without errors. And to see if this has really worked, we can get back to the Firebase console and head over to Cloud Firestore. And at this point, we may need to refresh this page. And once this is done, we can see that we now have a top-level product collection. And this contains a document with ID equal to 1. And this document contains the same ID as a field, along with the image URL. And as we have seen before, we can copy this image URL and paste it on the browser. And this allows us to preview the image. And this means that this image really is downloadable and we can show it in our Flutter app. Okay, so this is great progress. And the next logical step that we should do at this stage is to navigate over to the edit products page if these operations are successful. So let me go ahead and remove this to do. And instead, here I can type ref.read, passing the Go router provider as an argument. And in order to use this, I need to import it. And once we have the Go router object, we can call Go named. And the first argument should be the name of the route that we want to navigate to. And we should also pass a parameter, which is going to be the ID of the product that we want to edit, like this. And now that we made this change, we can save and hot reload again. And then we can try to upload this image one more time. And as soon as this is done, we are taken to this edit product page. However, all we see here is this message telling us that the product is not found. And that's because inside the products repository, we haven't implemented the logic for reading products data from Firestore just yet. And by the way, if you're confused by this syntax that I've just used, I recommend that you read this article on my website, which explains different techniques for performing navigation without context using Go router. And the bottom line is that inside any controller class, you can access the Go router instance by reading the corresponding provider. And as soon as you do this, you can then call any of the navigation APIs, such as Go named. And this is very convenient. And before we move on and start working on this edit product page, there is a small bug that we need to fix. And to show you what I mean, I can open the debug console and clear it just for now. And I can also dismiss this page and start the image upload process once again. And once I'm on this screen, I can press on the upload button and then immediately click on the back button. And if I do this quickly enough, you can see that we get an error on the console that says bad state, feature already completed. And this happens on line 31 of our controller. And the reason this is happening is that inside this method, we are trying to set this state after these asynchronous calls. But the problem is that in the example that we have just seen, the controller will have already been disposed by the time we set the state and navigate away from this page. And if we were running this code inside the widget, we could easily check if the context was mounted, like this, before setting the state. But over here, we are inside an async notifier, and we don't have a context. And in fact, we don't have a mounted property either. And this is one scenario where RiverPod makes life a bit difficult. And this is something that I've explained in detail on this article on my website. So feel free to read this if you want to understand all the details. But for now, what we are going to do is to take a shortcut. And that is that in the declaration of our controller, we are going to add with notifier mounted, which is a mixin that I've included in the starter project. And as you can see, as soon as we add this, then we can access this mounted getter variable without getting any errors. However, in order to use this correctly, we need to get back to the build method. And here we need to use a provider lifecycle hook called ref.onDispose and call setUnmounted, which is a method that is also declared inside this mixin. And once again, this is what we need to do if we want to check that a notifier is mounted before setting the state. And if we want to test this again, we can open the debug console one more time and clear the output log. And then we can select a product. And this time we can see that if we leave the page before the upload has been completed, then we don't get any errors on the debug console. But we still get redirected to the edit product page, because here we're still navigating to this route, regardless of whether the controller is mounted or not. And this seems like the right thing to do, because we always want to land on this page after uploading a product. In fact, if it is certain that we are going to navigate to this page on success, then we might as well remove these lines entirely, because there is no need to update the state if we are going to navigate to a different page anyway. However, we do need to be a bit careful about the error case. And I'd like to suggest that it's a good idea to check if the controller is mounted, in this case, before setting the state when an error takes place. Though keep in mind that using the mounted flag in this way is not something that is recommended by the author or reader pod, but it works well enough for our use case. And if you want to understand this more in detail, you can read this article on my site. In any case, these are just small implementation details, so don't worry too much if this mounted stuff is not 100% clear. And what matters the most is that we have now completed the implementation of our controller, which is now used to upload the product image, as well as to create a product using Cloud Firestore. However, I think that there is one more improvement that we can make, and I'll show you what that is in the next lesson. In the last lesson, we have completed the implementation of our admin product upload controller class, and we have seen that we can use it to upload an image using the image upload repository, and create a product document in Firestore using the products repository. And as you can see, the resulting code uses two separate await calls. And if everything goes well, we can navigate to the next page. However, I'd like to suggest that if you need to make two or more asynchronous calls that may talk to different repositories, it's probably best to do so inside a separate service class that is completely independent from the UI. And this can be more easily tested and can improve code reuse too. And for this reason, I think it would be best to create a separate image upload service class that mediates between our controller and the repositories. And for the time being, this class will only contain a single method that we can use to upload a product. But as we will see in the coming lessons, we will also add a method that we can use to delete a product. So overall, it seems worthwhile to arrange things this way and create a dedicated class for this. And rather than spending too much time refactoring our code, I think it's best if I share an updated code snapshot that we will use going forward. So please go ahead and open a terminal, and at this stage the build runner process may still be running. And if we want to keep this running, what we can do is to open a separate terminal session using this button. And then inside here we can type git checkout image upload service. And if you have any local changes at this stage, you may want to discard them before you run this. Okay, so let's run this command, and this will update the project to the new code. And the first thing that we can notice is that our controller class is now significantly simpler, and it contains only one asynchronous call to this upload product method. And if we want, we can go to the definition of this method. And as you can see, this lives inside this image upload class, which I've added to the application folder inside our products admin feature. So as you can see, this is just a simple class that takes a ref argument, which is passed in when we create the corresponding provider, and we can use this method to upload the product image using this repository, as well as save the product data with this other repository. And this is exactly what I have represented in this diagram. In summary, we have now simplified our admin product upload controller by moving some of the asynchronous logic to a separate image upload service class. And we'll continue to use this class in the coming lessons, where we'll add some more functionality. And by the way, now that we've added all these classes, you may ask yourself if we should add some automated tests. And while this is a worthwhile endeavor, I already covered automated testing in detail in the Flutter Foundations course, and you can go back to that course if you want to figure out how to add test coverage for controllers and service classes. But for now, we'll carry on working on the image upload flows, and we can continue on the next lesson. Lessons, we have figured out how to upload images using Firebase storage, and we have completed the implementation of this page. However, we have seen that as soon as the image upload is completed, we are redirected to this page that should be used for editing the product data. But at the moment, we only get a message telling us that the product wasn't found. So why does this happen? Well, as we can see, when we make this call to GoNamed to navigate to this page, then we are passing the product ID for the product that we want to load. And if we take a look at the corresponding route in GoRouter, we can see that this product ID is extracted from here, and then it is passed as an argument to the admin product ID screen widget. And if we open this screen, we can find that inside the build method, we get the product as an asynchronous value with this call to ref.watch by reading the product provider, which takes the product ID as an argument. And then we pass this value to this async value widget. And if the product is not null, then we show the entire content of this page. But if it is null, we just show a simple scaffold, which contains the message that we see over here. And since this is what we see in the app, then it means that this value must be null by the time this screen is loaded. But why is that? Well, if we open the products repository, we can see that there is a to-do here telling us that we need to implement all these methods. And in particular, we can see that this watch product method takes a product ID, but all it does is to return a string with a value of null. And since this is the method that is called by the product provider that we are watching in the widget class, then we won't be able to see any data on this page until we implement it. So let's go ahead and implement this. And rather than returning an empty string, we can type final ref equal to Firestore and get the document that is located at product/ID using string interpolation. And as it is, this expression will return a document reference, which contains a map of key value pairs. But since we don't want to work with maps directly, we can use the converter method to ensure that when we get a document from Firestore, then we return product.fromMap, and here we can pass the document data. And it's okay to use the assertion operator here, if we know that the product exists. And then we also need to implement the toFirestore callback, so that we can convert a product back to a map of key value pairs. And by the way, if you are curious to see how these serialization methods are implemented, you can just come and click on them to open their definition. For example, let's take a look at fromMap, which is a factory constructor for the product class. And as you can see, all I do here is to extract all these properties from this map of key value pairs. And note how I've added a default value to all these properties. And this is necessary in cases where we want them to be non-nullable, but it's possible that these values have not been set in Firestore. And this is exactly what is happening in our case, because when we first create a product, we only set the ID and the image URL, but not all the remaining properties. And by the way, note that since we are setting the ID as a key value pair over here, then we can extract it from map ID over here. Though if we didn't do this and only decided to save the image URL, then we would have had to extract the ID from the document snapshot over here and make this an additional argument of the factory constructor. So keep in mind that there are different ways to write and read the document ID. And in this case, I've chosen to store it as a key value pair. And as we will see, one advantage of this is that we can sort the data by ID if we want. And this also makes parsing data a bit easier. Okay, so let's get back on track. And in order to complete the implementation of this method, we need to return a string with a nullable product. And we can do this by returning ref.snapshots. But if we just do this, we get an error, because this method returns a stream of document snapshot, and instead the return type that we want is a stream of product. And to address that, we can use the map operator, and this will give us a snapshot that we can use to return snapshot.data, like this. So this fixes our problem, and the way this works is that every time the data changes on the backend, then a new snapshot will become available, and we can use it to return the corresponding product and update the UI. And now that we have completed this method, we can save and hot reload, and then we can test our code by uploading a product one more time. So let's go ahead and choose a product and try to upload it. And this time we can see that we get the product image along with these text fields that we can use to edit the metadata. And by the way, one thing that I'd like to point out is that this image is loaded from Firebase storage, and not from the assets that we have bundled in the app. And if we want to find out where is the code that loads this widget, we can open the DevTools using this button, and this will open the widget inspector window, and here we can use the selection tool and click on this image. And here we can see that this is a cached network image, which I'm returning inside this custom image widget. And in turn, this custom image widget is created inside a card that is part of the layout that we see on this page. So let me go ahead and close the DevTools. And one thing that we can notice is that when we return this custom image over here, we give it the image URL of the product as an argument. And this image URL comes from the value that we have stored using Cloud Firestore. So it looks like we can already load images from Firebase storage and show them on this page. And even though we haven't added the logic for saving the remaining product data, we should already see the products that we have uploaded in the Manage Products page. But this doesn't seem to be happening, and we still get this No Products Found label. And the reason for that is that we haven't implemented the remaining methods in our repository. So let's go ahead and do that in the next lesson. In this lesson, we're going to implement the remaining methods in the products repository so that we can show the correct products data in the UI whenever these methods are called. And as part of this, we'll talk about two different ways of reading data from Firestore. And the first way is to use real-time listeners using the Snapshots API, which is useful when we want our UI to update in real time. And the second way is to use get to read the data just once. And this can be useful in certain scenarios. And I think it's important to cover this topic so you get a better idea of the difference between real-time listeners and one-time reads. And to get started, we can try to implement this watch products list method, which returns a stream with a list of products. And this is what we use to show the products on this page. So let me go ahead and remove this statement. And instead, we can type final ref equals to firestore.collection. And in this case, we want to access the products collection. And since the serialization logic is the same as what we used over here, then we can copy all the converter code from here and paste it in here. However, this last line is different because this time we are iterating over a collection reference and not a document reference, like in this case. So what we had to do in this time is to return a ref.snapshots, and we should also call the map operator. And this will also give us a snapshot. But note how this is a query snapshot of type product, whereas this is a document snapshot of type product. So what we need to do in this case is to iterate through the documents of this snapshot, and then we want to map each individual document. And inside this inner map, we'll get a document snapshot that we can use to return the data inside it, like this. And one thing we need to be careful about is that this map will return an iterable and not a list. So if we want our code to compile, then here we need to convert this iterable into a list, like this. So in essence, what this entire statement does is to convert from a stream of query snapshot of type product into a stream of list of product. And it does this by extracting the product data from each query document snapshot that we get inside the inner map method. So keep in mind that the syntax to use changes depending on whether you're reading data from a collection or from a document. And now that we have implemented this method, we should be able to test it. So let's go ahead and hot restart. And this time we can see that we no longer have an empty screen, but instead we have two product cards over here. But we can also see that there is no title and the price is 0 because we haven't completed the functionality to edit products just yet. However, what I can show you is that if I go to Cloud Firestore, I can edit this product data manually. For example, here I could add a field called title and set it to bruschetta plate. And as soon as I save this, you can see that the title appears on the UI. And if I wanted, I could add a price as well, which I could set to a number with a value of 100, for example. And as soon as I do this, you can see that the price is updated as well. And the reason for this is that by returning a stream, then we are effectively working with real-time listeners. And this will guarantee that every time the data changes in Firestore, our UI will rebuild. On the other hand, if we are fetching the data using a method that returns a future, then the data will only be loaded the first time, but the UI will not automatically update when the data changes. And for reference, I think it's a good idea to learn how to implement one-time reads with Cloud Firestore. And to do that, we can remove this statement from here. Then we are going to copy and paste all this code so that we get a reference to our collection. But this time we are not going to use ref.snapshots, and instead we can type final snapshot equal to await, and then we can type ref.get. And what this will do is to return a future that contains a query snapshot. And because we are using await here, then we need to mark this method as async. And now that we have this snapshot, we can return, and then we can go ahead and copy all this code from here and paste it in here, like this. And with this, we have completed the implementation of this method. And this is a good time to highlight the similarities and differences between these two methods. In fact, we can see that both methods get a list of products from this collection. And as you can see, this code is identical and always returns a collection reference. But in this case, we call ref.get to fetch the documents as a one-time query. And in this case, we are accessing a stream that will emit a new value every time the data changes. And once again, the syntax for reading the data is different depending on whether you want a future or a stream. And at this stage, I'd like to point out that we have a lot of duplicated code because we are repeating this with converter logic every time. And I think this would be a good time to refactor this class a little bit. However, rather than doing this by hand, I think it's best if I share an updated code snapshot that contains a cleaned up version of this class. So please go ahead and open up a terminal. And since we just made some changes, I think it's best if we discard them by running git reset hard head. And then we can go ahead and run this command, git checkout cleanup products repository. And what this will do is to update the repository code to my latest changes. So let me give you an overview of what's changed. And as you can see, I've added two static methods at the top, which I use to reference the location of the product collection, as well as the corresponding document for a given ID. And you can see that I've also added two helper methods called productsRef and productRef with ID. And if we go to the definition of these methods, we can see that internally, they use the with converter syntax, like this. And in the case of the productRef method, I decided to order the results by product ID, so that all the products will show in a very specific order. And in addition to this, I've also added a default implementation for the search method, which is something that we will discuss later on when we talk about full text search with Algolia. But for now, all you need to know is that this is just a temporary implementation that works by reading the entire products list, and then it tries to filter the results by checking if any of the products have a title that contains the search query. And once again, this is something that we will tackle later on. And for now, the search bar on the homepage is still disabled. But as far as we are concerned, we are happy with the current implementation of the products repository, because this already allows us to see the products that have been added. In fact, if we want, we can get back to the admin screen, and then we can choose to add a new product, such as this one, for example, and then we can upload it. And once this is done, we can dismiss this page, and we can see that the new product appears on this page. And that's because the UI on this page is watching a stream provider that gets the data from the watch products list method that we have implemented. And once again, this is the beautiful thing about real-time updates, because we can write some data in one part of the app, and any other part of the app that listens to that data will automatically rebuild when the data changes. And by the way, in this lesson, we have seen how to retrieve the data from Firestore either as a future or as a string. But if you remember, when we talked about Firebase basics in the first section of the course, we have seen that another way to get data from Firestore into our UI is by working with queries. And in fact, back then we created this jobs query method that returns a query of type job that we can use to show all these items in the UI using a Firestore list view widget. And in fact, this Firestore list view widget was designed to take a query as an input. So if we get back to our e-commerce app, we could ask ourselves if this watch products list method should return a stream with a list of products, or if we should just return a query of type product instead, so that we don't have to write all this code to extract the data inside it. And this will certainly be possible. However, it would also mean that we would end up exposing the query type, which is Firestore specific, inside the UI layer. And if we want our UI code to be backend agnostic, then this is not a good idea. So as far as we are concerned, our repositories will only return futures or streams that will extract all the data from the underlying querying objects, so that we only expose domain-specific types to the rest of the app. Alright, so we have now reached the end of this lesson. And I feel that along the way, we have learned a lot of useful stuff about real-time updates versus one-time reads. And before we continue, I recommend that you watch this video on this page about real-time updates with Cloud Firestore, since it explains all the benefits of using real-time data in detail. Okay, so let's continue on the next lesson. In the last lesson, we have completed the implementation of the products repository so that we can see all the products that we have uploaded in the homepage. And this means that we can now focus on how to edit the product data so that we can write all these additional fields to Cloud Firestore. And the main idea here is that after uploading a product, we should enter all the product details such as the title, description, price, and available quantity. And in addition to this, I've also added an option to load these fields from a template. And as we can see, when we select this option, then all this data is preloaded so that we don't have to enter all these values by hand. So our next goals are to implement all the logic to save the product details, as well as to delete a product. So let's go ahead and open the admin product edit screen, which contains all the widgets that we see on this page. And if we scroll to the build method, we can see that if there is a product for the product ID that was given as an argument, then we return this admin product edit screen contents widget. And this is a consumer stateful widget that takes the product as an input. And if we scroll down a bit, we can see that this contains a bunch of text editing controllers that are used for the text fields that we see over here. And inside the init state method, we initialize all the text values from the properties of the product that was given as an argument. And this is important because we are using this page to create new products as well as to edit existing products. And the code inside the init state is what allows us to preload the product data inside these text fields. And if we scroll down a little bit, we can find this load from template method. And what this does is to load some product template data from this provider. And then it uses it to update all the text fields. And in fact, if we click on this button, we can see that this functionality is already implemented and all these fields become updated with the value that we get from the template. And if you're wondering where this data comes from, then the answer is the test products file, which contains this list of hard-coded products. And our code decides which product data to use based on the product ID that is passed to this provider. So this is just some helper functionality that I've added so that we don't have to enter all this data by hand. Okay, so let's scroll down. And here we can find this delete method, which is not implemented. And this is followed by the submit method, which attempts to validate the form, but it doesn't actually write the product data just yet. And if we keep scrolling, we can find the build method, which contains the entire UI for this page. And while this build method is quite long, there isn't really any special magic in here, because all we do inside here is to create a responsive two-column layout, which will arrange the image alongside these fields if the window is wide enough, or will default to a one-column layout otherwise. And if you scroll down a little bit more, you'll find that all these text form fields are just arranged inside a column. And you'll also see that each one of these text fields has its own controller, along with a validator. And all the validators are defined inside this product validator class that I've also included in the starter project. So as you can see, all the client-side validation happens inside this class. And each one of these methods is called directly by the validator callback that is included inside each one of the text fields. And if we keep scrolling a little bit more, we find this edit product options widget, which is a class that I've defined over here. And all this does is to show two custom text buttons that you can see over here in the UI. And when we click on these buttons, then the load from template and delete methods will be called. So as you can see, there is quite a bit of code on this file, but none of it is clever or fancy. And when it comes down to it, this is just a form with a bunch of text fields, along with some action buttons. And as you can see, some of the code in this file is commented out. And the reason for this is that in order to handle all these actions, we had to create a new admin product edit controller provider, which will contain an async notifier with all the logic that we need. And this is the same approach that we have taken when we have implemented the upload controller for the corresponding widget. So let's continue on the next lesson, where we will start implementing this. In this lesson, we are going to write a new controller class that we'll use to submit the data that we have entered in this form. So let's go ahead, and inside the presentation folder, we can create a new file called admin product edit controller.dart. And then inside it, we can create a new river pod as sync class, like this. And we can call this admin product edit controller, which extends the base class. And we can also make sure that the build method returns a future or of type void. And then we can go ahead and import river pod annotation. And we should also create a river pod part file, like this. And we should also remember that the build runner needs to be running if we want the river pod code generator to work. So make sure that you are running this command at this stage. And once we have verified this, we can go ahead and save this file. And as we will see, build runner will have generated the part file over here. And then we can remove this return statement from the build method because we don't need to do any initialization when the controller loads. And now we can start adding some methods to this controller. And the first method that we want to add will return a feature of type void, and we can call this update product, and it will take some named arguments. And the first argument will be a required product variable. And this represents the product that is already loaded, which will already contain the correct product ID and image URL. And then we can pass all the string arguments that we will get from these text fields. And this will be a required string title, as well as a description, a price, and the available quantity, like this. And then we can add a method body and also mark it as async. And in order for this code to compile, we need to import the file that contains the product class, like this. And then inside this method, the first thing that we are going to do is to declare a final products repository equal to ref.read with products repository provider. And we should also import this from the correct file. And what we want to do next is to create an updated product from the existing one. And we can do that with the copy with method by updating all these values, like this. And as you can see, the title and description are fine, but the price and available quantity properties have a problem, because the product class declares them as numbers, but the values that we get from the text fields are strings. And for this reason, we need to parse these strings as numbers before we can use them in the copy with method. So let me add a comment about this, and then we can declare a final price value equal to double.parse with the price that was given as a string argument. And we can also do the same thing with the available quantity, like this. And now that we have these values with the right type, we can use them like this and pass them to the copy with method. And this takes care of the type errors. And by the way, one thing that I'd like to point out is that these values are already pre-validated by the validators that we have applied to the text fields. And as a proof of this, we could try adding some letters to the available quantity field. And if we hit save, we get a validation error. And this will prevent us from submitting the form. And this means that this method will only ever be called if the validation is successful when we submit the form. And for this reason, we don't need to use a try and catch block to deal with parsing errors. And now that we have done this, we have an updated product that we can submit to our products repository. And we can add a comment here to clarify our intent. But as we can see, this products repository has a create product method that we have added before, but it doesn't have an update product method yet. So before we can continue here, we need to go ahead and add it. So for now, we can save this file, and then we can move over to the products repository file over here. And what we want to do is to add a new update product method that will be used by our controller. And this is quite easy to do because it's just a case of adding a method that returns a feature of type void, and we can call it update product and give it the product as an argument. And then inside it, we can obtain a ref, which will use the product ref helper method that we have declared over here. And then we can give it the product ID as an argument. And once we have this ref, all we need to do is to return ref.set, passing the product as an argument, like this. And what this will do is to set the data on the document overwriting any existing data. And then we can go ahead and save this file. And if we open the Project Explorer, we can see that we now have an error inside the fake products repository. And that's because this repository implements our products repository. And if we want to keep the compiler happy, we need to create the missing override, which will be added at the bottom over here. And like we said before, we're going to leave this unimplemented, since we just want to focus on the Firebase implementation for now. And now that our update product has been created, we can get back to our controller class. And now we can complete the implementation of this method by calling products repository.update product, passing the updated product as an argument, like this. But we need to remember that this is an asynchronous operation, and we need to update the state as well, like we always do inside our controllers. So let's go ahead and wrap this method inside a call to asyncValue.guard, like this. And this is an expression that we need to await so that we can assign it to the state variable. And before the asynchronous operation starts, we should also set the state to async loading, like this. And now that we have done this, let's add one more step, and that is to check if the operation has been successful by checking if state.hasError is equal to false. And if this condition is true, then I suggest that we should go back to the previous screen. And we can do this with a call to ref.read with goRouterProvider.pop, like this. And if we want to access our goRouterProvider, we need to import it, like this. And in addition to this, I think it would be a good idea to return a success flag to tell the caller of this method that everything went well. And if we want to do this, we should change the return type to a feature of type bool, like this. And with that, we have a working implementation of this method. And this means that we should be able to call it from our widget. So let's go ahead and find the submit method over here. And here we can remove this temporary dialog. And instead we can uncomment all this code, like this. And now that we have created our controller, all we had to do is to make sure that we import it. And as you can see, the way this works is that we use this notifier to call the update product method, passing along the old product along with the updated values from all the text controllers. And once this operation has completed, we can show a snack bar telling the user that the product has been updated. And by the way, I think we should do a little tweak to this logic, and that is to make sure that we check if the result is successful, so that we can add an if condition like this, and ensure that we only show the snack bar if this condition is true, like this. And now that we have done this, we can save and hot reload, and we can see if our code works as intended. And in fact, I think it's probably a good idea if we hot restart the app entirely, because we have just added a new controller. And now that the app has restarted, we can get back to the admin page, and then we can select one of these products, which still have a price of 0. So let me go ahead and select this, and then on the edit product page, I can load all these values from a template, and then I can hit save. And as soon as I do that, you can see that something went wrong, because an exception has been triggered. And if we take a look at the debug tab, we can try to get a better idea of what the issue is. And if we look at the stack trace, we can see that the code that triggered this exception is this line inside our controller, where we are trying to set the state after the product has been updated. But what is causing this problem, and what should we do? Well, as it turns out, the reason that we get this problem is that we don't have any active listener to this controller, because we haven't added any code to our widget class to watch the controller state. And this means that when we submit the product data over here, the controller is first created by this code to ref.read, but it is disposed immediately. And this causes an exception when we try to set the state after this async call has completed. And the way to fix this is to make sure that we watch the controller state in the build method of the widget. So let's get back to the widget class and scroll down to the build method. And as you can see over here, we find all this code that we need to uncomment, like this. And then we can quickly go ahead and fix these errors by removing this temporary variable. And we should also import our async value extension, and we can remove this to do as well. And then we can save our code and resume the execution. And if we want to test this once again, I think we should close this page and get back to this product one more time. And just to make sure that the data is getting saved, we could try to change the available quantity to 10, for example. And this time we can hit save. And as we can see, the page gets dismissed. And we should also see all the product data on this page, because this has been written to Firestore. And this proves that our controller is working as intended. And one thing I should point out is that we should probably check if the controller is mounted before setting the state after this asynchronous call. But this is something that we can leave for later. And once again, the most important thing is that we can save the product data to Firebase. In fact, if we want, we can open the Firestore console, and then from here we can go ahead and add another product. So let's go ahead and upload this. And as you can see, the product has already been created in Firestore with the ID and the image URL. And then in the UI, we can preload all these fields from a template. And as we can see, as soon as we hit save, then all these fields are written to Firestore as well. In summary, we have now figured out how to edit a product by entering all the required information using some text fields, and how to submit the updated data with a new controller class, which in turn uses the products repository to write the data to Firestore. Okay, so this is great progress, and we can continue on the next lesson where we'll see how to delete products. In this lesson, we are going to complete the implementation of the image upload flows, and the last thing that we need to tackle is how to delete products, which is a feature that is currently not implemented. And in fact, this is the last remaining to-do in our code inside the edit products screen. And the main idea here is that we should implement a new delete product method inside our controller. And if you remember, when we first implemented the image upload feature, we ended up with two repositories that can be used to upload an image using Firebase storage and to create the product data using Cloud Firestore. And when it comes to deleting a product, we also had to perform two separate operations because we had to delete the product image from Firebase storage and also delete the product data from Cloud Firestore. So what I propose we do is that we add some new methods to the controller, service, and repository classes that we have already created. And I'm going to keep this diagram over here for reference. Okay, so let's get started by opening the image upload repository. And all we have to do over here is to create a method that we will use to delete the product image from Firebase storage. And this method will return a feature of type void, and we can call it delete product image. And it will take the string image URL as an argument, because this is a property that is available inside our product class. And then we can implement this method by returning storage dot and call this method to get a reference from a URL. And here we can pass the image URL as an argument. And just to be clear, this gives us the same kind of reference that we can obtain when we call storage.ref. And now that we have this reference, we can just call .delete like this. And then we can go ahead and save this file. And this completes this part of the diagram. And next up, we can move over to the products repository. So we can add a method to delete a product. So let's go ahead and open this file. And all we have to do here is to create a method that returns a feature. And we can call this delete product. And we're going to give it a product ID as an argument. And then inside it, all we have to do is to call return with firestore.doc, passing the product path of ID as the location. And now that we have this document reference, all we have to do is to delete it like this. And then we can save this file. And just as a reminder, every time we add a new method to this class, then we'll get an error in the fake products repository. So let's go ahead and make sure that we add the missing override like we had done many times before. And then we can save this file. And with these changes, we have completed all the work that we needed to do in the repositories. And as a next step, we can move over to the image upload service. So let's open this in VS Code. And what we want to do in this case is to create a method called delete product, which will take a product as an argument. And this is going to be an asynchronous method. And then inside this method, we need to make two async calls. And the first one will be used to delete the image from storage. And to do that, we can call await ref.read with image upload repository provider. And once we have this, we can call delete product image, passing the product.image URL as an argument. And once this is done, we can also delete the product from Firestore by calling await ref.read with product repository provider. And then we can delete the product, passing the product.id like this. And if we take a closer look at these two methods, we can see that there are a lot of similarities. Because in both cases, we obtain the image upload repository and call a method on it. And then we call the products repository and call another method on it. And that's because when we create and delete products, we always have to talk to Firebase storage and Cloud Firestore. So strictly speaking, this is not simply an image upload service. And we could consider renaming it to something like managed product service or something like that. But for now, let's stay on track. And now that this method is ready to use, we can save this file. And then we can get back to the admin product edit controller. And then we can scroll to the bottom. And here we can add a new method that returns a feature of type void. And we can call this delete product and give it a product as an argument like this. And then we can mark this method as async and implement the method body. And as a first step, we can get the image upload service by reading image upload service provider, which is a provider that we need to import. And then we need to implement the rest of this method, which is going to be very similar to the update product method that we have created in the previous lesson. So to make our life easier, we can select all these lines, and then we can go ahead and paste them in here. And the only thing that we need to change is that inside the async value.guard closure, we can replace this code with image upload service .delete product, passing the product as an argument, like this. And then we can save our file. And now there is only one last step that we need to follow, and that is to get back to our widget class. And then we can locate the delete method. And inside here, we can delete all the old code, and instead we can uncomment the new code. And with this, our implementation is complete. And we have implemented all the code that was needed inside all these different layers. So if we want to test this, we can get back to our Firebase console, and then we can get back to our app. And then we can choose to delete any of these products. For example, I could choose to delete the last product that I've added. And I can do this by clicking on the delete product button and confirming my selection. And as you can see, we are now getting the same future already completed exception that we have seen before. And if we take a look at the call stack, we can see that this is triggered when we call this line to set the state after deleting the product. And by now, we know that this happens because the controller has been disposed by the time we set the state. And the reason that the controller has been disposed this time can be found in the build method of the admin product edit screen widget. And what is happening here is that as soon as the product has been deleted, then this stream provider will rebuild because the product is now null. And this will cause this placeholder widget to be returned, which is what we see over here. And this also means that the admin product edit screen contents widget has been unmounted along with the controller that it was listening to. So once again, if we want to prevent errors like this, it will be safer to check if the controller is mounted before setting the state. So for now, let me just go ahead and resume the execution. And then I'm going to do a temporary fix, which is to assign the result of this expression to a final value variable that I can check over here. And we will deal with this specific edge case properly in the next lesson. But for now, we can save this controller, and then we can try to test this flow once again. So let me go ahead and select this product, and this time I should be able to delete it without any errors, like this. And as you can see, the product that we have just deleted no longer appears on this screen, and it has been removed from Cloud Firestore 2. Not only that, but if we open the Firebase storage console and open the products folder, we can see that there are only 2 images left. And this confirms that everything works as intended. In summary, we have now completed the image upload flows so that we can save products data on the backend using Firebase storage and Cloud Firestore. And because this was a fairly complex feature, we have split it across multiple layers following our usual app architecture. And as a result, each one of these classes is relatively small in size and doesn't have too many dependencies. For example, the image upload repository class only has 2 public methods and only takes Firebase storage as a dependency. And as you can see, the image upload service is relatively simple as well, because all it does is to execute some simple business logic by delegating some specific implementation details to these repositories. So overall, I like that each one of these classes is small and testable. And another thing I like is that since our project is structured with a feature-first approach, then most of the code for this feature lives inside this folder rather than being scattered all over the place. Though I should point out that in the process of implementing this feature, we have also added some new methods to our products repository called create product, update product, and delete product. And as a result, this repository now contains some methods for fetching the products list, which is something that all users should be able to do, as well as methods for creating, updating, and deleting products, which is something that only admin users should be able to do. And if we wanted to have a more clear distinction between these 2 sets of methods, then perhaps we could have put these 3 methods inside a separate repository that will live inside the data folder of the products admin feature. However, since all these methods are used to read and write to the same products collection, then I felt that it would make more sense to keep them together inside the same repository. And the bottom line is that sometimes it's hard to create features that live completely in isolation from each other, because features that may be separate in the UI may require access to the same repositories from the data layer. And ultimately, there is always going to be a bit of crossover between features. And my best advice for you is that you follow a specific app architecture and project structure like we are doing in this course. But always remember to be pragmatic and note that you'll have to make some trade-offs as you build your own apps. Okay, so let's continue in the next lesson where we're going to make some final tweaks. Last lesson, we have completed the image upload flows, but there are still a few small improvements that we should take into account if we want to polish this feature. And the first improvement is that when we choose a product from a template, we should only show the products that have not been added yet, rather than the entire list. And the second improvement is that we should make the edit product feature more robust, so that we don't get any exceptions, and our UI works as intended when we delete products. So in the next couple of lessons, we'll take care of these improvements, and I'll also share an updated code snapshot that contains the completed code for this section. Okay, so let's get started. And the first thing that I want to point out is that if we already have some products, such as these ones, and we choose this option to add another one, then this list of templates contains the products that we have already uploaded. And this is a bit confusing, and it would be best if we could filter out the products that have already been added to this list. And the best way to do that is to open the template products providers.dart file. And this contains this function, which contains the stream provider that is used to return this template products list. And as you can see over here, I have a to-do with some code that I've written exactly for this purpose. So let's go ahead and select all these lines and uncomment them. And we can also remove the old code like this. And one thing you can notice is that over here I'm calling this combine latest 2 method, which comes from the rx-dart package. And if we want to use it, we need to import it like this. And the way this code works is by obtaining both the list of template products and the list of existing products as streams. And then it merges them using this combine latest 2 method. And then inside this closure, we get the list of template products, as well as the list of products that we have already uploaded. And what we can do here is to return the list of template products by filtering out the existing products using this where clause. And if we want to see how this code works in practice, we can save and hot reload. And from here, we can choose this option to add the new product. And as you can see, the old products that we had already uploaded are no longer on this list. And from here, we could go ahead and add another product by following the usual steps. And once this product has been saved, we can choose to add another one. And as you can see, only the products that have not been uploaded will appear on this list. And if you want, you can go ahead and repeat this process until all the products have been uploaded. Okay, so this takes care of improving the logic for loading the template products. And one important takeaway from this example is that if you ever need to combine one or more streams inside a provider, you should probably use combine latest, because internally this listens to both input streams and emits an output value as soon as either of the input streams emits a value. And if you want, you can check this diagram on the RX Marbles website to better understand how this all works in practice. And if you're looking for a more complete tutorial about how to use combine latest with Firestore, you can check this page on my website. And I'll leave links to both of these resources in the notes below. Okay, so let's continue on the next lesson. I want to focus on the edit product screen and show you how we can fix one of the problems that we experienced in the previous lessons. So let's get back to the admin product edit controller, which is used to update or delete products from this page. And if you remember, when we added this method to delete a product inside this controller, we noticed that we were getting an exception if we tried to set the state directly on this line. And what we said back then is that this exception was caused because the controller was unmounted by the time this asynchronous operation had completed. And to prevent this exception, we decided to not set the state and just assign the result to a local variable instead. And in addition to that, we also discovered a minor UI problem. And that is that when we delete a product, we get this product not found label very shortly before the page is dismissed. And this happens because inside the admin product edit screen, this provider emits a new value with a null product as soon as the product is deleted from Firestore. And this happens because under the hood, this provider loads this data from a stream, which comes from a method that is declared inside our products repository. And this method is called watchProduct, which we can find over here. And after studying this problem more in detail, I came to the conclusion that inside this widget class, we should be using a future provider and not a stream provider. And this will also have the benefit of preventing unintended widget rebuild while the user is editing the form data. And as it turns out, if we want to fix this problem properly, there is quite a bit of refactoring that we need to do. And for this reason, I decided to share a new code snapshot that contains the completed code for this section. So please go ahead and open a terminal. And inside here, you can discard any changes you may have with git reset hard head. And then you can run git checkout image uploads complete. And this will update the project to the latest code. And one thing that we can see right away is that the code inside this widget has changed. And what happens now is that inside the build method, we are watching a product future provider. And internally, this gets its data from this new fetch product method that I've added to the products repository. And as you can see, this method returns a future, while the watch products method returns a stream. And if we scroll down closer to the bottom of the file, we can see that I've declared two functions that will be used to generate the corresponding product stream provider and product future provider. And this means that inside our widgets, we can choose to use one or the other depending on what we are trying to accomplish. And in this case, we said that it's best to use product future provider to prevent unintended UI rebuilds while the user is editing. Though if we do a project-wide search for product stream provider, we can see that there are other places where we use the product stream provider instead. And the main takeaway here is that depending on what we are trying to do, we can choose to use real-time listeners by watching a stream provider if we want our UI to rebuild when the data changes. But if we want to load the data and build the UI just once, then we should use a future provider instead. And while I recommend to use real-time listeners by default, there are cases such as when we are editing a form, where doing a one-time read may be best. Alright, so what does this all mean in practice? Well, now that we have the completed code, we can try to hot restart the application. And then we can get back to the admin feature. And from here, we should be able to go ahead and add a new product. And once we get to this page, we should be able to go ahead and delete it. And as soon as we do this, the page is dismissed without the product not found UI, which was a bit confusing. And by the way, there is one last thing that I want to show you. And that is that inside the admin product edit controller class, I've added a notifier mounted mixing. And this makes it possible to check if the controller is mounted before attempting to set the state and going back to the previous screen. And this is something that makes our app more robust against situations where the user closes this page before this asynchronous operation has completed. And with these latest changes, we have now completed the implementation of our image upload flows. And if you want, you can do some manual testing on all these different pages. And you should see that everything is working as intended, including the edge cases that we talked about. And while our code is complete, there are two additional things that I want to discuss in the next lessons. And these are security rules and adding a course policy for Flutter Web. So let's continue on the next lesson. In this lesson, we need to talk about one very important topic, and that is security rules. And the reason we need to talk about this is that at the beginning of this section, we decided to disable all security rules both for Cloud Firestore and Firebase storage. And while this may be fine for testing purposes, it is definitely not a good idea if you are planning to launch your app to the public. Because as it stands, anyone who knows the location of our cloud storage bucket has full read and write access to it. And since this is an e-commerce app, it makes sense for all users to have read access to the product's data, even if they're not authenticated. But when it comes to writing data, only admins should be able to do that. And we will only be able to set the correct permissions once we implement role-based authorization in the coming sections. But for now, the least we could do is to only enable write access for users that are authenticated. So let me show you how to do that. And as you can see, at the moment, everyone has read and write access to all the paths inside our storage bucket. However, we have decided that we are only going to upload products inside this folder. And for this reason, it makes sense to modify this match condition so that we can only read and write data from /products/ID inside curly braces. And now that we have restricted access to this location only, we should make a change to who is allowed to read and write. And what I suggested before is that everyone should be allowed to read, and this can be accomplished with this line. And for now, we can set things up so that only authenticated users can write. by adding a condition that says if request.auth.uid is not equal to null, like this. And once again, later on we will implement role-based authorization. And at that stage, we'll be able to replace this rule with a stricter one that will only give access to admin users. And in fact, I can already show you what that rule looks like. But for now, I'm going to have to leave this commented out because we haven't implemented role-based authorization just yet. And now that we have made these changes, we can go ahead and publish them like this. And next up, we can move over to Cloud Firestore. And once again, we can go to the Rules tab. And here we should be able to set up similar rules. So rather than matching on every single Firestore document, we should match on products, / and then ID within curly braces. And we should allow all users to read the data but not write it. And then we can give write access only to users that are authenticated, like this. And once again, what we really want to do is to give access only to admin users. So let me add a comment about this. And then we can go ahead and publish these changes. And at this stage, we should be able to go back to our app and verify that the image flows still work as intended. So let's try to upload a new product like this. And once we get to the edit product page, we can load all these fields from a template and we can save the product. And as you can see, this now appears on the list of products, as well as on the home page. And if we go back to the data tab inside Cloud Firestore, we can see that we have 3 products inside this collection. In summary, in this lesson, we have improved the security rules both in Cloud Firestore and Firebase storage, so that only users that are authenticated can write product data. And while this is better than giving full write access to the public, we still need to improve this so that only admins have write access. And we'll only be able to achieve this once we add role-based authorization in the coming sections. And in general, a good rule of thumb is that you should make your security rules as strict as possible, and we'll get some more practice doing this in the coming sections. And by the way, feel free to check the resources in the notes below, where you can learn more about security rules. Okay, so let's continue on the next lesson. I'm going to talk about displaying images on Flutter Web, which is something that requires some additional configuration when we try to load images from Firebase storage. And as part of this, we will talk about cross-origin resource sharing, which is also known as CORS. And this is a security feature that is built in inside all modern browsers. And this is designed to prevent websites from making HTTP requests to other sites. And chances are that if you try to run a Flutter web app that loads images from Firebase storage, you'll come across some errors that are related to CORS. And in this lesson, I'm going to show you how to deal with it. In fact, a good place to start is by trying to run our e-commerce app on Flutter Web and see what happens. So let's go ahead and select Google Chrome as a build target. And then we can try to run the app and see what happens. And we can also open the debug console as well. And this may take a little while. And as you can see, as soon as the app starts, we end up on the home page, but all the product images are not loading. And if we head over to the debug console, we can see some errors telling us that we failed to load the network image. And this also tells us that if you're trying to load an image from another domain, then we should go and visit this page. And this is exactly the page that I was showing you at the beginning of this lesson. And when it comes to CORS, we can find some generic information on this page. But what we really need is a guide telling us how to solve our issue. And luckily, there is a Stack Overflow question that points us in the right direction. And if we scroll down a little bit, we can find some answers with instructions telling us what we need to do. So let me show you how to do this step by step. And the first step is that we need to go to the Google Cloud Console, which is located at console.cloud.google.com/home. So let's go ahead and do that. And once the page has loaded, this is what we should see if we are signed in. So make sure that you are signed in with the Google account that you use to manage your Firebase project if you want to proceed. And once you have done this, the next step is to click on this button, which is called Activate Cloud Shell. And what this will do is to start a new Cloud Shell terminal where you'll be able to run some commands. And if you've never done before, it might take a little while for this to load. So just be patient until the terminal is loaded. And once you get here, you should see that a specific Cloud Platform project has been loaded. And this is the same as the project that is selected on this drop-down here at the top. And if you want, you can switch to a different Firebase project using this command. But as far as we are concerned, this doesn't matter too much. And what matters is that we go ahead and follow the instructions in the Stack Overflow answer. And what this is telling us is that we need to run this command, which you can copy and paste from the notes below. And then we can get back to the Cloud Console and we can paste it in here, like this. And then we can get back to Stack Overflow once again. And then we need to run a second command. And once again, feel free to copy this from the notes below. And then we can get back to GCP and we can paste this in here. And before you run this, note how the last argument should be the location of your storage bucket. So before you run this command, make sure that you go back to your Firebase project. And from here, you should select the storage page. And here you can find the name of your storage bucket. So make sure that you copy this location from here. And then you can get back to GCP. And here you can delete this temporary argument and paste the correct value from your Firebase project. And now we can go ahead and press enter to run this. And at this point, we should authorize Cloud Shell to execute this command. And now that we have done this, our configuration is complete. And this means that we can go back to our Flutter web app. And at this stage, we should be able to reload this page. And we should see that now all the images are loading correctly. And this is possible because we have updated the CORS policy of our storage bucket. And this means that our Flutter web app can now load all the images that we have uploaded to Firebase storage. And by the way, one thing that I'd like to point out is that when we have configured our bucket, we have set the origin field to this wildcard argument. And what this means is that any website on the internet is allowed to load images from it. And I think it would be best to restrict this policy only to certain domains. For example, during development, we could restrict the origin field only to localhost, so that we can only load images from this domain. So let's go ahead and do this. And then we can run this command again to update the settings. And now we can go back to Google Chrome and reload the page once again. And we should see that the images are still loading. Though keep in mind that if you deploy your Flutter web app to a specific domain, then the images will stop working again, and you'll have to update the CORS policy one more time to include that domain. Okay, so this wraps up this lesson about CORS configuration and loading images from Flutter storage on web. So let's continue on the next lesson. The end of this section about image uploads. And along the way, we have learned a lot of useful stuff about Firebase storage and Cloud Firestore. And because this was a complex feature, we ended up creating separate widgets, controllers, services, and repositories, each with their own specific job. And this was yet another example of how capable this app architecture is. And just as a reminder, when we were outlining the initial requirements, we decided to upload the product images that are already included as assets in the app bundle. But once again, if you want to use something else as the image source, you can use the image picker plugin for Flutter to load images directly from your device. And in fact, if you want to get some more practice with Firebase storage, I have a couple of exercises for you. And the first exercise is to try to build a new standalone app where the user can select one or more images using the image picker. And then you can upload these images to Firebase storage and keep track of the download URL using Cloud Firestore. And this app should also show all the images that you have uploaded inside the list. And this will be a great way to get some practice with all the concepts that we have learned. And if you want an even bigger challenge, there is a second exercise that you could consider, and that is to modify the e-commerce app so that each product can have more than one image. And as part of this, you would have to work out how to store more than one image inside Firebase storage, as well as how to keep track of multiple image URLs when you save the product data in Cloud Firestore. And as far as the UI is concerned, you had to show all the images inside a carousel in the product page so that users can swipe left and right to see them. And you would also have to modify the edit product page so that you can upload additional images for a given product. And I feel that this is a pretty challenging task, but it is a great way to get some practice with Cloud Firestore, Firebase storage, and learn how to put things together. And you can find some additional guidance about these tasks in the resources below. Alright, so I hope that you have enjoyed this section, and let's continue on the next one. Welcome to this new section where we'll learn how to work with the Firebase local emulator and get started writing cloud functions that can run securely on the server. And since the Firebase local emulator and cloud functions are two entirely new topics that we haven't encountered before, we're going to take a break from our e-commerce app and instead we are going to focus on the demo app that we've built in section 1, since this is a much smaller project and it's better suited to give you a practical introduction to these topics. So broadly speaking, this section is divided in two parts: local emulator and cloud functions. And in the first part, we'll start by learning about the Firebase CLI tool, which we can use to configure the Firebase local emulator and perform many other Firebase related tasks from the terminal. And we'll learn how to use the Firebase local emulator UI and see what are its differences compared to the Firebase console. Then we'll see how to connect our Flutter app to the local emulator. And we'll also learn about important features of the local emulator, such as the ability to import and export data. And then we'll move on to the second part, where we'll get started with cloud functions using TypeScript. And as part of this, we'll get familiar with how a typical cloud functions project looks like. And we'll go over important files such as package.json and eslint.rc.js. And we'll learn how to run and debug our cloud functions locally using npm. And then we'll get some practice writing our own cloud functions, with particular focus on cloud function triggers that are executed when a certain event happens, such as when a Firestore document is written. And we'll also learn how to create HTTP callable functions that can be called directly from our Flutter app. And by exploring these common use cases, you'll get a better idea of what makes cloud functions so useful. And as part of this, we'll also learn how to avoid infinite loops, which can happen when a cloud function writes some data to Firestore, which causes the same cloud function to be triggered again recursively over and over. And once we are happy that our cloud functions work as intended, we'll go ahead and deploy them so that we can use them in production. And we'll also get familiar with the Logs Explorer inside Google Cloud. And finally, we will learn how to set up a project budget so that we can limit our costs if things go wrong. So as you can see, we have a lot to cover, and along the way I'll share many additional resources that you can follow if you want to go deeper. And of course, we'll continue working with cloud functions in the coming sections as well, so you can learn how to add server-side logic to your Flutter apps. Alright, so let's get started in the next lesson. We are now ready to get started with the Firebase local emulator, and as I said in the previous lesson, we're going to use the demo project that we have created in section 1 as an example. So if you already have this project on your system, all you have to do is to open it in VS Code. And then you can open a terminal and run git reset --hard head to discard any working changes that you may have. And then you can run git checkout cloud functions starter to get the starter project for this section. On the other hand, if you no longer have this project on your system, you can do a fresh checkout of the official project on GitHub. And then you can follow the instructions that I've included in the notes below to get it up and running. And by the time you are done with this, you should see that inside the lib folder, you have this Firebase options.dart file that was generated with the Flutter Firebase CLI. And at this stage, you should be able to run flutter pub-get to install all the latest packages. And you should also be able to run the project. And if you're having any issues with this, please check the project FAQs for how to resolve them. And once the project is up and running, you should also be able to open the Firebase project that this app is connected to. And if you go to the Firestore database page, you should be able to verify that the data that is stored in Firebase is the same data that you see in the app. And as long as you use this Firebase project for development purposes, there's nothing wrong with connecting your app directly to it. However, you should know that you also have the option to spin up a Firebase local emulator that runs on your machine so that you can test your app with an emulated Firebase backend. And this is something that is quite handy in certain cases, especially when you start working with cloud functions. And we'll see exactly what I mean by that in the coming lessons. But for now, I just want to show you how to use the Firebase local emulator so that you can make the most of it for local development. And in order to set up and configure the Firebase local emulator, we need to use the Firebase CLI tool from the terminal. So as a next step, please go ahead and open the terminal. And the first thing that you want to do is to make sure that you have the right version of the Firebase CLI installed. So please go ahead and run firebase -- version like this. And if you have version 12 or above, then you're good to go. But if you're still running on version 11 or below, then you should upgrade by running npm install -g firebase tools like this. And the next thing that you want to do is to make sure that you're logged in with the Google account that you've used when you first created your project on Firebase. And you can always find that out by typing Firebase login. And assuming that you're already signed in, this will show you the Google account that is currently in use. And if you happen to have multiple Google accounts that you use with Firebase, you can always run Firebase logout and Firebase login again to select the correct one. And once you have done this, you can go ahead and type Firebase init. And as a first step, we need to choose which Firebase features we want to use. And in our case, the ones that we are interested in are Firestore, functions, and emulators. So make sure that all three of these features are selected, and then you can confirm by pressing enter. And then we need to associate this project directory with a Firebase project. And since we already have a project over here, then we should choose the default option to use an existing project, and then we can find and select the correct project from this list. And then the next step is to create a file that will contain our Firestore rules. So let's go ahead with the default value, and we should also do the same for the Firestore indexes file, like this. And then we need to configure the Cloud Functions project. And as we can see, we get to choose between JavaScript, TypeScript, and Python, but unfortunately, Dart is not an option. So let's go ahead and choose TypeScript. And we are also going to go ahead and enable ESLint for this project. And once we confirm, the CLI will generate a bunch of files for us. And finally, we can go ahead and install the dependencies with npm. And this is a process that can take a while, and you may have to wait a minute or two until it is complete. And once all the dependencies have been installed, we can move to the next step, which is to set up the Firebase emulators. And the ones that we're going to need for this project are the authentication emulator, the functions emulator, and the Firestore emulator. So let's make sure that we select those and we don't care about the remaining ones. And then we need to choose which port we want to use for each one of these emulators. So let's go ahead with all the defaults like this. And finally, we can go ahead and enable the emulator UI as well and choose the default port for it. And finally, we can go ahead and download the emulators like this. And with that, the Firebase initialization is complete. Okay, so it looks like the Firebase CLI has completed and it has created a bunch of new files for us. And I think it's a good idea to look at these files so we understand what they do and how to modify them if needed. So let's start with firebase.json, which we can find over here. And this is the main file that contains all the configuration and deployment options that are used by the Firebase CLI. And as we can see, this file contains three sections called Firestore, functions, and emulators, which are the Firebase features that we have selected earlier on. And as far as Firestore goes, we have these two files that contains all the rules and indexes that were already loaded in the Firebase console. And what I mean by this is that if we want, we can open the Firebase rules file, and we should see that the contents of this file match the rules that we had previously set up in Firestore. And this is quite handy because once we have these files in our project, we can add them to version control. And if we edit them, we can choose to deploy them directly using the Firebase CLI by running this command, firebase deploy --only firestore rules. In fact, you should know that the Firebase CLI is a very powerful tool that can do a lot of things. And if you run firebase --help, you can find out all the commands that are supported. And as you can see, this is a very long list. And we'll cover some of these commands in more detail in the coming lessons. Next up, let's move over to this file called .firebase.rc, which at the moment contains only one project, which is the Firebase project ID that we have selected when we run the Firebase init command. And one thing that I'd like to point out is that if you want, you can manage more than one project by running firebase use --add. And this can be quite handy if you have multiple environments for development, staging, and production. And one thing that I'd like to point out is that I've added this file to gitignore, because chances are that your project ID in Firebase may be different from the one that I've created. With that said, we can move over to the functions folder. And as we can see, over here we have a bunch of new files. In fact, this entire folder is a Node.js project, which contains its own configuration files, as well as a source folder, where we will place our cloud functions. So for now, we are not going to touch this folder since we want to focus on the Firebase local emulator first, but we'll get back to it soon once we start learning about cloud functions. And with that said, we have completed this overview about how to configure the various Firebase features from the command line using the CLI. And if you look at the notes below, you'll find some additional resources that you can use to learn more about the Firebase CLI. So let's continue on the next lesson where we'll start using the emulator. In this lesson, we're going to get started with the Firebase local emulators. And as part of this, we'll get some practice with the emulator UI and learn how to connect our Flutter app to the emulators And we'll also talk about exporting and importing data when we work with the emulator. And since we have done a lot of configuration in the previous lesson, I recommend that you get the latest code snapshot from the official project, as this will ensure that your configuration files are the same as mine. So please go ahead and open a terminal, and from here you can type git reset --hard head to discard any working changes, and then you should go ahead and check out this branch called firebase-init, so that you can get the latest project files, including a couple of additional configuration changes that I will explain in the upcoming lessons. And once you have done this, you can go ahead and start the emulator. And since we have already completed all the configuration steps, all we had to do is to type firebase emulators :start, like this. And as we can see, this is going to start the auth, functions, and Firestore emulators. And after a little while, we should get this information, telling us that the emulator is running at this URL. And we can also see where the various Firebase services are running. And by the way, I should point out that if you wish, you can change these settings in the firebase.json file, where you can edit both the port and the host for each one of these emulators. And by the way, what you can also see is that there was an error running the functions emulator. And this happens because we haven't compiled our Cloud Functions yet. But for now, we don't care about that. And we can go ahead and open the emulator by clicking on this URL. And this takes us to the emulator dashboard UI, where we can see which emulators are available and which ones are currently running. And if we want, we can choose the Firestore emulator, for example. And this takes us to a page with a very similar UI to the one that we get on the Firebase console. And this means that if we want, we can create collections and documents, just like we do on the Firebase console. And what is also handy is that we get this tab showing all the logs for the current emulator session. So this all looks good, but let's not forget that we are building a Flutter app. And at the moment, this app is still connected to the real Firebase project that we can see over here. And any changes that we make in the app will be reflected on this project and not on the emulator. So how can we tell our app to connect to this emulator? Well, this is very easy, because all we have to do is to get back to VS Code and open the main.dart file. And over here, we can add a new function that returns a feature of type void, and we can call this setup emulators, and we're going to make it an async function. And then inside the function body, we can await for firebase auth.instance.useAuthEmulator. And this is a method that takes two arguments, where the first one is the host and the second one is the port number. And these two arguments should match the host and port that we can see on the terminal. And in order for this code to work, we need to import firebase auth.dart like this. And in addition to the auth emulator, we should also use the Firestore emulator. And we can do that by typing firebase firestore, which we can import from cloud firestore.dart. And then we can type .instance.use Firestore emulator. And once again, we need to pass the host number, and then we can look up the port number, which in this case is 8080. And we can use it over here. And by the way, one small detail that I want to point out is that the useAuthEmulator function returns a feature. However, the useFirestore emulator does not return a feature. And that is the reason why I've used await here, but not here. In any case, the important thing is that once we have declared this function, we should call it inside main. And the place to do that is after this call to initialize the app. So all we had to do here is to call await setup emulators, like this. And then we can go ahead and save this file. And since this is the first time that we use our Flutter app with the emulator, it might be a good idea to run it from scratch. So let's go ahead and do that. And once the app is up and running, we can notice that it's still showing the Firestore data from the real Firebase backend. And the reason this happens is that even though we have configured the emulators over here, the Firebase client SDK may still hold on to the cached data from the previous run. So keep in mind that if you ever want to switch from the Firebase backend to the emulator and vice versa, you should make sure to sign out before doing anything else. So let me go to the profile page. And as it turns out, I've just been redirected to the sign-in page. And the reason for that is that the Firebase SDK has figured out that something has changed and I'm no longer signed in. And as a result, I'm back here on the sign-in page. And now we can check if the Firebase emulator is working as intended by going to the Authentication tab And then we can try to create a new account on the Flutter app. So let's click on register. And then we can enter a dummy email, such as a@b.c, and a dummy password, such as test1234. And we can confirm that password as well. And then we can click on register. And we should see that a new account appears on the emulator UI. And if it doesn't, we can try to refresh the page. And as we can see, it is now showing as intended. Next up, we can head over to the Firestore tab, and then we can use the app to add a few items, like this. And soon enough, we should see that some data shows up on the emulator. And if we inspect this jobs collection, we can see that it contains the same data that we can also see in the app over here. And by the way, if you're having some trouble at this stage and you can't see any documents on the Firestore emulator UI, then check the notes below for more info. But assuming that everything is working for you, then you should see some documents and collections on this page. Okay, so let's continue on the next lesson, where we're going to talk about exporting and importing data. In this lesson, we're going to learn how to export and import data with the Firebase local emulator. But what do I mean by exporting and importing data, and why do we need it? Well, in the last lesson, we have connected our Flutter app to the Firebase local emulator, and we have managed to save some data using Firestore. And just to be clear, this data is only temporary and will only exist as long as the emulator is running. And what this means is that if we go back to the terminal, we can press Ctrl+C to shut down the emulator. And once we do this, we can see the emulator suite has been disconnected. And at this stage, it looks like our app is still working. But what I suspect is happening is that it's using the cached data from the Firebase client SDK. Though if we go to the profile page and sign out, then we end up back on the sign-in page. And if we try to sign in again with email and password, then we should get a network error because the emulator is no longer running. So keep in mind that when the emulator is disconnected, the Flutter app will work as if it's offline. Okay, so let's get back to VS Code, and what we're going to do next is to start the emulator again. However, this time we're going to append a new argument called --export on exit. And this is going to be equal to /seed, which is the name of a folder that will be used to export all the data that we have generated. And as we will see, this folder will be created when we quit the emulator. Okay, so let's press enter so that we can start the emulator once again. And once this is up and running, we should see that both the authentication and the Firestore pages are empty. Because every time we start the emulator, we have a clean slate, and the data from the previous run is not preserved. And this means that we need to register a new user account once again. So let's go ahead and do that by entering the same email one more time, along with the password. And if we refresh this page, we can see that a new user account has been generated. And then we can go to the Firestore page, and then we can use this button to save some new jobs, like this. And as we can see, the data has now appeared on this page, on the emulator. And by the way, if we want, we can click on this Requests tab. And this will show all the requests that have been made by our Flutter app. And now comes the interesting part, because we can get back to VS Code, and then we can press Ctrl+C to shut down the emulator. And then we can open the Project Explorer. And what we will find here is that we have a new seed folder. And this contains all the Firebase data that has been exported. And as you can see, all these files are grayed out because I've chosen to add this seed folder to the git ignore file so that you don't get merge conflict when you check out the code from my project. In any case, what is most important is that we can import this data again when we restart the emulator. So let's go ahead and start the emulator again. But this time, rather than exporting the data on exit, we can change this flag to import from seed, like this. And then we can press enter to start the emulator. And then we can get back to the Firebase emulator UI. And as you can see, inside the authentication tab, we have the user account that we created in the previous session. And just to prove that everything works as intended, we can go back to the sign-in page. And over here, we should be able to use the email and password that we had registered before, and we can sign in successfully. And when we land on the home page, we can see that all the data that we had generated before is available again, because this was also loaded from the seed. Okay, so let's do a summary of what we have learned. And the main takeaways of this lesson are that the local emulator suite gives us a convenient way to emulate our Firebase backend on our local machine. And as we have seen, it's very easy to configure our Flutter app to use the emulator, because all we had to do is to call these methods by passing the correct host and port numbers. And we have also seen that when we shut down the emulator, all the Firebase data is lost, unless we use the export on exit flag to save all the data to a local folder. And if we want to load that data again on the next run, we can use the import flag like this. So overall, it seems like the local emulator is easy to use and easy to configure. And if you want to use it in your projects, what you have seen so far should already help you to get started. And if you want to learn more about it, you can check the official docs, which explain what you can do with it in more detail. And what the docs also say is that you can use the local emulator suite to write different kinds of tests, including integration tests, where you use the local emulator suite as the backend rather than talking to your production backend. And as we're about to see in the coming lessons, one of the greatest advantages of the local emulator is that it makes it easy to develop and test your cloud functions locally. Okay, so let's continue on the next lesson. We are now ready to start learning about cloud functions. And if you remember, when we ran the Firebase init command in the previous lessons, we decided to add support for cloud functions. And as a result, this functions folder has been generated for us. And just to be clear, this functions folder is a Node.js project. And if you ever worked with Node.js before, you should be familiar with these files. In any case, I think it's worth spending some time going through them so that you know what is their purpose. And the first file we should look at is called package.json. And this is the equivalent of the pubspec.yaml file that you use in Dart. In fact, if we scroll down, we can find that it has a dependencies section. And as you can see, the two main dependencies that we are going to use are the Firebase admin and the Firebase functions libraries. And in addition to this, we also have some dev dependencies, which include things such as ESLint and TypeScript. And at the top, we have this scripts section, which contains a set of useful scripts that we can use to build, test, and deploy our functions. And we'll see how to use these scripts shortly. Next up, let's move to this file called .eslint.rc.js. And this is the equivalent of the analysis options.yaml file that we are familiar with. In fact, this is a file that can be used to set up our preferred linter rules for the project. And just to be clear, when I shared my updated code in the previous lesson, I have made some changes to this file to relax some linter rules so that we don't spend too much time fighting linter errors in the coming lessons. So if you want to make sure you're using exactly my same settings, you can open the terminal and then you can check out a branch called updated ESLint rules, like this. And once you do this, you'll see that you'll have the same rules that you can see over here. Next up, I want to focus on these subfolders. And as you can see, inside the functions folder, we can find node modules and SRC folders. And as far as we are concerned, we spend all our time writing cloud functions in TypeScript inside this file called index.ts. And as part of the build process, all our TypeScript files will be transpiled into JavaScript files, which will be stored inside a folder called lib. And since all the JavaScript files will be generated by the build process, they can be git ignored, as we can see from this local git ignore file. And in addition to this, there is also a node modules folder, which contains all the dependencies that are needed by our project. And as you can see, this contains a lot of dependencies. But as far as we are concerned, we are not going to touch this at all. And by the way, if you are wondering why I've chosen to use TypeScript, the answer is that if you want to write cloud functions for Firebase, the only languages that are supported are JavaScript, TypeScript, and Python. And out of these three, TypeScript is the one that is most similar to Dart, in that it offers strong type safety. And this helps us catch a lot of errors at compile time rather than at runtime. And this is particularly important when you write server-side code, because any code that runs on the server needs to be robust and secure. And if you are not careful and introduce bugs in your server-side code, you may wake up to a big bill to pay on Google Cloud. And to minimize the risk of that, I think it makes sense to use a type-safe language such as TypeScript. And by the way, if you are not familiar with TypeScript, I highly recommend that you install this Total TypeScript extension by Matt Pocock, which offers a TypeScript error translator that I found immensely useful to get past many errors in my code. So once again, make sure that you install this extension, as you'll find it very useful when you work with TypeScript code. And with that said, we have completed our overview of the functions folder. And before we continue, I'd like to mention that on my website, you can find this article, which offers a good introduction to Cloud Functions. And if you never used Cloud Functions before, I recommend that you give it a read. And you can find a link to this article on the notes below, which also include a list of useful resources that I found useful when I was learning about Cloud Functions. Okay, so let's continue on the next lesson. In this lesson, we're going to learn how to write a simple Hello World Cloud function and how to run it locally with the Firebase local emulator. And as part of this, we'll also learn a bit about modules in TypeScript and how the import and export syntax works. So as a first step, let's go ahead and open this file called index.ts, which was generated for us when we run Firebase init. And as you can see, this file is quite simple because it only contains a couple of imports, as well as some code that is commented out. So let's go ahead and uncomment this code. And before we attempt to run it, I'd like to explain how it works, so that you can become more familiar with how Cloud Functions work. And the essence of this is that this is a simple HTTP function that we can use to respond to a web request. So on the left side, we declare the name of the function, which is hello world, and this is assigned with this onRequest function that comes from the HTTP module that we have imported over here. And what we do inside it is to use the response object to send this string as a response back to the client. And since this is an HTTP request, we can also choose to send a status code of 200 to make it explicit that the request has completed successfully. But since 200 is the default status code, we can choose to omit it if we want. And as we can see, here we also use this logger, which we have imported from here, to log that the function has been called. And one thing that I'd like to point out is that when we import modules using TypeScript, we can use this structuring to only import the things that we need. Or alternatively, if we want to import all the things that are exported in a given module, we can use this syntax. And by the way, if you want to better understand how imports, exports, and modules work in TypeScript, I recommend that you read this page on the TypeScript documentation, since modules are quite different from how we import and export things in Dart. And as far as we are concerned, the main thing to remember is that when we declare a function like this, but without the export keyword, then this function will not be visible from the outside and will not be compiled as a Cloud function that can be invoked. So keep in mind that if we declare this function like this, it is just a function that is local to this file. And if we want to compile it as a Cloud function, then it needs to be exported like this. And now that we have covered the basics, let's see if we can compile this function and run it with the Firebase local emulator. And the first thing that we need to do is to open the terminal, and then we should cd into the functions folder like this. And then from here we can run npm run build like this. And what this will do is to build our project and transpile this file into JavaScript using the TypeScript compiler. And in fact, once this is done, we can see that the corresponding index.js file has been generated inside the lib. And if you're curious, you can take a look at how this generated file looks like. But this is not really relevant for our purposes, since we can trust the TypeScript compiler to do the right thing. On the other hand, what we are really interested in is how to run this function. And if we want to do that, then we need to be able to serve that function from somewhere. And we can do that by running the Firebase emulator. So let's go ahead and run Firebase emulators :start. And then we should pay some attention to the output log. And if we take a closer look, we should see that an HTTP function was initialized. But how can we call it? Well, one easy way to do this would be to simply click on this URL, like this. And we should see that a browser window opens with the text hello from Firebase inside it. But what we can also do is to open a new terminal using this button, and then we can call the function directly using the curl command by copying this URL from here and pasting it in here. And once we do this, we can see that we get the hello from Firebase text on the console. And one thing that you may not know is that there is an even simpler way to run the function, and that is by using the npm shell, which is a way to run JavaScript code from the console. So let's make sure that we are inside the functions folder like this, and then we can type npm run shell like this. And once we do this, we get a couple of warnings telling us that we shouldn't run the Cloud Functions emulator and the function shell simultaneously. But for now, we can ignore this, and as you can see, here we get a prompt on the terminal. And this means that we can start typing the name of the function and get this nice autocomplete behavior. So let's press tab, and then we can add open and close parentheses. And if we press enter, we can see that the request has been sent, and we get this log from Firebase, and we also get this response as expected. So keep in mind that when you create HTTP functions such as this, there are many ways to run them. And now that we have tested this, we can press Ctrl+C to exit the npm shell. And if you head over to the package.json file, you can find this collection of useful scripts that you can run using npm. And if you want to run these scripts, all you have to do is to type npm run followed by the name of the script that you want to execute. In summary, in this lesson, we have seen how to write a simple Cloud function that responds to a web request, as well as how to compile and run this function using npm. And along the way, we have learned a little bit about modules, import and export using TypeScript. And with these basics in place, we can go ahead and start writing useful Cloud functions that can interact with our Firebase project. So let's do that in the next lesson. Now that we have learned how to create a simple HTTP Cloud function, we are ready to tackle something that is a little bit more complex, but also more useful. In fact, in this lesson, we are going to learn how to write a Cloud function trigger that is executed when some data changes in Firestore. And to get a better idea about what triggers are useful for, you can consider this diagram on my website, which explains that in general, Cloud functions are triggered in response to events. And there are many different types of triggers that you can use, which are all covered here. And I've also included some examples to give you a better idea of what you can do with triggers. For example, you may write an authentication trigger to send a welcome email when a new user signs in, or perhaps generate a thumbnail when a user uploads an image to Firebase storage, or even receive an email or a Slack notification when there is a new issue in Crashlytics. And these are all examples of logic that should be executed server-side. And when you think of it, it wouldn't make sense to perform these operations on the client, either because it's not reliable or convenient or safe to do so. With that said, we can get back to VS Code and get started writing our first trigger. And since we are still getting started, I suggest that we implement a very simple trigger. And the idea here is that this trigger will fire every time a document is written to Firestore, which is something that happens when we add or update jobs from our application UI. And what this trigger will do is to take the job title from Firestore and convert it to uppercase, and then write the result back to Firestore. And what we should see is that since our Flutter app uses real-time listeners, then the UI should rebuild as soon as the data is updated in Firestore. So let's go ahead and try to write this trigger. And since we are no longer going to need all the old code, we can delete everything that is currently on this file. And then we need to start with 3 import directives. So let's go ahead and import star as admin from Firebase-admin within double quotes. And as we will see, we will use this to initialize the Firebase admin SDK. And we should also import the logger from Firebase functions /logger, just as we were doing in the previous example. And then we're going to import star as functions from Firebase functions /v2. And what this v2 is telling us is that we are going to use the second generation of Cloud functions, which are now recommended in the Firebase docs. And if you want to understand what are the differences between the first and second generation, you can read all the details on this page. Okay, so let's get back on track. And the next thing that we want to do is to initialize the Firebase admin SDK. And we can do that by typing admin.initialize app like this. And before we go ahead and do anything else, let's open the terminal where the emulator is running, since I want to show you something. And then what we can do is to save this file. And we can see that as soon as we do this, we get this log from the emulator telling us that we loaded the function's definitions from source. However, the hello world function no longer exists. And it would be nice if the Firebase emulator could work out that our Cloud functions have changed. and automatically make any changes available so that we can call them. And this would give us a development experience that is similar to hot reload in Flutter. And as it turns out, we can do exactly that by running a command called build watch. So let's go ahead and click on this button to open a new terminal window. And then we can cd into the functions folder. And then we can run npm run build watch like this. And as we can see, this will start the compilation in watch mode. And at the moment, we get 2 errors because we are importing some objects that we are not using yet. So what we are going to do is to keep the build running in watch mode. And then we can go ahead and start writing our cloud function trigger. And just like we have seen in the previous lesson, to write a new cloud function, we need to export const with the name of our function, which in this case will be make job title uppercase. And we're going to say equals to functions, which is the object that we have imported from here. And then we can type dot. And as soon as we do this, we get this dropdown showing us all the kinds of triggers that we can use. And the one that we want in this case is Firestore. And if we type dot again, then we get some more autocomplete suggestions. And these options let us choose when this trigger should fire. So is it when the document is created, or deleted, or updated, or written? And in this case, I suggest that we choose on document written, because this is an event handler that triggers when a document is created, updated, or deleted in Firestore. And the reason this is the right trigger to use is that it allows us to make the job title uppercase, both when the document is created and updated. And now that we have chosen the trigger, we need to pass 2 arguments. And the first argument is the path to the document that we are interested in. And this should be a string literal that points to /users, /, and then we can use curly braces to interpolate the user ID, and then /jobs, /, and then we can use curly braces again to interpolate the job ID, like this. And this is what allows us to specify UID and job ID parameters that can change. And then we need to pass the second argument, which is a callback that gives us an event, and we can use the arrow notation with a pair of curly braces, which will contain the body of our callback. So keep in mind that the syntax for declaring callbacks in TypeScript is different to what we are used to in Dart. Okay, so let's go ahead and implement our callback. So what I'm going to do is to type in some code, and then I'm going to explain it. So for a start, we're going to declare a const change, which is going to be equal to e.data. And if we hover on this, we can see that it's possible for this data to be undefined. For this reason, we can add some defensive code to check if change is equal to undefined. And if that is the case, we're going to return early. And if you don't know why this equal operator looks like this, then you can check the notes below for more details. Okay, so let's go ahead, and assuming that this change is not undefined, then we can declare a const data, which is going to be equal to change dot, and since this is a change object, we can check what data was inside it before and after the change. So let's choose after, and then we can type dot data like this. And we need to use parentheses because this is a function like this. And if we hover over here, we can see that this function retrieves all the fields in the document as an object, and it returns undefined if the document doesn't exist. For this reason, we need to check if this object is undefined, which is something that will happen if the document has been deleted. And in this case, we should also return early, and we can add a comment to remind us of this. And now that we have taken all the safety precautions, then we can write the actual logic that we are interested in. So let's go ahead and type const uppercase equal to data.title.toUppercase like this. And once we have done this, we can return change.after.ref to get a document reference that we can use to update the data. And once we have a ref, we can call .set, and then we need to pass the data, which is a map of key value pairs. So over here, we can write title, which is going to be our key, colon, and then uppercase, which is going to be our value. And we can also pass a second argument, which allows us to set merge equal to true, like this. And what this allows us to do is to update the document by passing the updated title, and it will make sure to merge this title with all the remaining fields that are already in the document. And by the way, I think it would be a good idea to use our logger as this will help us see if the cloud function is doing what it's supposed to do. So let's go ahead and type logger dot, and then we need to choose one of the possible log levels. And I think in this case, log should be fine. And then we need to pass a string argument. And since we will interpolate some variables inside this string, we need to use a pair of backticks as the limiters. And inside this string, we're going to type uppercasing, and then we're going to string interpolate change.after.ref.path, which represents the path of the document that we are updating. And then we can type column, and then we can string interpolate data.title. And we can show that this will be converted to uppercase like this. And with this, we have completed the first basic implementation of this function, and we can save our file. In summary, in this lesson, we have learned how to write a cloud function that is triggered when a document is created, updated, or deleted at this location. And the way this function works is that we return early if some of these preconditions are not met. But if the document exists and contains some data, then we can convert the title to uppercase, and then we can write the result back into the same document. And as you can see, the way we declare callbacks or compare objects in TypeScript is different to what we are used to in Dart. But luckily, we have good autocomplete support, and we can always hover over the methods and properties that we use to get a better idea of what is their purpose. And in fact, there are some types that we are already familiar with, such as document snapshot or document reference. Okay, so let's continue on the next lesson where we're going to test this function. In the last lesson, we have written our first cloud function trigger. And since we are running the build in watch mode, we can see that our function has been initialized and it's ready to use. So let's see if we can test it. And since our iOS simulator is already connected to the Firebase emulator, all we had to do is to click on the plus button to add a new job. So let's do that. And as you can see, shortly after doing this, the title has been converted to uppercase. And this confirms that our cloud function is doing the right thing. But it seems that we have a problem because the terminal log is stuck in a loop, printing all these logs. So why does this happen and how can we fix it? Well, to understand what is going on, we need to consider this diagram, which represents the trigger that we have just written. And as you can see, we have a cloud function that is triggered whenever a document is written at this location. And what the cloud function does is to convert the title to uppercase and then write it back to the same location. But as a result of this, the function is triggered again over and over, even if the title already is in uppercase. Because what causes this function to be triggered is this last line over here where we write the document data. And since we are just running on the emulator, this mistake is harmless and we are just wasting a few CPU cycles on our machine. But if we were to deploy this function on Google servers, this would be a recipe for disaster that could cost us a lot of money. Because when you run these functions on the cloud, you are charged for compute time. So if we want to break out of this infinite loop, we need to add some kind of guard that prevents this code from being executed if the title is already in uppercase. So let's go ahead and do this. And the fix is actually quite simple because all we have to do is to check if uppercase is equal to data.title. And if that's the case, we can return early without writing anything. And this simple check is all we had to do to prevent our infinite loop. And since this code is quite critical, I think it's a good idea to add some comments so that we don't make the same mistake again. And as soon as we save this file, our function will be recompiled. And we should see that the logs stop right away because the function has been reloaded. And if we want to verify that the trigger still works as expected, we can click on each one of the remaining jobs so that we can update them in Firestore. And we can see that they are updated and converted to uppercase right away. And by the way, if we wanted to, we could even update these existing jobs from the Firebase UI by editing the title. For example, here we could replace this value with something like writer. And we should see that as soon as this job is saved, then the title is converted to uppercase because our cloud function trigger is still working. And since we use real-time updates in the UI, we get the updated data here as well. And with this, we have completed this lesson about cloud function triggers. So this is a good time to do a summary. And what we have learned is that we can write a cloud function that is triggered when a Firestore document at a specific location is written. And inside it, we have written some defensive code so that we can return early if there is nothing to do. And as we have seen, it's critical that we return early if the job title is already in uppercase, so that we can prevent an infinite loop. On the other hand, if there is work to do, we can update the document and write it back to Firestore using this call. And we can add a log here as well. So as you write your own cloud functions, make sure that you have some defensive code in place so that you can return early and prevent infinite loops where your cloud functions are triggered over and over. And one thing that should be obvious is that writing and testing our cloud functions with a local emulator is very convenient. In fact, my top tip for this lesson is that we can use npm run build watch to build the cloud functions in watch mode and get the same hot reload experience that we are used to when we write Flutter apps. And only when we are confident that our cloud functions work as intended, then we can deploy them to production. And by the way, since infinite loops can make you bankrupt, it may be a good idea to write unit tests for them, so you can sleep better at night knowing that everything works as intended. And just to be clear, I won't show you how to write unit tests for your cloud functions in this course, but you can head over to this page if you want to learn more about this topic. Alright, so this completes our lesson, and we'll look at how to deploy cloud functions later on in this section. But before we do that, I want to show you how to write different kinds of functions that can be called directly from our Flutter app. So let's do that in the next lesson. In this lesson, we're going to talk about callable cloud functions, which, as the name implies, are functions that can be called by a client, such as our Flutter app. And if you read the documentation, you'll find that these kind of functions are also known as HTTP functions. However, you should be aware that there are two kinds of HTTP functions, and there is an important distinction between them. So on one side, we have regular HTTP functions, which are more portable and they can be called directly from the command line, just like any REST API. But they are harder to use since you need to know what their full URL is and pass all the required HTTP request headers, such as authentication tokens. And when you write them, you have to implement all the serialization logic, as well as the logic for validating and authenticating tokens. On the other side, we have HTTP callable functions, which are much easier to use because they work using the Firebase client SDK, which does all the heavy lifting for us by automatically including all the necessary tokens for us. So as far as we are concerned, we are going to use HTTP callable functions because they are easy to use and more secure. And in fact, I would recommend that you always use them as well. And at this stage, you may have some questions, such as what are HTTP callable functions useful for, and why do we even need them? After all, our client app can read and write data directly from Firestore. And as we have already seen in the previous lessons, we can use cloud function triggers to modify the data that is stored in Firestore and write our own server-side logic. And then the client app can read the updated data using real-time listeners. But as it turns out, there are cases where it's not appropriate for the client app to manipulate data in Firestore directly. Either because we might not have the right permissions, or because we had to write security rules that are too complex, or because we had to run some complex server-side logic that should be triggered but not executed by the client. And a very simple example of this is when we want to delete all the documents inside the collection, which is something that needs to be done one document at a time. Because the Firestore client SDK doesn't give us a way to do it with a single delete operation for the entire collection. And deleting all the documents with a for loop is not something that can be done reliably on the client, because the network connection may fail, or the app may be killed halfway through. And in this scenario, it makes more sense for the client app to call an HTTP callable function, which in turn can run all the required code and update the data in Firestore. And then the client can read the updated data. So in the next few lessons, we're going to learn how to write our first callable function, as well as how to invoke it from our Flutter app, and also how to handle both success and failure scenarios on the client, so that we can inform our users if something went wrong. Okay, so let's get started in the next lesson. In this lesson, we're going to write our first HTTP callable function. And as I said before, the function that we are going to write is quite simple, and its purpose is to delete all the jobs that a given user has created using our Flutter app. And since our main focus will be on writing the actual cloud function and getting our client app to call it, I prepared a new code snapshot that already includes all the necessary UI, as well as some of the setup code. So please go ahead and open a new terminal window. And if you have any working changes at this stage, you can discard them by running git reset --hard head. And then you can get the latest code by running git checkout intro callable functions, like this. And once you have done that, you can open the pubspec.yaml file. And inside it, you'll find that I've added a new package called Cloud Functions, which is what allows us to call HTTP callable functions from our Flutter app. So at this stage, you can get all the latest packages. And then you can move over to the main.dart file. And as you can see, at the top, I've added a to-do with this line that we need to uncomment if we want to enable the functions emulator. And we'll need this so that we can more easily test the function that we're going to write without having to deploy it. So let's go ahead and uncomment this. And we can also remove the to-do. And in order to use this, we need to import cloudfunctions.dart like this. So this is a good time to go ahead and run the app. And as usual, if you have any errors at this stage, please check the notes below for how to resolve them. And now that the app is running, I want to show you some of the other changes that I've made in the code, starting from the home screen. And assuming that you're already signed in, you should see that here on the app bar, there is a new delete icon. And if we take a look at the build method, we can see that I've added a new icon button. And inside the onPressed callback, we read this functions repository provider and use it to call this delete all user jobs method. And if anything goes wrong, we show an alert dialog with the error that has been caught. And as you can see, if we press on this button, nothing happens. And that's because this method has not been implemented yet. So our goal for this lesson is to write an HTTP callable function that can be called from here so that we can delete all the jobs in one go. And now that I've shown you all the changes on the Flutter client, let's go back to our index.ts file so that we can start writing this function. So let's scroll down to make some space. And over here, we can export a const delete all user jobs function, which is going to be equal to functions.https.onCall. And this is a callback that gives us a context of type functions.https.callable request. And then we can add the arrow notation and a pair of curly braces, which will contain the body of our function. And since we are going to write some asynchronous code inside it, we can mark this callback as async over here. And by the way, if you want to learn more about what data is inside this callable request, you can go to its definition. And over here, you can find all these properties, such as the data parameters that were passed by the client, as well as information about the Firebase app check and auth ID tokens, along with these other properties as well. And out of all these properties, the one that we are interested in is the auth data, since we can use it to check if the user is authenticated. Okay, so let's get back to our cloud function. And then inside the body, we can write const UID equal to context, and then we can type dot auth dot UID like this. And since it's possible for this auth object to be undefined, then we should add some defensive code by typing if UID is equal to undefined. And if this is the case, it means that the user is not authenticated. So what should we do? Well, since this is a function that is called by the client, we should have a way to tell the client that an error has occurred because the request was unauthorized. And when we work with HTTP callable functions, the way to do this is to throw an exception that we will be able to catch on the client. So let's go ahead and type throw new functions.https error, which is an object that takes two arguments. And the first one is the error code, which should be unauthenticated in this case. And the second one is a message, which should say you need to be authenticated to perform this action. And by the way, one thing that you may notice is that if you spelled unauthenticated incorrectly and add a typo like this, then you get an error that says that the argument of type unauthenticated to is not assignable to the parameter of type functions error code. So how can TypeScript decide that this string is not valid, but this one is? Well, the secret is that the HTTPS error constructor takes a functions error code. And what is interesting about this type is that it specifies all the possible strings that could be assigned as a value. And one of the allowed strings is unauthenticated. And if we pass a string that isn't any of these values, we'll get a compile error. And this is something that is quite cool about the type system in TypeScript, and not something that we can do in Dart. Okay, so let's get back on track. And the next step is to add the code for deleting the jobs associated to this user ID. And to do that, we need to first get a Firestore object from the admin SDK, and then we can create a const collection ref, which is going to be equal to firestore.collection, and this should point to the collection that we are interested in, which lives inside users/UID using string interpolation /jobs, like this. And then we can get a list of all the document references in this collection by calling await collection ref.list documents, like this. And now that we have all the document references, we can write a for loop that iterates on each document reference of docrefs. And inside the loop, we can await docref.delete, like this. And by the way, note that this is a for of loop and not a for in loop. And this is the kind of loop that we should use to work with iterables. And you can check the notes below if you want to learn more about it. And finally, we could return some kind of success value if we wanted. For example, we could return a map of key value pairs where the key is success and the value is true, like this. And just to be clear, this return statement is by no means necessary, since we don't have any data that we need to send back to the client in this case. But I just want to show you how to return something from an HTTP callable function, so that we can parse it on the client if we want to. And by the way, one question you may have at this stage is whether we need to worry about security rules. After all, we know that when we use the Firestore SDK in our Flutter app, we can only read, write, or delete documents if we have the right security rules in place. But as it turns out, when you use the Firebase admin SDK inside our Cloud Functions, security rules do not apply, because you are running code from a trusted environment and you have full control over the data in Firestore. But as they say, with great power comes great responsibility. So once again, be careful when you create, update, or delete documents using Firestore with the admin SDK, because you have full control and the security rules do not apply. And this completes the implementation for our function. And before we test it, I think it's a good idea to add a log that will show up when the function runs. And what this log should say is deleted, and then within string interpolation, we can type docrefs.length, and then we will say docs at, and then within string interpolation, collectionref.path, like this. And with this, our function is complete. So let's continue on the next lesson, where we are going to see how to call it from our Flutter app. In the last lesson, we have written all the code for our delete all user jobs function. And assuming that the Firebase emulator is still running, and we are still running the build in watch mode, we should see that the function has been initialized. So in this lesson, we are going to learn how to invoke this function from our Flutter client app. So as a next step, let's get back to our functions repository. And then from here, we can remove this to do, and we can start implementing this method. And the first thing that we should do is to get a handle to the function that we want to call by declaring a callable, which is equal to functions.https callable. And then we need to pass a string, which contains the name of the function. And once we had this, all we had to do is to await callable, like this. And by the way, you should know that this callable is actually an object of type HTTPS callable. And the reason we can use it like this without calling any methods on it is that we are using a feature of the Dart language called callable classes. And you can read the notes below for more info about this. And guess what? If all we want to do is to call the function without checking for error or success, this code is enough. In fact, we can already save and hot reload, and then we can go ahead and click on this delete button. And as we can see, all the jobs have disappeared. And if we want to confirm that everything has worked as intended, we can check the emulator log. And what we can see here is that the delete all user jobs function has been called, and we have got this log telling us that we deleted 5 documents at this location. And what we can also see is that this US Central make job title uppercase function has been called 5 times. And if you remember, when we implemented this function, we said that the onDocumentWritten trigger is called when a document is created, updated, or deleted. And since this other function has deleted all the documents, then this function is called for each one of them. And even though we've added some defensive code, to return early if a document has been deleted. It would be even better if this function was not called at all in this case. And if we really want to do this, then we have to replace this function with two other functions that use the onDocumentCreated and onDocumentUpdated triggers instead, and maybe find a way to reuse some of this logic inside them. But for now, we're going to stay on track and keep this function as is. And the most important thing to understand is the relationship between the Flutter client, the Firestore data, and the cloud functions. In fact, when we have some jobs on this page and we press on this delete button, then three things are going to happen. The first one is that our client app calls the callable function, and then the callable function deletes all the document in Firestore, and then the Flutter app rebuilds the UI because we are listening to Firestore in real time. And with this, we have completed the minimal implementation for our delete user jobs feature. And while we are here, I think it will be useful to show you a bit more of what you can do with callable functions. For example, over here, we could try to get the result value, and we could try to print it by passing result.data.toString as an argument. And in order to use this, we had to import foundation.dart. And then we could save this file and get back to our debug console. And then we could try to add one more job and delete it as well. And as soon as we do this, we can see a log that says success equal true. And this is exactly the response that we return from our cloud function over here. In fact, if we wanted, we could make this return value a bit more useful and use it to return the number of documents that have been deleted by returning count with a value of docrefs.length, like this. And then we could save this file to rebuild the cloud function. And we should see that if we press the delete button one more time, then this time we get count with a value of 0 on the debug console. So as you can see, we are able to use hot reload both on the Flutter side and on the cloud functions as well, thanks to the Firebase local emulator. And this means that we get a very nice developer experience both on the client and the server, because we can see if our code works right away. Okay, so as a next step, let's talk a bit about error handling and see what happens if we simulate an error inside the cloud function and how our client app handles it. And the easiest way to test this is to copy this statement from here, and then we can paste it in here. And then we can save our file so our function gets recompiled, and then we can press the delete button once again. And as we can see, this time we get an alert dialog showing us the error that has happened along with this stack trace. And the reason for that is that if our callable function throws an exception, then the try and catch block inside the home screen will catch it, and it will show the error over here. And by the way, if we want to show a user-friendly error message, then we need to add a bit of code to check if the exception is a Firebase function exception, which is a type that we need to import from cloudfunctions.dart. And if that is the case, then we can show an alert dialog passing the error message to the content property. And if we save and hot reload and we attempt to delete the jobs again, then we see that this time the error is a lot more readable. And now that we're happy about how the error alert looks like, we can get back to our cloud function and we can remove this temporary code like this. And finally, I want to mention one last thing, and that is that the code in the home screen doesn't contain any logic to handle the loading state. And especially when working with callable cloud functions, I think it's a good idea to show some formal loading UI and disable this button until the callable function returns, so that we don't call it more than once while one request is in progress. And this is something that I'm going to leave to you as an exercise. And a good way to implement this would be to create a controller class that uses a sync notifier from the Riverpod package, like we have done many times before. In fact, there are a few more tweaks that we could do to make this code more production ready. But for now, I just wanted to focus on how to call an HTTP callable function, how to get the result value, and how to handle exceptions. And you can find more details about this in the notes below. And with that said, it's time to do a summary. And as we have seen, on the server side, we can create our own HTTP callable functions using this syntax. And then inside them, we can add some defensive code and throw an HTTPS error if some preconditions are not met. And we have also seen how to manipulate collections and documents using references and iterables, as well as how to return a result back to the client. On the other hand, on the client side, we can call our callable functions using this callable API. And if we want, we can even pass parameters like this. And we can retrieve the result value. And we can also catch exceptions so that we can show an alert to the user if something went wrong. And while the example that we have used was relatively simple, it should give you at least a basic understanding of how to work with callable functions. And we will see more examples of callable functions in the coming sections. Okay, so let's continue on the next lesson. In this lesson, we are going to learn how to deploy our cloud functions so that they can run in production rather than on the Firebase local emulator. And along the way, we'll learn about how to monitor cloud functions using the Google Cloud Console, as well as other important things that we should be aware of. And by the way, before we deploy our cloud functions, we have to make sure that they do not contain any bugs that would cause an infinite loop. Because if our cloud functions end up being called recursively once they are deployed, we could end up having to pay a lot of money to Google Cloud, and I don't want that to happen to you. So before you go ahead, you can open the index.ts file, and here you should make sure that you have all the defensive code that we have added in the previous lessons. And if you are not 100% sure that your code is bug-free, I recommend that you check out the latest code snapshot from Git. And you can do that by opening the terminal. And if you still have the emulator running, you can close it by pressing Ctrl+C. And then you can run git reset --hard head to discard any working changes. And you can run git checkout completed callable functions to get my latest code. And this will bring you up to date with the latest changes. And now we can get started with this lesson. And the first step is to type Firebase deploy like this. And one thing that you should know is that if you run this command like this, it will deploy not only the cloud functions, but also the Firestore rules and indexes that we have configured in our firebase.json file. And if you're hosting your project as a Flutter web app with Firebase hosting, then the CLI will try to deploy that as well. However, we can be selective about which things we want to deploy. And if we want to deploy our cloud functions only, we can append --only functions like this. So let's go ahead and run this. And as part of this process, the CLI will try to compile our functions using npm. And then it will try to deploy them. But as you can see, we are currently getting this error on the console, telling us that our project must be on the Blaze plan to complete this command. And it is also telling us that we need to upgrade by following this URL. So let's go ahead and open this on the browser. And this takes us to the usage and billing page where we can see that we are on the Spark plan. So if we want, we can go ahead and modify the plan from here. And you should also notice that there is an option to upgrade the plan on the bottom left corner here on the sidebar. So let's go ahead and click on this upgrade button. And this shows up this dialog where we get the option to upgrade our project to the Blaze plan. So let's go ahead and select this plan. And one thing that you should be aware of is that since the Blaze plan gives you access to Google Cloud, which is where the cloud functions will run, then you have to create a billing account, which you can do by choosing this option and by following all the steps so that you can add a payment method. So keep in mind that if you want to go ahead and enable cloud functions for your project, you had to add a billing account. But in my case, I have already registered one, so I can just go ahead and use it. And I can press on this purchase button to upgrade the project like this. And then I can go ahead and dismiss this dialog. And once this is done, we can open the build dropdown on the sidebar and move over to the functions page. And as we can see, Firebase is waiting for our first deploy. And we can also see that we are on the Blaze plan on the bottom left corner over here. And this means that we are ready to get back to our terminal in VS Code and try to deploy our functions again. So let's do that. And just so you know, this is something that can take a little while, and we had to wait for this process to complete before we can use our cloud functions. So let's wait for the deployment to complete. And as it turns out, there has been an error when deploying one of our functions. And if we read the log carefully, we can see that there was a permission denied while using the event arc service agent. And what the log also tells us is that since this is our first time using second-gen functions, we need to wait a little bit longer to finish setting everything up. And if we want to check the status of our functions, we can get back to our Firebase console and refresh this page. And as we can see, only one of the two functions has been deployed. So if you are also getting this error at this stage, what I suggest you do is to run the Firebase deploy command one more time, like this. So I'm going to pause the video and resume once the deploy has been completed. And as we can see, this time everything went well and the new function has been created. And we also get a green check mark telling us that the deploy has been completed. Not only that, but we can get back to the Firebase console, and if we refresh this page, we now see that both functions have been deployed. Okay, so let's continue on the next lesson where we are going to test our functions. In the last lesson, we have managed to deploy these two cloud functions, and we are going to test them shortly. And before we do that, I think it would be a smart idea to set up a project budget so that we can control the maximum monthly spend that is available for our project, and we don't get overcharged if something goes wrong. And in my opinion, this is a very important safety net that you should use anytime you upgrade a Firebase project to the Blaze plan. And since we are discussing this topic, I want to mention that if we head over to the Usage tab, we can monitor the usage of our cloud functions directly. And what this is showing is that I've had 24 invocations to my cloud functions on June 12th, which is when I was testing them. And if we want to find out how much money we're spending, we can click on this button to move to the usage and billing page. And this will tell us how many resources we have used out of our free quota for products like Cloud Firestore and Cloud Storage. And it also shows us how many invocations we have made using cloud functions. Not only that, but if we head over to the Google Cloud Console, we can open the sidebar and move over to the billing page. And from here, we can see an overview of our monthly costs for the current project. And if we open this sidebar, we can go to the budgets and alerts page. And here we can set up some budgets to make sure that we are notified if our spending goes above a certain amount. So if we want, we can set a global budget for our entire billing account, which is what I have done over here with a limit of £10. And in addition, we can set up new budgets for each one of our Firebase projects. In fact, this is exactly what I'm going to show you. And this is easy because we just need to click on this Create Budget button. And as a first step, I can give my budget a name, such as Faker, App, Flutter, and Firebase. And I can set the time range to monthly. And then I can select my project from this dropdown over here. And then I can say that this budget applies to all the services. And then I can click on Next. And then I get to choose the budget type, which in this case will be a maximum of £5. And then I can also set some alert thresholds so that I get some notifications by email when these thresholds are exceeded. And once I'm happy with all the settings, I can click on Finish. And I can see that a new budget has been created for my project. And before we move on, I want to make one thing clear, and that is that the purpose of setting a budget is so that we get notified when we exceed a certain threshold. However, what this does not do is to stop the spending on our project, which means that we will still need to take further action if we don't want to incur additional costs. And you can read the notes below if you want to know how to completely disable billing so that you can cap your spending. In summary, in this lesson, we have seen how to monitor the usage and cost of our Firebase project. And we have also learned that we can create budgets from the Google Cloud Console. And my recommendation is that at the very least, you should create a global budget for the billing account that you have registered. And when you upgrade a Firebase project to the Blaze plan, it's probably a good idea to set a project-specific budget early on so that you can keep your costs under control. And once you have done that, you'll get email notifications if you exceed the thresholds that you have set. And with that said, we can move over to the next lesson, where we are going to test our cloud functions. In the last couple of lessons, we have deployed our cloud functions and we have set up a project budget that will save us if things go wrong. And now that we have done this, we are ready to test our cloud functions using our Flutter app. So let's get back to VS Code. And before we run the app, we should get back to our main.dart file. And then inside the main method, we should make sure that we comment out this line to ensure that we no longer use the Firebase emulators, because this time we want to connect to the real Firebase backend instead. And then we can go ahead and run the app. And then we can wait until this is up and running. Okay, so here I have my Flutter app now running on the iOS simulator. And if you happen to be signed in from the previous session, then make sure you go to the profile page and sign out before continuing. And by the way, if we get back to the Firebase console, we can see that here we have this message telling us that we can visit the Google Cloud Console if we want to see the logs view, as well as these other pages. So let's go ahead and click on this link. And as we can see, we have been taken to the Logs Explorer inside the Google Cloud Platform. And we'll be keeping an eye on this as we test our functions. Okay, so let's go ahead and sign in with a test email and password that we had previously registered using the real Firebase project. And what we would expect to happen is that as soon as we add a new job, then the title will be converted to uppercase, and we should also be able to delete all jobs in bulk. So let's go ahead and click on this plus button, and as you can see, a new job is added, and shortly afterwards, the title is updated to uppercase. And by the way, the reason why the UI didn't update immediately has to do with the time it takes for our serverless cloud functions to start, and the difference between cold start and warm start. And you can read the notes below for some more information about this. But for now, let's stay on track. And if we want, we can click on all the remaining jobs. And what we should see is that all the job titles are updated to uppercase, like this. And this confirms that our deployed cloud function is working as intended. And if we take a look at the logs, we can scroll all the way to the bottom, and we should be able to see that our cloud function has been invoked. In fact, we can open each individual log to see all the details, including the timestamp, severity, and the actual payload of the log itself. Okay, so let's stay on track. And as a next step, let's try to delete all the jobs that we have created by pressing this button. So let's go ahead and do this. And as we can see, after a few seconds, all the jobs have been deleted as well. And this confirms that both our cloud functions are working as intended. And by the way, I should mention that when I first attempted to test the delete functionality, I did get an error telling me that the request was not authorized to invoke this service. And this is something that has to do with the Identity Access Management feature in Google Cloud. So just be aware that if you are calling an HTTP callable functions from your Flutter app, you may also encounter this issue. And if that's the case, you can follow the resources in the notes below for how to resolve it. Okay, so let's do a summary of what we have learned in this lesson. And the first thing that we need to keep in mind is that we need to enable the Blaze plan in order to deploy our cloud functions to Google Cloud. And once we have done that, we can deploy our functions by running Firebase deploy only functions from the terminal. And we should also remember to disable our emulators if we want to test our Flutter app with the functions that we have deployed. And finally, we have seen that we can explore the cloud function logs using the Logs Explorer inside GCP. And if you take a look at the notes below, I've also included some additional resources that you'll find useful if you want to learn more about cloud functions. Okay, so let's continue on the next lesson. We have now reached the end of this section about the Firebase local emulator and cloud functions. And as we have seen, using the local emulator can be quite convenient during development, because we can simulate a Firebase backend locally and use it by simply telling our Flutter client to connect to all the emulators that we want to use. And of course, the main reason for introducing the Firebase local emulator is that it makes it much easier to develop and test cloud functions, because we can build them in watch mode and debug them as we write our code without having to redeploy them every time we make a change. However, writing cloud functions is quite different from the ordinary code that we are used to when writing Flutter apps, because for a start, we can't write cloud functions in Dart just yet, and we have opted to use TypeScript instead. And beyond that, the programming model is completely different, because cloud functions run on the server rather than on the client app, and they are triggered in response to events, and not directly by user interactions within our app. And I hope that by following this section, you have at least a basic understanding for how to work with cloud functions. And if you want to dig deeper into this topic, I've included many additional resources about them in the resources below. In any case, we'll continue to work with cloud functions in the coming sections. In fact, in the next section, we'll tackle role-based authorization with custom claims, which is a feature that will require some server-side code, and cloud functions are very well suited for that. Okay, so let's continue on the next section. In this section, we are going to talk about role-based authorization with custom claims. And what makes custom claims useful is that you can use them to give users different access levels or roles that can be enforced using security rules. And a common use case for this is when you want to unlock certain features in your app only for users that have paid for them. And beyond that, there are many real-world examples where you need to support different kinds of users. For example, you may have a tutoring app with different roles for teachers and students, or a ride-sharing app with drivers and passengers, or an e-commerce marketplace with sellers and buyers. And indeed, our e-commerce app is also a good example of this, because we have regular users that should be allowed to purchase items and leave reviews. But we also have admin users, which can manage and upload new products. And in fact, we will use our e-commerce app as a real-world example for how to implement role-based authorization. So here is what we will cover in this section. We will start with a high-level overview about custom claims so that you can have a general idea of how they work and how to use them. Then we will use the Firebase CLI and configure our e-commerce app so that we can use it with the Firebase local emulator. And this will help us write and test a Cloud Function trigger that we'll use to set custom claims securely on the server. Then we will see how to enforce some security rules so that only authorized users can perform certain operations with Cloud Firestore. And then we will look at the UI side of things and ensure that only admin users have access to certain pages in the app. And as part of this, we will update our Go router redirect logic as well. And we will also talk about how to combine custom claims with real-time listeners so that we can deliver the best user experience. And we'll wrap up by deploying our Cloud Function so that we can run and test the new logic with the real Firebase backend. And the overall goal is that by the end of this section, you should have a clear understanding about when and how to use custom claims to enable role-based authorization so that you can enable multiple user roles in your Flutter apps. Okay, so let's get started in the next lesson. In this lesson, I'm going to give you an introduction to custom claims by explaining what kind of problems they solve, and I'll also give you a high-level overview of what logic we need to add on the server and on the client if we want to enable role-based authorization. And since we are just getting started with custom claims, there are two main resources that I want to recommend. The first one is this official page in the Firebase docs, which explains how to control access with custom claims and security rules. And the second one is this video by the Firebase team, which is definitely worth watching. And you can find the links to both of these resources in the notes below. And in fact, to get started with custom claims, we can use this document as a reference. And what we can learn here is that the Firebase admin SDK supports defining custom attributes on user accounts. This provides the ability to implement various access control strategies, including role-based access control in Firebase apps. And these custom attributes can give users different levels of access, also known as roles, which can be enforced in the application's security rules. And the document also lists some use cases where it makes sense to define user roles, such as giving a user administrative privileges to access data and resources, as well as defining different groups that a user belongs to, and also providing multi-level access by differentiating between paid and unpaid subscribers, or differentiating between moderators and regular users, or between teachers and students. And another example is if we have something like Uber, where there are regular users and drivers. And as it turns out, our e-commerce app is also well suited for custom claims, because we have regular users which should be allowed to purchase existing products and leave reviews. And we also have admin users, which should be allowed to upload and edit products using the image upload flows that we have implemented earlier on in the course. And now that I've given you a few examples of custom user roles, we can try to understand how to work with custom claims. And to do that, we first need to talk about the Firebase ID token. And if you've ever asked yourself what happens when you sign in with one of the available authentication providers, the answer is that Firebase Auth will generate a Firebase ID token and store it locally on the client SDK. And every time you make a request to one of the Firebase services, such as reading a document from Cloud Firestore, that token will be sent along, so that the Firebase backend can identify the user and do all the necessary validation checks before sending a response back to the client. And what is cool about the ID token is that you can use it to store some custom claims that are used to give special permissions to the user. And one important thing that we need to understand is that custom claims can contain sensitive data, and for this reason, they should be only set inside a Cloud function by using the Firebase admin SDK. For example, here we have a Cloud function that is used to add this custom admin flag to the user identified by this UID. And as you can see, we only do this if certain preconditions are met, by checking if the email address has been validated and it comes from a specific domain. So this takes care of setting the custom claims using server-side code. But once our custom claims are set, how do we propagate them to the client so that we can show the appropriate UI depending on the user role? Well, if we head back to the docs, we can find this section called Propagate Custom Claims to the Client. And this says that custom claims are propagated to an authenticated user on the client side via the ID token. And this happens when a user signs in or re-authenticates after the custom claims are modified, or when an existing user session gets its ID token refreshed after an older token expires, or when an ID token is force refreshed by calling current user.getIDToken with a value of true. So what does this mean in practice? Well, let me show you some sample code that we can use to check the custom claim on the client. And as we can see, over here we have two functions. And the first one is called refresh token, and is used to call this getID token method on the current user. And the second one is called isAdmin, and inside it we get the current user, and then we use it to obtain the ID token result object. And in turn, this can be used to check if we have the custom claim or not. And once we have these functions, we can call them when needed to refresh the ID token and extract the data that we need from it. And just to be clear, keep in mind that this code is just an example, and as we will see in the coming lessons, it can be improved by using real-time listeners. But for now, I'm just sharing a conceptual overview of how to work with custom claims. And by the way, in addition to what we do on the server and on the client, there is one more thing that we need to consider, and that is security rules. In fact, the whole point of custom claims is that they can give privileged access to authorized resources to certain users. For example, here is a diagram showing that only admin users have write access to documents inside this product collection, while regular users only have read access. And now that we have seen some example code for how to use custom claims on the server side and on the client side, let's take a step back and look at the big picture. And the main takeaway here is that custom claims can be used to give authorized access to certain resources only to certain users by using security rules. And on the server side, we can write some code to set a custom claim inside the Firebase ID token for a specific user. And on the client side, we can call these feature-based APIs to refresh the token and check if the user is an admin. And if that's the case, we can update our UI accordingly. And for now, this is just a high-level overview of how to implement role-based authorization. And there are some additional concerns that we haven't covered yet. For example, how are we meant to consume these feature-based APIs on the client? And where should this code live? And is there a way to use custom claims in combination with real-time updates, just like we do when we read data from Cloud Firestore? And as we will see, things can get a little bit complicated, and implementing role-based authorization with custom claims can be a bit challenging. And we'll also see that if we want, we can implement role-based authorization with Cloud Firestore only, without using custom claims. However, there are always some trade-offs to consider, and we'll make sure to discuss these trade-offs as we make progress. Okay, so this completes our high-level overview of custom claims. And like I said at the beginning, you can check the official documentation as well as this video by the Firebase team if you want to learn more. And as far as we are concerned, our goal in the rest of this section will be to add role-based authorization to our e-commerce app, so that only admin users can manage products using the image upload flows that we have covered earlier on. And this will be a good opportunity to learn how to use custom claims on a real-world project. Okay, so let's get started in the next lesson. Now that I've given you a high-level overview about custom claims and how we are going to use them, it's time to get back to VS Code. And just to be clear, we'll be working on the e-commerce app, and not the demo app that we have used in the last section. And what we said in the previous lesson is that custom claims can only be set on the server side using Cloud Functions. And as we know, it's much easier to write and test Cloud Functions if we use the Firebase local emulator. So in this lesson, we're going to configure the local emulator using the Firebase CLI. So make sure that you've opened the correct project, which is our e-commerce app. And before we do anything else, I have an updated code snapshot to share, which contains some small changes that we will need going forward. So please go ahead and open the terminal, and then you can run git reset --hard head to discard any working changes that you may have. And then you can run git checkout section 06 --starter to get the starter project for this section. On the other hand, if you no longer had this project on your system, you can do a fresh checkout of the official project from GitHub. And then you can follow the instructions that I've included in the notes below to get it up and running. And by the time you are done with this, you should see that inside the lib folder, you have this Firebase options.dart file, which was generated by the Flutter CLI. And at this stage, you should be able to run flutter pub-get to install all the latest packages. And you should also be able to run the project. And for this section, I recommend that you use the iOS simulator or the Android emulator. So in this case, I'm going to run using my iOS simulator. And once the app is running, you should end up on this page that shows all the products that you have up during section 4, when we talked about the image upload flows. And if you're having any issues when running the app, please check the project FAQs for how to resolve them. Okay, so the next step is to run the Firebase init command so that we can initialize the Firebase project. So make sure that you are inside the e-commerce app folder, and then you can run Firebase init like this. And as the first step, we need to choose which Firebase features we want to use. And in this case, the ones that we are interested in are Firestore, Functions, Storage, and Emulators. So you can select them using space, and then you can press enter to confirm. And then we need to associate this project with a Firebase project. So let's go ahead and select this option to use an existing project. And at this stage, you should select the project that you have configured before, which in my case is called Flutter and Firebase Masterclass. And then the next step is to choose the file that will contain our Firestore rules. So let me go ahead with the default. And I can also choose the default file to store the Firestore indexes. And then we need to configure our Cloud Functions project. So let's go ahead and choose TypeScript as the language that we want to use. And we are also going to go ahead and enable ESLint for this project. And once we confirm, the CLI will generate a bunch of files for us. And we can also go ahead and install the dependencies with npm. And this is a process that can take a little while. And you may have to wait a minute or two until it is complete. And once this is done, we will be able to see that all these packages have been installed. And then the CLI will ask us which file we want to use for the storage rules. So let's go ahead with the default choice. And then we can move on to the next step, which is to set up the Firebase emulators. And the ones that we're going to need for this project are the authentication emulator, the functions emulator, the Firestore emulator, and the storage emulator. So let's make sure that we select those. And then we need to choose which port we want to use for each one of these emulators. So let's go ahead with all the defaults. And finally, we can go ahead and enable the emulator UI as well and choose the default port. And we can also go ahead and download the emulators like this. Okay, so it looks like the Firebase CLI has completed and it has created a bunch of new files for us. And I'm not going to go through all these files at this stage, since we have already done that in the previous section. But you should definitely see that these files are now in your project, and you should also have a new functions folder, which contains the Node.js project that we can use to write our cloud functions. Okay, so let's continue on the next lesson, where we'll start working with custom claims. In this lesson, we are going to complete our project setup so that we can connect our Flutter app to the Firebase local emulator. And since we have done a lot of configuration in the previous lesson, I recommend that you get the latest code snapshot from the official project, as this will ensure that your configuration files are the same as mine. And this is particularly important since there is a good chance that your Firestore.rules and storage.rules files are different from mine. And you'll also need the updated ESLint rules from my project to avoid any issues going forward. So please go ahead and open a terminal. And from here, you can type git reset --hard head to discard any working changes. And then you should run git checkout section 06 cloud function starter. Like this. And this will get you up to date with the latest code. And once you have done this, please go ahead and run Firebase emulators start. And you should see that this will start all the emulators that we have configured. And if you get any errors at this stage, please check the notes below for more details. And by the way, you can ignore this error from the Firebase functions, since we haven't added any yet. But assuming that everything else is working as intended, then you should be able to click on this URL to open the emulator UI on the browser. Next up, let's see if we can connect our Flutter app to the local emulator. So let me hide the terminal, and then we can head over to the main.dart file. And as you can see, over here we have the Firebase initialization code. And down here we create this app bootstrap instance that we can use to set things up. And if we go over here and add a new line, we can type app bootstrap dot, and then we can call this method called setup emulators like this. And if we go to the definition of this method, we can see that it is a helper method that we can use to connect to the old Firestore and storage emulators. And what this means is that the next time we run our app, it should connect to the Firebase emulators rather than the Firebase backend. And to remember that, we can add a comment like this. And before we do anything else, I want to warn you that when I first attempted to get this working, I got a few different kinds of errors, which had to do with the cached data from when the app was connected to the Firebase backend. And when you switch from running on the Firebase backend to the Firebase local emulator, this can cause problems. So what I recommend you do at this stage is to use either the iOS simulator or the Android emulator. And then you should make sure that you are logged out from the app, and then you can get back to the home screen. And I think it would be a good idea to delete the app altogether from the system, like this. And once you have done this, you can go ahead and run the app once again, and wait until it is up and running. Okay, so the app is now running again, and what you should see at this stage is that the products page is empty, because the app is now loading the products data from the Firestore emulator, which currently has no data. And what this also means is that you can open the sign-in page, and then you can try to register a new account by entering test at test.com, for example, with a test password. And once you have created an account, you can move over to the authentication tab, and you should see that the account appears over here. Okay, so this proves that the Flutter app is connected to the Firebase local emulator as intended. And if you are experiencing any issues at this stage, please check the notes below for more details. Okay, so let's continue on the next lesson. In this lesson, we're going to learn how to set some custom claims on the server by writing a Cloud function that is triggered when a new user is created. And this page on the official docs about Firebase authentication triggers explains how we can do this. And if we read this note, we can learn that the second generation of Cloud functions for Firebase does not provide support for the events and triggers described in this guide. In other words, what this is telling us is that if we want to create an auth trigger, we need to use a first generation Cloud function. And we'll keep that in mind as we make progress. Okay, so let's get back to VS Code. And to get started, we can open the functions folder and find the index.ts file inside source. And then we can delete the contents of this file entirely, so we can start from a clean slate. And then we can import all the files that we're going to need. So let's start by typing import star as admin from the Firebase admin module. And we're also going to import star as functions from the Firebase functions module. And as usual, we can import our logger from Firebase functions /logger, like this. And since we need to use the Firebase admin SDK, we need to call admin.initializeApp, as usual. And then we can start writing our Cloud function. So let's go ahead and type export const. And then we can call this function makeAdmin if whitelisted. And this is going to be equal to functions.auth.user. And if we press dot, then we get this dropdown that we can use to choose one of these triggers. And the one that we need is on create. And what this trigger gives us is a callback with two arguments, where the first is a user and the second one is a context. So let's go ahead and add this argument. And since we don't need the context, we can use an underscore. And then we can use the arrow notation and open the body of our callback like this. And since our callback will contain some asynchronous code, we can add the async keyword as well, like this. And now we can implement all the logic that goes inside this function. And as we have learned in the previous section, it's always a good idea to add some preconditions at the beginning so that we can return early if there is nothing to do. And in this specific case, what we want to do is to get the user email, like this. And then we can check if it is undefined, which is something that is actually possible if we are using anonymous sign-in in our project. So if this is the case, we can add a log that says user, and then we can pass the user ID using string interpolation. And then we can say doesn't have an email address. And then we can return early. And once we get past this check, we need to answer one question, and that is which users can become an admin. And for this, there are many criteria that we could use. For example, we could define a whitelist of email addresses, such as admin@codewithandrea.com or andrea@codewithandrea.com. And then we can check if the user email is found inside this list. And if it isn't, then we can return early. And the general idea here is that only users with an email address that belong to a domain that you own can become administrators. In fact, rather than using a hard-coded whitelist of email addresses, a more flexible solution is to simply check if the email ends with a certain domain that we own. And if that's not the case, then we can return early. And we can also add a log that says that the email doesn't belong to a whitelisted domain. So overall, it's up to you to decide how you want to do this. But for our purposes, we're going to keep this domain check and not go for the whitelist approach. So we can go ahead and delete this code. And since we now have this defensive code in place, we can be assured that if we reach this point in the function, then a user with an email address that belongs to this domain has just signed up. So the next step is to set a custom claim for this user. And this can be done by typing admin.auth.setCustomUserClaims. And this is a function that takes two arguments, which are the user UID and the custom user claims. So to this function, we can pass the user.uid as well as a map of key value pairs, which contains an admin field with a value of true, like this. And since this is an asynchronous operation, then we can add an await in front of it. And then we can add another log that says that the custom claim has been set and confirm that the email address is now an admin, like this. And while we're here, we can also add a comment over here. And by the way, if you're wondering whether we need to return some kind of value at the end of this function, then the answer is no, because this is an authentication trigger, which is not invoked directly by the client, and as such, we don't need to return a value. Okay, so at this stage, you may be wondering if this function is complete. And in fact, you could even try to execute it and check if it gets invoked in the Firebase emulator logs. But before we do that, I want to point out that something is missing. And can you figure out what that is? Well, when it comes to writing defensive code, more is always better. And one thing that we could do is to ensure that we only set this custom claim if there isn't one already. And we could do that by typing if user.customClaims .admin is equal to true. And if that is the case, we can log that the email is already an admin and we can return early. And now that we have written this additional code, you could argue that it's not really possible for the custom claim to be already set when a user is first created. And to be fair, I agree with you. But it's also true that your cloud functions could become more complex in the future, and you may end up reusing this logic somewhere else. So I think it's worthwhile having this check so that we only set the custom claim if necessary. And finally, I want to point out one more thing. And that is that for extra security, we could also check if the email is verified before setting the custom claim, as this would ensure that the email address belongs to the user that has just signed up. And we can do that by typing if not user.emailVerified. And if that's the case, we can return early and log that the email is not verified. However, I suggest that for now we can disable this check, since it will make testing a bit easier. So let me go ahead and comment out this code, and I'm also going to add a comment explaining why. And with this, our cloud function is complete and we can go ahead and test it. So as a first step, we can open the terminal and we should see that the emulator is still running, but it can't deploy the cloud functions because we haven't transpiled them to JavaScript yet. So let's go ahead and open a new terminal and cd to the functions folder. And then we can type npm run build to build the cloud functions. And then we can wait for this process to complete. And now that this is done, we can get back to the other terminal and we should see that our cloud function has been initialized. And what this means is that we can get back to our Flutter app. And if we want, we can try to register a new account that doesn't end with the whitelisted domain that we have defined in our cloud function. And to do that, we first need to sign out like this. And then we can go on the sign-in page and click on register. And here we could enter a@b.c, for example, with a test password. And once we created the account, we can get back to the Firebase authentication emulator and refresh the page. And we can see that the new user account has been created. And if we head over to the logs, we can see that the function was executed. And we get this log telling us that this email address doesn't belong to a whitelisted domain. And this is what we expect. And now we can go ahead and test the happy path. So let's log out one more time. And then we can go on the sign-in page and click on register. And this time we can enter admin@code codewithandrea.com with a test password. And then we can go ahead and create an account. And as we can see, we get a new log, and this time we can read that the custom claim has been set and that admin at codewithandrea.com is now an admin. And this confirms that our function is working as expected. And another thing that I want to show you is that if we go to the authentication tab, we can click on this button and choose this option to edit this user. And this shows us a page where we can edit all these fields. And one thing that we can notice is that one of these fields is called custom claims. And here we can see that the custom claim has been set as expected. So this is a nice feature of the Firebase local emulator, which lets you edit all these fields manually. And this is something that is not possible with the regular Firebase console. In fact, the only options that are available here are to reset the password, disable the account, and delete the account. So this is another example of how the Firebase local emulator makes it easy to develop features locally. Okay, so let's continue on the next lesson, where we are going to talk about security rules. In the last lesson, we have added this cloud function that we can use to set a custom claim when we create an account with the whitelisted email address. But at the moment, our Flutter client app doesn't use the custom claims in any way. And in fact, if we use this dropdown, we can see that we always get access to the admin page, regardless of whether the custom claim is set or not. And this means that there is nothing stopping us from adding new products as a regular user, which is something that should not be allowed. So our goal for the next few lessons is to add some restrictions to our Flutter app so that only admin users can use the functionality for managing products. And in order to do that, we need to focus on two areas: security rules and UI updates. And the reason we need to update our security rules is to ensure that we can only upload product images to Firebase storage and write the corresponding product data to Cloud Firestore if we have an admin token. And on the UI front, we need to restrict access to certain features of the app if we detect that a user is not an admin. In other words, if we want our app to be secure and deliver the best user experience, we need to focus on both these areas. And in this lesson, we are going to focus on the security rules. And if you remember, when we have configured our Firebase project using Firebase init, the CLI has generated a few files for us, including firestore.rules and storage.rules. And one thing that you should know is that while the emulator is running, you can modify these rules. And if you make changes and save them, then the rules will be updated automatically. So let's go ahead and look at this firestore.rules file. And what you should see here is that at the moment, we are always allowed to read documents inside the products collection, but we are only allowed to write them if we are authenticated. But this is not correct, and we have this to do here telling us that only admins should have write access. And now that we have enabled custom claims, we can go ahead and uncomment this rule and use it to replace the old one. And we can remove this to do as well. And by the way, if we try to edit this code and type dot after request.auth.token, we can see that we get a number of useful properties such as email, email verified, name, and the phone number. But the property that we really want is admin, which is not listed here because autocomplete doesn't know about the custom claims that we have set. But it is the correct one to use. And now that we have made these changes, we can save this file and we should see this log telling us that the rules have been updated. And strictly speaking, if we want to make sure that these rules are correct, we should check if request.auth is not equal to null before we attempt to check the token, since these auth objects will be null if the user is not signed in. So let's go ahead and save this file. And next up, we can do the same change to the storage.rules file by removing the old rule and using the new one and removing this to do as well. And over here, we can also check if the request.auth is not equal to null before checking the token, like this. And once we save our file, we can see that it is updated. And now that all these changes have been applied, we can go ahead and test them in our Flutter app. So as a first step, I suggest that we go to the account page and log out, like this. And then we can head back to the authentication page on the emulator suite. And what we're going to do is to test the image upload flows with both of these accounts, keeping in mind that this account has the admin custom claim, but this one doesn't. So let's go ahead and try to sign in. And here I can enter a@b.c with the test password. And then I can go over to the admin page. And then from here, I can press the plus button to add a new product, and then I can choose a product from this list. And as soon as I press the upload button, I get this error telling me that the user is not authorized to perform the desired action. And this is exactly what we want, because this user doesn't have an admin custom claim. And the updated storage rules prevent us from uploading the image to Firebase storage. And now that we have confirmed that this works as intended, we can get back to the account page over here, and then we can log out, and then we can sign in again. And this time we're going to use this account. So let me go ahead and paste it over here, and then I can enter the test password like this. And then we can go to the admin page once again and try to add a new product like this. And this time, as soon as we press the upload button, we can see that the product has been uploaded, and we are taken to the edit product page. And this confirms that the upload has succeeded. But as we can see, there is a problem because the image is not showing over here. However, if we get back to the Firebase emulator and head over to the storage tab, we can see that we have a products folder. And if we open it, we can see that over here we have this bruschetta plate, which is the image that we have uploaded. And this means that we can go ahead. And if we click on this button to load from template, and then we press on save, we can see that the product is saved as intended. And as a proof that everything works, we can get back to the emulator suite and move over to the Firestore tab. And here we can see that the product has been added with all these properties. In summary, in this lesson, we have seen how to update our security rules so that we can only write data to Firestore and Firebase storage if the Firebase ID token has an admin custom claim. And this ensures that users have the correct permissions based on their roles, regardless of what we do in the UI. And the next step is to make some changes to the Flutter client so that it's not possible to show the admin UI in the first place unless we are logged in as an admin user. And we are going to tackle this in the next lesson. In this lesson, we are going to figure out how we can hide this option to open the admin page unless the current user has an admin custom claim. And before we start making any changes, let's open the command palette and head over to this file called home app bar. And if we scroll down a bit, we find this home app bar widget, which is what we use to show the app bar that you see over here. And the first thing we can notice is that inside the build method, there is a to-do, reminding us that we need to add role-based authorization. And for now, what we are doing is to declare this is admin user variable, which is going to be true as long as the user is not null. And if we scroll down a little bit, we can see that this is admin user variable is passed as an argument to the more menu button, which is responsible for showing the drop-down menu that we can see over here. And this only happens if we are on a small screen. On the other hand, if we are on a wide screen, such as when our phone is in landscape mode, then you can see that all the options appear directly on the menu bar, including this admin button, which is shown over here only if is admin user is equal to true. And what this all means is that if we add the appropriate role-based authorization code here, then this UI will work as intended and only show the admin button if the signed in user is an admin. And before we can get any of this working, we need to add some additional code inside the data layer of our authentication feature, because this is where we have defined our auth repository, which acts as a wrapper for the Firebase auth APIs. And as it turns out, in order to check if a user is an admin, we need to add a few methods in different places. And to make life easier, I decided to share an updated snapshot that contains all the required changes and give you a walkthrough of the updated code rather than writing all the code by hand. So please go ahead and open a terminal. And here we can leave the emulator running and press this button to open a separate terminal. And then if you have any working changes, you can discard them by running git reset --hard head. And then you can git checkout section 06 user admin like this. And now that you have the latest code, I can give you an overview of what's changed. And as a first step, let's open the command palette, and then we can take a look at the Firebase app user class. And just as a reminder, what we said in the previous sections is that the purpose of this class is to abstract away the logic inside the user class that comes from the Firebase auth package. And what is new in this class is that I've added this new method called isAdmin. So let's see how this is implemented. And the first thing we do is to call the getIDTokenResult method, which is used to return an ID token result containing the user's JSON Web Token, along with other metadata. And once we add the ID token result, we can read the claims property, which is just a map of key value pairs. And if this is not null, then we can check if the admin claim is set to true and return that. And otherwise, we can just return false. And now that we have reviewed this method, let's move back to our auth repository class, since I made some changes in here as well. And if we scroll down a little bit, we can find that over here I've added this method called ID token changes. And as we can see, this is nearly identical to the auth state changes method. And the only difference between these two methods is that auth state changes is a stream that notifies about changes to the user's signing state, such as sign in or sign out, while the ID token changes method is a stream that does the same thing, but also notifies about token refresh events. And this is very important because when we work with custom claims, we rely on token refresh events to know if the Firebase ID token has changed. And since we now have these two methods that return a stream, we are also going to need the corresponding providers, which are defined at the bottom over here. And as you can see, the two providers are nearly identical, and the only difference is that they call different methods from the repository. And as you can see, over here we have an extra provider as well. And what this does is to return a feature or of type bool. And what we do inside it is to watch the ID token changes provider that comes from here. And this way we can get the updated user object every time the ID token changes. And since the user can be null when we are signed out, then here we need this condition. And if the condition is true, then we return this expression using the isAdmin method that we have reviewed a minute ago. And otherwise we return false. And now that I've given you an overview of all the code changes, let's get back to the Home App Bar widget so that we can understand how to use the new code. And since we are just saying that the app user class has an isAdmin method, you may be wondering if we can just call it directly inside the build method. For example, here we could replace this expression with user dot isAdmin, like this. However, we must not forget that this method returns a feature, and we can only get the value inside it if we await it, like this. But the problem is that we can't really do this here, because we can't use asynchronous code inside the widget build method. So what should we do? Well, for now, let's comment out this code, and we're going to do something else instead, and that is to declare the isAdmin user to be equal to ref.watch. And this time we're going to use the isCurrentUserAdmin provider that we've added to our auth repository file, because this allows us to get the data that we want as an async value rather than a feature. But this is still not what we want, because over here we want to unwrap the bool value inside it and not use the async value directly. However, this is easy to do because we can just add .value like this. And since this is a nullable value, then we can use the if null operator with a default value of false like this. And once we do this, all the compile errors go away. In summary, what we have just learned is that we can check if a user is an admin by calling this method that we have added to the app user class. However, this method returns a feature, and we can't really use it directly inside the build method. And to work around that, we have decided to watch this feature provider instead. And since watching a feature provider gives us an async value, then we have to unwrap the value and provide a fallback value, which will be used while the data is still loading. So this is yet another example of how to deal with asynchronous data inside our widgets by using feature provider. And now that we have made this change, we can remove these comments, and then we can go ahead and test our code. And the first thing that we should do is to go to the account page and log out like this, because our goal is to test the entire sign up process. So let's go over to the sign in page and register a new account. And this time I'm going to enter admin2@codewithandrea.com, which is an email that I've never registered before. And then we can enter a test password and go ahead and create an account. And as soon as we do this, we are taken to the home page. And if we open the dropdown, we can see that the admin button is not showing. However, if we get back to the Firebase emulator suite and open the logs tab, we can see that the custom claim has been set. So why can we not see the admin button on this dropdown? Well, the solution to this mystery lies in the documentation for the custom claims feature in this section about propagating the custom claims to the client. And this explains that newly set custom claims are propagated in 3 possible ways. And these are when the user signs in or re-authenticates after the custom claims are modified, or when an existing user session gets its ID token refreshed after an old token expires, or when ID token is force refreshed by calling currentUser.getIDToken with a value of true. However, custom claims are not propagated automatically when we set them using the Firebase admin SDK. In other words, it is only when any of these 3 scenarios takes place that the client will get an updated ID token. And as we will see in the next lesson, the most reliable way of force refreshing the ID token is by writing some additional code that involves setting up a Cloud Firestore listener. But for now, I want to show you that indeed, if we sign out and sign back in again, then we'll get an updated token which will contain the custom claims that we need. So let's go ahead and log out from here, and then we can sign in once again using the credentials that we have just created. And as soon as we sign in, we're taken to the home page. And if we click on the 3 dots, we can see that this time the admin option is visible. And this proves that the ID token has been refreshed correctly after signing in. Okay, so it looks like we have covered a lot of ground in this lesson. And as we have seen, it is not straightforward to add all the logic for refreshing the ID token and updating the UI. And I ended up writing additional methods and providers in different files to make things work. And if something is not clear at this stage, you can find a summary of all the most important steps in the notes below. Okay, so let's continue on the next lesson. In the last lesson, we have seen how to check if the user is an admin by reading the custom claims on the client. And we have discovered that our implementation is not optimal because the Firebase ID token is only guaranteed to be updated if the user signs out and signs back in, which is not a great user experience. And in this lesson, we're going to make some changes so that our client app can detect automatically if the token has been updated using real-time listeners. And just to be clear, the reason that this is not already working is that the ID token changes stream inside our client will not get a new event when we set the custom user claims using the Firebase admin SDK. So how can we tell the client that it needs to refresh the ID token once the custom claims have been set? Well, to answer this question, I've prepared this diagram. And the idea here is that we can write a document to Cloud Firestore as soon as the custom claims have been set. And then on the client, we can listen to all state changes to be notified of sign in and sign out events. And when we have a user, we can set up a real-time listener that gives us a new snapshot every time this document changes. And then we can use this to force refresh our ID token. And in turn, this will cause the ID token changes to emit a new value. And as a result, our UI will rebuild automatically. And we should also not forget to make this document readable by signed-in users in the Firestore security rules. So how can we implement this logic? Well, as it turns out, the code for doing this on the server is very simple, because all we had to do is to add these 3 lines to our Cloud function. However, the corresponding logic on the client side is a bit more complex, and for this reason, I've decided to share an updated code snapshot with all the completed code. So please go ahead and open the terminal, and then you can run git reset --hard head to discard any working changes that you may have. And then you can git checkout section 06 refresh token real-time listeners, like this, to get all the latest code. Okay, so let me give you an overview of what's changed, starting from the index.ts file. And the main idea here is that once we've set the custom claims for a given user, we can write some metadata to Cloud Firestore by using this code. And what this will do is to write a timestamp inside the document at this location. And as far as the server side goes, this is all we need to do. And next up, let's move over to the client code. And if we get back to our diagram, we can see that we had to set up 2 different listeners. In fact, the first one listens to the old state changes string so that we know when the user signs in and signs out. And if we detect that the user has signed in, then we set up a second listener by referencing this document using the user ID. And as soon as we get a new snapshot, we can force refresh the ID token. And as we can see, this code has nothing to do with the UI, and it certainly doesn't belong to the presentation layer. So where should this code live then? And should it all happen inside one class, or should we split it into multiple classes? Well, let's take a look. So let's open up the Project Explorer, and if we scroll down, we can find the authentication feature. And over here, you can see that I've added a new application folder inside it. And this contains a class called User Token Refresh Service. And this is used to force an ID token to refresh on sign in. And as you can see, this is just a regular class that takes a ref argument, which is used to access external dependencies. And as soon as this class is instantiated, it calls this init method, which is used to listen to the old state changes provider. And inside the callback, we extract the user object. And if we detect that the user is not null, then we listen to another provider called user metadata refresh time provider by passing the user ID as an argument. And then we extract the refresh time. And if we detect that this is not null, then we call user.forceRefresh ID token, which is a new method that I added to the Firebase app user class. But how and when should this class be initialized? Well, since we need to listen to the old state changes stream, it makes sense to initialize this class as soon as the app starts. So let's head over to the app bootstrap class, which is used to create the root widget. And as you can see over here, I've added this code to initialize the user token refresh service. And this will ensure that our listeners are registered as soon as the app starts. Okay, so let's get back to our service class. And the next question you may have is, where does this user metadata refresh time provider come from? And the answer is that inside the data folder of our authentication feature, I've added this new user metadata repository class. And as you can see, this takes a Firebase Firestore object as a dependency. And inside it, I've added this watch user metadata method, which returns a string with a nullable datetime object. And as you can see, what we do inside it is to get a reference to this document, and then we use the snapshots API to get the string we want. And we use the map operator to extract the refresh time from the snapshot data. And since this is stored as a timestamp, here we parse it to a datetime object that we can return. So overall, all this method does is to extract the data that we need from this document and return it inside the stream. And since we want to listen to this stream, over here I have created the corresponding stream provider. And this is the provider that we listen to inside our user token refresh service over here. And once we extract the refresh time and we check if it's not null, then we can call this force refresh ID token method, which is defined inside our app user class. And since we are using Firebase, the corresponding implementation lives in the Firebase app user class. And as you can see, all this does is to call this ID token with a force refresh value of true, like this. And finally, there is one more thing that I need to show you before we test this code. And that is that I've updated my security rules, which you can find inside the firestore.rules file over here. And as you can see, I've added this new rule, which is needed so that signed in users can access the document that corresponds to their UID. And this completes our overview of all the code changes that I've added. And now that everything is in place, we can go ahead and test the new code. And at this stage, I think it will be good to start from a clean slate. So let's go ahead and log out from the account screen. And then we can open the terminal. And then we can shut down the emulator by pressing Ctrl+C. And then we can go to the second terminal and make sure we are inside the functions folder. And then we can compile the updated cloud function by running npm run build, like this. And once this is done, we can get back to the first terminal, and then we can start the emulators one more time. And once the emulator is up and running, we can get back to the emulator UI. And if we go to the Firestore tab, we should see that there are no documents. However, our Flutter app is still showing this product because the data is cached on the client. But if we click on the product and navigate back, then we should see that everything is in sync again. And now we are ready to test that the new logic works as intended. And at this stage, we need to hot restart the Flutter app, since the new listeners are only registered when the app starts. And then we can get back to the emulator UI, and we can move over to the logs tab. And then we can click on sign in and choose the option to register a new account. And here we can enter admin@codewithandrea.com with a test password like we've done before. And once we create an account, we can see that we are taken to the homepage. And if we turn the device to landscape mode, we can see that the admin button shows as expected. And in fact, our logs confirm that the custom claim has been set. And if we move over to the Firestore tab, we should also see that a document has been created inside a collection called metadata. And this includes the refresh time that we have set in the cloud function. And this confirms that everything is working as intended. In summary, in this lesson, we have seen that we can use Cloud Firestore as a way to tell the client that it needs to force refresh the ID token. And as we have seen, in order for this to work correctly, we need various moving parts, including some updated server-side code, so that we can write to Firestore after we set the custom claims. And on the client, we need a user token refresh service class that is initialized when the app starts, as well as a user metadata repository that we can use to get the updated metadata. And that is in addition to all the new authentication code that we have added in the previous lessons, so that we can check if the user is an admin and get real-time updates when the ID token changes. So overall, it seems that if we want to combine custom claims with real-time updates, we had to write all this additional code. And to make this code more maintainable, I think it's a good idea to keep all the relevant logic inside this user tokens refresh service class, which lives inside the application folder and is completely independent from the UI. In fact, all the UI should care about is to rebuild itself when there are ID token changes. However, there is no doubt that this solution is fairly complex and relies on many different moving parts. And you may be wondering if there is a simpler way. Well, since we have already gone through the trouble of writing this data to Firestore, we could consider writing the admin flag directly inside this document, like this. And then we could modify the client code to read this value directly from Firestore and decide if the current user is an admin without using custom claims at all. And indeed, this will make our client-side code much simpler, since we could work with real-time listeners directly without having to force refresh the ID token. However, this route would make our security rules more complex. And to show you what I mean, we can head over to the Firestore rules one more time. And here, rather than checking if we have a custom claim like this, we could check if the user is an admin with this alternative rule, which works by running a get query to read a document at this location, and by checking if there is an admin field set to true inside it. And this can only be done if the user is currently authenticated. And as your application becomes more complex, it can be difficult to maintain security rules that look like this. And you will also incur additional costs, because you'll pay for an additional document read every time the security rule is evaluated. So let me go ahead and remove this rule. Okay, so this has been a long lesson, so let's do a quick summary. And as we have seen, there are two main ways to implement role-based authorization, each with different trade-offs. The first option is to implement role-based authorization with custom claims. And in this case, your server-side and client-side code becomes more complex, but the security rules are simpler and your Firebase bill will be lower. And the second option is to implement role-based authorization with Firestore only. And in this case, your code will be simpler, but the security rules become more complex and your Firebase bill will be higher. And overall, I think it was worthwhile to show you a complete implementation using custom claims, since this is something that is not covered well enough in the Firebase docs. And by the way, in the notes below, I've included some additional details that you might find useful. Okay, so let's continue on the next lesson. In this lesson, we're going to update the Go router redirect logic so that only admin users have access to the admin pages. And just to be clear, the reason we need to do this is that at the moment, if we run our app on Flutter Web, nothing stops us from navigating directly to the admin page by URL. And this should not be allowed unless we are signed in as an admin user. So let's go ahead and change this by using the command palette to open the app router.dart file. And then we can scroll down and locate the redirect callback. And as you can see, this callback already includes some logic to send the user back to the home page, depending on the logged in state and the location of the requested route. So let's go ahead and make some changes. And the first thing that we want to check is if a logged in user is also an admin. And we can do that by typing final is admin equal to await user.isAdmin, like this. And since this is some asynchronous code, then we need to turn this into an async callback, which is something that is supported by GoRouter, since the redirect function can return a future. And now that we have made this change, we can type if not is admin and the state.location starts with /admin, and if that is the case, we can return /, which represents the homepage. And just to be clear, the reason I'm using starts with here is that I want this expression to take into account the admin route along with all the subroutes, so that regular users are not allowed to navigate to any of these pages. And I can add a comment here to make this clearer. And by the way, we also need to add the same logic inside the else branch as well, because non-signed in users should also not be allowed to open the admin pages. So over here, we can add a similar condition to check if the state.location.starts with admin. And if that is the case, we can return / like this. And now that we have made these changes, we can save our file and test them. So in my case, I already have the app running on Google Chrome, but if you haven't, you can run it as well. And what I can show you is that if we are signed in as a regular user, then we can append / admin to the address bar. And if we press enter, we can see that we are redirected to the homepage. And as a second test, we can try to log out like this. And then we can try to append / admin to the address bar once again. And in this case, we should also be redirected to the homepage. And this confirms that our redirect logic is working as intended. And by the way, one question that you may have at this stage is whether this is the best way to handle the redirect, or whether there is a more efficient way to get this working without using any asynchronous code. And you can find the answer to that in the notes below. Okay, so let's continue on the next lesson. In the last few lessons, we have completed our implementation of role-based authorization with custom claims. And we have used the Firebase local emulator to verify that everything works as intended. And this means that there is only one thing left to do, and that is to deploy our cloud functions along with the updated security rules so that we can test our project with the real Firebase backend. So let's get back to VS Code and open the terminal. And at this stage, we can hit Ctrl+C to shut down the Firebase local emulator. And before we do anything else, I recommend that you check out the latest code snapshot from Git. So please go ahead and run git reset --hard head to discard any working changes. And then you can run git checkout section 06 -completed like this. And this will bring you up to date with the latest changes. And just so you know, if you open the main.dart file, you'll see that over here I had disabled the Firebase emulators, since we now want to run our Flutter app using the real Firebase backend. And in fact, if you still have the app running on iOS or Android, we should probably log out at this stage. And since we're switching from the Firebase emulator to the Firebase backend, I think it's a good idea to delete the app entirely from the device, like this. And we are going to reinstall it shortly. Next up, we can get back to our browser and head over to the Firebase console. And from the side panel, we can open this build dropdown and choose the functions item like this. And if it's the first time that you go to the functions page for this project, you may see a different page telling you to upgrade the project to the Blades plan. And in fact, this is exactly what we're going to do. And another way of doing this is by clicking on this upgrade button on the bottom left corner over here. So let's go ahead and do that. And from here, we can select the Blades plan. And then we need to select a billing account or create a new one if needed. And then we can click on continue. And we can confirm our purchase. And then we should see that we have successfully upgraded the project to the Blades plan, like this. And once we have upgraded our plan, we should be ready to make our first deploy. So let's do that by getting back to VS Code. And then we can open the terminal. And over here, we can type Firebase deploy, like this. And then we can run this and watch the console log. And as you can see, this is going to apply the updated configuration for the storage, Firestore, and functions options. And as we can see, both the Firebase storage and the Cloud Firestore rules have been compiled successfully. And then the CLI is going to do a bunch of additional checks. And then it also uploads the storage rules and the Firestore rules. And then it's going to go ahead and create our Cloud function. And this is a process that can take a little while. And assuming that everything has worked as intended, we should see that our Cloud function has been created. And this means that we can get back to the Firebase console. And at this stage, we can refresh the page. And we should see that our Cloud function has been deployed. So the next step is to go ahead and test it. So let's get back to VS Code one more time. And at this stage, we can choose a device to run on. So in my case, I'm going to go for iPhone 14, and then we can press F5 and run the app, like this. And then we can wait until it's installed. Okay, so the app is now up and running. And to make testing easier, we can keep the Firebase project alongside it. And as a first step, we can open the authentication page, which lists all the users that we have created so far. So let's go ahead and open the sign-in screen and choose the register option. And then we can enter an email address that we haven't used before, such as this, along with a test password. And then we can create the account. And if we refresh this page, we should see that the new user account appears over here. And once we are back on the home page, we should see that the admin option is not available here, because this is not an admin user. And next up, we can test the happy path by creating an admin user. So let's go ahead and log out from the account page. And then we can go to sign in once again and register a new user. And this time I can choose an email address that belongs to our whitelisted domain, like this, along with a test password. And then we can go ahead and create the account. And I'm also going to turn the phone to landscape mode. And we should see that the admin option appears over here. And as it turns out, eventually it does indeed show up, but only after a rather long delay. And this is because our Cloud function has been invoked for the first time and has gone through a cold start. And if you want to get more insights about this, we can check the Logs Explorer inside the Google Cloud Console. And in this case, what this is showing me is that the function took 3.5 seconds to execute. So keep in mind that if you want to learn more about cold starts and how to improve the performance of your Cloud functions, you can check the resources in the notes below. But for now, let's stay on track. And at this stage, we should be able to go ahead and add some new products as an admin user. So let's go ahead and click on this plus button, and then we can select a product and try to upload it. And then we are taken to this edit product page, where we can load all these details from a template, and then we can save, and we can see that the product appears over here and everything is working as intended. And the reason that we have been able to do this is that we have all the correct security rules in place, because these have been deployed when we've run the Firebase deploy command from the terminal. Okay, so this completes this lesson about testing the new admin functionality with the real Firebase backend. And if anything is not working for you at this stage, please follow the notes below for more details. And as a reminder, in order to enable Cloud functions, we had to upgrade our Firebase project to the Blaze plan, which means that we will get charged based on usage. And for this reason, I recommend that you set up a project budget on the Google Cloud Console, which is something that we have already covered in a previous section. And just as a reminder, you can do this by going to the billing page. And from here, you can head over to the budgets and alerts page. And then you can click on this button to create a new budget. Okay, so let's continue on the next lesson. We have now reached the end of this section, so let's do a quick summary of what we have learned by looking at the big picture. And as we have seen, when it comes to implementing role-based authorization, there are three main things that we need to consider. The first one is that we need to write some server-side code that is triggered when a new user is created. And if all the preconditions are met, then we can set the custom claims for that user. And if we want our client app to detect changes to the custom claims in real time, we can write some metadata to Cloud Firestore. And then on the client, we can set up some listeners that should be used to detect when the custom claims have been set on the server. And when that's the case, we can force refresh the ID token so that our UI will rebuild automatically. And finally, we need to update our security rules to ensure that only authorized users get access to the appropriate data in Cloud Firestore. And of course, we have implemented all this logic based on some requirements that are unique to our e-commerce app. But of course, when you write your own apps, you had to adjust this logic to fit your specific use case. For example, you may decide that rather than setting a custom admin flag, you want to introduce an access level instead, so that you can enable different permissions based on that. Or perhaps you may decide that rather than using a Firebase authentication trigger to set the custom claims, you may want to use a callable cloud function that is called directly by the Flutter client app. And this can be useful if you want users to explicitly request certain permissions. And another use case would be to use custom claims together with in-app purchases, so that you can unlock some functionality in the app after the user has paid for it. In fact, if you already have some Firebase apps that support different user roles, you can improve them by implementing role-based authorization with custom claims. And once you are done, you should see that your security rules become a lot simpler. Okay, so let's continue on the next section. Welcome to this new section, where we are going to dive deeper with Cloud Firestore by taking a closer look at one of the most important features in our e-commerce app, which is the shopping cart feature. And what makes this feature interesting is that we can use it to add, update, or delete items from our shopping cart. And as we do this, the shopping cart total should update automatically. And when it comes to building a feature such as this, there are some important things that we need to take into account, such as how we can set up real-time listeners so that our UI rebuilds automatically when the data changes. And also, how should we model our data so that we can combine data from different documents and calculate the shopping cart total efficiently. And we'll also figure out how we can reduce costs by minimizing the number of reads and writes, as well as the storage and network bandwidth that is used by our app. And these are all essential topics that you need to understand if you want to provide a good user experience while minimizing the cost of your Firebase bill. So here is what we will cover in the coming lessons. We'll start off by getting an updated starter project that will make it easier to work with the shopping cart feature by using the Firebase local emulator. Then I'll give you an overview of this feature from an architectural point of view, so that you can better understand what classes are involved and how they interact with each other. And then we'll talk about data modeling and try to figure out how we should store the shopping cart data in Firestore. And as part of this, we'll implement a remote cart repository that we can use to read and write the shopping cart data, and we'll update the security rules as well. And after that, we'll look at different strategies for calculating the cart total, which is something that depends on the items that we have added to the cart as well as their price. And finally, we'll look at how we can estimate the cost of our e-commerce app by using a spreadsheet that takes into account how many daily active users we have, as well as other application-specific metrics. And as we will see, if we are not careful, we will end up with a Firebase bill that is 100 times or 1,000 times more expensive than it needs to be. So as you can see, we have a lot to cover. And as usual, I'll guide you through various important concepts using diagrams, so that we can always keep an eye on the big picture. And by the end of this section, you should have a better understanding of data modeling, as well as how to identify issues that could lead to a big Firebase bill, and what you can do to fix them in your own apps. Okay, so let's get started in the next lesson. In this lesson, I'm going to share a new starter project that we will use as a starting point for this section. And we will need this since it contains some tweaks and bug fixes that will make it easier to work with the Firebase local emulator in the coming lessons. So please go ahead and open a terminal, and then you can run git reset --hard head to discard any working changes you may have. And then you can run git checkout section 07-starter to get the latest changes. And then you can also run flutter pub get to get the latest packages. And I'll tell you a bit more about what's changed in the coming lessons. But for now, the important thing to notice is that inside the main.dart file, I've enabled the Firebase emulator by uncommenting this line. And the reason we are going to use the emulator is that we can only test the shopping cart feature if we have already preloaded some products inside Firebase. And this is something that we have covered in section 4, where we have seen how to upload products as an admin user. And one cool feature about the Firebase local emulator is that it gives us the ability to start the emulators by importing some seed data. And in fact, if we take a closer look at the Project Explorer, we can see that I've included this folder called seed, and this contains another folder called all products, which in turn contains all the data that I've exported for you, so that you can get up and running more quickly. So before you go ahead and run the Flutter app, please open the terminal. And from here, you can run Firebase emulator start. And then you can pass a -- import flag equal to seed / old products, like this. And what this will do is to start the emulators by loading all the data from this seed. And what you should see in the console log is that the data is imported as needed from the seed folder that we have specified. And one more thing that I also recommend you do is to open a separate folder and go into the functions folder. And from here, you can run npm run build, since this will take care of compiling the cloud functions. And once this is done, you will see that our cloud function is loaded. And once you have completed all these steps, you can go ahead and choose a device, which in my case is macOS. And then you can go ahead and run the app and wait until the build is complete. So make sure that you can run the app without problems. And if you experience any issues at this stage, you can check the notes below. Okay, so it looks like our app is up and running. And we can see that the entire product list is available on the homepage. And this is because we have started the Firebase emulator by preloading some data from a seed folder. And if you head over to the authentication tab, you should see that these two accounts already exist. And if you go to the Firestore tab, you'll see that all these products are already loaded. And these are exactly the products that we can see in the app over here. In summary, in this lesson, we have checked out the latest starter project, which includes a seed folder that contains all the products that we are going to use. And we have also configured the Firebase local emulator to import this seed folder. And we have connected our Flutter app to this emulator. And once again, if you're having any issues with all these setup steps, please check the notes below. But assuming that everything is working as intended, we can continue on the next lesson where we'll get started with the shopping cart feature. Now that our application is up and running, it's a good time to give you an overview about how the shopping cart works. And by the way, this is something that we have already covered in detail in section 8 of the Flutter Foundations course. And if you want to get a complete overview of how this feature works, you can watch the first 3 lessons of that section. But for now, I just want to give you a little refresher. And a good place to start is by looking at the application UI. And the way this works is that as soon as we select a product from this list, we can choose the desired quantity using this widget. And then we can go ahead and add it to the shopping cart. And as you can see, over here we get a small badge telling us how many items are in the cart. And if we want, we can go ahead and add a different product as well, like this. And once we open the shopping cart, we can see a list of all the items that have been added, along with the total price. And as you can see, if I update the quantity of any of these items, then the total updates automatically. So it kind of looks like this feature is already working as intended. But if we open the Firebase local emulator, we can see that no shopping cart data has been written to Cloud Firestore. So how does this all work under the hood? Well, to better understand this, we can consider this diagram, which shows all the different classes that are used to make this work. And the most important class in this diagram is the cart service class, which is used to mediate between the code in the presentation layer and the code in the data layer. And the reason I've introduced this class in the first place is that we had 2 separate cart repositories. The first one is a local cart repository, which is used as a local storage system where we are not signed in. And the second one is a remote cart repository, which we can use to communicate to our backend as a signed in user. And as a reminder, when we implemented all these classes in the Flutter Foundations course, we decided to implement this repository using the sembast package, which gives us a way to persist some data on disk. However, what we have not done yet is to provide a proper implementation for the remote cart repository. And in fact, if we get back to VS Code, we can use the command palette to open the remote cart repository file. And we can see that there are some to-dos in this code, telling us to implement this class using Firebase. And indeed, our first goal in this section will be to figure out how to implement these methods using Firestore, so that we can read and write the shopping cart data. And by doing this, we'll be able to save the shopping cart items to Firestore, rather than using a fake remote cart repository, which is what we have been using up until now, as a placeholder for our backend. So once again, our first goal is to implement all the methods inside this remote cart repository, so that we can store the shopping cart data with Firestore. And once we have done that, we'll also revisit the code for calculating the shopping cart total, which at the moment uses a naive implementation that is not optimal and could result in many unnecessary document reads. Okay, so this completes our initial overview of the shopping cart feature. And by the way, before we move on, I want to mention that on my website you can find this article about the application layer. And this article offers a very good overview of the shopping cart feature that we'll be working on, as well as an in-depth explanation of what is the purpose of the application layer, which is something that people sometimes ask me in the course Q&A. So make sure to use this article as a reference if needed. And now that we have a high-level understanding of what we are trying to build, we can continue on the next lesson, where we will talk about data modeling. In this lesson, we're going to talk about data modeling, so we can get a better understanding of how to represent the shopping cart data using Cloud Firestore. And as a starting point, I want to show you this diagram, which represents the various entities that exist in our application domain, along with their relationships. And if you are familiar with how relational databases work, this kind of diagram should be familiar to you. So let's try to understand this in more detail and see how we might represent the same entities using documents and collections with Cloud Firestore. Okay, so for a start, we can see that we have this user entity over here on the left. And we also have a product entity over here on the right. And we also have a cart entity, which has a one-to-one relationship with the user class, because each user has their own shopping cart. And as we can see from this relationship, a shopping cart contains 0 to n items, where each item is represented by a product ID and a quantity. And this product ID is what allows us to reference the corresponding product entity, so that we can access all these different fields. And one such field is the price, which is something that we can use to calculate the shopping cart total using this formula. Okay, so how can we represent these entities and their relationships with Cloud Firestore? Well, for a start, a user entity is something that is managed by Firebase Auth. And we already know that when a user account is created, it is added to the authentication page on the console. And we can use this user ID to create user-specific documents in Firestore. So let me copy this ID from here, as we will use it shortly. And if we head over to the Firestore tab, we can see that over here we have this collection called products. And this contains all the products that we have created so far. And what this means is that we already know how to represent users and products using Firebase. And what we need to figure out next is where to store the cart data and all the items inside it for each user. And as we know, when we work with Firestore, we have to store data using documents and collections. So one possible way to approach this would be to create a top-level collection called cart. And if we wanted to store user-specific shopping cart data, we could use the user ID as the document ID, which is the value that I copied earlier on from the authentication tab. And once we have done this, we can hit save. And if we refresh the page, we can see that this cart collection appears over here with this empty document inside it. And just to be clear, this document represents the shopping cart of the user that matches this UID. And since the shopping cart is something that is private to each user, in the next lesson, we'll add this additional security rule to ensure that authenticated users can only have access to their own shopping cart. And now that we have worked out the location of the shopping cart in Firestore, we need to figure out how to store the actual items inside it. So let me show you two different ways of doing this so that we can compare their pros and cons. And the first way is to store the cart items as a sub-collection. So to do this, we can click on this button, and then we can add a sub-collection called items, like this. And then we need to add some documents inside it. And one thing that we could do is to use the product ID as the document ID. So in this case, I can type 1, since our product IDs are numbered from 1 until 14. And then inside this document, I can add a quantity, which is a number, and then I can give it a value of 5, for example. And if I hit save, we can see that the document appears over here with this quantity. And if we wanted to add another document, we could do it from here by choosing a different product ID and adding a quantity, which again is a number with a value of 10, for example. So as you can see, every time we want to add a new item, we need to add a new document to this collection. In summary, by following this approach, we can add a new item to the cart by adding a new document inside this sub-collection. And if we want to edit the item quantity, we can update the document that is identified by the product ID. And if we want to remove an item from the cart, we can just remove the corresponding document, like this. And if we want to read an item, we just need to read the document with the given product ID. So overall, it seems that this approach of using a sub-collection would work. But it is not very efficient, because by doing things this way, we had to perform one read or write for each item that is inside the cart. And this leads us to the second approach, which is to store items as a map of key value pairs inside the cart document itself. So how does this work? Well, over here we could add a new field called items, and we can set its type to a map. And then we could add some key value pairs, where the keys inside the map represent the product ID, and the values are numbers that represent the quantity, like this. And if we want to store multiple items, we can just add additional key value pairs, like this. And if we hit save, we can see that all the data is inside a single document. And the benefit of this approach is that we can read, write, update, and delete all the cart items with a single operation, rather than having to perform one operation for each item. And one thing you should know is that the maximum size of a document in Firestore is 1 megabyte. And this is more than enough for our purposes, because usually we only store a few items inside the shopping cart. So overall, it seems that this approach is much more efficient. And since we no longer need this sub-collection, we can delete it, like this. In summary, in this lesson, we have figured out where we can store the shopping cart data for each user by creating a top-level collection called cart, where each document is the user UID. And inside each document, we can store a map of key value pairs, where the key is the product ID and the value is the quantity. And this is the most optimal representation I can think of, since we only need to perform one operation to read or write all the shopping cart items. And the takeaway of this lesson is that when it comes to data modeling, it pays off to do a bit of thinking up front and figure out what is the most optimal way to store your data before writing any code. And as you do that, try to think about what data you need to store, what queries you need to perform on that data, what security rules you will need, and how to minimize the document reads and writes, because this is what you pay for. Okay, so let's continue on the next lesson, where we'll write the code for reading and writing the shopping cart data with Cloud Firestore. In this lesson, we're going to implement the remote cart repository, which is the class that we're going to use to read and write the shopping cart data using Cloud Firestore. So let's get back to VS Code, and then we can use the command palette to open the remote cart repository. And over here, we can find this class with a bunch of methods that we have to implement, along with a provider that currently throws an unimplemented error. So the first step is to remove the abstract keyword from this class, along with this to-do as well. And as a result, we are going to get some errors because these methods don't have a body. But before we address these errors, we can go ahead and add a final Firebase Firestore _ Firestore property. And in order to use this, we need to import Cloud Firestore. And while we're here, we should also add a constructor like this. And before we forget, we are also going to update this provider by returning an instance of our remote cart repository, passing Firebase Firestore.instance as an argument like this. And next up, I suggest that we add a helper method that will be used by all these three methods. This method should return a document reference of type cart, and we can call it _cartref. And this method will take a user ID argument like this, and we can use it to return _firestore.the document that is located at cart /UID using string interpolation. So as it stands, all this method does is to return a document reference to this location. However, we're getting an error telling us that a value of type document reference with a map of key value pairs can't be returned because the return type of our method is document reference of type cart. And this is something that we have seen before. And the way to handle it is to use a converter. So let's go ahead and add the with converter syntax. And inside it, we need to specify the from Firestore callback, which gives us a document and another argument that we don't need. And we can use this to return cart.fromMap, passing the document data as an argument. And here we can use the assertion operator because this data will not be null in this case. And then we also need to specify the to Firestore callback, which gives us our shopping cart along with an options argument that we don't need, and we can use it to return cart.toMap. And just to be clear, the reason we can do this is that we have already implemented the fromMap and toMap methods inside our cart model class. And now that we have this helper method, we can go ahead and implement the method body for all these other methods. So let's start from the fetch cart method, which is going to be an asynchronous method. And inside it, we can type final ref equal to, and then we can use our cart ref method, passing the UID as an argument. And then we can get a snapshot by awaiting ref.get like this. And then we can return the snapshot.data. And since this method returns a nullable cart object, we can use the if null operator to return an empty cart as a fallback value, like this. Next up, we can implement the watch carts method, which in this case returns a string. So let's go ahead and get a ref object in the same way that we have done before, like this. But what's different in this case is that we can return ref.snapshot, which is a method that returns a stream of type document snapshot. And since we need to return a stream of type cart, we can use the map operator to map our snapshot to snapshot.data. And just like we have done over here, we can use the if null operator to return an empty cart if this value is null. And finally, we can implement this setCart method. So let's start by making it into an async method, and then inside it, we can get a ref object as usual from cart ref with UID as an argument. And in this case, all we have to do is to await ref.set with cart as an argument, like this. And with this, we have completed the implementation of this class. And just to be clear, this first method allows us to fetch the shopping cart for the current user as a one-time read, while this method allows us to do the same, but by using a real-time listener, which returns a stream. And this method can be used to set the shopping cart data for the current user at this location. And all these methods are called by the cart service class, which is already implemented as part of the starter project. So before we continue, I think it's a good idea to take a look at how the cart service and cart classes work. So let's go ahead and command click on this cart class to open its definition. And as you can see, this class has an items property, which is a map of key value pairs, where the key is the product ID and the value is the quantity. And this is exactly what we decided to store inside the carts document in Firestore. And since we are storing these values exactly as we receive them from Cloud Firestore, then the serialization logic is very simple. However, how can we add, update, or remove items from this model class? Well, to deal with that, we can open the Project Explorer. And as we can see over here, we have this file called mutable cart. And if we open it, we find this extension, which contains some helper methods that we can use to update, add, or remove items. And all these methods work by making a copy of the current items and returning a new cart object with the updated data. But where are these methods used? Well, to find out, we can open the cart service class. And if we scroll down over here, we can find these methods that are used to set, add, or remove items. And these are the methods that are called directly by the code inside our presentation layer. And as we can see, each of these methods works by fetching the current cart and then getting an updated cart by using one of these helper methods, and then by writing it back to the repository using some helper methods that are defined over here. So overall, this should give you a better understanding of how all these classes fit together. And with that said, we can get back to our remote cart repository. And before we continue, there are still a couple of things that we need to do. The first one is that we need to update the security rules, which are stored inside the firestore.rules file. So over here, we can add a comment with a new match statement using /cart/UID as the location. And in this case, we need to allow reads and writes if the request.auth.UID is equal to the UID that matches this location. And this is very important because we want to ensure that users can read and write only their own shopping cart data. So this takes care of the security rules. And as long as the emulator is still running, we should see that they have been updated. And finally, we need to do one more thing, and that is to go to the app bootstrap Firebase file. Then we can scroll down a little bit to locate this method to create the Firebase provider container. And as you can see over here, this remote cart repository provider is being overridden by this remote cart repository, which is a fake remote cart repository. And this is no longer what we want. So let's make sure that we delete this line from here and this line from here. And this will ensure that when the app starts, we will use this implementation, which is returned by this provider. Okay, so let's continue on the next lesson, where we are going to test our new implementation. In the last lesson, we have completed the implementation of the remote cart repository. And now that we have made these changes, we can go ahead and test our new implementation. And assuming that we still have the Firebase emulator running and using the seed data, we can go ahead and hot restart the app to ensure that all the latest changes have been applied. And one thing I want to point out is that currently I'm not signed in. And over here I had 2 shopping cart items, which were stored using the local cart repository using the Sembast package. So let me go ahead and delete these items so that we can start from a clean slate. And then I can go ahead and sign in using the test account that is already stored in the emulator. So in this case, the email is test@test.com and the password is test1234. So we can use this to sign in, and then we can head over to the Firestore tab to see if the shopping cart data is stored as intended. And as a reminder, in the previous lesson, we have already added some test items over here. And as it turns out, if we open the shopping cart in the app, we can see that these same items are already showing up. And this proves that the app is loading the data correctly from the Firestore emulator. So what we can do at this stage is to edit the product quantities inside the app. And as we can see, the corresponding data is updated in real time over here. Likewise, if we edit the quantity from the console, our app updates automatically. And this is because we are using real-time listeners to show the shopping cart data in the UI. And of course, if we want, we can go back to the homepage and select another product and add it to the shopping cart as well. And we should see that it appears over here, and a corresponding key value pair appears in Firestore as well. And this confirms that everything is working as intended. And if something is not working for you at this stage, please check the notes below for more details. And by the way, one thing that you may be wondering at this stage is how does the shopping cart data go from the repositories all the way into the UI? And to answer that, we can use the command palette to open the shopping cart screen file. And if we scroll down a little bit, we can see that inside the scaffold body, we have this consumer widget. And over here, we are watching this cart provider, which is a stream provider of type cart. This is a provider that is generated from this function inside the cart service file. And what this does is to check if the user is authenticated or not. And if it is authenticated, it watches this remote cart repository. It calls this method, which is what we have implemented in this lesson. And if we get back to the shopping cart screen, we can see that we use an async value widget to unwrap this async value of type cart. And if there is some data, then we return the shopping cart items builder, which is responsible for returning this UI. And this builder takes a list of items as an input, which is something that we can obtain with this helper method that I've added to the cart class. So hopefully this gives you an idea of how everything fits together. And you can take a closer look at these classes if you want to dig deeper. In summary, in this lesson, we have seen how to read and write the shopping cart data using Firestore by implementing the remote cart repository class, as well as how to update the security rules so that users only have access to their own data. And we have also tested that everything works as intended, and we can correctly read and write data to Firestore. And we have also seen that in order to show the data in the UI, we need to do a bit of manipulation to convert the map of items inside the cart into a list that can be rendered in the UI. So as it turns out, we had to do a bit of work to massage the data that comes from Firestore into a list of items that we can show in the UI. But this is something that pays off for us, because it means that we can read, write, update, or delete the shopping cart data with a single operation, since all this data is stored in the same document. And since we have been able to test that the shopping cart works as intended, it looks like this feature is complete. However, there are still some important considerations to make about how to calculate the cart total. So let's continue on the next lesson, where we'll look at this in more detail. In this lesson, we're going to revisit the logic for calculating the shopping cart total, which is a value that is not stored directly into Firestore, but instead it is calculated using this formula that depends on the product price and the item quantity. And this will be a good opportunity to talk about how to minimize the number of reads that we do when we fetch data from Firestore. And in order to understand how we can show the correct total in the UI, let's go ahead and use the command palette to find the cart total text widget, which lives inside the presentation folder of our shopping cart feature. And just to be clear, this widget is responsible for showing the cart total that we see over here. And as you can see, this total updates automatically when we add or remove items. But how does this work? Well, as you can see inside the build method, we have this code to ref.watch cart total provider. And this gives us back an async value of type double. And this is then passed as an argument to this async value widget, which is used to show this text widget if we have a value. And to better understand how the cart total is calculated and used to rebuild this widget reactively, let me show you this diagram. And as you can see, on the left, we have the widgets that are used to show the shopping cart UI inside the app. And on the right, we have the data that is stored in Firestore. And in the middle, we have these providers, which are used to glue everything together. And one of the things that we learned earlier on in the course is that if we want our UI to be reactive, we can use real-time listeners. And this can be done using the Firestore Snapshots API, which gives us a way to read the data as a stream. And once we have a stream, we can wrap it inside a stream provider that we can watch directly in the UI. And this is what makes our data reactive. And as you can see, the shopping cart screen widget watches the cart provider, which is directly listening to this Firestore document. However, the cart total text watches this cart total provider, which is not directly connected to Firestore. And since the cart total is not stored in Firestore, it needs to be calculated on the client. And this is what the cart total provider is for. And as we can see, by watching the cart provider and the product stream provider, this cart total provider can get the data that it needs, calculate the total, and return it. And then the cart total text can watch this provider. So the important thing to notice is that this entire flow of data is reactive, because the cart total provider itself will rebuild if the data from any of these two providers changes. And now that we have a better idea of how the data flows from Firestore all the way into the UI, let's take a closer look at how this provider is implemented. And to do that, we can use the command palette and open the cart service file. And as we can see, this file contains the cart service that is used to create, update, and delete shopping cart items. But if we keep scrolling, we find a number of additional providers, such as this one, which is used to obtain the shopping cart as a stream, and this one, which is used to calculate the number of shopping cart items. And then we can find this cart total provider, which is exactly the provider that we are interested in. So how does this work? Well, as you can see, the body of this provider contains some business logic that is used to calculate the shopping cart total. And in order to perform this calculation, we need to fetch both the shopping cart, which contains all the items, as well as the products list, which contains all the products prices. And as you can see, inside the for loop, we use this products list to find the product that matches with a given item and use it to update the total by multiplying the product's price with the item quantity. And one thing you may have noticed is that the way we are watching these providers is by using this .future syntax. And what this allows us to do is to await until a value is available so that we can use directly. And this is in contrast with the syntax that we are used to, where we watch the provider without awaiting it, and we can get an async value as a result. And if we were to use this syntax, we would have to add some extra conditional logic to check if each of these values is not null. So as you can see, when you want to combine the data from two or more providers, then having to unwrap multiple async values is quite complicated. And for this reason, it's much easier to watch the underlying feature and await for the result, so that we can more easily combine the data. However, this also means that we need to mark this provider as async and declare it as a future provider. And as a result, if we get back to our widget, we can see that by watching this provider, we get an async value of type double. And we need to remember to handle the loading and error states, for example, by using this async value widget helper class. Okay, so let's get back on track and return to our provider. And if we look closer at this code, we should see that there is a problem with this implementation. And can you guess what that is? Well, consider the case where we have a large product catalog with thousands of items, but only a few have been added to the shopping cart, like in this case. And in this scenario, what happens is that inside this provider, we are reading the entire product list, even though we only need the prices of the products that are currently in the shopping cart. And this is a waste because it means that we are reading all these items for nothing, since most of them will be discarded. Instead, a more efficient implementation would be to only read the products that we need. In other words, what I suggest we do is to modify the implementation of this provider so that it doesn't do any unnecessary reads. And in order to do this, we can change the way we obtain this product by replacing this expression with await ref.watch with product stream provider, passing item.key as an argument, since this represents the product ID, and then we can add .feature at the end. And just to be clear, this is a provider that is used to obtain a single product as a stream, given the corresponding product ID, which is represented by the item key. And once again, we can use the .feature syntax to await for the first value in this stream to become available. And as a result, we can use this product to update the total. And since we can obtain the product like this, then we can delete this code, and we can also delete this line, since we no longer need to get the entire product list. And over here, we can remove this check as well, like this. And at this stage, we should be able to save and hot reload, and then we can close and open the shopping cart once again, and we can verify that the total calculation still works as intended when we change the item quantities. Not only that, but there is one more thing that I want to show you, and that is that if we head over to the Firestore console, we can open one of the products that is currently on the cart, such as this one, and then we can go ahead and change this price to 30, for example. And we should see that as soon as we save this, then the cart total updates. And the reason for that is that both this provider and this provider are stream providers. And this means that whenever the Firestore data changes, then this provider will rebuild itself. In summary, in this lesson, we have learned that when we declare a provider, we can perform some calculations inside it. And that if these calculations depend on the values returned by other providers, we can watch these providers using the .feature syntax, so we can more easily combine the data. And we have also seen that we need to be careful and avoid any unnecessary Firestore reads by only reading the data that we need. And by the way, I'd like to point out that the change that we have made inside this provider will cause a bunch of unit tests to fail inside a file called cart_total_provider_test.dart. And in fact, if you try to run these tests, you get a bunch of failures that are not very easy to figure out. And to make life easier, I've decided to share an updated code snapshot where I fixed all the unit tests. So please go ahead and open the terminal. And over here, you can open a new terminal window if needed. And then you can go ahead and run git reset --hard head to discard any working changes. And then you can run git checkout section all 7 fixed tests, like this. And this will get you the completed code for this section. And at this stage, you should be able to go ahead and run these tests one more time. And you should be able to see that they are all green. And if you want, you can take a closer look at these tests to get a better understanding of how they work. Okay, so let's continue on the next lesson, where we'll talk about Firestore usage and costs. In the last few lessons, we have completed the implementation of our shopping cart feature. And before we wrap up this section, I want to talk about one important topic, and that is how we can minimize the cost of our Firebase bill, since this is something that becomes very important as soon as we exceed the limits of the free tier. So in this lesson, we'll try to make a cost analysis of our e-commerce app so that we can get a better idea of how much it would cost to run it in production for a given number of daily active users. And before we dive into the specifics of this project, I want to mention that the Firebase docs already include this section, which contains a lot of useful information about pricing. And in the notes below, you'll find links to these pages, as well as other relevant resources, including some of the tips that I recently shared on this page. So make sure that you read these pages if you want to understand how pricing works with Cloud Firestore. And as we discussed earlier on in this course, all the Firebase projects come with a free tier, meaning that if your application falls within certain usage limits, you won't be charged anything at all. And when it comes to Cloud Firestore specifically, we can use the free tier by storing up to 1 GB of data, as well as making up to 50,000 reads a day, as well as 20,000 writes and 20,000 deletes every day. And this also includes up to 10 GB of network egress per month, which includes all the traffic that is incurred by your Flutter app when communicating with your Firebase backend. And once you exceed these limits, then you'll be charged for additional document reads, writes, and deletes, and stored data based on this table, which is specific to the region where your Firebase instance is running. And if you want to learn more about pricing, I also recommend to read this page, which offers a lot of useful information showing how to estimate costs for an example chat application based on a number of assumptions. And what you'll find here is a breakdown of all the costs based on different metrics. With that said, it would be interesting to get a cost estimate for our e-commerce app, and this is what we are going to do in this lesson. And to make life easier, we will limit our analysis to the one feature that all users would interact with, and that is the product list. So if we were to run this app in production, what kind of costs would we expect to see? Well, to get an estimate for that, we need to consider how many daily active users we have and how many documents reads and writes we perform every day. And since we are showing product images that are downloaded by the Flutter app, we should also take into account the size of these images and the bandwidth costs for downloading them. And to make it easier to get an estimate, I prepared this spreadsheet where we can enter some data, such as the daily active users, the size of the products list, the average size of each image, and how many products users read every day. And as we will see, when we change these values, then the spreadsheet will update all these other columns, which are based on some formulas that are specific to our e-commerce app. For example, suppose we have 1,000 daily active users, as well as 1,000 products in our database, and an average size of 100 kilobytes for each product image. And in addition to this, let's also assume that each user looks at 40 products every day. And based on this, we would get a total of 40,000 document reads, which is just below the free daily quota of 50,000 document reads per day, meaning that we wouldn't pay anything on data reads. And as far as the Firebase storage goes, we would have to store 100 megabytes in total, which is below the free quota of 5 gigabytes, meaning that we would pay nothing for storage as well. But we would also have to account for the data that is transferred over the network in order to show these images on screen. So if we assume that each one of our 1,000 users loads 40 images that weigh 100 kilobytes each, then we would transfer 4 gigabytes of data every day. And over a period of 1 month, we would transfer a total of 120 gigabytes, which is above the free quota of 10 gigabytes a month, which is offered by Firebase Storage. However, this figure would only be accurate on the assumption that we are not caching the images in our Flutter client app. And this is not the case because we are using the cached network image package from pub.dev. And under the hood, this package uses the Flutter Cache Manager package, which by default caches our images for 7 days. And this means that to get a more accurate estimate, we would have to divide this number by 7, which gives us 17.14 gigabytes per month, which is still above the free quota, but not by much. And based on this, we would expect to pay $0.86 per month. So as you can see, these figures give us a very rough estimate of how much data we are using in terms of document reads, storage, and network egress. And once again, this estimate is based on a number of different assumptions, such as how many daily active users we have, and how many products they see each day on average, and how long the product images are cached for. But of course, these are just estimates, and there are many other factors that can affect the actual usage. And in fact, it's always a good idea to check the actual usage on the Firebase console. For example, this is the usage and billing page for the Flutter web demo of our e-commerce app, which is something that gets a small amount of usage on a daily basis. And if I scroll down, I can show you that this project falls within the no-cost tier for all these different metrics. And based on these figures, it's clear that if I wanted to further optimize this project, I should focus on the bytes stored inside cloud storage, since this accounts for a much higher percentage of the free tier compared to all these other metrics. But for now, let's get back to our spreadsheet, because there is one important thing that we have not considered up until now. And that is that this estimate of product reads is only valid if we implement pagination inside our products list. Because it would be foolish to load the entire product list, which contains 1000 items or so, if the users are only going to scroll through the first 40 items. In fact, if we did not implement pagination, then our document reads would shoot up from 40 to 1000. And that will result into a total of 1 million reads per day. And out of those reads, only the first 50,000 would be free. And the remaining 950,000 reads would be priced at 6 cents per 100,000 reads, which gives us a total of $17 per month. So as you can see, not enabling pagination would be a very expensive mistake. And as we have seen in the first section of this course, we can use the Firebase UI Firestore package to enable pagination when we load a collection of items from Firebase. So one important takeaway from this lesson is that whenever you are loading data from a collection, then you should enable pagination by default. And this can make a big difference to your Firebase bill. And it will also improve the UX in your app, since you don't have to load and parse all the items at once. Okay, so let me put this value back to 40 products read a day, and then we can move on. And just like I've created this spreadsheet to estimate the costs for our product list, we could also go ahead and build a similar spreadsheet to calculate the costs for using the shopping cart feature as well. And what I could expect to see is that these costs should be lower compared to the products list, because users typically only add a few items to the shopping cart, while they may browse the products list a lot more. So it's worth pointing out that these costs would only be low if we didn't make any expensive mistakes in our code, such as when we were loading the entire products list in order to calculate the cart total. Okay, so let's make a summary. And as we have seen in this lesson, I've shared a few resources that you can use to get a better understanding of how Firebase pricing works. And based on this data, I created a spreadsheet that I can use to predict how much it would cost to run our e-commerce app in production, based on all these different parameters. And what we said is that this spreadsheet is based on a number of assumptions about how the product list works. And while this is helpful, it's always a good idea to check the actual usage on this page on the Firebase console. And by studying the cost profile of this app, we have learned that we can reduce costs by implementing pagination using the Firebase UI Firestore package, and by caching images using the Cached Network Image package. And by the way, I should also remind you that Riverpod itself is a data caching framework. And when you use Feature Provider and Stream Provider to load data from the network, caching is enabled by default, and Riverpod will hold on to the cached data as long as there is at least one active listener, or when you use the Keep Alive flag. And if there is only one thing that I'd like you to take away from this lesson, is that whether you build your Flutter apps with Firebase or not, there are many things that you can do to reduce the load on your backend. And if you're expecting your app to be used by many users, it is worthwhile to optimize it based on the pricing model of your specific backend, so that you will pay less on server or cloud specific costs. And once again, you can check the notes below for more details. Okay, so let's continue on the next lesson, where we'll do a wrap-up. We have now reached the end of this section, and as part of this, we have completed the implementation of our shopping cart feature using Firebase. And one of the most important things that we have learned is that there are many factors that can affect our Firebase bill. And as we have seen, some of the most important things that we need to consider include pagination, caching, and data modeling. And we have seen that by making the wrong decisions, we can shoot ourselves in the foot and end up with a much higher bill than expected. So if you have some Flutter apps that use Firebase as a backend, my recommendation is that you take a look at the usage and billing page on the Firebase console and see if you can find a way to reduce your usage. And if your costs are too high, consider doing a code audit by looking at all the code that interacts with your Firebase backend and make a note of all the areas that could be improved along with the expected gains. And sometimes you might find some low-hanging fruit and unlock big savings by simply enabling pagination. But other times you might have to dig a bit deeper and find ways to store data more efficiently. And I hope that all the resources that I shared will help you in reducing the cost of your Firebase bill. Okay, so let's continue on the next section. Welcome to this section where we'll learn how we can add a checkout experience to our e-commerce app using Stripe, which is a complete solution for accepting payments online. And as we will see, in order to implement a complete payment solution and build a seamless checkout experience, there are many moving parts that need to come together both on the front end and on the back end. So let me give you a preview of the complete checkout flows that we will have at the end of this section. So as you can see, I have the e-commerce app running on Flutter Web over here on the left, and also on the iPhone simulator over here on the right. And at the moment, the app is showing these three products. And since we'll be using Stripe to take payments, I've defined all the products themselves in the Stripe dashboard. And what is really nice about this is that if you want, you can go to the details for any of these products, and then you can click on Edit. And here you could change the title, for example, as well as the price down here. And the cool thing about this is that you can save the product. And what you should see is that after a few seconds, the product details are updated in real time and are reflected in the Flutter app. So how does this happen? Well, all the magic happens thanks to the Stripe extension for Firebase, which is something that we will cover in the course. And what this extension does is to synchronize all the products that you configure in Stripe with a Stripe product collection that is defined in Cloud Firestore. And inside each document, we can find all the product data that we are configured on the Stripe dashboard. And we'll talk in detail about how the synchronization process works inside the course. But next up, I want to show you how the checkout process works. So once you have some items in the cart, you can proceed to checkout. And from here, you can go ahead and pay for this purchase. And what this will do is to present this native payment sheet on iOS and Android. And from here, we can go ahead and use Apple Pay, for example. And then we can confirm by pressing this button. And once the payment has completed, our order will be fulfilled. And will be taken to the orders page where we can see a summary. So this is how payments work on mobile. But on web, the native payment sheet is not available. So let me show you what we can do in this case. So let's start by adding a couple of items to the shopping cart, just like this. And then we can open the shopping cart and proceed to checkout. And once we click on Pay, then our app is redirected to the Stripe checkout page. And from here, we can enter all the cart detail, like this. And once we've entered all the billing information, we can go ahead and pay. So this will take a few seconds, and when the process is complete, we are taken back to the orders page inside our Flutter app, where we can see that our order has been confirmed. And what we can do at this stage is to get back to the Stripe dashboard and head over to the Payments tab. And over here, we can see all the most recent payments. And we can go ahead and check out all the details if we want. And this proves that our Stripe integration is working as intended. And as we are seeing, the payment flows are a bit different on mobile and web, but the end result is the same. And in order for all of this to happen, I had to do quite a bit of work, especially on the backend, where I've defined a bunch of cloud functions to work in tandem with the functions that are configured by the Firebase Stripe extension. In fact, I can assure you that this is the most complex feature that I've implemented in the entire app. And when I first built this, it took me over a week of work to get it done, even as an experienced developer. And it took longer still to package all my learnings into a series of lessons. So here is what we will cover in this section. We'll start with an introduction about Stripe from a conceptual point of view, and learn about when you should use Stripe versus other payment methods, such as in-app purchases and subscriptions on mobile. Then we'll talk about the Flutter Stripe SDK, which you can use to show the payment sheet and other payment options on mobile and web. And then we'll focus on the Firebase Stripe extension and learn how to install it and configure it for our project. And as part of this, we'll talk about webhooks, which are an essential part of any payment system. Then we'll focus on the backend and introduce some cloud function triggers that we can use to synchronize the data between Firestore and Stripe. And once our backend is ready, we'll move back to the client side and learn how to implement payment flows on mobile and web. And after that, we'll talk about order fulfillment, which is an essential part of the entire system. And finally, we'll learn how to handle API keys on the backend and how to make calls to the Stripe APIs from our Cloud Functions. So this is what we will cover. And as I was planning all this content, I realized that it would take too long to code everything from scratch. And instead, I decided to give you an in-depth explanation of all the important concepts so that you can understand how everything fits together. And as we make progress, I'll be sharing a number of updated code snapshots and give you a walkthrough of all the new code, so we can tackle all these different topics incrementally. But before we dive in and cover all these topics, I want to answer one important question. And that is, should you even use Stripe to collect payments in your apps? Or should you use in-app purchases, which is something that is encouraged by both the iOS App Store and the Google Play Store? So let's continue on the next lesson where I'll talk about payments in more detail. In this lesson, we're going to find out what options are available for collecting payments inside your apps, so that you can choose the most appropriate ones for your project. And if you spend some time researching this topic, you may come across payment processors such as Stripe and PayPal, which can be used to collect payments for digital products or subscriptions on the web. But if you're building a mobile app, things get a bit more complicated because the Apple Store and the Google Play Store have guidelines that will tell you to use their own APIs when charging users for in-app purchases and subscriptions. So how do you decide which payment processor should you use? Well, that depends on what products you're trying to sell and on which platform you're trying to sell them. For example, if you have a mobile app or a game where users can purchase additional levels or unlock a full version, then you must use in-app purchases. And for the privilege of doing that, Apple and Google will keep 30% of the value of the purchase. However, these fees only apply to digital goods and services, but not to physical goods or products. So if you're building a food delivery app or selling products with an e-commerce app, then you're free to use an external payment processor such as Stripe, which will charge you something like 3% rather than 30%. So keep in mind that if what you're selling is digital goods or services inside a mobile app, then you had to pay the Apple and Google ransom tax. But if you're selling physical goods or products on mobile or web, or perhaps you're building a software as a service on the web, then you can go for Stripe or one of its alternatives. And by the way, one thing I should mention is that if you end up using in-app purchases or subscriptions on mobile, you can use the official in-app purchase package, which is maintained by the Flutter team. However, you also have the option of choosing third-party services like RevenueCat or Glassify, which are built on top of the StoreKit and Google Play billing APIs, and give you additional infrastructure that makes it easier to manage in-app purchases and subscriptions. So the takeaway from this lesson is that there are different payment providers, and you can choose one or another based on the criteria that we have discussed. And to make your life easier, I've shared some useful resources in the notes below, so you can get a more clear picture. With that said, in the next lessons, we'll go ahead and focus on Stripe, because we are building an e-commerce app that we can use to sell physical products. And as I said in the introduction, many of the concepts that we will cover will also apply if you choose a different payment provider. Okay, so let's continue on the next lesson. In this lesson, I'm going to give you an introduction to Stripe, and we are also going to get familiar with some of the Stripe products that we will need for our e-commerce app. And if we take a look at the Stripe website, we can see that Stripe offers an extensive range of products. And each of these products is useful in its own right and has its own learning curve. In fact, Stripe is a very large platform that is used by millions of businesses all over the world. And covering all these products is well beyond the scope of this course. In fact, as far as this course goes, we're going to focus on the most important feature. And that is, how can we take payments from our Flutter e-commerce app using Stripe together with the Firebase backend? Okay, so let's get started. And if you don't already have a Stripe account, the first thing you should do is to register by filling out this form. And since I already have an account, I'm just going to sign in. So please go ahead and register or sign in if you already have an account. And once you have done that, you should end up in the Stripe dashboard, which gives you access to all the different features that you can see over here. And one important thing to notice is this dropdown that you can use to manage different accounts independently. And this is quite useful if you have different products or even different companies and you want to track your revenue separately. In fact, since we are creating this e-commerce app, I recommend that you go ahead and create a new account that you can use for testing purposes. So on this page, you can choose an account name such as e-commerce app, for example, along with the country of operation. And once you're happy with this, you can go ahead and create your account. And as you can see, once you get back to the dashboard, you can still use the drop-down to switch between all the different accounts. Okay, so as you can see, here we have a bunch of tabs with all the features that are available. And out of these, the three most important features that we are going to use are the Products tab, where we can define all the products that we will show in our app, along with the Customers tab, which will be synced with all the users that are registered inside our app. And we also have the Payments tab, where we can keep track of all the payments that have been made by our users. And later on, we will also look at this Developers tab, that we can use to obtain some API keys and configure some webhooks that will be used by our Firebase backend. And as we will see, being able to create and edit products directly from the Stripe dashboard is very handy, and certainly much nicer than having to manipulate products data directly inside Firestore. Okay, so this completes our basic introduction to Stripe. So let's continue on the next lesson, where we'll talk about how to use Stripe inside a Flutter app. In this lesson, we're going to start learning about the Flutter Stripe package that you can use to take payments in your Flutter apps using Stripe. And if you spend some time looking at the README, you'll find an overview of all the features that are supported, along with some installation instructions for Android, iOS, and web. And you'll also find a lot of other essential information, including a list of all the Dart APIs that are supported. However, what I find most useful about this package is that it comes with an official example app, which I've already got up and running on the iOS simulator. And what's great about this app is that it shows how to use all these different payment methods. And if you want, you can grab the source code for this app by cloning the official repository from GitHub. And once you have done this, you can open this example folder in VS Code. But for now, I just want to give you a brief overview of how this app works. And as you can see, here we have these dropdowns that show all the payment methods that are supported, including with payment sheets and card payments and wallet and so on. And for each of these payment methods, we can see the platforms that are supported with a green icon and the platforms that are not supported with a red icon. And if we select one of these payment methods, such as this single-step deferred payment, for example, we are taken to a screen where we can initialize a payment sheet. And then we can click on this Pay Now button, which is used to present this configurable payment sheet, where we can pay with Apple Pay or by credit card. So once again, if you want to run this app yourself, you can check out the official repository from here. And then you'll want to open this example app in VS Code, like I have done over here. And once you have done that, it is essential that you follow all the instructions for running the example app, which can be found over here on the README file. And these instructions include how to get some test Stripe API keys, as well as how to store them inside these environment files. And you'll also need to use the terminal to install and start the server by following these steps. And in the next lesson, we'll talk about why you need to start a server in the first place. But for now, all you need to know is that if you don't have a server running, then the example app will not work as intended. But assuming that you've completed all these steps, and you've got the app running on iOS or Android, then you should be able to try some of these examples. And if you want to take a closer look at how this app works, you can study the source code. And a good place to start is the main.dart file, which contains all the Stripe initialization code. And you can also look at this file called screens.dart. And if you scroll down, you can find this list, which contains all the screens that you can see on the example app. However, I should warn you that when I was testing this, some of the examples were working correctly, but others were crashing. So just be aware that the example app may still have some issues, but I still found it very useful in understanding how the various APIs work. Okay, so this completes our overview of the Stripe example app. And if you want, you can spend some time playing with it. But once again, I want to make it clear that this app will only work correctly if you configure and run a server on localhost, which can be used to communicate securely with Stripe on the backend. So keep in mind that if you want to integrate Stripe in your apps, then having just a Flutter client is not enough, and you'll also need to run some server-side code on your backend. And since this course is about Firebase, we'll see how to integrate Stripe with Firebase. But very similar considerations would apply if you've written your backend using Node.js or Python or PHP and so on. Okay, so let's move to the next lesson where I'll give you a conceptual overview of how payments work when you use Stripe. In this lesson, I'm going to give you an overview of how we can accept payments securely using Stripe. And while this course is about Flutter and Firebase, the same concepts apply if you have a different tech stack. For example, you might be writing a regular web app using a front-end framework such as React or Svelte, or you may have a backend written in Node.js or PHP or Python. And the main thing you need to understand is that making a payment is not as simple as calling a single REST API where we get a simple response that indicates success or failure. And instead, you have to follow a multi-step workflow that takes place across your Flutter app, your Firebase backend, and the Stripe servers. So assuming you want to take a payment using this payment sheet that you see over here, then these are the steps that you need to follow. First of all, you're going to have a button somewhere that you can use to initiate the payment. And when this event takes place, then you need to tell Stripe that you want to create a new payment. And for security reasons, this is not something that should be done on the client. Instead, your Flutter app should call a cloud function on the backend, and that cloud function can communicate securely with Stripe. And once this is done, then Stripe will return a so-called payment intent client secret, along with an ephemeral key, and this can be returned to the Flutter client along with the customer ID. And once the Flutter client has this information, then it can use it to initialize a payment sheet using the Flutter Stripe SDK, and then you can present this native payment sheet to the user. And at this stage, the user can choose to pay with all these different options. And once this happened, then the payment information is sent over to Stripe, and the payment will be processed. And then a very important step happens, and that is that Stripe will call a webhook, which is a cloud function that lives on your Firebase backend. And the job of this cloud function is to verify the signature of the request to ensure that indeed it comes from Stripe. And if the request was successful, then the Firebase backend needs to fulfill the order and update some of the data in Firestore. And once this is done, then we can show the confirmation page to the user. So as you can see, processing payments is a multi-step process involving both the Flutter client and the Firebase backend. And there are some important steps, such as creating a payment and processing the webhook data, that must be performed securely on the backend using a secret Stripe API key. And it will be very dangerous to store this API key on the client, because if someone were to steal it, they will be able to call the Stripe APIs using your account. So as you can see, the whole workflow is quite complex. And if you choose to implement all the server-side logic yourself, you'll face many challenges, including how to set up the Stripe API keys on your backend, and how to write all the server-side code for creating a payment intent, as well as creating a Stripe customer object that is associated with the current user in Firebase. And you'd also have to correctly implement the Stripe webhook signature verification, which is essential to prevent man-in-the-middle attacks. And in the past, I've implemented all this logic myself, but the whole process was quite challenging, and it was hard for me to know if I had implemented all the backend logic following best practices. However, if you want to add Stripe to your Flutter app today, there is an easier way, and that is to install the Stripe Firebase extension. And what is good about this extension is that it takes care of much of the logic for communicating between your Firebase backend and Stripe. And in the coming lessons, we'll see exactly how it works. So let's continue on the next lesson, where I'll share a new starter project that we'll use as a starting point for our Stripe integration. In this lesson, we are going to add the Flutter Stripe SDK to our e-commerce app and make sure that we can initialize it with the correct API key. And if you ever need to add Stripe to your own apps, then the right thing to do is to follow the installation instructions on the README, especially with regards to Android. Because if you don't follow these steps, then your app will crash during startup. But like I said at the beginning of this section, we have a lot of stuff to cover, and to speed things up, I've decided to share a new starter project where most of the configuration is already done for you. So please go ahead and open the e-commerce app inside VS Code, and then you can open a terminal. And if you have any working changes, you can run git reset --hard head to discard them, and then you can run git checkout section 08-starter. Like this. And once you have done this, you can go ahead and open the pubspec.yaml file. And if you scroll down, what you'll find in here is that I've added some new packages such as Flutter Stripe Web, and Pay. And these are all the packages that we need in order to accept payments on mobile and web using Stripe. So this looks good. However, if we take a look at the file explorer and open the lib folder, we can notice that there is a file called end.dart which has some errors inside it. But what is this file? Why do we need it? And how do we fix these errors? Well, as it turns out, in order to initialize the Stripe SDK, we need an API key, which we can grab from the Stripe dashboard. And if you need to store an API key on the client, there are various techniques that you can use, and I covered all of them in detail on this article on my website. And if I'm honest, my favorite technique is to use a flag called Dart define from file, which was introduced in Flutter 3.7. However, after using this flag on my project, I noticed that the API key wasn't loading correctly on Flutter Web. And so I've decided to opt for a different alternative, which is to load the API key from a .env file using a package called embed. So the bottom line here is that if we want these errors to go away, then we need to follow these steps. And the first one is to click on this link, which will take us to the API keys page on the Stripe dashboard. And over here, we can find a publishable key and a secret key. And the idea here is that the publishable key should be used on the client app, whereas the secret key should only ever be used on your backend. So let's go ahead and click here to copy the publishable key. And then we can get back to VS Code. And then inside the root of our e-commerce app, we can create a new file called .env, like this. And then we can paste our Stripe key. Then we can go to the start of this line and make sure that we assign it to this environment variable called Stripe publishable key, like this. And once this is done, we can save this file and get back to the m.dart file. And then we can copy this command from here and open the terminal. And then we can paste it and run it on here. And what this will do is to run the code generator on all the files inside our project. And this is a process that can take a little while. And once this is completed, we should see that a new m.g.dart file has been generated. And this will contain an obfuscated version of the API key that we have set in the .env file. And if everything has worked as intended, you should see that the errors go away. Next up, let me show you where the Stripe SDK is initialized. And this happens inside a file called app.bootstrap.stripe.dart, which contains an extension of the app.bootstrap class. And here we find this setup Stripe method. And as you can see, here we check if we are on web, iOS or Android, since these are the only platforms that are supported by the SDK. And then we set the Stripe publishable key, merchant identifier, and URL scheme. And then we call this method to apply all the settings. And the most important step here is that we set the API key, which comes from the environment variable that we have configured. And if you're wondering what is the purpose of these other properties, then you can follow these links for more information. Finally, if we go back to the main.dart file and we scroll down, then we find this code to await app.bootstrap.setupStripe. And this completes our overview of the Stripe setup code. So at this stage, we should be able to choose a target device, such as iOS, Chrome, or Android. And we should be able to go ahead and run the app without problems. And by the way, I should also point out that from this point forward, we will no longer be able to run on macOS, because the Stripe package only supports web, iOS, and Android. Okay, so this completes all the setup stuff on the client. And as you can see, the e-commerce app is running on the iOS simulator. But of course, we are not done yet. And before we can start taking payments, we also need to configure our Firebase backend. So let's go ahead and do that in the next lesson. In this lesson, we're going to get started with the Stripe extension so that we can more easily integrate Stripe with our Firebase backend. And as part of this, we will learn how to install the extension and configure it. And in the coming lessons, we'll see how to use it to synchronize data between the Stripe dashboard and our Firebase backend. Okay, so as a first step, you can head over to extensions.dev, which is a bit like a package repository, but for Firebase extension. And over here, we can see some popular categories. And if we click on payments, then we are taken to this page where we can find the extension that we need. And as you can see, there are extensions both for Stripe and Revenue Cut. So if we want, we can go ahead and view the details. And then we can go ahead and click on Install on the Firebase console. And from here, we can choose our Firebase project. And then we are taken to this wizard, where we can follow a number of steps. And as a first step, we are told what costs we'll incur by using this extension. And once we click Next, we are taken to the second step, which tells us which APIs and resources are used by this extension. And what is interesting here is that this extension is going to create all these different cloud functions for us. And these functions contain important server-side logic that we would have to write ourselves if we didn't use the extension. And if we scroll down, we can find out that the extension also uses the Cloud Secret Manager to manage the Stripe API key and the Stripe webhook secret. And if we scroll down a little more, we get this warning telling us that we need to enable the secret manager if we want this extension to work properly. So here we can go ahead and click on enable. And after a little while, we should see a green check mark. Next up, we have this step telling us that this extension will generate a new service account that has access to all these different resources. So let's go ahead and click on next. And at this point, it's time to configure our extension. So as a first step, we should choose the location where the cloud functions will be deployed. And in general, I recommend that all our cloud functions and the Cloud Firestore instance are deployed to the same region, which in this case is US Central 1. And then we get to choose the Firestore collections where the Stripe extension will write to. And as you can see, products, customers, and configuration have been chosen for us as default names. However, if we get back to our Firestore project, we can see that we already have a products collection in Firestore, and we don't want the existing data to be overwritten by the extension. So let's get back to the wizard. And what we want to do at this stage is rename these collections to Stripe_products and Stripe_customers and Stripe_configuration. And later on, I'll explain more in detail why this is important. Next up, we should choose if we should sync new users between Stripe customers and Cloud Firestore. And for this project, I suggest that we enable this. Likewise, I think we should also enable the auto-delete option on this dropdown. And then the next step is to configure these API keys. And this means that it's time to get back to our Stripe dashboard, and then we can head over to the developers page and open the API keys tab. And from here, we can reveal the test key, which might require us to enter our password. And once we have done this, we can go ahead and copy it, and then we can get back to our extension and paste it over here. And then we can click on Create Secret, like this. And as we can see, we also get the option to set the webhook secret. However, this is a step that we are going to complete later on, and we can leave this empty for now. Next, we get to choose the minimum number of instances for our Create Checkout section function. And if we hover on this tooltip, we can read that this is useful to reduce cold starts. And since this is a test project, I'm going to leave it to 0 for now, and we can always change it later if needed. Finally, we should choose if we want to enable events. But this is not a feature that we are going to need, so I'm going to leave it unchecked. And now that we have followed all these steps, we can click on Install Extension. And this will take us to this screen, telling us that it will take 3 to 5 minutes for this extension to be ready. So this wraps up our lesson. So feel free to check out the notes below, where I've included a summary of all the steps that we have covered. And once this extension has been installed and you are ready to continue, you can move over to the next lesson. In the last lesson, we have installed the Stripe extension, and at this stage, you should see a green check mark here. And in this lesson, we're going to get started using it and complete some additional configuration steps that are needed for our project. So let's go ahead and click on Get Started. And this takes us to this page where we can find a lot of useful information, including many additional configuration steps that we need to perform if we want everything to work correctly. And if you spend some time reading this document, you can find a lot of useful instructions. However, not everything that you find here is relevant for our project. And for our purposes, we only need a subset of the features that are offered by this extension. And I will explain what features we're going to need and why in the coming lessons. So let me scroll back up to the top. And one of the first things that we can find are these instructions for setting up the security rules. And these will be relevant later on when we get back to our Flutter client. But for now, we're going to focus on the backend. And the most important thing that we need to do is to configure the Stripe webhooks. And what we can read on this page is that you need to set up a webhook that synchronizes relevant details from Stripe with your Cloud Firestore. This includes product and pricing data from the Stripe dashboard, as well as the customer's subscription details. So let's go ahead and do this by opening the Stripe dashboard. And inside this webhooks tab, we get this option to add an endpoint. So let's click on this. And this takes us to this page where we can set the endpoint URL. So where can we get this from? Well, let's get back to our extension page. And at this stage, we should copy this URL from here and paste it over here. And since we're going to go back and forth between the Stripe dashboard and the extension page, I think it's a good idea to keep them side by side. So let me detach this tab into a separate window, and then I can rearrange it like this. Next up, we should tell Stripe which events to listen to. So let's click on Select Events, and in the extension page, we can see all the events that we need to add. So what we're going to do next is to add them one by one to the Stripe dashboard. And here we can see that we are interested in 5 different categories of events, and these are product, price, checkout session, customer subscription, and payment intent, while all these other events are optional and we don't need them. So let's get back to the Stripe dashboard and add them all. And a quick way to do this is to use the search box. So here we can type product, for example, and this makes it easy to select product created, product deleted, and product updated, like this. And then we can do the same for the price events and select price created, price deleted, and price updated. Then we can select the checkout session completed and paste it in here and select it on this checkbox. And then we can do the same for customer.subscription and make sure that we check created, deleted, and if we scroll down, updated as well. And the last one we need to do is called payment intent. And out of these options, we should select cancelled, as well as payment failed, as well as processing and succeeded, like this. And once we are done, we can go ahead and click on Add Events. And at this stage, I recommend that you double check that all the events that are listed in the extension page have been added over here. And the reason this is important is that the webhook will be called every time one of these events is triggered. And when this happens, our Stripe extension will write all the relevant event data to Cloud Firestore. And we'll take a look at how this all works later on. But for now, let's stay on track. And once we are happy with our changes, we can click on Add Endpoint, like this. Okay, so let me put this tab back into this place. And as we can see, our webhook has been registered and it is waiting for events. And before we continue, we need to do one last step, and that is to tell our Stripe extension that it needs to use the sign-in secret that is specific to our webhook. So let's go back to our extension and scroll to the top, and then we can click on Extension Configuration and click on Reconfigure Extension over here. And if we scroll down, we can see that down here we have an empty Stripe webhook secret, which we need to set. So let's get back to Stripe and click on this link to reveal the secret. And then we can select and copy the secret from here. And then we can paste it in here and click on Create Secret, like this. And finally, we can save the settings over here at the top. And at this stage, the configuration will be updated, and this may take a few minutes. Okay, so this is great progress, and we can continue on the next lesson where we'll start creating some products using Stripe. In this lesson, we're going to revisit the way we store products for our e-commerce app. And just to be clear, up until now, we have decided to store the products data inside this collection in Cloud Firestore. And as you can see, the Flutter app is currently showing 3 products, which are loaded from the corresponding documents inside this collection. And if you remember, in section 4, we have implemented some admin UI that allows us to upload new products directly from the Flutter app. However, if we want to manage a big product catalog, then the Stripe dashboard offers a much more robust solution that allows us to create new products, as well as configure things such as coupons, shipping rates, tax rates, pricing tables, and much more. And the main idea here is that we can create, edit, and delete products directly from the Stripe dashboard. But if we do this, how can we synchronize the products data with Cloud Firestore and make sure that the Flutter app shows the correct data? And to explain this, I created this diagram. So how does this work? Well, the idea is that if we create products directly from Stripe, then this becomes the source of truth for our product catalog. And thanks to the Stripe extension that we have configured, all the product data will be synced with the Stripe product collection inside Cloud Firestore. But as we have just seen, the Flutter app reads the data using real-time updates from a different collection called products. And as we will see in the next lesson, we can write some cloud functions to keep these 2 collections in sync. And as we will see, this is going to be a very flexible solution that will work well for our project. So if we want to get this working, the first step is to create some product using Stripe. So let's head over to the Stripe dashboard, and we can get started by clicking on this Add Product button. And this takes us to this page where we can add the product name and description, along with an image. And we can also set the pricing details by specifying options such as the pricing model. And here we can set the price along with the desired currency. And we can choose if this is a recurring or a one-time payment. And if we look closer, we can see that there are also some additional options that we can set. So as you can see, this products page seems very well designed. And we can use it to create subscription-based products with a recurring payment model, or products that can only be purchased once, which is ideal for e-commerce apps where you purchase physical products. And this solution is certainly more flexible than what we have built so far using Cloud Firestore on its own. Okay, so let's try to add a product. But where can we get the product data from? Well, if we get back to VS Code, we can open a file called testproducts.dart. And this contains all the products that we need. So what we are going to do next is to get some of this data from here and use it to create new products on Stripe. For example, we can copy the title from the first product, and then we can paste it as the product name on Stripe. And then we can copy the description and paste it on Stripe as well. And then we can scroll down to the pricing, and then we can get this price, which is $15, and paste it here. And then we need to work out where we can save the available quantity. Well, as it turns out, we can use this additional options field. And here we can click on add metadata. And here we can set the key to available quantity and the value to 10, for example. And the last thing that we need to do is to upload an image. And if we go back to VS Code, we can scroll up and open the assets folder. And inside we can find a products folder where we can find all the products that we need. So let's go ahead and reveal this inside the Finder, which I have over here. And from here, I can just select the first image and drag it over to my browser and drop it in here. And as we can see, the image has been uploaded. So let's go ahead and save this product. And once this is done, we are taken to this product page where we can see all the details that we have added. And one thing that we can notice is that Stripe has created a product ID, which appears over here. And now that we have created this product, I can show you something really cool. And that is that if we go back to Cloud Firestore and we refresh this page, we can see that a new Stripe product collection has been created. And this contains one document which has the same product ID as the one that we have created in Stripe. And here we can find all the fields that we have created in Stripe as well, such as the name, description, and even the metadata that we have stored. And we also get an image URL, which points to the image that we have uploaded to Stripe. And what we can also see is that we have this prices sub-collection, which contains one price document. And this has a bunch of fields, including the currency, the type, and the unit amount, which is represented in cents. So this is all really cool because it means that we can create products using Stripe, and the Stripe extension will take care of syncing them with the data in Cloud Firestore. And as a proof of that, we could try to edit the product and change the title to Bruschetta Plate 123, for example. And if we save this and return back to Cloud Firestore, we can see that the name has been updated over here. Okay, so it seems like the synchronization is working as intended. And once again, this is happening because we have configured our extension to write the product and pricing plans to this collection. And now that we have done this, I suggest that we add a couple of additional products so that we have some more data to work with. So let's go back to the products page. And here we can add a new product. And then we can get back to VS Code and move to our test products file. And from here, we can copy the title and then paste it as the product name. And then we can copy the description as well and paste it in here. And then we can go to the additional options and add some metadata and set the available quantity to 10, for example. And then we can scroll down to the pricing section and we can copy the price, which is 13, over here and set it in US dollar and make it a one-time payment. And finally, we need to upload a new image. So let's get back to our folder. And from here, we can select the mozzarella plate and drop it over here. And once we have done that, we can save our product. And once again, we can verify that the Stripe products collection now has 2 products. Okay, so let's do this one more time and create a new product. And this time we're going to select this product from here and paste it in here and do the same for the description. And then we can go ahead and add some metadata, with the available quantity like this. And then on the pricing section, we can enter $17, for example, and set it as one time. And finally, we can get back to our File Explorer and upload our pasta plate image like this. And then we can save the product once again. And by the time we are done with this, we should have 3 products on this page, as well as 3 documents inside the Stripe products collection. In summary, in this lesson, we have seen how to create products using Stripe, and we have verified that they get correctly synchronized using Cloud Firestore. And this completes the top right part of this diagram. So let's continue on the next lesson, where we are going to focus on the next step. In the previous lesson, we have seen how to create products directly on the Stripe dashboard. And we have noticed that thanks to the Stripe extension for Firebase, the corresponding product data is written to Cloud Firestore. And this is very convenient because as administrators, we get a nice UI for managing a product catalog using Stripe. And since our Flutter app is already connected to Cloud Firestore, we could read the product data directly from this collection if we wanted. However, I'd like to remind you that at the moment, this Flutter app reads the product data from this collection and not this one. So one important question we need to ask ourselves is, should we modify the Flutter code to read the data from Stripe products, or would we rather keep the Flutter code as it is and find a way to keep the product collection in sync with the Stripe product collection? And to answer this question, we need to take a closer look at the differences between these collections. And if we select any of the documents in here, we can see that we have all these fields, and some of these fields are different from the ones that we have over here. And as far as we are concerned, the biggest difference is that the documents inside the Stripe product collection have a separate prices sub-collection. And if we take a look at one of these documents, we can see that we have all these fields, because these are all the values that we can set when we create a new price using Stripe. And if we had to modify our Flutter app to read the pricing from here, then our client-side code will become a lot more complex, and we would no longer be able to get all the product data that we need with just a single document read. And additionally, the logic for calculating the card total price will become a lot more complex too. And rather than trying to change our client code to read all the products data in a more complex format, I think it will be wiser to write some cloud functions that can detect when new Stripe products are added by the Stripe extension, and write the corresponding data to the products collection using the same field that our Flutter app is expected to read. And if we can do that, then our Flutter code won't have to change at all. And this is exactly what we are going to do next. And like I said at the beginning of this section, we are not going to write all the code from scratch, since that would take too long. And instead, I'm going to share an updated code snapshot and show you what's changed. So please go ahead and open a terminal. And then from here, you can run git reset --hard head to discard any working changes. And then you can git checkout section 08-triggers, which contains all the updated code. And then you should cd into the functions folders. And from here, you should run npm install. And once you've done that, you should also run npm run build, like this. And you should be able to see that this step completes without any errors. Okay, so let's go ahead and open the functions folder and see what's changed. And if you open the source folder, you can see that we now have 4 files inside it. So let's start from the index.ts file. And if you scroll down a bit, you can see that over here, I've declared some new cloud functions using this export called onStripe product written, onStripe price written, and onStripe customer created. And to keep things tidy, all these triggers are now calling some functions that are defined and imported from this Stripe file, which I've added over here. And this technique is quite handy because it allows us to move the implementation details of our cloud functions to separate files, rather than having one gigantic index.ts file. With that said, let's take a closer look at what these functions do. And for the time being, the functions that we are most interested in are onStripe products written and onStripe price written. And just to be clear, their purpose is to keep the data in sync between the Stripe products collection and the products collection. In fact, both of these functions are Cloud Firestore triggers that are executed when a product is written at this location and when a price is written at this location. So let's go ahead and go to the definition of the Stripe products written function. which is stored inside the stripe.ts file. And if you read my comment here, you can read that this function is used to update the product data at this location when Stripe products are added, updated, or removed. So how does this function work? Well, as you can see over here, we get this document from this event argument. And the first thing we do is to check if the document is undefined. And if that's true, it means that the product was deleted from Stripe. And as a result, we should delete the corresponding product from the product collection as well. And we also call this delete image from storage function, which I will explain later. And if the document was deleted, then we can return early. On the other hand, if we reach this code, it means that the product was created or updated. And in this case, what we want to do is to grab all these fields from the document, and then we run some code to get the image URL, which I will explain shortly. And finally, once we have all the data that we need, we can write it back to the products collection using the same product ID. And as you can see, we need to do a bit of data manipulation as well. For example, here we parse the available quantity from a string to an integer, and then we write it over here using some defensive code to check if it's not a number. And in addition to this, we also make a call to this update image method. And just as a reminder, the main idea here is that when we create products using Stripe, we can also upload an image. And if we head over to Cloud Firestore, we can see that the image is stored inside a file that is hosted at files.stripe.com. And when we run our Flutter app on mobile, we can load the image directly from this URL and show it in the UI without problems. But if we try to do the same thing on Flutter Web, then we are going to encounter some CORS issues, because web apps are not allowed to load resources from a different domain unless a proper CORS policy is in place. But since the images are hosted by Stripe, we don't really have any control over the CORS policy. And this is a problem for us when we run on Flutter Web. So to work around that, and with a bit of help from ChatGPT, I figured out that the easiest solution is to download the image from this URL and then upload it to our Firebase storage bucket, which is already configured with the correct CORS policy. And if you want to take a closer look at how this code looks like, you can go to the definition of this function, which lives inside a file called stripeimages.ts. And this file contains functions for updating an image to storage as well as deleting an image from storage. And the most interesting function is called upload image to storage. And like I said, I managed to write this code with some help from ChatGPT. And if you click on this link, you can read the entire chat that I had with my AI assistant. So if you want, feel free to spend some time getting familiar with the code inside this file. But for now, we can get back on track. And the next function that I want to talk about is called onStripePriceWritten, which I've declared over here inside the index.ts file. And just to be clear, this needs to be a separate trigger from the one above, because the prices and products are stored at different locations. So how does this function work? Well, let's go to its definition, which lives over here. And the main idea here is that we can fetch all the prices that live inside this collection. And since Stripe supports different types of prices, here we do some filtering to only extract the prices that are active and are one-time payments and are made in US dollars. And then we can extract the price from this list of results, and then we can write it back to our product document, making sure to set the merge flag to true so that we don't wipe out the remaining fields. So this completes our overview of these two functions. And as you can see, there is also a third function called onStripeCustomerCreated, and we'll take a look at this one in the coming lessons. In summary, in this lesson, we have seen that we can write some cloud function triggers to synchronize the data between these two collections. And as we have seen, inside the onStripeProductWritten function, we had to write some business logic to convert the incoming data into a format that is more suitable for our Flutter client. And this is exactly the kind of logic that we should write on the backend, so that our Flutter client code remains as simple as possible. And now that we understand what these functions do, the next steps are to deploy them and test that they work as intended. So let's go ahead and do that in the next lesson. In this lesson, we are going to deploy the new cloud functions that we have introduced. And once we have done that, we're going to verify that they work as intended. So let's open a terminal once again and make sure that we are inside the functions folder. And then from here, we can run firebase deploy -- only functions like this. So let's go ahead and run this command. And this should take a little while to complete. So I'm going to pause the video here and resume when it's finished. Okay, so it looks like my Cloud Functions have been deployed. And if anything is not working for you, you can check the notes below for more information. But assuming everything has worked as intended, we can head over to the Firebase console and open the Functions page. And we should see that all these additional functions have been deployed. And this means that we can go ahead and test them. And before we do that, I suggest that we head over to Cloud Firestore. And as you can see, this collection currently contains all the products that we have previously uploaded using our Flutter app. And what I suggest we do is that we delete all these products, because going forward, all the products data will be synced with the data that comes from Stripe. And the quickest way to do this is to select these three dots and choose Delete Collection. And here we get this confirmation dialog where we need to type the name of the collection that we want to delete, like this. And as soon as we do this, we should see that our Flutter app should now show an empty product list. And now that we have done this, we can keep this page on one side. And on the other side, we can open the Stripe dashboard and go to the products page. And what we would expect to happen is that if we edit one of the products, then the products data will be written to the Stripe products collection. And then our Cloud function will be triggered and write the corresponding data to the products collection. And as a result, the data should show up inside our Flutter app. So let's see if this is indeed what happens. And in order to trigger an update, let's open this product and click on this button to update it. And then we can go here and change the name, for example. And then we can go ahead and save the product. And here I had to confirm my password to continue. And as soon as this has been done, we can get back to the Firestore console. And at this stage, a refresh might be needed. And what we can see is that a new product document has been created. And this will have the same product ID as the one inside the Stripe products collection. And as we can see, it has all the properties that we have configured inside the Cloud function. And what is cool about it is that this product now appears on the mobile app as well, because our app is already configured to load the products from this collection. And by the way, one thing that you can notice is that the image URL is still pointing to the old URL at files.stripe.com. And if you remember, in the previous lesson, we talked briefly about Flutter Web and Course. And what we said back then is that if we try to load an image from this URL on Flutter Web, then we'll get an error because we don't have the correct course policy in place. And as a proof of that, over here, I started a Chrome build, showing that indeed the image can't be loaded. So if we want images to load correctly on our Flutter Web app, then we need to ensure that these images are loaded from Firebase storage. And the reason this is not the case for this product is that I've optimized the image upload code inside my Cloud function to only run when the image has been changed inside Stripe. So if we want the image to be uploaded correctly to Firebase storage, then we need to edit the product in Stripe, and then we need to remove it and save it. And then we need to edit the product again and upload it again. And as we have seen in the previous lessons, all the images are stored inside our project in VS Code. So what we have to do in this case is to reveal the image inside our Explorer, and then we can drag it and drop it over here. And then we can save the product to Stripe one more time. And what we should see after a little while is that the image URL has been updated and now points to Firebase storage. And for the final test, we should get back to our app running on Chrome. And as we can see, now the image shows up correctly. And finally, there is one last thing that we need to verify, and that is that the price is updated correctly. So let's go back to Stripe and edit this product one more time. And if we scroll down to the price, we can change it to a different value, such as $18, for example. And then we can click on Save. And soon after that, we should see that the price gets updated both on the web app and on the mobile app, like this. But what about the remaining products? Well, if we want all our products to show, then we need to go back to Stripe and edit each of the products that we have added, because our Cloud functions will only be triggered when there is new data. So I'm not going to repeat all the steps in this video, and instead I'm just going to show you the end result. Okay, so I've just gone through the process of updating all the products in Stripe, and as you can see, we now have 3 products on the web app and on a mobile app as well. And if we head over to Cloud Firestore, we can see that we have 3 products in this collection as well. And this confirms that everything is working as intended. In summary, what we have learned in the last few lessons is that we can use Stripe to define all our products. And by using the Firebase Stripe extension, alongside our own cloud functions, we can ensure that the product's data propagates from Stripe to Cloud Firestore and from Cloud Firestore to our Flutter app, and this happens almost in real time. And what I mean by almost is that we incur some latency due to the time that it takes for the cloud functions to run. But since product updates tend to be quite infrequent, this is not really a problem. And the biggest takeaway that I'd like you to take home is that if you're loading some data from external sources and that data is not in the format that you want, you can leverage Cloud Functions and Cloud Firestore to do some manipulation on the backend. And as a result, your client code can remain as simple as possible. Okay, so let's continue on the next lesson. In this lesson, we are going to continue with the Stripe backend integration by focusing on a specific cloud function called onStripeCustomerCreated. In fact, one thing that I haven't mentioned up until now is that one of the things that the Firebase Stripe extension is doing for us is that when we create a new user account with Firebase Auth, then a new Stripe customer is created. And the main idea here is that if we want to make any payments using Stripe, then we have to register a Stripe customer first, which is the person that is making the payment. And since we have already configured the Stripe extension to handle this, I want to show you what happens as soon as we register a new user. So over here, I have the app running on iOS, and I can go ahead and open the sign-in screen, and then I can select this option to create a new account. And then we can enter a new email that we have never used before, such as test3@test.com with a test password. And then we can go ahead and create an account. And assuming that everything has worked as intended, we should see that the new account has been added to Firebase Auth. And if we head over to Cloud Firestore, we should see that 2 new collections have been created. And these are called Stripe Customers, which is created by the Firebase Stripe extension, as well as Stripe Customer User Lookup, which is created by the new cloud function that I have deployed. Not just that, but if we go back to the Stripe dashboard and refresh this page, we can see that there is a new customer with the email that we have just registered. And this confirms that whenever we register a new account with the app, the corresponding Firebase user is also saved as a customer in Stripe. And one important thing to notice is that Stripe will create its own customer ID, which is shown here. However, this is different from the Firebase UID, which is shown over here. And if we go back to Cloud Firestore, we can see that the Firebase UID is used as a document ID over here, while the Stripe customer ID is stored as a field over here. And as we will see in the coming lessons, in order to process payments, we will need a way to find the user UID for a specific Stripe customer ID. And it would be ideal if we could do this by performing a single document read, rather than going through the entire Stripe customers collection to find the user UID that we need. And after thinking about how to do this efficiently, I realized that the best solution is to implement a technique known as a reverse lookup. So how does this work? Well, to explain that, let me get back to VS Code and open the index.ts file. And the idea here is that we can create a cloud function that is triggered whenever a Stripe customer document is created inside this collection. And then inside this function, what we can do is to obtain the user ID as a parameter from the event object. And we can also obtain the Stripe ID from the document data. And then we can write a new document to a different Stripe customer user lookup collection, where the document ID is the Stripe ID and the UID is stored as a field inside it. And what this means is that if we ever need to obtain the Firebase UID for a given Stripe ID in the future, we can do so with a single document read. And if we get back to Cloud Firestore, we can see that this is exactly how the data is represented inside this collection. And once again, this will come handy later on when we need to process payments. Okay, so let's continue on the next lesson. In the last few lessons, we have focused on the Firebase backend logic, and we have seen that by writing some cloud functions that work in tandem with the Firebase Stripe extension, we can synchronize the Stripe products and the customers with the data in Cloud Firestore. And we have also seen that after making these changes, the Flutter e-commerce app continues to work as expected. And this is a good time to get started with payments. And if you remember, earlier on in this section, I've shown you this diagram, which shows all the steps that we need to do if we want to show a payment sheet inside our app. And as you can see, some logic needs to be executed on the client, and some other logic needs to run on the server. So in this lesson, we're going to focus on our Flutter client app once again, and learn how we can show a payment sheet, just like the one that is included in the Stripe example app. And like I said before, we're going to need a significant amount of code to get this working. And rather than writing all the code from scratch, I'm going to share an updated code snapshot, and then I'll walk you through all the changes. So let's get back to VS Code, and from here we can open a terminal, and then we can run git reset --hard head to discard any working changes that you may have. And then we can check out this branch called section 08-checkout, which contains all the new code. And once you have done that, you can go ahead and run the app on iOS or Android. Or if you already had the app running, you can just hot restart it, like this. And assuming that you have already created some products in the Stripe dashboard and the corresponding data has been written to Cloud Firestore, you should see these products over here. Okay, so let's go ahead and see if we can purchase this product. And in order for this to work, we should check that we are signed in with a user account that was previously synced with the Stripe customer in Cloud Firestore, like in this example. And once we have verified this, we can get back to the product page, and then we can add this item to the shopping cart. And from here, we can proceed to checkout. And from here, we can click on pay. But as you can see, we get an error telling us that we don't have the permission to execute this operation. And the reason for this is that when we are pressing on this button, the Flutter app will execute some code that tries to write some data to Cloud Firestore, which requires some additional security rules. So let's go ahead and open the firestore.rules file. And what you should see here are some additional permissions that I've added for your convenience. And what these permissions allow us to do is to read and write a checkout session if we are currently signed in and our UID matches this document ID. And I've also added a rule to this payments document that we will use later. And of course, these rules will only be applied if we deploy them to our Firebase project. So let's get back to our terminal. And from here, we should run firebase deploy --only firestore rules, like this. And then we can wait until the deployment has been completed, like this. And once we have done this, we can dismiss this dialog, and then we can try to pay once again. And what we should see is that this time we get this native payment sheet that we can use to pay with Apple Pay or credit card. And if you're running on Android, a very similar payment sheet should appear. So in this case, I can go ahead and choose Apple Pay, and then I get this screen with a simulated credit card. And if it's the first time you use this, you might need to enter a billing address. And this could be anything you want and doesn't really need to validate to a real address because we're still using Stripe in test mode. And assuming you have done this, you can get back to the payment sheet, and then you can click on this button to proceed with the payment. And what you should see at this stage is that you're taken back to the payment screen. And just to be clear, what should really happen at this stage is that the order is fulfilled and we are redirected back to the orders page. However, this requires some additional logic that is not implemented yet. So keep in mind that we will complete our backend logic in the coming lessons. But for now, I can already show you that if we head back to the Stripe payments page, then we can see that our payment for $14 has succeeded. And if we click on it, we are taken to this page where we can see all the payment details. Not only that, but if we head back to Cloud Firestore and open this document inside the Stripe customers collection, we can see that a checkout session has been written with all these fields inside it. And we should also find a payment document which contains all the payment details. So this confirms that everything is working as intended, and we'll dive deeper into the code that makes this possible in the next lesson. But for now, I want to show you one more thing, and that is that if you want, you can try to run the app on Flutter Web as well, by selecting Chrome as a build target and starting the app once again. And once this is up and running, we should be able to follow the same steps. So for example, let's select this product and add it to the shopping cart. And then we can open the shopping cart and proceed to checkout. And at this time, we need to sign in with the same account that we have registered before, like this. And the interesting bit is that when we click on pay, something different happens. And as you can see, we are redirected to the Stripe checkout page, which is completely separate from our e-commerce app. And from here, we could go ahead and enter all the details and complete the payment. Or alternatively, we can press on this back button, and as you can see, this takes us back to the e-commerce app. So as you can see, by running the latest code that I've shared in this lesson, we can already make payments using Stripe, both on mobile and web. And as we have seen, all the payment information is correctly saved on the Stripe dashboard and on the Firebase console as well. Okay, so let's continue on the next lesson where we'll take a look at all the new checkout logic. In this lesson, we're going to take a look at all the Dart code that I've added to the Flutter client in order to enable payments on mobile and web. And I think the easiest way to show you how this works is by starting from the UI code. And the place where everything starts is this Pay button, which is implemented inside the Payment button widget inside our codebase. And just to be clear, this widget lives inside the presentation layer of our checkout feature. So how does this work? Well, the idea is that when this Pay button is pressed, then we call this Pay method. And what this does is to tell our payment button controller that we want to make a payment by passing all these arguments. And just to be clear, these arguments are specific to Flutter Web, and we'll take a closer look at what they do in the next lesson. But for now, let's just focus on the main payment flow. So let's go ahead and open this Pay method inside the payment button controller. And as you can see, what this method does is to obtain the checkout service from this provider, and then it uses it to call this Pay method by passing along all these arguments. So as you can see, there is nothing special about this controller. On the other hand, if we head over to the Pay method inside the checkout service, then things start to get interesting. And in fact, you can see that there is a significant amount of code in this class, and the logic inside it is fairly complex too. So to explain how this all works, I've prepared this diagram that shows all the main operations that take place when we place an order. And the main idea here is that when we start a payment, we call this writeCheckoutSession method, which lives inside the checkout session repository. And what this does is to write some data to this document in Firestore. And because we have the Stripe extension installed, a CRUD function will be triggered and will tell Stripe to create a payment intent. And once this is done, some data is written back to this same document. And in order to get this data, we call this method called watchCheckoutSession, which also is in the checkout session repository. And if we detect that the session data has been written, then we can go ahead and initialize a payment sheet. And then we can present it by calling these two methods inside the payment sheet repository. And internally, these methods communicate with the Stripe client SDK. So by the time this method is called, then the payment sheet is presented in the UI. Like this. And if the user goes ahead with the payment, then Stripe will process all the payment details. And then the Stripe extension will use the webhook that we have configured earlier on to write some data back to this document in Firestore. And this means that our client app can listen to updates to this document and detect if the payment has succeeded or not. So as you can see, there is a fair amount of logic involved. And if we get back to VS Code, we can see that the checkout service class is already quite big at over 150 lines of code. And in addition to this class, we also have a data layer, which contains the checkout sessions repository that we can use to read and write the checkout sessions document, as well as a payment sheet repository, which uses the Stripe SDK to initialize and show the payment sheet. And finally, we have a payment repository that we can use to watch payment documents in Firestore. So this is yet another example of how we can use multiple classes to break down a very complex piece of logic into smaller and more manageable chunks. And now that I've given you a high-level overview of how things work, we can dive a bit deeper into the code. And if we look closer at the checkout service class, we can see that it declares two stream subscriptions along with a completer object. And I'll explain why these objects are needed in a second. But for now, let's just focus on the pay method. And what this method does is to make sure that we have a current user and throw an exception if this is not the case. And then down here, we get the cart total and the payment amount in cents and the list of products in the cart from this provider. And then we have some Flutter Web specific code that we can ignore for now. And then we write a checkout session object with all the values that we have retrieved above. And once we have done that, we start a stream subscription. And the reason we need to do this is that once we have written a checkout session as a Firestore document, we need to listen to updates to this document. because the Stripe extension will write back into it. But we don't just want to do a one-time read using async and await. Instead, we should listen to updates in real time and only stop listening when we have received the data that we need. And since this watch checkout session method returns a stream, then what we can do is to listen to it and process the events inside this callback. And once we receive the data that we need, then we can cancel the subscription that we have initialized over here and proceed to the next step. And if we are on mobile, then we call this method that takes care of initializing and showing the payment sheet. And if we are on web, we run some different logic that I will explain later. And as you can see on the last line of the pay method, we return this completer.future object. And the idea here is that we want our method to only return once we have received the data that we need inside our listeners. And because the logic is quite complex and we have multiple listeners and conditional code, there are multiple places where we call completer.complete. In fact, if we take a closer look at the showPaymentSheet method, we can see that it contains some additional logic for initializing the payment sheet and presenting it. And if the payment has completed without errors, then we can set up another listener, which listens to changes to this document. And only if a payment object has been written, then we cancel this subscription and call this completer. And assuming all this logic works correctly, then this method will return at the right time, and we will be able to update the state inside the payment button controller. And also our payment button widget will rebuild as well. Okay, so up until now, I've shown you how the checkout service class looks like. But so far, we haven't really looked closely at the repositories, which are used to read and write data to Cloud Firestore and communicate with the Stripe SDK. So let's get back to VS Code and take a closer look at the checkout sessions repository. And the most important method inside it is called writeCheckoutSession. And this method takes a number of different arguments, including the user UID, as well as the total amount that we're going to pay, and a list of the products that are currently in the shopping cart along with their quantities. And it also takes this isWeb argument along with two nullable, cancel, and success URLs. So how does this method work? Well, the main idea here is that we should add a new document to this collection, which is defined over here. And as you can see, there are many fields that we need to set, such as the client, which should be web or mobile depending on this flag. And we also need to write the payment amount along with the currency. And if we are making a payment on web, then we need to specify a list of line items, which will be shown on the Stripe checkout page. Though, once again, keep in mind that these fields are only needed if we are making a payment on web. And if we are running on mobile only, we can omit them entirely. So this method takes care of writing a checkout session, but what about reading it? Well, this is done by this method called watchCheckoutSession, which returns a stream of checkout session. And if we go ahead and open this class, we can see that it contains some amount and currency properties, but it also contains a checkout session platform data object, which I've defined inside a separate file using a sealed class. And the idea here is that when we get a response from Stripe, then we need to read different fields depending on whether we are making a payment on mobile or web. And if we use a sealed class with two subclasses, then we can capture all this information using type safety. And what this means in practice is that the checkout session will have a from map constructor that we use to parse the Firestore data. And over here, we can check if the client is mobile. And if that's the case, we can extract these properties and return a checkout session with a checkout session mobile data object. On the other hand, if the client is web, then we extract different properties and we return a checkout session with this data instead. So as you can see, this is just a way to extract the properties that we need based on some conditional logic and returning them inside the appropriate subclasses like this. And if we scroll down, we can find the toMap method. And when implementing it, I decided to use the new Dart3 switch expression to produce the correct keys and values depending on whether we are on mobile or web. So this takes care of all the code for writing and reading data inside the checkout sessions repository. Next up, we can open the File Explorer and take a look at the payment sheet repository. And as you can see, this class takes the Stripe client as a dependency, and then it uses it to initialize the payment sheet by configuring all these parameters. And as we can see, in order to initialize this correctly, we had to pass the payment intent client secret, the customer, and the ephemeral key secret that we have read from the checkout session. And just so you know, all the code that I've written here is based on the official Flutter example app, which is included in the Flutter Stripe package on pub.dev. So if you want to learn more about how to configure the payment sheet, you can read this page. With that said, we have one more repository to review, and that is the payments repository. And this one is quite simple, because all it does is to give us a method to watch a payment object that was written at this location. And as we have seen before, the payment document itself contains a ton of information that comes from Stripe. But as far as we are concerned, we only want to know if the payment was successful. And for this reason, I'm only parsing the status flag inside this model class. Okay, so this completes this lesson about how to enable payments on mobile. And as we have seen, in order to get everything working, we had to pull a few tricks out of the bag, including using stream subscriptions and completers inside our checkout service, so that we can listen to updates to the Firestore documents that are written by the Stripe extension. And we have also used sealed classes when reading the checkout session data from Firestore, since we are interested in different fields depending on whether we are on mobile or web. And like I said earlier on, this was going to be the most advanced section in this course. And if something is not clear at this stage, I recommend that you spend some time getting familiar with all the code. And I hope that all the comments that are left in the codebase will make it easier to understand what's going on. And once you're ready to continue, you can head over to the next lesson, where I'll show you how the payment flows work on Flutter Web. In the last lesson, I've given you an overview of the client-side logic for collecting payments using Stripe. And as we have seen, when we make payments on mobile, we need to configure and present the native payment sheet. However, this is not supported on Flutter Web. And to account for that, the web implementation relies on a separate checkout mechanism, which involves redirecting our app to a separate checkout page that is hosted by Stripe. So in this lesson, we're going to take a closer look at how this all works. And the easiest way to explain this is to open the checkout service class. And then if we scroll down to line 103, we can find that this web URL callback is called by passing this session data.url object. And what we can do here is put a breakpoint. And then we can get back to our Flutter web app. And then we can click on the pay button once again. And after a little while, we can see that the debug breakpoint is triggered. And if we want, we can inspect this session data object. And we can see that this points to a Stripe checkout page. And what we can do next is to use the debugger to step into this function. And we can do this one more time, like this. And as we have seen, we are taken into this function called setHTML window URL, which is a helper function that I've added to this file inside the utils folder. And what this line of code does is to change the browser URL from the current page, which points to localhost, to the Stripe URL that we have retrieved from Firebase. So if we go ahead and resume the execution, we can see that indeed we are taken to the Stripe checkout page. And once we get to this point, there are two likely outcomes. And the first one is that we click on the back button, and this will cancel the payment and take us back to the page where we came from. And the other outcome is that we fill all this information and complete the payment. So let's try that by entering the test card data. And then we can fill some information here, like this. And we can enter a test address, like this. And then we can go ahead and click on pay. And once the payment has been processed, we can see that we are redirected to our Flutter app and taken to the orders page. And at the moment, this page is empty because we are still missing some functionality. But the thing that matters here is that we have been able to redirect our app to the Stripe checkout page and then back to the app once the order was complete. So how does this work? Well, if we get back to the payment button class, we can see that the first thing that we do inside the pay method is to call this getHTML window URL function, which is defined inside this file. And because setting the window URL is an operation that is only allowed on web, here I'm using a conditional import, which will ensure that we use a stub implementation that simply returns a null value if we are on mobile. And if you want more information about how conditional imports work, you can read the notes below. But for now, let's stay on track. And as you can see, once we have this URL, then we can pass it to our controller. And the controller in turn will pass it to our checkout service over here. And if we scroll down a little bit, we can see that here we have some interesting logic that is used to get a cancel and a success URL from the window URL. And as you can see, the cancel URL is the same as the window URL because we want to return to the same page if we cancel the payment. However, the success URL is calculated by replacing the current path, which in our case would be /cart/checkout with /orders. And since /orders is one of the routes that we have defined with GoRouter, then setting the window URL to this route will take us to the orders page. But once we have these two URLs, what do we do with them? Well, as you can see, the idea is that we can pass them as arguments to this writeCheckoutSession method. And what this will do is to take them and write them to Cloud Firestore. And as a proof of this, we can get back to the Cloud Firestore page and open the Checkout Sessions collection. And then we can look at these documents and see if we can find one where the client is web, such as this one. And as we can see, the cancel URL is here and points to the checkout page, and the success URL is here and points to the orders page. Not only that, but if we head over to the Stripe dashboard, we can refresh the payments page, and then we can select the payment that we have just completed. And if we scroll all the way to the bottom, we'll find a section called Events and Logs. And over here, we can choose to reveal all the event data. And if we scroll all the way to the bottom, we can see that the success URL has been set. And this is what tells Stripe that when the payment has been completed, it needs to redirect back to this page. In summary, what we have just seen is that when we take payments on web, we can use a standalone Stripe checkout page, which looks like this. By manipulating the window URL and setting some callbacks, we can get the payment flow to work as intended. And you can check the notes below for a summary of all the implementation details. And before we continue, I want to highlight one thing, and that is that what makes it possible for this entire checkout flow to work is that we're using Cloud Firestore as an intermediate communication layer between the Flutter client and Stripe. And much of the backend magic that makes this work is done by the Firebase Stripe extension, which has registered all these different cloud functions that make our life easier. And when I first started working on this e-commerce app, I implemented the payment flows by writing some cloud functions that were called directly by the Flutter client. And overall, I much prefer this new solution, where the client app just writes and reads some data from Firestore, rather than calling any cloud functions directly. So it looks like we've made very good progress up until now. However, our payment flows are not complete until we figure out one last problem, which is order fulfillment. And we're going to tackle that in the next lesson. In this lesson, we are going to learn how to fulfill orders when a payment has been made. So what do I mean exactly when I talk about order fulfillment? Well, if you think about popular e-commerce apps such as Amazon or eBay, the idea is that you may have some items on your cart, and then you can proceed to checkout and make a payment. And from here, you can go ahead and make the payment. And once this is done, an online order is created, and you'll be taken to an order confirmation page that might give you additional information such as the order status along with the delivery date. And if the items you have purchased are in limited supply, then you should also update the available quantity on the backend. So while the Stripe extension takes care of the payment side of things, it is still our job to fulfill the order on the backend and to take the user to a separate orders page, which shows the order confirmation. And as it stands, our mobile app doesn't do this yet. And this is what we are going to tackle in this lesson. And like I said before, in this section, we are not going to write any code by hand, as that would take too long. And instead, I'm going to share an updated code snapshot that you can use for reference. So please go ahead and open the terminal. And from here, you can run git reset --hard head if you have any working changes. And once you have done that, you can git checkout section 08-orders, like this. Okay, so what are the most important changes that I've added to the latest code? Well, for a start, I've added a new cloud function called onStripePaymentReturn, which is the trigger that I use to fulfill the order on the backend. And we'll take a close look at this function shortly. And in addition to this, I've also made some changes to the Flutter code and added some new security rules as well. And I'll give you an overview of the client-side changes later on. But for now, I just want to give you a demo of how the new functionality works. And before we do that, we need to deploy the new cloud functions and security rules. So please go ahead and open a terminal once again. And from here, you can run Firebase deploy like this. And what this will do is to upload all the latest changes to the Firebase backend. And this includes some updated Firestore rules and indexes, as well as the updated cloud functions. So we can wait for this operation to complete before moving on. Okay, so as you can see from my terminal, the deployment has completed and we are good to go. And if you've encountered any issues at this stage, you can check the notes below for more info. But assuming that everything went well, we can go ahead and run the app on iOS or Android, or hot restart if you already had it running before. And once the app has restarted, we should see that we still have some items on the shopping cart. So let's go ahead and proceed to checkout. And from here, we can click on Pay. And once the payment sheet appears, we can go ahead and select Apple Pay. And then we can proceed with the payment, like this. And once this has been completed, we should see that we are redirected from the payment page to the orders page, where we can see the order details. So as you can see, everything seems to work as intended. And if we head over to Cloud Firestore, we can open the users collection and select the document that corresponds to the current user. And as you can see, inside it, we have a sub-collection called orders. And if we open the only document inside it, we find all these fields, which are used to show all the data that we can see on the orders page. But how is this data written to Cloud Firestore in the first place? Well, to learn about that, we can get back to our cloud functions by opening the index.ts file. And as we can see, here we have a new on-Stripe payment written function. And this function is triggered when a new payment is written inside this document. And just as a reminder, this document is written by the Stripe extension when a payment has been completed. And as we can see in Cloud Firestore, this document has all these different fields. And the job of our cloud function is to read some of the data from here, as well as some of the data from the shopping cart items, and use it to add a document to the orders collection for the current user, which the client app can watch to show this data. So let's go ahead and open this function inside the stripe.ts file. So let's see if we can understand how this function works. And as you can see, at the beginning, we have some defensive code to check if the document exists and if the payment has been successful. And then over here, we extract the payment ID and the customer ID that comes from Stripe. And then we call this function to look up the user UID from the customer ID. And if we hover over here, we can see that what this function does is to read the document, which is located at this spot, and uses it to extract the user UID. And by the time we are making a payment, this is already stored in Firestore, as we can see over here. And as a reminder, the reason this works is that earlier on in this section, we decided to add some logic to the onStripe customer created function in order to write this data when a customer is created. And this means that by the time this code is executed inside the onStripe payment written function, then this UID will be defined. And we should never hit this condition. And once we have the UID, we can use it to fetch the shopping cart data, which contains all the product IDs and quantities. And what we can do next is to extract the payment amount from the payment document. And we can also calculate the cart total separately by using this calculate cart total function that I defined below. And if for any reason these two values don't match, then we log a warning so that we can investigate. But assuming that everything is alright, we can extract the cart items, and then we can pass all these arguments to this function, which is used to fulfill the order. So how does this function work? Well, the idea is that we need to do a few things. The first one is to create a new order object, which contains all these different fields, and write it as a new document inside this collection. And once we have done that, we should also remove all the data from the shopping cart, since it wouldn't make sense to keep the items in the cart after the order has been fulfilled. And also, we write the latest order ID as a separate document, which will be used by the Flutter client to figure out when it needs to redirect to the orders page. And one important thing to notice is that all these operations should happen as a single transaction so that we don't end up in an inconsistent state where one of them succeeds but the other one fails. And in order to make this possible, I've used the Firestore transaction APIs. So this completes the implementation of the order fulfillment logic, apart from one small detail, which is that we still need to update the available quantities in Stripe, and we'll take a look at that in the upcoming lessons. But for now, the bottom line is that once a Stripe payment document has been written, we can use a new Cloud Function trigger to update the data inside Cloud Firestore and write a new order document that the Flutter client can use to show this page. In fact, all the client needs to do is to redirect to the orders page and show the data. So let's continue on the next lesson where we are going to see how to do this. In the last lesson, we have seen how the order fulfillment logic works on the backend. And now it's time to look at the front-end code. So let's get back to VS Code. And a good place to start is to open the orders repository file, which lives inside the data layer of the orders feature. And as you can see, this repository takes Firebase Firestore as a dependency. And inside it, we find this method that allows us to watch all the user orders. And as you can see from this helper method up here, all the orders are written inside a sub-collection of the users collection. And by structuring things this way, it becomes easy to find all the orders made by a given user, because we can just read all the items inside this collection. And if we take a look at this helper method called userOrdersRef, we can find out that we are not just querying a regular collection, but instead we are using a so-called collection group, which is something that you can learn about by reading this page. And I'll explain why I made this decision later on. But for now, let's stay on track. And the next question we need to ask ourselves is, how does the UI know how to read the data from this repository? Well, if we open the presentation layer for the orders feature, we can find this orders list screen file. And this contains this widget, which is used to show this page. And as you can see inside the build method, we watch this user orders provider, which is something that I've defined inside the application layer in this file called user orders provider. And what this provider does is to check if you are currently signed in. And if that's the case, it calls this watch user orders method and returns the result. And if we are not signed in, we just return a string with an empty list of orders. So as you can see, all the Flutter client needs to do is to read the orders data from this collection and show it in the UI. However, there is something else that we need to take care of. And to show you what that is, we can add another item to the cart and then go ahead and proceed to checkout and then click on this button to make the payment. And if you remember, what I shown you in the last lesson is that if the payment is successful, then we should redirect the user from the payment page to the orders page. And on Flutter Web, this is a concern that is already handled when we redirect to the success URL from the Stripe checkout page. But on mobile, we never leave the app, and instead we simply show a payment sheet on this page. So what I've decided to do is to put some redirect logic inside the payment page. And as you can see inside the build method, I'm listening to this latest user order ID provider. And what I do inside this callback is to go to the orders page if the previous UID is the same as the current UID and the previous order ID is different from the current order ID. And this relies on the fact that on the backend, we overwrite this document inside the latest orders collection for a given user ID when the order ID has been fulfilled. And as a proof that this code works, we can put a breakpoint over here, and then we can go ahead and complete this payment like this. And as you can see, shortly after the payment sheet has been dismissed, then this breakpoint is triggered. And if we resume the execution, then we are taken to the orders page. So this explains how the redirection logic works on mobile. And by the way, the reason I decided to put this logic inside the payment page is that I only want to send the user to the orders page from the payment page. But if the user happens to dismiss this page quickly and navigate somewhere else, then the redirection won't take place because this widget will no longer be in the widget tree. And I feel that this is a reasonable behavior. Okay, so before we wrap up, I want to briefly talk about collection groups. And if you remember what we said at the beginning of this lesson, is that in order to query the user orders inside the orders repository, we need to pass the user UID. However, when I was implementing this, I was asking myself if it was also possible to read all the users that have ever been made, regardless of who made them. And this is something that could be quite handy if we were to build an admin dashboard, where we can keep track of all the orders made by all users and update their status. And to make this possible, I decided to use a Firestore feature known as a collection group, which is used when we create this query. And if you click on this link, you'll be taken to this blog post by the Firebase team where you can learn more about collection queries. And you can find a link to this page in the notes below. So overall, this is one interesting implementation detail. And this all sounds good. However, we must not forget that we can only read the orders data if we have the right security rules in place. And to make this possible, I've updated the security rules file and added this additional permission so that users can read their own orders. And I've also made it possible for admin users to read or write this data. And by the way, since we are using a collection group, then the syntax inside this match statement uses a double wildcard. And if you follow this link, you can learn more about why it is like that. Finally, I want to mention that since I'm using collection groups, I also had to add some Firestore indexes. And once again, if you want to understand how collection groups work and why we need to do this, then head over to this blog post by the Firebase team. Okay, so let's continue on the next lesson. In this lesson, we're going to complete the implementation of our backend code by adding the ability to update the available quantities in the Stripe products that we have defined as part of the order fulfillment process. And by tackling this feature, we'll get to learn about two interesting things. The first one is how to handle API keys inside our Cloud Functions. And the second one is how to make calls to the Stripe APIs from our Cloud Functions. And in order to cover these topics, I've prepared another code snapshot for you. So please go ahead and open a terminal. And from here, you can run git reset --hard head to discard any working changes. And then you can go ahead and git checkout section 08-quantities. Okay, so what is different about this new code snapshot? Well, all the changes that I made are related to our backend. And if you want to find out what's changed, we can open the index.ts file. And what we should see is that over here at the top, I'm importing a Stripe secret key from this Stripe secret file that I've defined over here. And if we scroll down to the implementation of the onStripe payment return function, we can see that over here I'm passing two objects inside a map, where the first one is the location of the document, and the second one is an array of secrets that contains our secret key. And if we want to find out how this secret is defined, we can command click to reveal its definition. And here we can see that we are using this define secret function, which can be set from the Firebase CLI by running this command. And additionally, here we export a function called getStripe. And what this does is to extract the value of the secret key and then uses it to initialize and return a Stripe object that we will use shortly. And if you want to get a better understanding of how to work with secrets inside your Cloud Functions, I highly recommend that you read this article on my website, where I explain all the details. But for now, let's stay on track. And the next thing that we want to do is to deploy our updated Cloud Functions. So let's get back to our terminal and then cd into the functions folder. And before we deploy, we should run npm install, because I've added a new dependency called Stripe to the package.json file. And once the Stripe package has been installed, we can go ahead and run firebase deploy --only functions. So let's go ahead and run this. And as we know, this is a process that can take a little while. And at some point during this process, we can see that we get this prompt asking us to enter a value for our Stripe secret key. So what we want to do at this stage is to head over to the Stripe dashboard and open the developers page. And then we should head over to API keys. And over here, we should click this button to reveal the secret key. And at this stage, we might be asked to enter our password. So let's go ahead and do that. And then we can go here and copy the secret key. So make sure that you've copied the secret key and not the publishable key. And then we can get back to VS Code. And over here, we can simply paste it like this. And then we can go ahead and continue with the deployment process. And if everything goes well, after a little while, you will see that the deployment has been completed, like this. In summary, in this lesson, we have seen that if we want to store some secret keys inside our Cloud Function, we need to follow some specific rules and use a certain syntax. And once again, you can read this article on my website if you want to learn more about this. And you can find a link to this in the resources below. With that said, we can continue on the next lesson, where we'll review the completed implementation. In the last lesson, we have seen how to securely store the Stripe secret key inside our Cloud Functions. And now that this is out of the way, we can check out the completed order fulfillment logic, which lives inside the stripe.ts file inside a function called fulfill order. And just as a reminder, what this function does is to write the order data to Cloud Firestore and then deletes the shopping cart document and also writes the latest order ID to this document. And since this is an e-commerce app, it makes sense that if a given product has an available quantity of 10, for example, and we purchase 3 items, then we should update this quantity accordingly. And to make this possible, I've implemented an additional function called update Stripe available quantities, which is called over here. So how does this work? Well, the idea is that when we add some items to the shopping cart, then we end up with a document that looks like this inside Cloud Firestore. And this items field is a map of key value pairs. And this gets passed as an argument to our Cloud function. So what we can do is to run a loop where we extract the product ID and the quantity for each entry inside this map. And also we can extract the available quantity from the product document, which is always kept in sync with the Stripe product data. And once we have all these values, we can use the Stripe client, which we have obtained over here, to update the metadata of this specific product ID by updating the available quantity using this formula. And if everything works as intended, we should see that all the product quantities get updated when we make an order. So let's go ahead and test this out. And to show you that this works in real time, I can open the Cloud Firestore page and select this product, for example, which I already added to the shopping cart. And then I can go ahead to checkout and proceed to payment. And then I can use the payment sheet to pay with Apple Pay, like this. And once the payment has been completed, we should see that we are redirected to the orders page. And shortly afterwards, we should see that the available quantity is updated with a value of 8, because we have purchased 2 items for this specific product. And this confirms that everything is working as intended. And if we want an extra proof of this, we can go to the Stripe dashboard page and get back to the products list. And if we open one of the products that we have purchased, we can scroll down and we can see that the available quantity has been updated with a value of 9, because we have purchased 1 item for this specific product. And I think that this is pretty cool, because it shows how well this synchronization works between the data that is stored in Stripe and the data that is stored in Firestore. And since our client app listens to Firestore in real time, then all the data changes can propagate to the Flutter app automatically. And as a result, if we head back to the home page, we can see that the product quantities are updated as well. And once again, this confirms that when we update some data in Stripe, then all the changes propagate to Cloud Firestore once the Cloud functions have been triggered. And eventually, our Flutter client gets the updated data as well. And with this, we have completed our Stripe integration. So let's continue on the next lesson, where we're going to do a summary. We have now made it to the end of this section about Stripe. And if you managed to follow along all the way to this point, you can pat yourself on the back, because what we have covered here is an advanced full-stack feature made of different many moving parts, which involve our Flutter client, our Firebase backend, and Stripe. And I feel that along the way, we have learned a ton of useful stuff, including when you should use Stripe as opposed to other payments system, as well as all the conceptual stuff about how Stripe works and how you can use it to define products and manage customers. And after that, we have seen how to configure the Firebase Stripe extension and learned how it makes our life easier. And we have also seen that by adding our custom Cloud function triggers, we can synchronize the data between Stripe and Firestore. And then we have seen how to implement a complete payment flow on mobile and web. And after that, we have taken things even further by implementing a complete order fulfillment flow, which is an essential part of the entire system. And now that we have reached this point, we have a reference implementation that you can reuse in your own projects. And of course, along the way, we have made some decisions about implementation details that are specific to this e-commerce app. But I've done my best to keep things organized so that you can take bits and pieces from my code and reuse it in your own projects. And beyond that, many of the concepts that we have learned apply to any other kind of full stack application based on Flutter and Firebase. And on a closing note, I want to mention that up until now, we have used the Stripe dashboard in test mode. And this is great for development. But if you ever want to use this stuff in production, then you have to follow some additional steps to activate your Stripe account. And if you're planning to go live, you can follow this checklist, which includes a lot of useful information. And of course, if you're serious about Stripe, you can head over to the documentation and learn about all the things that you can do with it. Alright, so let's continue on the next section. Welcome to this section, which is all about full text search with Algolia, Flutter, and Firebase. And when it comes to e-commerce apps, full text search is a very important feature, especially if we have a large product catalog. And as you can see from this completed demo, the way this works is that we can type any search query on this text field and get a list of matching search results. And as we will see, when implementing full text search, there are many things that we need to consider, including how to implement a good user experience, as well as how to add caching and debouncing so that we don't make too many API requests to the server, and how to deal with real-time updates and pagination. So here is what we will cover in this section. We will start with an overview of all the Firebase extensions that we can use to implement full text search. Then we'll focus on the Algolia extension and see how to install it and configure it so that it can talk to Cloud Firestore. And then we'll add Algolia to our Flutter client app. And as part of this, we'll add the API keys and write a basic search implementation. And then we will optimize our implementation and deal with caching, debouncing, and real-time updates. And by the end of this section, we'll have a robust and cost-effective full-text search implementation that is powered by Algolia. And along the way, we'll also learn how we configure our Algolia search index by tweaking many different settings in the Algolia dashboard. And as usual, we'll make sure to use a modular architecture that could be adapted to use any kind of server-side search API, so that we are not tied into Algolia. Okay, so let's get started in the next lesson. Welcome to this lesson, where we'll start talking about full text search with Firebase. And before we make a decision about how we are going to implement this, I want to get back to the completed project so that we can understand why we need full text search in the first place. And as you can see, the main idea here is that if we have a list of products, we want to type in some search query, such as pizza or bank, for example. And the list of results is updated to find some matches based on the product name or description. And the important thing to notice is that as long as the search query is contained inside the title of our product, then we treat this as a match and show that product in the list of results. But how does full text search work in the first place? Well, the idea is that we can use some kind of search formula to filter the entire product list and return only the products that match the search query. And if we really wanted, we could implement this by fetching all the items up front and then do this filtering on the client. However, if we have hundreds or thousands of items, it will be very wasteful to fetch all the items at once and then do filtering on the client and then discard most of them. Instead, for large datasets, it's much more efficient to perform full text search on the server and return only the filtered results on the client. And while popular databases such as MongoDB support full text search as a built-in feature, when it comes to Cloud Firestore, we are not so lucky. In fact, if we take a look at this page on the Firebase forums, we can find that this feature is highly requested. But for the time being, it is only supported by these Firebase extensions. And if we head over to the Firebase Extensions hub, we can select the search option, and we can see that all these popular extensions appear over here. And the most popular ones are Algolia, TypeSense, Elastic App Search, and Melee Search. And when I was researching all these different options, I came across this comparison on the TypeSense blog, which shows all the features that are supported by each one of these solutions. And if you're planning to add full text search to your Firebase apps, you can check this table to see if all the features that you need are supported. And beyond that, the most important consideration is pricing. And to make life easier, I prepared this table, which shows how all these different providers compare. And as you can see, they all have different pricing models. And to work out what's best for you, you need to calculate some estimates based on your use case. In fact, if you want to research this further, you can head over to the pricing pages for each one of these products, and you can find all the links to these pages in the notes below. With that said, as far as we are concerned, we are going to go ahead with Algolia, since it offers a free plan and it is quite easy to use. So let's continue on the next lesson, where we are going to get started with Algolia. In this lesson, we're going to create an account using Algolia, and we are also going to install the Algolia extension for Firestore. So as a first step, we can head over to algolia.com. And if you don't yet have an account, you can choose this option called Start Free to create one. And from here, you can choose these providers or sign up with email and password. Alternatively, if you already have an account, you can simply use it to log in. So let me go ahead and do this. And once you have done that, you'll be redirected to the dashboard, which looks like this. And the first thing that you should do is to go ahead and choose the option to create a new application from this dropdown, like this. And this will take you to this screen where you can name your application, such as e-commerce app, for example. And then you can choose this option to start building for free. And then you can go ahead and click on this option. And this takes you to this page, which is showing your closest data center. And in my case, this is the United Kingdom. However, the data center that you should choose is the one that is closest to your Cloud Firestore instance. And since we had chosen US Central when we created our Firebase project, it makes sense to choose the same region, as this will minimize the latency between Algolia and Firestore. And once we have done this, we can go ahead and click on this button. And this will take us to this summary where we can accept the terms and conditions and create our application. And once we have done that, we are taken back to the dashboard. And at this stage, we could go ahead and configure our application. But for now, I think the best thing to do is to go back to the Firebase Extensions hub, where we can find Search Firestore with Algolia as one of the search extensions. And from here, we can go ahead and install it. Next up, we need to choose the Firebase project where we want to install this. And this will take us to this page where we can follow all the installation steps. So once we have reviewed the building settings, we can go ahead and click on Next. And on the next step, we can learn about which APIs will be enabled and which resources will be created. So let's go ahead and click on Next. And here we are told that this extension will generate a new service account that has access to all these resources. So let's go ahead and click on Next one more time. And now we're taken to the most important step of this process, where we need to configure this extension by filling out all these fields. So let's start with the collection path, which contains the data that we want to search. And in this case, this is the products collection. And then we're going to leave these indexable fields empty, and this will cause all the fields to be indexed. And then we're going to leave this option disabled. And then we need to choose an Algolia index name. And in this case, we can call it products_index, like this. And before we continue, we need to go ahead and create the actual index in the Algolia dashboard. Otherwise, our extension won't be able to find it. So let's get back over here. And on the left, we can click on this search icon. And this takes us to this page where we can create an index. So let's go ahead and do this. And as we said, we can call this product index. And we can go ahead and create it like this. And once we have done this, we are taken to this page where we can see that the index has been created. And one thing we should do at this stage is to click on this configuration tab. And as you can see, here we can find a ton of different configuration options that we can use to fine-tune the search settings. And the fact that we have all these options is something where Algolia really shines. And we'll take a look at some of these options in the coming lessons. But for now, the most important thing is that we configure the searchable attributes that will be used for searching. So let's go ahead and choose this option to add both a title, and we're going to make it ordered, and we're going to add a description as well. And we are also going to make this ordered like this. And then we can go ahead and click on this button to confirm, like this. And if you want to learn more about searchable attributes, you can click on this link. And just to be clear, I've decided to add the title and description as searchable attributes, because these are the names of the fields inside our products in Cloud Firestore. So keep in mind that if you are working on your own apps, your fields may be named differently, and you need to set the searchable attributes accordingly. With that said, let's head over to our Firebase extension, where we need to set the Algolia application ID and the Algolia API key. But where can we find these API keys? Well, let's get back to the Algolia dashboard, and then we can click on this home icon. And from here, we can go to the API keys page. And what we can do from here is to copy the application ID, and then we can paste it here. And then we need to take care of the API key. And if we hover on this icon, we get a tooltip. And what this is telling us is that we should create a new API key with all these permissions, and that we should not use the admin API key. So let's get back to Algolia. And from here, we can choose this tab called All API Keys. And then we can click on this option to create a new API key. And out of all these fields, the one that we should set are the indices. And here we should select the products index that we have created previously. And then we can scroll down to the bottom and find this field called ACL. So here we can remove this search setting. Instead, we should select all the options as instructed in the Firebase extension. So I'm going to add object, as well as delete object, as well as list indexes, as well as delete index, and edit settings, and settings as well. So once again, these are all the permissions that are recommended for this specific key. And before we confirm, we could also set the maximum number of API calls per hour. And this is quite handy, especially if we want to avoid a big surprise bill. So for now, I'm going to set this to 1000 so that we can do some testing without hitting the rate limit too quickly. But keep in mind that you only get 10,000 free searches per month. And doing a lot of searches has a cost. And it makes sense to set this to a reasonable value. Okay, so once we're happy with all these settings, we can go ahead and create our API key. And as you can see, this is now listed here. So we can go ahead and copy it, and then we can get back to our extension and paste it in here. And then we can click this button to create a secret, like this. And once we have done that, our key should be saved. Next up, we can scroll down a bit and enable this option to fully index the existing documents. And finally, we can choose the Cloud Functions location. And once again, this should be the same location as our Cloud Firestore instance, which in our case is US Central 1. So this completes the configuration of our extension. And before we continue, I want to mention that as soon as we install the extension, it will start indexing all the products data that is stored in Cloud Firestore. And this means that it's a good idea for this data to be ready in advance. In fact, before recording this video, I decided to upload all the products to Stripe. And since in the last section we have implemented the synchronization between Stripe and Cloud Firestore, then we can see that all the Stripe products are already saved in Cloud Firestore. And I recommend that you also go ahead and add all the products to Stripe, if you haven't already done so, as this will help you test that everything works as intended inside the app. And you can check the notes below for more instructions on how to do this. With that said, let's get back on track, and assuming that we are happy with all the settings, we can go ahead and install the extension. And once we clicked on this button, we should see that the extension is being installed. And this process should take 3 to 5 minutes. So what I'm going to do at this stage is to pause the video and resume once the extension has been installed. Now that the extension has been installed, we can go ahead and click on Get Started. And this takes us to this page where we can find some information. And if we want, we can reconfigure our extension if needed. And before we wrap up, I want to show you a cool thing. And that is that if we get back to Algolia and open the Search tab, then we should see that all the products have been indexed. And this confirms that the Algolia search index has been synced with the products data that is saved in Cloud Firestore. And by the way, if you don't see any data yet, you may need to wait a few more minutes before it shows up. And eventually you should be able to refresh this page and see all the products from Cloud Firestore, along with all their properties. And in addition to this, whenever the products are updated in Cloud Firestore, then the extension will update the indexed data in Algolia. And this will ensure that we always get search results that are up to date. In summary, in this lesson, we have installed the Algolia extension, and we have also configured a new application in the Algolia dashboard. And as part of this, we have added a products index, and we have also generated a new API key that will be used by our extension. And finally, we have verified that all the Firestore products have been indexed correctly. And what this means is that we are ready to add Algolia to our Flutter client app and use it to power our search implementation. Okay, so let's continue on the next lesson where I'll share a new starter project. In this lesson, I'm going to share a new starter project that we'll use as the basis for our search implementation. And I'll also give you a walkthrough of all the relevant code so you get a better idea of how everything fits together. So let's get back to VS Code and open a terminal. And from here, you can run git reset -- hard head to discard all your working changes. And then you can git checkout section 09 -- starter to get all the latest code. Finally, you can run flutter pub-get to get all the latest packages. At this stage, you can also go ahead and run the app. And as a reminder, since we have installed Stripe in the previous sections, the only platforms that we can use at this stage are iOS, Android, and web. So let's go ahead and select Google Chrome as a build target, and then we can try to run the app. And just to be clear, the reason I'm using Chrome is that this will give us a resizable window that will make it easier to test our search feature. And once this is up and running, we can see that we end up on the homepage where we can see a list of products. And one thing that you can notice is that I've enabled this search bar at the top, and we can already use it to search for products, like this. And just to be clear, the way this starter project works is by implementing search on the client. And what we said in the previous lessons is that this is not what we want, and instead our goal is to implement server-side search with Algolia. And before we dive into the code, I think it's a good idea to share this diagram. That gives us a better idea of how everything fits together. So from a high-level point of view, the way search works is that we have a search query that we can edit with this text field. And this represents our input. And we also have some search results that are related to that query. And these represent our output. So let's take a closer look at all these classes and providers. And a good place to start is from the UI. In fact, our search field is implemented inside a widget called Product Search Text Field, which is a consumer stateful widget. And if we scroll down, we can see that inside the build method, we return a text field, which is wrapped inside a value listenable builder. And the most important thing here is that when the text input changes, this onChanged callback is called. And we use it to read this product search query notifier provider and use it to set the search query. So let's go ahead and open the definition of this method. And as we can see, this method belongs to a product search query notifier, which is just a regular RiverPod notifier subclass. And all this does is to store the current search query as a variable, which is an empty string by default. But once we know what the search query is, how do we show the list of results? Well, as we can see here, all the search results are rendered by a widget called Sliver Product Grid. And if we go ahead and open this widget, we can see that inside the build method, we watch this product search results provider and pass the output to an async value sliver widget that takes care of showing all the items inside the grid. And this is what takes care of showing all these items inside this grid. So let's take a closer look at this provider. And as we can see, this is the provider for this product search result function, which is defined over here below the notifier that we had just reviewed. And what this provider does is to get the search query from this notifier, and then it uses it to watch this products list search provider, which is actually a family that can be indexed using the search query. And as we can see, the same thing is represented in this diagram, which shows that this provider watches this provider to get the search query, and then it uses it to watch this other provider. So let's go ahead and open this provider. And from here, we can head over to the corresponding function. And as we can see, we end up inside the product search repository file, which contains a product search repository, which is a new class that I've added to this project. And the purpose of this class is to give us an API that takes our search query and returns a list of products asynchronously. And as we can see in the diagram, the search API is represented here at the bottom. But as we can see, this method is currently not implemented and currently throws an unimplemented error. So how does our search implementation work at the moment? Well, if we look closer at the products list search function, we can see that it sets up a few lifecycle callbacks along with a timer that is used to cache the input queries for a duration of 30 seconds. And I will explain all this code in detail in one of the upcoming lessons about caching. But for now, the thing that is most important is the code at the end of this function. And what this code does is to retrieve this products repository, which is different from the one that we have defined above. And then it calls this search method on it. So let's head over to this search method. And as you can see, this method belongs to the products repository. And the way it works is that it fetches the entire products list from Firestore. And then it uses this where clause to perform the filtering on the client. I only return those products whose title contains the search query. But as we can see, I left a to-do here to clarify that this is only some temporary code and we should replace it with a proper server-side search implementation using Algolia. So as you can see from this diagram, most of the classes and providers that we need are already in place. And in the coming lessons, we will focus our efforts on the data layer so that we can update our implementation to use server-side search inside the products search repository, which is currently not implemented. And now that we have a better idea of how everything fits together, we can continue on the next lesson where we'll get started with the Algolia implementation. Now that we have a better idea of how the search feature works, it's time to figure out how to add server-side search using Algolia. And if you remember, in the last lesson, we said that we will use this product search repository to search products using the Algolia client. And if we head over to pub.dev, we can find this package, which is a convenient wrapper for the Algolia REST API. And if we want to use this package, there are two things that we need to do. The first one is to add it as a dependency, as explained here. And the second one is to initialize the Algolia client by using the application ID and the API key. And this is what we will do in this lesson. So if we get back to VS Code, we can head over to the pubspec.yaml file, and we can see that I've already added Algolia as a dependency. And this means that the only thing that we have to do is to set up the API keys. Just as a reminder, in the last section, we discussed various ways of storing API keys on the client, and we decided to use the embed package, which allows us to generate the keys from a .env file. So as a next step, let's open this .env file. And over here, we want to add two new lines called Algolia app ID and Algolia search key. And then we can head over to the Algolia dashboard. And from here, we can open the API keys page. And what we want to do here is to copy the application ID and paste it over here. And then we can copy the search key as well. And we can paste it in here too. And once we have done this, we can save this and move over to the env.dart file. And as you can see, at the top of this file, I've included some instructions for how to use it. And here at the bottom, I've declared all the keys that we need to use. And now that we have added some additional keys to the .env file, we can uncomment this code. And we can remove this to-do as well. And once we have done this, we can open a terminal. And from here, we should run dart run build runner build -t. And what this will do is to generate all the code for our project. And this process might take a little while. But once it is done, we should see that there are no more errors on this file. And this means that we can now use these keys inside our project. And if you're experiencing any problems at this stage, please check the notes below for more details. But assuming that everything is working as intended, we can continue on the next lesson. In this lesson, we're going to see how to initialize the Algolia client by using the API keys that we have configured. And we are also going to add all the necessary logic so that we can actually search for products using Algolia. So as a first step, let's head over to the product search repository file. And as we can see, here we have a bunch of to-dos telling what we have to do. So as a first step, let's head over to this provider and remove this to-do. And inside it, we can declare a final Algolia equal to algolia.init. And in order to use this, we need to import algolia.dart. And once we have done this, we need to add the application ID. And we can load this from the env.algolia app ID value. And we also need to specify an API key and load this from env.algolia search key, like this. And then we can go ahead and add Algolia as a dependency to this class, and also pass it as a constructor argument, like this. And then we can remove this to-do. And once we have done this, we can update our provider by passing the Algolia variable that we just created to the constructor, like this. And we also need to remove this const keyword from here, like this. And now that the initialization code is complete, we can go ahead and focus on the search method by removing these two lines. So let's start by declaring a final index variable and get a reference to our algolia.index. And in this case, we need to make sure that we use the index name that we have configured in the Algolia dashboard. And once we have an index, we can get a query object, which is going to be equal to index.query, passing our text object that was given as an argument. And once we have a query, we can retrieve all the result objects, which are going to be equal to await query.getObjects, like this. And finally, we can return object.hit. But as we can see, we get this error telling us that we are trying to return a list of Algolia object snapshot from a method that returns a list of type product. And if we want to fix this error, we need to use the map operator so that we can convert each hit object using the product.fromMap constructor. And here we can pass this hit object like this. And if we press dot here, we can see that we have all these properties to choose from. And the one that we want is called data, which is a map of key value pairs. And finally, we also need to add two lists at the end to convert the result from an iterable to a list object. And while I'm here, I also want to make sure to add a comment to better explain what index name we should use, like this. So as you can see, querying data with Algolia is fairly similar to querying data with Firestore. In fact, the index name is much like a collection name, and the index object is like a collection ref. And once we get a query, we can do a one-time read to obtain an Algolia query snapshot, much like we get a collection snapshot in Firestore. And then we can iterate over all the objects to parse the data using a factory constructor that we have already created. And the reason we can use this constructor is that the data that is returned from the Algolia query will contain all these different fields, which are the same as the ones that we are using to store the products data in Cloud Firestore. And the end result is that for a given query, we can get a list of products. And now that this method is implemented, we can scroll down all the way to the products list search provider. And at the bottom, we can delete these lines, like this. And instead, we can type final search repository equal to ref.watch products search repository provider. And then we can use this to return search repository.search, passing our query argument, like this. And believe it or not, this is all we need to do to get a basic search implementation. And this means that we can go ahead and test our code. And like I said before, I'm going to use Google Chrome to test this. And one thing that we can already notice is that the products are sorted in a different order. And this matches the order that we can see on the Algolia dashboard over here. And if we want, we can enter a search term, such as pizza, for example. And as we can see, we get a single search result. Or alternatively, we can type pig, and we get 3 results. And if we want to confirm that we are indeed getting the results from Algolia, we can get back to the dashboard and click on this home icon. If we scroll down, we should see that some search operations have been made. Okay, so it looks like our basic search implementation is working as intended. However, one thing that we can notice is that as we type on this text field, the loading indicator keeps appearing. And I think this is a bit jarring. So let's continue on the next lesson where we will do some improvements. In the last lesson, we have completed our basic search implementation, and as a result, we can use Algolia when searching for products. And now that we have a basic implementation, it's time to make it better. In fact, there are a few things that we need to talk about, including how to improve the UX by preventing the loading indicator from appearing every time we type a new character, as well as how to deal with real-time data as part of our search implementation. And we also need to talk about debouncing and see if there is a way to throttle our requests to prevent too many calls to Algolia. And finally, we need to talk about pagination, which is something that is necessary if we are indexing a large number of items. So in this lesson, we're going to focus on the first of these points, while on the upcoming lessons, we'll address the remaining ones. Okay, so let's get started. And the first thing that I need to point out is that at the moment, we always end up showing this loading indicator every time we change the search query. And this is not a great user experience. And I think it would be much better if we could show the previous search results until the new ones are available. And just to be clear, the reason we are showing a loading indicator in the first place is that inside the Sliver Products Grid class, we are watching this product search result provider, which is a future provider. And then we pass this value to this async value sliver widget class. And by default, this class shows a circular progress indicator when the data is loading and not yet available. But this doesn't really work that great for this use case. So let me show you a different approach that will work better. And over here, rather than returning this async value sliver widget, we can type final product equal to product list value dot value. And then we can check if the product is equal to null. And if that's the case, it means that we don't have any previous data to show. So in this case, we can return a center with a circular progress indicator as a child. And we should also wrap this widget with a sliver to box adapter, because this class is a widget that is added to a list of slivers in the parent widget. So let me go ahead and add some comments here to explain that when we are loading, the previous value will be returned. And as a result, we only show the loading indicator if the value is null. Otherwise, we should use the current or previous value to show the product. And as a result, we no longer need this async value sliver widget. And instead, we should select this sliver products aligned grid and cut it from here. And instead, we should return it here like this and remove the old code. So this is a good improvement. However, we are not done yet because we should also check if there was an error. And to do this, we can add some code here at the top to get the error from the products list value.error. And then we can check if the error is not null. And if that's the case, we can return a sliver to box adapter, which will have a center widget as its child, which in turn will have an error message widget as its child. And this is a custom widget that we need to import from this file. And to this widget, we can pass error.toString as an argument, like this. And this completes the updated implementation for our sliver products grade class. And this means that we can test it. And as you can see, as soon as we start typing into our search box, then we no longer see the circular loading indicator. And once again, this is because over here we're using the value property from the async value class. And if we hover over it, we can read that it will return the previous value during the loading or error state. And if there is no previous value, then reading value during the loading state will return null. So it looks like this is exactly what we need, because it means that we can continue to show the previous search results until the new ones are available. And as we have seen, this leads to a much better user experience. Okay, so let's continue on the next lesson. In the last lesson, we have made some improvements to our search implementation. However, there are still some issues that we need to address, including how to deal with real-time updates. And what I mean by this is that we need to consider what happens if the product data changes while we are on this page. And to test this, I can open the Cloud Firestore console and select one of the products in this collection, such as this honeypot, which is the last document in here. And what I could do here is to edit any of these properties. For example, I could set the price to $20. And what I would expect is that this change is reflected in the app, and the updated price shows over here. But this is not the case, and the app is still showing a price of $16. So what is going on? Well, the reason this is no longer working is that when we load data from Algolia, we are no longer using real-time updates in the product page. In fact, we can see that this product search results provider is a future provider and not a stream provider. And if you remember, a few lessons ago, we have seen that this provider is generated from this function, which gets its data by watching the products list search provider. And in turn, this provider is generated by this function. And at the bottom, we are returning this expression that gives us a future and not a stream. So as it turns out, our search implementation is using futures all the way. And because of this, we have lost the ability to get real-time updates when the data changes in Cloud Firestore. And this can cause our UI to show the old data. So how can we address this? Well, when I was thinking about it, I came up with a neat little trick. And that is to check if the query is not empty. And if that's the case, we get the results from this method, just like before. However, if the query is empty, then we can ref.watch the products list stream provider.future and return this value. And in order to use this provider, we need to import it like this. And the important thing to notice here is that this is a stream provider that gets the data from Cloud Firestore and not from Algolia. And this provider will rebuild every time the data changes. And as a proof of this, we can save our code. And then we can get back to Cloud Firestore. And then we can find this bruschetta plate, which is the first document inside this collection. And over here, we could change the price to $20, for example. And we can see that as soon as we do this, then the price is updated inside the app. However, if we search for the same product, and then we change the quantity one more time, like this, then we can see that the UI will not update. And that's because when the query is not empty, then we are only fetching the data once. But as soon as we clear the search field, then we get real-time data once again. And overall, I think this is a very good improvement because it guarantees that when we are searching, we only do one-time reads. But if we need to show all the items, then we can use this stream provider, which gives us real-time updates. And another big benefit of this approach is that we only use Algolia when we are actually searching, and revert back to Cloud Firestore when we are not. And since Algolia is more expensive than Cloud Firestore, this can even save us some money. Okay, so let's continue on the next lesson, where we'll make some additional improvements. In this lesson, we are going to learn about caching and debouncing, which are two techniques that we can use to make our search implementation more efficient and cost-effective. So to get started, let's take a closer look at how our product list search provider is implemented. And something that I haven't highlighted up until now is that since this provider takes a query argument, It is actually a family of providers that we can use to cache a list of search results for each search query. And another thing I want to point out is that over here we have some custom caching logic, which ensures that the search results are kept for a minimum of 30 seconds. And if you want to get a better understanding of how this logic works, you can read this article on my website, which is all about the provider's lifecycle and how it relates to data caching. And as you can see, this article also contains a section about caching, and this shows some example code that is very similar to what we have over here. And the bottom line here is that when the search query changes, then all the intermediate results are cached for 30 seconds. And while this code looks quite complicated, the idea behind it is quite simple and can be represented by this pseudocode, which shows us that if the query is cached, then we return the results from the local cache. Otherwise, we fetch the results from the server, and then we add them to the cache, and then we return them. And the net result here is that by caching the search results, we make fewer queries to the Algolia API, and this can reduce the cost of our bill. However, our implementation is not as cost-effective as it could be, and it could be improved by using a technique known as debouncing. So what is debouncing and how does it work? Well, the idea here is that whenever we type in a new search query that has not been cached before, we are still making a lot of requests to the search API. For example, since the word mozzarella has 10 characters, when we type it, we end up making 10 API requests. And it would be better if we could somehow add a short delay between the time the text changes and the time we perform the query. And then we could use this delay to discard any search terms that come in very quickly. And if we can do this, we can effectively reduce the number of calls that we make to the Algolia API. But how can we implement this in practice? Well, to figure this out, we need to answer two questions. How should our debouncing code look like? And where should we add it? And one thing that should be clear from this diagram is that we always call the search API whenever there is a new query. And since debouncing is something that is applied to the text input, which happens on this side of the diagram, I suggest that we add it to the product search query notifier. And as we are about to see, we can implement our debouncing logic using the rx-dart package. However, it can be a bit tricky to get the correct logic in place. And to make life easier, I've decided to share an update called Snapshot that contains the debouncing implementation. So please go ahead and open a terminal. And then you can run git reset --hard head to discard any working changes. And then you can git checkout section 09-debounce, which contains all the new code. And once you have done this, you can close the terminal. And then you can open the product search query notifier file. And you should see that the product search query notifier class has been updated. So how does this work? Well, the main idea is that at the top we declare a new stream controller. And the way we use this is that whenever the setQuery method is called, rather than setting the state directly, we add the query to the stream controller. But the interesting stuff happens inside the build method, because what we do here is to take this stream, which will output all the search queries, and debounce it with this special method from the rx-dart package, which will suppress all the stream events that happen too close together. And then we can take the filtered output and listen to it. And every time we get a new event, we call this update state method, which in turn will update the state. And this in turn will trigger an update on all the providers that depend on this notifier. And in addition to all this logic, we also need to close the stream controller and the stream subscription when the provider is disposed, and we can do so with the ref.onDispose callback. And by the way, you can see that I've added two debug print statements, which tell us when some input events are received and when the state is updated. And now that we have this product search query notifier, we can go ahead and run our app so we can test our code. So let's go ahead and open the debug console, and then we can hot restart the app. And once it's ready, we can click on the search box. And here we can type mozzarella, for example. And what we can see here is that all these input queries have been detected, but the state has only been set a few times when we were typing a bit slower. And as a result, all the providers that depend on this notifier have been rebuilt fewer times, and the Algolia API has also been called fewer times. In summary, in this lesson, we have seen that by using caching and debouncing, we can significantly reduce the number of calls that we make to our search API. And this is particularly important when using services like Algolia, which are quite expensive. And if we want, we can fine-tune the debounce time, as well as the cache time. In fact, if we think that the cache products are unlikely to change very often, we could increase this cache to something like 300 seconds, which is the same as 5 minutes. Okay, so let's continue on the next lesson where we are going to do a wrap-up. We have now reached the end of this section about full text search with Algolia. And as we have seen, writing a search implementation that is user-friendly as well as robust and cost-effective requires attention to details. In fact, in the last few lessons, we have seen how to improve the search UI by showing the previous results rather than a loading indicator while a search is in progress. And we have also implemented caching and debouncing as a way to ease the load on our server API. And we have also made sure that we still get real-time updates when we are not using the search feature. And in my opinion, taking these additional measures is absolutely essential if we want to use full text search in production. And before we wrap up, I want to mention a couple of extra things. The first one is that if we head over to the search page on the Algolia dashboard, we can open the configuration tab for our index. And here we can find a wide range of settings that we can tweak. And these settings include which fields can be searched and their relative order, along with ranking and sorting options. And there are also many optimizations around typos, synonyms, word proximity, and much more. And in addition to this, we also have some options for pagination, which is something that becomes very important if we have a large number of records. And if you remember, at the beginning of this course, we have talked about pagination. And we have seen that when we query data with Firestore, we can use the Firestore list view widget to easily handle pagination. However, this only works with Firestore, and if you want to enable pagination with Algolia, we had to write some additional client-side code. And since the implementation for this can be quite complex, I'm not going to cover it at this stage. And perhaps I will write a separate article about it in the future. In any case, if you want to learn more about search, you can check the resources below for more details. Alright, so let's continue on the next section. Welcome to this new section of the course, where we will complete our e-commerce app and deploy it as a Flutter web demo using Firebase hosting. And since I've already done this myself and deployed the app on Flutter Web, I can give you a preview of the last feature that we need to implement. And that is the ability to see the average review score for each product along with a list of reviews. And of course, in order for this to be possible, we need to be able to submit a review in the first place using this form. And given that we've already implemented most of this logic in the Flutter Foundations course, all we have to do now is to focus on the data layer and add the Firebase integration. So as part of this section, I will share a new starter project and show you what's changed. And then we'll implement a reviews repository class that will be used to read and write product reviews with Cloud Firestore. And then we'll talk about aggregate queries such as count, sum, and average, which were recently added to Cloud Firestore. And since these are only available as one-time reads, I'll show you how to use a Cloud Function trigger to calculate the average review score and write it to Cloud Firestore so that the Flutter app can read it using real-time updates. And after that, I'll show you how to build and deploy the Flutter web app with Firebase hosting. And we'll also update the course policy so that the product images load correctly on the web. And like I said, this will complete all the features inside our e-commerce app. And now that we have a better idea of what we are going to build, let's continue on the next lesson where I'll share a new starter project. In this lesson, I'm going to share a new code snapshot that we will use as a starting point for the rest of this section. So to get started, please open a terminal. And then inside here, you can run git reset --hard head to discard any working changes that you may have. And then you can git checkout section 10-starter, which will contain the updated code. And once you have done that, you can run flutter pubget to get the latest packages. And just to be clear, for the rest of this section, I'll be running on iOS, but you can choose Android or Chrome if you prefer. So let me go ahead and select the iPhone simulator and run the app. And then I can wait until the build has completed. And if anything is not working for you at this stage, you can check the notes below for more details. But assuming that everything is working as intended, let me give you an overview of the product reviews feature starting from the UI. And if you remember, what we said in the previous lesson is that users should only be able to leave a review for products that they have purchased. So if we are currently signed in and we are testing an account for which there are no orders, we'll want to make a purchase first. So let me go ahead and choose this bruschetta plate, and then I can add it to the cart. And from here, I can proceed to checkout, and then I can pay for this item. And here I can choose Apple Pay and proceed with the payment. And once this is done, I should be redirected to the orders page. And at this stage, we can dismiss this page. And if we get back to the product page, we can see that we now have an option to leave a review. And if we click on it, we can go ahead and give it a rating along with a comment. But if we click on submit, we get this unimplemented error because this functionality is not implemented yet. So let's get back to the code and see what we can do to enable this. And the main file that we want to focus on is called reviews repository.dart. And inside it, we find this class, which takes Firebase Firestore as an argument, along with all these methods. And as we can see, these methods are not implemented, and they only return some null values or empty lists. So it will be our job to implement them. And additionally, we also have this setReview method, which at the moment throws an unimplemented error. And this is the reason why we get this alert when we press this button. But how is this repository used by the rest of the app? Well, this is something that we have already covered in detail in the Flutter Foundations course. And if you need a refresher, this diagram explains how everything fits together. And the idea here is that when we submit a review, this leave review form talks to the leave review controller, which in turn talks to the reviews service, which in turn talks to these two repositories. And if we go ahead and open the reviews service, we can see that it is just a simple class with one method. And what this method does is to get the current user and throw an exception if we are not signed in. And then it gets this repository and calls the setReview method, which is used to leave a review for the product. And once again, this is the method that we need to implement. Okay, so let's continue on the next lesson where we are going to do this. In the last lesson, we have decided to focus on the reviews repository. And we have seen that if we want to be able to leave reviews inside the app, we need to implement these methods. And before we write any code, we need to decide where we are going to store the reviews data in Firestore. And if we head over to the Firebase console and open the Cloud Firestore page, we can see our collection of products. And I think a good place to add user reviews would be a sub-collection inside each product. And if we wanted, we could call these reviews, like this. And what we said before is that once a user has purchased a product, he or she can leave a review inside it. So it makes sense that we should use the user UID as the document ID inside this collection. And by doing this, we can ensure that each user can leave exactly one review for each purchased product. And of course, we are not going to do this from the Firebase console. And instead, we want to add this functionality in the S code by implementing this repository. And since implementing repositories with Firestore is something that we have done many times before, there shouldn't really be anything surprising at this stage. For this reason, I'm going to share an updated code snapshot where I've already implemented all of this for you. Though if you want, you can pause the video here and attempt to implement this on your own and see if you can get it working. And you can check the notes below if you need some more guidance on this. With that said, I'm now going to share the completed implementation. And if you want to grab the latest code, you can open a terminal, and then you can type git reset -- hardhead to discard any working changes. And then you can git checkout section 10 -reviews -repository like this. And once you have done this, you should see all the updated code. So let me give you a walkthrough of how this works. And as you can see at the top, I've defined two helper methods that we can use to get a path to a given review document and to the collection of reviews for a given product. And the way the watch user review and fetch user review methods are implemented is by getting a reference to this document, and then by using the snapshots API if we need to return a string, or a one-time read if we need to return a feature. So these methods take care of getting an individual review for a given product ID and user ID. On the other hand, these two methods are used to read all the reviews for a given product, and they work pretty much in the same way, with the difference that they return a list of reviews rather than a single review object. And then we have this method that is used to write a review object by calling ref.set. And finally, we have these helper methods which take care of all the serialization logic using the converter API that we have used many times before. And if there is one thing that I should highlight here, is that since it's possible for a review to not exist for a given product and user, we can return a null review object. And in the serialization logic, we can account for this by checking if the document exists before attempting to parse the data. Otherwise, we just return null. Okay, so this completes our overview of the reviews repository. And before we test the new code, I should mention that in order for this code to work, we need to update our security rules. So let's go ahead and open the firestore.rules file. And if we scroll all the way to the bottom, we can see that I've now added this match statement. And what this shows us is that all the users should be able to read all the reviews, but only users that are authenticated should be able to write their own reviews. And since these rules have been updated, we need to deploy them. We can do this by opening the terminal. And here we can run firebase deploy -- only firestore : rules like this. And once this has been done, we can go ahead and test our code. And I think at this stage, it's a good idea to hot restart our app. And then we can open this product once again and try to leave a review. And then we can try to submit it. And if everything works as intended, we'll be taken back to the product page. And if we scroll down, we can see that the review has been added over here at the bottom. And if you're curious to know which is the widget that is responsible for showing this, you can go ahead and open the product reviews list widget. And as you can see, this is a consumer widget that watches this product reviews provider, and it uses this to return a sliver list, where each item is a product review card. And if we open the definition of this provider, we can see that it is a product reviews family that has been generated from this product reviews function. And this in turn reads the data from the watch reviews method of this repository, which we have just reviewed. So if you want at this stage, you can go ahead and purchase a few more products and did some more reviews. And you can also verify that all the reviews appear inside Cloud Firestore, inside this reviews subcollection. And for each document, we can see that we have written the comment, the date, and the rating. Okay, so let's continue on the next lesson, where we are going to figure out how to calculate the average review score. In this lesson, we're going to figure out how we can calculate and show the average review score along with the number of reviews for each product, just like we can see here on the completed app. And one question you should ask yourself at this stage is, are there any APIs that we can use to calculate the count and average values for a collection of documents? And as it turns out, the answer is yes. And in fact, I've already shown in one of my previous tips that if you have a collection reference, you can call the count method to get an aggregate query that will contain the data you need. And as it turns out, since October 2023, Firestore also supports sum and average queries, which means that in theory, we should be able to calculate the sum and average with the Firebase Client SDK without having to write any cloud functions. However, there is one caveat, and that is that these functions are only available as one-time reads. And ideally, what we really want is to update the count and average in real time, every time a review is added or updated for a given product. And if that is what we want, then the only option we have is to write a cloud function that calculates these values for us and writes them back to a document so they can be parsed and shown by the Flutter client. So how does this function look like? Well, to make life easier, I've prepared another code snapshot that I can share with you. And if you want to get it, you can open the terminal. And as usual, you can run git reset -- hard head to discard any working changes. And then you can git checkout section 10 -- update -- ratings like this. And once you have done that, you can head over to the index.ts file where all our cloud functions are defined. And if you scroll all the way to the bottom, you can find this new function called onProductReviewWritten. And as you can see, this is a trigger that is called whenever a document is written at this location. And when this happens, this update rating function is called. And this function is defined inside the ratings.ts file. So let's go ahead and see how it works. And as you can see, this function gets an event argument, which contains a document snapshot. And over here, we use it to get the product ID from the event params. And then we use it to get a reference to this reviews collection. And over here, we list all the documents inside this collection. And then we use a for loop to accumulate this total value. And once we reach the end of the loop, we calculate the average rating by dividing the total by the number of ratings. And finally, we write both the average rating and the number of ratings inside this product document. And the bottom line here is that this document will be updated every time a review has been added, updated, or deleted. And since the client app is listening to products data in real time, it will automatically get the updated values. However, the price we pay for real-time updates, in this case, is that we perform n document reads and 1 document write every time a new review is written. And this is more expensive than using aggregate queries as one-time reads, especially if you have a lot to reduce. So this is another example showing that when we make certain implementation decisions, there are some trade-offs to consider. And by implementing this function, we have decided to use real-time updates and pay for the extra document reads and writes. And now that this new function is defined inside our index.ts file, we want to go ahead and test it. And of course, before we do this, we have to deploy it. So please go ahead and open the terminal. And from here, you can head over to the functions folder. And then you can run firebase deploy -- only functions like this. And this is a process that should take a while. So I'm going to pause the video here and resume it when it's done. Okay, so it looks like my cloud function has been deployed successfully. And this means that we can get back to our app. And if we want to test that everything works, we can choose a product that we have previously purchased. And then we can go ahead and leave a review or update an existing review, like in this case. And over here, I'm going to update the rating to 5 stars. And then I'm going to submit this. And after a little while, we can see that the average rating score and the number of reviews appears over here on the product page. And the same rating should also appear on the product card inside the homepage. And this confirms that everything works as intended. And just to be clear, the reason our Flutter app is able to show this data is that inside the product model class, I've already defined this average rating and number of ratings properties. And these properties are part from the data that comes from Cloud Firestore. And in fact, if we want to verify that the data is actually there, we can head back to the Cloud Firestore page, and then we can open this product document. And as we can see, we have an average rating of 5 stars and a number of ratings equal to 1. And this confirms that our new cloud function is doing its job correctly. In summary, in this lesson, we have learned that if we want, we can use aggregate queries to calculate the count, sum, or average of a set of documents inside a query. And what we said is that these operations are available as one-time reads. However, if we want to calculate these values in real time, we can write a cloud function trigger that listens to document writes, and then it calculates the updated values and writes them back to a document that the client can read using real-time updates. And we have also said that this approach is more expensive, so make sure that you understand the trade-offs when implementing similar functionality inside your apps. Okay, so let's continue on the next lesson. After the changes we made in the previous lesson, our e-commerce app is now feature complete. And if you want, at this stage, you can go ahead and run it on a physical device, whether it's an Android phone or an iPhone. However, in this lesson, I'd like to show you how we can deploy our Flutter web app using Firebase hosting. In fact, deploying your app on the web makes it much easier to share it with a simple URL without having to download it from the App Store. And as we're about to see, Firebase hosting makes this process super easy. So assuming you have the latest code from the previous lesson, you can go ahead and open a terminal. And from here, you can run Firebase init hosting like this. And at this stage, the CLI will tell us that we are initializing within an existing Firebase project directory. And it will also tell us the project ID over here. And then we are taken to this interactive hosting setup, where we have to answer a few questions. And the first one is, what do we want to use as the public directory? And here, rather than using the default public folder, we can type build/web, since this is where the Flutter web app will be built. Then we get this question asking us if we should configure it as a single page app and rewrite all the URLs to /index.html. So make sure to answer yes in this case. Otherwise, you won't be able to navigate to the various pages by URL. And then it asks us if we want to set up automatic builds and deploys with GitHub. And we can say no to this. And once this is done, the configuration is complete. And at this stage, we can open the Project Explorer and scroll all the way down so we can open the firebase.json file. And if we scroll down, we should be able to find this hosting section, which contains all the configuration options that we have chosen. So this looks good. And the next step is to build our Flutter web app in release mode. And we can do this by typing flutter build web / release like this. And then we can wait for the build to complete. And this may take a little while. And once this is done, we can go ahead and open the build folder. And inside here, we should be able to find a web folder. And as you can see, here we find this index.html file, which is the root of our Flutter web app, along with all these other files. So this looks good. And the last step is to deploy our app. And we can do this by typing firebase deploy -- only hosting, like this. So let's run this and wait for the process to complete. And what this will do is we'll take all the files that have been added to the web build and deploy them. And eventually we get this public hosting URL, which is where our app is hosted. And if we want, we can command click on this URL to test our app in production. So let's do this. And as you can see, after a little while, our app appears on the browser. However, we have one problem, and that is that the product images are not showing. And the reason for that is that we have not configured our Firebase storage bucket with the correct CORS policy for this URL. So let's go ahead and fix that in the next lesson. Now that our Flutter web app has been deployed, we have one last step to do, and that is to update our CORS policy on the Google Cloud Console. So let's go ahead and head over to console.cloud.google.com. And from here, we want to make sure that the correct Firebase project is selected. And in my case, this is called Flutter Firebase Masterclass. But in your case, the project name might be different. And then we want to click on this button to activate the Cloud Shell. And once we have done this, we need to wait a little while until the terminal is ready. And once we have done this, what you want to do is to copy and paste this command, which you can find in the notes below. And before you run it, what you want to do is to replace this origin with your Firebase hosting URL. So the way to do this is to go back to your deployed app, and then you can copy this URL, and then you can get back here. And what you want to do is to make sure that you replace this value, like this, with your Firebase hosting URL, like this. And then you can press enter. And what this will do is to write the correct configuration into this file. And finally, what you want to do is to copy and paste this command, which you can also find in the notes below, so you can apply this configuration to your Firebase storage bucket name. And once again, you want to replace this storage bucket with the name that you can find in your Firebase console. And you can do this by heading over to the storage tab, where you can find the correct value. And you can click on this button to copy the folder path. And then you can go ahead and paste it in here, like this. And finally, you can go ahead and run this command. And you also have to click on authorize to grant permission to do this. And ideally, this command should work, but in my case, I got this 401 service exception. And after doing some research on Stack Overflow, I've come across this answer, which seems quite promising. So let me try to copy this command from here and paste it in here. And then I'm going to go ahead and proceed. And then I can go ahead and follow this link. And after signing in with Google again, I got an authorization code that I can paste in here. And now that I've done this, I can try to go ahead and set the CORS policy once again. And as I can see, this time the command is successful. And this means that I can go back to the Flutter web app. And if I refresh the page, I can see that all the images now appear correctly. And this completes the CORS policy setup for our Flutter web app. Okay, so let's continue on the next lesson. Congratulations for making it all the way to the end of this course. I'm very happy that you made it all the way to this point. And I feel that we have covered a lot of ground in this course. And we have this really nice Flutter web app to prove it. And I think the best way to wrap up this course is by highlighting some of the Firebase pros and cons that we have encountered along the way. So on the positive side, I'd like to mention that Firebase Auth made it easy to add user authentication to our app. And with Cloud Firestore, we've been able to build features such as products, reviews, shopping cart, orders. And as we have seen, using real-time listeners and security rules made our life much easier. And these are not things that you can take for granted when you build a custom backend. And thanks to Firebase storage, we've been able to easily store all the product images. And another thing that I really liked is that the Firebase local emulator made it much easier to develop our app locally, especially when we had to write and test our cloud functions. And thanks to Firebase extensions such as Stripe and Algolia, we've been able to implement our checkout flows along with full text search. And overall, I really appreciate the development speed that Firebase can bring when things are working as expected. However, there are also some things that I didn't like about Firebase. For example, we had to deal with platform-specific configuration. And even though we can use the Flutter Fire CLI to generate configuration files for each platform, the process can be error-prone, and we need to be a bit careful. And another thing that I didn't like too much is that configuring Firebase to run on macOS wasn't straightforward. And as far as Windows is concerned, support is even more limited, and if you need to ship your Flutter app to Windows, you should probably choose a different backend. And of course, another drawback is that we can't write cloud functions using Dart. And while I like TypeScript as a type-safe language, there is no doubt that it comes with a bit of a learning curve. And also, it's a bit annoying that we had to use a third-party solution for full text search. And one last issue that I want to mention is that I haven't found an easy way to prevent overbilling. And while it's possible to set budget alerts, manual intervention is still needed if something goes wrong and you're using too many resources. But despite these drawbacks, I still think Firebase is a great backend for building Flutter apps. And I hope that the techniques and concepts I shared here will be useful as you build your own apps with Flutter and Firebase. So once again, thank you for trusting me to be your instructor in this course, and happy coding!